In this video, I'm going to give you a comprehensive introduction to blockchain development in 2024 by building multiple different blockchain applications step by step. I'm going to take you over the shoulder and show you everything you need to know as a blockchain developer myself who works with this technology on a daily basis, who has helped thousands of people become real-world blockchain developers, even if they've never coded before in their lives. So don't worry if you're a total beginner. I'm going to show you everything you need to know from scratch. So if you're new around here, hey, I'm Gregory, and on this channel, I turn you into a blockchain master. And the only thing I ask in return for putting together this epic guide for you on YouTube is that you smash that like button down below for the YouTube algorithm and you subscribe to this channel. And if you like what you see in this video today and you want to take the next step toward becoming a pro blockchain master, that's exactly what I can show you to do over at dappuniversity.com/bootcamp. All right, so let's get into this. So I'm super excited to help you on your journey towards becoming a real-world blockchain developer. And so what I've done in this video is I've taken multiple different courses that I've created and I've put them together all in this video completely for free for you on YouTube. So how can you follow this? Well, I've put a link down in the description below of all the table of contents, which is going to give you some timestamps, which you can navigate with the video player down below, so you can see each project. So the easiest way is to start with the first one, finish that and go to the next one, but you can also choose whatever looks the most interesting to you and skip around that way. But whichever way you choose, you're probably going to want to bookmark this video, come back to it, share it with your friends so that you can keep this guide handy on your journey. So what are you waiting for? Let's get started. All right, so let's jump into this. A quick overview. What is Solidity? It's the main programming language for writing Ethereum smart contracts for the Ethereum blockchain and other EVM compatible chains. It's an object-oriented language. It's high level, and it's honestly pretty beginner-friendly on the grand scheme of things because it's heavily influenced by Python and JavaScript, which are also other pretty beginner-friendly languages. It is statically typed. Okay, it supports inheritance, libraries. It's a fully fledged programming language, as we're going to see throughout this tutorial. And one of the main things I want to focus on in this video is the features of Solidity version 0.8. So this is the latest major version of Solidity. And this technology is changing all this time, and I want to create this video so that you all can understand how this works with the current version of Solidity. So now let's start coding. We're going to do everything inside of our browser without having to set anything up on our computer. We're going to use Remix. So head on over to remix.ethereum.org. So this is a browser-based IDE where you can write Ethereum smart contract source code. You can see examples here in the contracts folder. Okay, we're going to create a new smart contract in a second. You can also compile the smart contracts in this tab and then deploy them live to a blockchain all in your browser. Okay, so we are going to work off a set of examples here. You can see this tutorial repository here on GitHub. I'll put a link to this down in the description below. It's got the examples that we're going to work through. So if you want to find the solutions after the videos, you can do that. But let's go through these step by step and learn Solidity. So the first thing we want to do is create a new file here at Remix. So on the sidebar, click this paper icon right here, and let's create a new file called counter. So capital C, counter.sol. So we use capital letters for smart contract file names, and we use the .sol file extension for the Solidity programming language. So the first thing that we want to do is declare the Solidity programming language version at the top of the file like this. We say pragma Solidity, and we use a caret here. Okay, and then say 0.8.0. So that will mean that we're using at least version 0.8.0. We have to tell it what version of the programming language we want to use so that the compiler understands that from our smart contract. So the next thing that we do is we create the smart contract like this. We use the contract keyword, contract, and then we give it a name. So I'll go ahead and bump this up so you all can see it, okay? So contract, counter, so capital C counter, just like the file name. And then we use these curly braces like this. And then all of the code for the smart contract goes inside of here. All right, so on the Remix page, or excuse me, the Solidity page, it talks about how Solidity is an object-oriented language. So that basically means that the contracts themselves are sort of like objects in other programming languages where they support inheritance, you can call other smart contracts, and also that contracts are the basic unit that you can reuse inside of the Solidity programming language. So this contract is an example of that. So all of the code that goes inside of here is kind of like going inside of a class with another programming language. All right, so let's create our first code here. What we're going to do is create a basic variable inside Solidity. So this counter contract, what does it do? Well, it's basically just going to store a count on the blockchain, and we're going to let a user change that count by 1. So example, we're going to have this variable called count here. And this variable value could be 1, 2, 3, etc., etc. And we're going to let the user set this value and make it go up and down. All right. So we can declare a variable inside Solidity like this, specifically a state variable. So what does that mean? Well, a state variable is a variable that's actually stored on the blockchain itself. And we create state variables inside Solidity by just declaring them inside the contract, not inside of any functions or anything like that, just inside these curly braces. Okay. So we create this variable named count, but with Solidity, we have to tell it the type of variable. Okay, so basically, Solidity is a statically typed language, which means whenever you are declaring a variable, you have to tell the type. In this case, we're going to say it's an unsigned integer, so uint. Okay, so what does that mean? Well, an unsigned integer is just an integer without a sign. So, the count can be 1, 2, 3, etc., etc. It can be an integer, but it can't have a minus sign in front of it. So it can't be -1. This is a sign, so it can't have a sign. So unsigned means that it's an integer that's only positive. All right. So again, statically typed uints means that this variable value count can only ever be count. It can only ever be a uint. It can't be a string. It can't be an array or anything like that. So now let's create our first function inside of Solidity. So what is a function? Well, a function is just a piece of code that can be reused and called over and over again inside of a smart contract with a certain set of steps. Okay, so you say step 1, step 2, step 3, and then you can repeat those steps whenever you want to simply by calling the function. So in this case, we're going to create a function that just gets the count that's listed here. So we'll do that like this. We'll say function get count. Okay, and then we use these parentheses like this, and then we give it some curly braces. So that's all you need to do to create your first function. You create the function keyword, you give it an arbitrary name that you decide, and then you use these curly braces if it has arguments or not, and then the function code goes inside of here. So what we're going to do inside of here is just return the count. Okay. So the return keyword is what we use inside Solidity just to specify, what this function is going to give back to the person that's calling it. In this case, it's going to be this count that we're reading directly from the blockchain. So the next thing that we want to do is declare the visibility of this function. What does that mean? Well, we're going to add this modifier like this. We say public. Okay, so what does that mean? Well, it means that now we can call this function outside the smart contract, because in a minute, we're going to put this contract on the blockchain and we're going to click some buttons that talk to the contract to actually read this count. And we wouldn't be able to do that if we didn't have this public modifier here. So Solidity supports other modifiers like internal and others, which we'll talk about later, so to where this could only be called inside the smart contract itself. But for now, we're going to make it public. And then next, we're going to say it's a view function, and that it specifies that it returns this value, returns uint. So this tells it the data type that the function returns. In this case, it's going to be a uint. Now let's create a new function to set the count. So we have get count. So we'll create a new function just like this. Function increment count. And then we'll use the curly braces, or excuse me, the parentheses. And then we'll say public. And then we'll use curly braces. And so this is going to be our function that we call to change this number and make it go up. So how do we do that? Well, we can get the count from the blockchain like this and say count equals count plus 1. And then we want to follow that with a semicolon. So I meant to mention that earlier. We definitely want to add semicolons after each line in Solidity, except when you're creating functions like this. So we have a semicolon here, and a semicolon here. So how does this work? Well, essentially what we do is we get the value of count from the blockchain like this. We say count, okay? And then we just add 1 to it. So we say count plus 1. You can do math pretty easily in Solidity just like this. And then we use the equal sign, which assigns the value back to the original variable. So we just read count, we add 1, and we save it back to count here. And again, whenever we save this, we're updating this value to the blockchain itself. That's what a state variable is for. It's stored on the blockchain's state. The state of the smart contract is decided by the blockchain. And whenever this variable changes, we change the blockchain. And whenever we do this, we have to pay gas. So this function is a write function. And therefore, we're going to call it public so that we can write it on the blockchain outside the smart contract. Whenever we write it, we have to pay gas. So there's two types of functions in Solidity. There's read functions, like getting the count here. We just get this information from the blockchain. And then write functions where we actually change the blockchain. So reads are free on blockchain and writes cost gas. So we have to pay a gas fee, which we'll see in a minute whenever we do that. All right, so the next thing that I want to do is set the default value of count. So we have created a way to get the count from the blockchain and increment the count. But right now, we don't have a default value set. So I'm going to do that with the blockchain's constructor function, or excuse me, the smart contract's constructor function. We'll do that like this. We'll create a special function like this called constructor. Okay, and we'll call it public. And then we'll write the code inside of here. We'll say count equals 0. So what is this? Well, a constructor is a special function for each smart contract that gets run once and only once. Whenever the contract is deployed to the blockchain, or whenever it's put on the blockchain, or whenever the contract's created, those are all the same way of saying the same thing, or different ways of saying the same thing. So whenever we create the special constructor function, we just use a constructor keyword. If we have any arguments, we can put them inside of here. We don't currently for this one. And we want to make our constructor function public so that it can be called whenever the contract is initialized. So any code that we write inside of here will be called during the contract creation. And the only thing that we want to do is just set count equal to 0 as a default value. And we can set this to anything we want to. It could be 1, it could be 2, it could be 3. But for now, we'll just do 0. All right, so let's test this out. So we have created some Solidity source code here, okay? But now what we want to do is put the contract in the blockchain, which is a two-step process. The first step is going to be compilation. So you can go to this right here, Solidity compiler. So what does this do? Well, essentially, this just takes our human-readable code that we've created here and turns it into machine-readable code that can be run on the Ethereum virtual machine, or the EVM, okay? Whether it's on the Ethereum blockchain or another EVM-compatible chain. So we can just click compile, all right? And you can see it's got some warnings here. Let's just fix this. Let's go into our file here, and let's add this license identifier, okay? This is a special thing that most compilers want to see now, so we just say SPDX license identifier, MIT. All right, let's compile it again. All right, we're going to ignore this for now because we're going to remove the constructor function in a minute. It's just a warning. We'll be able to change it. It's just talking about the visibility. We'll update this momentarily. But let's click compile. All right. And then you can see that this is successful. And what it does is it turns it into bytecode. So you can copy this bytecode. You can click it here. And I can open my text editor. And here you can see the actual bytecode that is generated, and this is the machine-readable code that's going to get run on the EVM. Okay, so we don't have to understand this, but I just want to show you what compiled smart contract code looks like as opposed to the human-readable code. So now let's deploy it. Okay, we can go to this tab here, and now we can deploy it to a JavaScript blockchain in our browser. So this is just a fake blockchain right here. You could do different environments, but we'll just do the fake blockchain in our browser built in JavaScript. And you can see it's got, several accounts here, each with some cryptocurrency credited to it, which makes it nice and easy. We don't even have to install a wallet. We don't have to run a blockchain on a computer. No, nothing. You just go to Remix and start writing your smart contracts. So we can deploy it like this. We just click this deploy button and boom, there you go. So I'll pull this with my screen in case it's cut off at the bottom. You can see the actual transaction that was triggered right here. So this shows you all the details of what happened when we put the smart contract in the blockchain. So again, whenever we're putting contracts in the blockchain, we're creating a transaction. What is a blockchain? It's a worldwide computer basically made up of transactions. So, all the data on the blockchain is contained in transactions, which are grouped together in bundles of records called blocks, which are chained together to make up the public ledger. And anytime you do anything in the blockchain, whether it's send cryptocurrency from one account to another, whether you call a smart contract function, where you put a smart contract in the blockchain, you're creating one of those transactions. Okay, and that's exactly what we just did whenever we put this smart contract to the network. And when we did that, we had to pay a gas fee. So you can see that some cryptocurrency was taken out of this first account right here. So this was 100 Ether, and now it's 99.99 Ether. Okay, and we can see our final smart contract deployed right here. And we can even copy the address if you want to see that, and then paste it right here. Okay. So now we can get the count. All right. By clicking this blue button here, this calls our get count function. We see it's currently 0, and then we can call increment count. All right. That worked. It created a transaction. You can see that we paid gas whenever this happened because our balance went down, and we can get the count again. And boom, there you go. It's 1. Okay. So now I want to refactor this code to make it better. So refactor just means to change and simplify. So in this case, what I'm going to do is change this right here inside the increment count function. Instead of saying count equals count plus 1, you can do that in Solidity just like this. You can basically just take the count variable and go count plus plus. All right. And then that will increment the count by 1. That's what the plus plus or increment operator means. So next we can get rid of this function entirely. So I'll show you how. Well, essentially, whenever we create this uint, we can assign it public visibility like this, uint public count. And whenever we do this, Solidity is going to give us a function called count for free. It's going to expose it outside the smart contract so we can just call a count function and remove the need of creating our own get count function entirely. Okay, so I can just literally delete that because now we can call a function called count, which Solidity is going to expose for free once we do this. All right. And the next thing that I can do is also get rid of this constructor function entirely. Okay. Because Solidity lets you set default values for these state variables in line. So I can literally just say public count equals 0. All right. And then get rid of this. But that demonstrates, I wanted to do those things first to demonstrate the other functionality of Solidity and introduce those concepts before we simplify things like this. So you can make it 1, you can make it 2, but let's just start with 0. All right, now let's go back to the process of compilation and deployment. So click compile, and now we have no warnings anymore because there's no constructor for it to yell at us about. And then we do deploy. Okay. And then actually I'm just going to delete all these and then click deploy again just to make things less confusing. You see the count is 0, and then we can do increment count, and then boom, there you go. The count is 1. All right, so now let's talk about variables and data types. So make sure you're over at remix.ethereum.org to follow along with this section. And what we're going to do is create a new smart contract inside of here. We'll go to the contracts directory and click this new contract icon right here. And we'll create a contract called my contract, capital M, Y, capital C, contract.sol. All right. And then inside of here, we're going to declare the Solidity programming language version. We can literally just copy this line from the previous example. All right. And then paste it in here with the license identifier. And then we can say contract, my contract, and then use the curly braces. And then we'll write all the code inside of here. Okay. So now let's talk about variables. All right. So what are they? Well, essentially variables are just ways to store information inside your smart contract that you can reuse later. So, we saw that functions were basically like snippets of code that you could run over and over again, reuse later. Variables is just data that you can store and reuse later. So we're going to talk about state variables versus local variables. So I made a brief mention of state variables in the last video, or the last section, I should say. But now let's talk about local variables, and then we'll get back to state variables. So basically, local variables are just variables that exist inside of Solidity functions. So you can see an example like this. We could say function, get value, like we did in the last section. Say public, okay. And then inside of here, we could have a value like this, value, and then it can return value. And we can set this value to an unsigned integer like this, uint, let's see here, value equals 1, okay. And so value in this case is just a local variable. So that basically means a variable that is declared and assigned and used only inside of this particular function. So that also has several implications, which means you can't read this variable value inside of any other function except get value. Okay, you can't access it up here as a state variable, and you can't call it from another function at all. So that's called the variable scope, which just determines like where the variable can be read, where it can be updated, and all that type of stuff. So, whenever we've assigned the value of value here, we can do anything we want to with that. We can do math with it. All right. We can do -1. we could, read the value, say value equals value plus 1, right? We can do lots of stuff. We can read it and we can assign it again, and we can also just simply return it. And now let's just finish this function off like this. We'll just say public, and we'll say pure returns uint. Okay. And we want to have this be public because we want to call it outside the smart contract. So I already did that. But pure because it doesn't modify the blockchain in any way. It just fetches information, doesn't mutate anything. And then, of course, it returns this data type, which is what uint is. So that's what a local variable is. And we're going to read it out with this function. Let's talk about a state variable and how that's different. So I can create a state variable like this that's basically the same thing. We can just say, we'll call it uint, my uint, and we'll say equals 1. So essentially, this is doing the exact same thing with a different name, but we're just creating an unsigned integer here with the value of 1. So this is a state variable, which is different from a local variable because this variable value is stored on the blockchain. Again, whenever we save information to the blockchain, we create transactions, we have to pay gas, and this is saved forever. So we can also update this, and every time we update it, it will also get saved to the blockchain. So again, an unsigned integer is just a data type. It's a number. It's an integer without a sign, so it can't be negative. So that won't work. It has to be 1, 2, 3. It can't be -1, -2. No sign in front of it. Okay. And the other thing I'll say about this variable, this state variable, is the scope. So again, the scope is basically where you can access this variable, where you can update it. So this variable has scope inside the entire smart contract. So if we had another state variable, we could access it there. We can access it inside this function. Okay, if we had any other function, we can read its value inside of there, and we can also update the value inside of any function because this variable has scope within the entire contract. Okay, so now let's talk about some different data types inside Solidity. We've covered the basics of the variables, and now we're going to create some new variables of different data types. So here we've just added an unsigned integer, and we've assigned it to 1. So let's go ahead and call this public so we can read it out to the smart contract if we want to. But now let's talk about some other unsigned integers. So I can do this. I can say uint 256. So my uint 256. I say public equals 1. And so what is that? Well, essentially, uint is short for unsigned integer 256. So 256 is the number of bytes that are actually stored in the number. Okay, we're going to see some more uints here in a minute. This is the default size for unsigned integers in Solidity, and for that reason, you can just use uint for shorthand, and this will give you a uint 256. So this is literally the exact same thing. This is just short for this. So we can use smaller uints like this. So uint 8 public, uint 8 equals 1. And lots of other sizes, but this is a really common one. And here inside the Solidity documentation, you can see that Solidity supports both signed and signed integers of various sizes. Keywords uint 8 to uint 256 and steps of 8. Okay, so you can say all these different sizes just like this, 32, etc., 16. All right. And so let's look at a couple of those. We also want to look at ints. So not just unsigned integers, but we can also do ints like this. Okay. We can basically say int 256, my int equals 1. So this is an integer, but it could also be negative if we wanted to. So this is an unsigned integer. It cannot be negative. And this is an int, and we can have this of different sizes. We could have int 8, or I could have int without any type of number that would, imply int 256 as well. So one might ask, why do you have different types of ints? Okay, well, it's because you care about the size of information that you're putting on the smart contract and on the blockchain. So basically, this is going to be a smaller integer. Okay. And sometimes you only want to allow, data that's of this size versus data of this size, which is going to be a lot bigger. Okay. So, by default, for most general purposes, 256 is going to be fine like this for, just general, tutorial programming projects. But when you get into production smart contracts, you probably want to start considering different sizes depending on the footprint that you're trying to save. And next, we can do strings. So what are strings? Well, they're just groupings of characters inside of quotation marks like this. So it could be a word, cat. It could be another word, dog. Or it could be a sentence. My cat looks like a dog. Okay. As long as you can fit the characters inside of the quotation marks, it'll work for a string. So we can create a string in Solidity like this. We can give it the string keyword because again, it's statically typed. So string, we'll say my string equals hello world. Okay. And then we're going to finish that with a semicolon like this. All right. And then we can also call this public. So we can read out the smart contract, say string public. And we'll also make these other variables public as well. Public. I'm going to move them before. My fault. I accidentally put them after. All right. That reads a lot nicer. I also realized that I didn't make this my uint 8. Sorry. My brain is just not working right now. So anyways, now let's look at another string. We'll do a bytes 32 string like this. We'll say bytes 32 public my bytes 32 equals hello world. All right. And so what this is it lets you store a string in a bytes 32 format, which basically treats your string more like an array and gives you some different flexibility that you don't have with the regular string. Okay. So you'll definitely see example use cases of this out in the wild. Next, we can store addresses inside of variables inside Solidity like this. So we can say address. All right. Public. And we can say my address. Okay. And then I'm actually just going to paste an address inside of here. Okay. Like this. Boom. So what is an address? Well, an address is sort of like a username on the blockchain. Okay. And it corresponds to an address for, a user account, like if you have your MetaMask wallet connected, or it, corresponds to a smart contract address. So any contract on the network is going to have a address, and any user connected to the network, any wallet is going to have an address associated with it, and we can store those for reuse, whatever purpose we want to, inside Solidity variables with the address data type, just like this. All right, so the last thing I want to talk about are structs. So we've seen different types of variables and different data types like strings, numbers, addresses. But the cool thing about Solidity is that it lets you create your own custom data types with structs. So, if you want to create something that's more sophisticated than just a simple number or a simple string or a simple address or any of the other basic data types, you can do that with structs like this. We'll say struct keyword. We can call it my struct. Okay. And inside of here, we can basically create a complex object that has multiple, values inside of it. So we can say, uint 256, my uint 256. And then string, my string. Okay. And so this just defines the struct. So, we don't need to define a string or an address because these are already, defined at the Solidity compiler level. But if we're going to create our own custom structs, we have to define it first like this. Now we haven't actually created an instance of my struct yet, but we can do that like this. We can say, my struct public, and then say my struct equals my struct, and then say 1, and then hello world. Okay. And then that's going to actually create the instance of my struct, because again, whenever we create a variable, we give it the data type first. We create the data type of my struct here. So this data type, it's public. We give it the variable name, my struct, and then we instantiate the struct by, just saying the name my struct followed by these parentheses, and then we pass in the first value of the struct, which is my uint 256. Okay, so it's an unsigned integer. This is an unsigned integer. And then the second value is a string, my string. And then this is the string that we pass in right there. All right, so let's go ahead and save all this and compile it. And compile and run. And it looks like we got a little bit of error here. Let's just fix that. So my fault. I put a comma, just a bad habit. We need to put semicolons here. All right. Sometimes it's a lot harder to code and talk than you might think. So this is real life software development, everybody. I like keeping these errors on screen because it keeps things real. So we'll do compile, and then we'll go to deploy. That also happens when you have multiple programming languages. So we'll say deploy. Okay. And then now the contract going to deploy the network. We can see the transaction here, and then we can see the value of these different things. So get value. All right. It's equal to 1. Okay. We can see my address. All right. Bytes 32. You can actually see the bytes 32 format returned here. My int is 1. My string, hello world. My struct. And here you can see how Solidity compiler handles structs. It gives you 2 different values. The first value is 0. The second value is 1. Okay. And then my uint is 1. All right. And there we go. All right, now let's talk about arrays. So I'm going to take the code from the last video, or the last section, I should say, and clear it out. So we're going to keep my contract inside of here, but we're going to just take out the guts from the middle. We're going to add our code here. So let's talk about arrays. What are they? Well, essentially, they are just sorted groupings of different pieces of data. So that's probably not the best computer science definition, but you'll see what I mean here in a second. So basically, we're going to say arrays, all right? And let's just go ahead and create our first array so that you can see what I'm talking about. I'm going to say uint, and then I'm going to give these brackets like this, say public, and then uint array, and then we'll say 1, 2, 3, and followed by a semicolon. So let's just illustrate the concept so that you can understand what it is. Well, an array here is this. All right, you can see it's these brackets, beginning bracket and closing bracket. So array really is just a list, and it's a list of numbers sort of separated by commas. So 1, 2, 3. These are 3 different items or elements inside this array, and they are sorted. They're in order. The order shouldn't change. And really, this is just a way of keeping things inside of a group that we want to pass around and use inside of our smart contract. Okay. So if you're a programmer already, you definitely probably understand what arrays are, but if you're brand new, I just want to explain that concept. Now, with Solidity, we declare the data type for an array like this. Again, anytime you're creating a variable like this, we're storing the array to a variable, we're calling it public, you have to declare the type. So for arrays, we do that like this. We tell it the data that's inside of the array first. So this is an array of unsigned integers. So we say uint. And then we give it the curly brackets, it's not the curly brackets, the brackets here that tell it that it is an array. So this means this is what's inside of the array, and this tells it that it's an array. So this reads like an array of unsigned integers. This is the array of unsigned integers, and then we're storing it to this variable called uint array right here. We also create arrays of different data types like strings. We could say a string array, okay, and then give it like this and say public string array. Okay, and then we can say, apple, banana, carrot. Okay, so this is another array, just has different data type inside of it. You get a string here. We can also just create new arrays that are empty. We can say string array and say public, my array. Okay. Okay, so now let's talk about how to manipulate arrays inside Solidity, because now that we've created these state variables, we could modify them inside of any function that we want to. So let's go ahead and create a function that's going to modify this variable value right here. So let's actually update this. We'll just call this value, not my array. And we're going to create a function right here called add value. So we'll say function add value, and it's going to give it one argument. We'll say string memory value. We're going to pass in a value here, and we'll call this public. Okay. And then inside of here, what we're going to do is say values. That's this right here. And we say push and then underscore value. So let's explain that. So value, of course, is passed into the function. And then values is this array right here. And then what push does is push adds a new item into the array at the last position. So basically, if you passed in the word, donkey or something like that, it would add the word donkey to the end of this array. Okay. So that's what the push function does, and it keeps the array sorted. And again, this is a local variable. It's being passed in Solidity. This is a state variable. So whenever we call this function, it's actually going to update this array on the blockchain itself and save it. And we'll have to pay gas whenever we call this function. So let's talk about another thing that we can do. We can get the length of the array. So we can work with another function here. So we could say function value. We say value count. Okay, we're just going to count the number of items inside this array. And we'll say public view returns uint. All right, and inside of here, what we're going to do, say return values.length. All right, so what that's going to do is take this and then actually get the number of items inside of it. That's what the length is. So length is just going to return 3 in this case. If we had added another one in that last function, it's going to return 4, so on and so forth. We can observe that behavior in our tools over here after we deploy it. So the last thing I want to talk about are two-dimensional arrays. So what is that? Well, a two-dimensional array is basically just an array inside of another array. So an array of arrays is another way of thinking about that. And you can do that with Solidity like this. You can say uint 256. All right, so this is going to be an array of unsigned integers inside of another array. Okay, so we'll call it public 2D. We'll say array 2D because you don't want to start Solidity variables with numbers. And then we're just going to say, an array of arrays. So the inside array is going to be 1, 2, 3, and then we'll say 4, 5, 6, and then we'll end that with a semicolon, just like this. All right, it looks like it's yelling at me here, but hopefully this should work. Let's add some space here. It's probably cleaner. Let's do that here too. All right, so we're not just all clumped up in there. But one thing I do want to do is update this. I realized that values is not defined, so we actually need to make this values plural here. So sorry about that, everybody. All right, so values push value, values length. All right, so let's go back here and we're going to compile. And then, all right, it works. So this is fine. Let's go ahead and deploy it and click deploy and see my contract. Okay, so we can see so start with value count is 0. We can add a value like this. We'll just say foobar. Okay, give it a string, click add value, and we can see this here. And now we can read the values count. Okay, it's 1, and we can actually read the values from the array. So what I'll say here is whenever you're reading from this public variable and you call values, it's not going to return the entire array itself. Okay, it's going to give you a function where you access each individual item out of the array. So that's why it's really important to understand the length of the entire array, and that's why we use values count here. So these arrays are 0-based index, which means that the first item in the array is 0, the second item is 1, etc., etc. So if I do value 0, it's not going to return anything here. Okay, what I want to do is type in values 0 to actually get that first item because there's only 1 inside of there, and boom, there you go. You can see the string is foobar. Okay, we can also see the uint array, string array. We can get the first item here. All right, apple. Second item is, number 1. Third item is number 2. All right, a 2-day array. Basically with this, what you want to do is you can use this menu here to get 2 inputs, and it's going to have 2 arguments. So the first argument is going to be the index of the first array, so 0. 0 is going to be 0, 0, this number here, so it should be 1, all right? And then 0, 1 should be this number here, 2, all right? But if I do, 1 is going to be the second array, and then the first item in that array is going to be 0. Okay, and then 1 should be the first item in that list. It should be this. Okay, awesome. So same thing for the uint array. I'll leave those up to you as an exercise. All right, so that's an overview of how arrays work inside Solidity, and I'll catch you in that next section. All right, so now let's talk about mappings inside of Solidity. So what are they? Well, they are a data type that lets you store data on the blockchain with key value pairs. So what is that? Well, key value pairs are common in many programming languages where you have things like a hash or a hash table or an associative array. And they're also really common inside of traditional databases like MySQL, Postgres, where you have an ID that corresponds to a data record, where you have a unique key that corresponds to one unique value, or maybe like MongoDB, for example. So you have a key here, first name, and anytime you look inside this key value pair, first name always corresponds to this value bugs. And then you have last name that always corresponds to this value bunny. Okay, so if you update first name, it's going to change this. And if you read first name, it's going to change, read this and nothing else. So you can create a mapping inside Solidity like this. So you can just say, mapping keyword. All right, that's going to create a new mapping. And then you give it the key value pair. So key and then value. I'm just using these names to illustrate it. We'll change these in a minute. But the key goes here, the value goes here. And we can call this, you give the name of the mapping like this. We can call it my mapping. Okay. So that's what a basic mapping would look like. And we can use this to write data to the blockchain, since this is a state variable. And we can treat the blockchain like a database in this way, where we give it a key, which is kind of like the ID, and then the value, which is, whatever information we're storing to the blockchain itself. So let's create a mapping of names to make this really simple. Okay. So this will make it less abstract. So we'll create a names mapping. All right, kind of like we just saw in this key value pair here. So let's do this. We'll say, give it a uint. That'll be the data type for the key. So it'll be like an ID, and the value will be a string. All right, so the key data type is uint, and the value data type is string. So we can assign stuff to the mapping like this. We'll create a constructor function, constructor. Again, this is the function that's run once and only once whenever the smart contract's deployed to the blockchain. And we can add items to the mapping like this. We can say names, and then use these curly brackets to either access information from the mapping or write information to it. So we can add a name here to the ID 1, or the key 1, this unsigned integer. And we can say this is equal to Adam. All right. And then we can do it again. We can say names 2 is equal to Bruce. And the names 3 is equal to Carl. All right. And that's how you add information to a mapping. All right. So now what I want to do is show you how you can use mappings to make the blockchain actually work like a database where you can store complex data. So in this case, we're just storing a mapping of unsigned integers that have a value of strings. This is pretty simple data. But we can make this much more complex and make it work like a traditional database with structs. So remember, we talked about structs in that last section. Definitely go check that out if you haven't already. We can create a new struct like this. We can call it book. So this is our own custom data structure. We just call the struct keyword here, and we give it the name book. And we give it a string title, okay, and then a string author. Okay, so it's going to have two attributes here, a title and an author. And we can create a theoretical database of books on the blockchain with a mapping. So this will be like our database, table, essentially, where we have these different columns, like a column for title and a column for author. And then we kind of have an imaginary column for, the ID with this mapping. So we'll create the mapping like this. Mapping, we'll say uint. And then we give the data type. We can give it our custom defined struct data type here of book. All right. And then we can say public books. And will this be the books mapping? So let's see how we can add a book to the mapping like this. So we'll go down here and we'll create a function that says function add book. And then we'll give it some arguments here. Say uint 256, or you can say uint for short, underscore ID. All right. A string memory title, and then string memory author. And we can call this public because we want to call outside the function. And then we want to add the book inside of here. So how do we do that? Well, again, we say the name of the mapping here, then we give it the curly braces, and we give it the, the key that we want to assign it to. So we say books, which is the name of the mapping. Okay. And then we give it the curly braces, and we add ID, which is this ID here, underscore. And then we say equals book, okay, like this, book. and then title, and then author. Okay. So I want to call out something here. These arguments here are local variables. We talked about the difference between local variables and state variables. Again, local variables are only accessible inside this function. They're not accessible anywhere else inside this contract. And I'm using a convention of underscores in front of the local variables just as a convention. These are not required inside Solidity, but it helps differentiate between local variables and state variables. And it's a common thing that Solidity developers do. So I'm also going to format this function. I'll show you a cool way to do that. We can break the lines up here. So after each argument, we can go to a new line so that we can save some horizontal space. And then we can have our add book function just like this. All right. So we're going to read this out in a minute whenever we compile the contract and deploy it. But now I want to show you one more cool thing with mappings before we do that, which is you can create nested mappings. So just like we saw in the last video where we had, an array of arrays, that's a 2D array or a nested array. Similarly, we can have a mapping of mappings. All right. So why would you want to do this? Well, this is really common for things like tokens and NFTs. You see this pattern all the time where you want to see a balance that's nested under a particular, user account. In a very similar way, we can, create a mapping of books that correspond to a particular Ethereum address. So we can create that nested mapping like this. Okay. So basically we'll just take the book mapping. Okay. Book. And we'll put it inside of another mapping. So the key, so we'll say mapping. The key is an address. And then the value is just another mapping. All right. And we'll call this public my books. So think about it's kind of like a library where, you have all the books in the database here. But then you want to see my particular books. The key is going to be the address of the person who owns the book. And then the mapping is going to be, the value is going to be another mapping of all the books that belong to this particular account. All right. So let's talk about how to add this to the mapping. So instead of add book, we'll just copy this and then paste it here. We'll say add my book. Okay. So it's got the same arguments. The ID, title, author, but instead of, books ID, we'll say my books, and then we'll pass it another key for this one, and we'll say message.sender. So what is this message sender? Well, Solidity has something called a global variable called message. Again, we talked about state variables and then local variables. We also have global variables, which are just exposed by Solidity in every single smart contract available on the blockchain. So message.sender, so message has a value or a key called sender. So you can do message.sender, and that's going to be the person who's calling the smart contract. So it's going to be the Ethereum address of the person who calls add my book. So that will be their address. That can be the key, which we add here. And then we create a second key for the nested mapping for the ID of the book, and then title and author for the book struct. Now we can compile this and see all this in action. Okay, I'm just going to reduce the font size here so we can kind of see it. And we'll go to our compilation tab here. And we'll compile, see if there's any warnings. So it looks like there's a warning here. So this constructor, visibility for constructor is ignored. Let's just take this off. Okay. And then we'll go to deploy. And then we'll click deploy. And there we go. So now we can interact with the smart contract like this. We can basically create, well, first of all, let's look at the names. All right. So actually, let's make it public first. So let's run through the steps again. Public. Let's read values from the mapping. So we'll go back and recompile. And then we'll go to deploy. Let's delete this. Click deploy. And now we can read items from the names mapping. All right, so here's names. So now we can basically see that to read items out of the mapping, we just give it the key inside this function right here. So I'll pull this up in case it's cutting off on the screen. And we'll give it an ID like this. So we'll just say 1. So names 1. Right, this should return Adam. And there you go. Boom, string Adam. And 2, names Bruce. Awesome. So we can do the same thing for books and my book, but we don't have any books yet. So let's add a book. Let's give an ID of 1 and then say title is, the Great Gatsby. And we can say author is Fitzgerald. Okay, then click transact. Of course, you have to pay gas to do that. You'll see your Ether balance go down. And we can read my books, books, ID 1. And then boom, The Great Gatsby, Fitzgerald. Books ID 2. And we can say, let's see, A Tale of Two Cities. And we say Dickens. Click transact. And then books 2. And then boom, there you go. Actually, that didn't work. Let's do books 2. I forgot to do the ID, so we overwrote that. Tale of Two Cities, Dickens. Awesome. And I think we actually overwrote it, so it's going to be the same for book 1. Yeah. Oops. Oh, well. All right. So next, let's talk about adding my book. So here you can see that we can do ID 1. Let's see, title. Let's just say, let's come up with another book. Say Lord of the Rings. Or let's do The Hobbit. And we can say Tolkien. All right, click transact. And then we can go to My Books. So how do we read that? Well, essentially we need the address. So we can copy the address from Remix here. Click copy. And then we can paste in the ID like this. And then boom, there you go. The Hobbit by Tolkien. And so, again, we were acting as this account. So message.sender is going to be read from the transaction. All right. And the transaction, the person who created the transaction is this account here. So it's automatically going to get the address from here. We don't have to pass it into the function. Okay, so that's an overview of the basics for Solidity mappings. Okay, so now let's talk about conditionals and loops. So these are two things you need to understand inside of Solidity. So we'll start off with conditionals. So what are those? Well, a conditionals was called a control flow structure. Okay, so basically that means it's just a logic gate inside of programming that says, hey, if this, then that. All right, so basically you have an if statement. So if, some condition, okay, then do some action, and else do some other action. And you don't even have to have the else clause, but basically this is the idea. If this is true, then do this. If else, do something else. Okay. So an example would be, if you had a number here, 1. So if, I'm just gonna do some pseudocode here. If 1, is even, this is literally just pseudocode. This is not real Solidity code. You can say, then console.log, number is even. Okay. Again, this is not real Solidity code, just an example to show you. Else, console.log, and Solidity doesn't even have console.log out of the box, just so you know. Number is odd. Okay. So this is an example. So we'll kind of code this out with real Solidity code. So what we're going to do is basically take an array, all right, of numbers and see if they are even or odd, just like we saw in that pseudocode example. So we'll take it, we'll start with an array. We covered these already in the previous section, so go check that out if you haven't already. Say uint an array of unsigned integers. We'll say public numbers equals, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, use a semicolon here. And what we're going to do is create a function that, evaluates a number and sees if that number is even or odd. So we'll say function is even number. I'm going to pass in a number, uint number, and we'll say public view returns Boolean, bool. So that's just a true or false value. That's what a Boolean is, just true or false. And then inside of here, we're going to create a conditional. So we'll say if number that we're passing in here, modulo 2 is equal to 0, then return true, else return false. Okay. So let's break that down. So first of all, we have this conditional. That's what it looks like. So if, and then you put in your condition inside of here. That's the condition for the conditional. If this condition is met, if it returns true, then do whatever's inside of this line of code. All right. So in this case, we're just going to return true from this function. That's the return value of bool. else, do whatever's inside of this part of the code, which is, return false. Okay. So, let's talk about the condition itself. So, how do we check if a number is even? Well, we use this thing called the modulo operator, which basically takes a number and divides it, and it gets the remainder. So the remainder is like this. So, 5, modulo, 2 is going to equal 1, because if you divide 5 by 2, it's going to be 2 remainder 1, right? If you do, 10 modulo 2, it's going to be 0 because 10 is divisible by 2, but 5 is not divisible by 2. You divide by 2 and you get a remainder of 1, okay? So, the number in this case, if it's 5 modulo 2 is going to equal 1, so it's going to be false. If you pass in 10 here, it's going to be modulo remainder is equal to 0, so it's going to return true. Because any even number, all right, is essentially going to be divisible by 2, and that's how you check. All right, so that's how we do a conditional. You can see it here. That covers the conditional side of things. Now let's talk about loops. So we're not actually going to use this array for the isEven number function. We'll just pass in our arbitrary number when we demonstrate this here in a second. But what we can do now is create a function that uses a loop. So what is a loop? Well, a loop is something that takes over an iterative data structure like an array, which has multiple items in it. You can iterate over this array, you can loop through it, and then perform an action on each item in the array. So there's 10 items here, numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can create a loop that checks each of these items, inside the array to see if it's even. So we did a function here that uses conditional to see if it's even. And we can use a conditional inside of a loop with a function like this. We can say function count even numbers. Okay. And we say public view returns uint. So it's going to return the count. It's going to tell me how many even numbers are inside of here. In this case, it's going to be, 5, 1, 2, 3, 4, 5. And I realized we skipped 5. Sorry, everybody. A little tired. 2, 1, 2, 3, 4, 5. Okay, you probably saw that. I'm sure you've been wondering when I was going to add 5 there. Here we are. So I'll show you how we do the loop. So first of all, we're going to create a variable called count. Say uint count equals 0. And then now we're going to create the loop like this. So we're going to use something called a for loop. So a for loop, what it does is it uses an iterator to iterate over each item inside of a collection like this. So we say for, all right, and then this is what we do inside the loop, but we pass the condition for the for loop here. We say uint equal I. Okay, we declare a variable I equals 0. And then we say I is less than numbers.length. Okay, and then I plus plus. All right, so what does this do? Well, basically, we start off with something, we start off in the loop with a counter variable. So that's what this I is. This is really common in other programming languages where you start with a number of 0, and you say, starting from the number 0, all the way up to the number's length, all right, which in this case is going to be up to 10, check, run the loop every single time until you get to this condition is satisfied. So you start with 0, and then the first time it runs, I is going to be 0. And then whenever we finish the loop, we're going to increment this value. That's what this is. So basically, here's what we start off with. Here's the condition at which it stops running. Okay. And then here is the value that we increase this number. So basically, what we're going to do is, we're going to, first of all, we're going to say count. We're going to loop through them like this. We'll say if is even number. And then we're going to use this function that we created here. And we'll say numbers I. So we're going to read the number out of this array like this. We're going to pass in this function we just created to check if it's even. Okay. So if it's an even number, then we will just increment the count plus plus. So we're starting off the count here as 0. So to count the even numbers, we start off with 0. We loop through each number in the array. And if it's even, then we increment the count, this count right here with this line. And then whenever it's done, we're going to return count. All right. And so let's go ahead and just test this out to see if this is working so far. There's one more condition I want to add, but basically what I also want to illustrate is you can do conditionals that have, if else statements here, like if and else, but this conditional right here has no else statement, right? It's just an if, because we don't want to do anything else, right? We just want to skip and continue on if there's no, we don't care about an else statement. So here, let's compile, just to make sure it compiles okay. All right, so let's see here. We can just ignore this for now. We'll fix it in a second. And then we'll go to deploy. Now let's just make sure it works okay. And so we'll do the count even numbers, and it returns 5. So that's what we expect. There's 5, 1, 2, 3, 4, 5. So this is working. And then let's see, is number even? All right, we can see if number's even. 1, so false. Number 2 is true. 100 is also true. And 99 should be false. All right, so that's working. We can also read the numbers from the from the array like this. Okay, awesome. All right, so the last thing I want to show you is how to use a quick one-liner to check something is true or false rather than having to do this if-else statement all the time. It's like a one-liner, okay? So what we're going to do is basically create an owner for the smart contract. So what's that mean? So we'll say constructor. Again, this is the function that's going to get called where the smart contract's put on the blockchain. We talked about message sender, all right, in the last section about how this is the person who's calling the function. In this case, this is going to be the contract that deploys the account that deploys the contract to the network. And we can assign it to a variable called owner. Okay. And then we can make this a state variable for the entire contract like this. We can just say address public owner. So this is really common to have ownable smart contracts where somebody has special privileges inside the smart contract. So ownable contracts is definitely a pattern that's important to understand when coding Solidity smart contracts. So here's the owner, the person who deployed it. And what we're going to do is create a function here that checks if the current address is the owner. So we say function is owner, and this is really common in smart contracts. Say public view returns, and then bool. And then we'll say return message to sender, the person who's calling this function, not the constructor. We'll say is it equal. So we use double equal sign. I'm thinking JavaScript here. Again, sometimes when you code multiple programming languages, you get things a little mixed up the first time. But again, double equals checks for equality, just like we have here. It doesn't assign anything. We're not assigning message sender to anything. We're just checking to see if two values are equal. And we say owner. So this is a quick one-liner to check to see if something is true or false. We just return message sender is equal to the owner, and that will return true. If the caller of this function is the owner of the contract, it'll return false if not. So now let's check that. Let's go to let's deploy again. Well, let's make sure it compiles properly. I can't remember how Remix does this, but sometimes I just do it over again just to make sure. And then now we can say is owner true, and we can change to a different account here and say is owner, and it's false. Okay, so that's a quick overview of conditionals and loops. Okay, so up until this point, we have covered different aspects of Solidity programming language, like, variables, data structures, different types of functions. And in this video, what we're going to do is move away from individual features of the programming language and put a lot of things together by coding out a complete smart contract that actually does something. Okay, so it's a little bit different approach. And so along the way, we're going to create a new contract here called Hotel Room, and it's going to teach us about the following concepts: how to pay with cryptocurrency inside of smart contracts, how to actually send Ether around or whatever the native cryptocurrency is of your blockchain, how to use function modifiers, okay, how to set the visibility of a function, how to work with Solidity events, and also enums. So don't worry if you don't understand exactly what all these things mean before we get started. You're going to see those along the way and learn how to apply them to your own smart contracts. So what are we going to create here? We're going to create a new smart contract called Hotel Room. All right, so go ahead and create that over here in your file browser if you haven't already. Capital H, capital R, hotelroom.sol. And, you can start off with the same, programming language version that we did in the previous sections. Just create a new contract called Hotel Room. And so what's it going to do? Well, essentially, it's going to be responsible for booking a hotel room and opening it. So someone, when they want to book the hotel room, they'll pay for it with cryptocurrency. They'll do it with Ether. I'll show you how to send Ether to the smart contract. And then whenever you do that, it's going to handle the booking. It'll work kind of like a vending machine in this way. That's kind of like what smart contracts are. Once you put them on the blockchain, they just do something whenever you interact with them, like send money. All right, so now let's code out the first bit of functionality for this particular smart contract. We want to create a new function here. We're going to call it book. Okay. And it's going to be like book the hotel room, not like a book like you read the book. And what we're going to do here is pay the person who created this smart contract, who's going to be the hotel room owner, and then actually book the hotel room so that it's open and they can, use it. So what we want to do is model the owner of the hotel room or this smart contract. So we can do that with a state variable here. All right, we can say address, payable, and say public owner. All right, so this is a state variable. It's going to be the Ethereum address of the person who created this smart contract, who owns the hotel room. And we want it to be public, so we can read this value outside of the smart contract on the blockchain. And then we also want it to be payable. All right, this is a specific modifier. That's what we said earlier. We're talking about modifiers. A modifier that lets this address actually receive Ethereum cryptocurrency, which we'll see in a minute. So we're going to save this owner. All right, we could just assign it here. We could say equals and then 0x blah 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 blah, and we could hard code in an address, but that's not really what we want to do. We want it to be dynamic, so we want it to be the address that actually puts this smart contract in the blockchain, no matter who it is. So we'll use the constructor function for that. So say constructor. All right, and inside of here, what we're going to do is say owner equals message msg.sender. So again, message is a global variable inside Solidity, and sender is a property on that message that tells us, who is calling this function, who is deploying this contract to the blockchain, because that's what the constructor function is. It's a special function that gets run once and only once whenever we put this contract on the network when the contract's created. So then we save owner is the state variable here. So now let's actually do something inside of the booking function. Okay. So the first thing we want to do is pay the owner. So we want to pay the owner of the hotel room in order to, actually open it. So we do that like this. We'll have, inside of our book function, we'll say owner transfer, and then we'll pass in message.value, and then use a semicolon here. So let's talk about the transfer function. What does it do? Well, it sends cryptocurrency to the recipient. In this case, it's the owner. All right. And so where does the cryptocurrency come from? Well, it comes from the person who's calling the book function. So as we'll see here in a minute, whenever we go here and compile the contract and run it, you can send cryptocurrency whenever you call a function. So if you had your MetaMask wallet out or something, or you're interacting with this website, you could call this book function and it'll say, do you want to call the book function? And you tell it yes. But it'll also say, hey, you need to send in some cryptocurrency, some Ether in this case, whenever you call the book function. Okay. And inside the transaction and inside the Solidity smart contract, that amount of cryptocurrency that you're sending in is going to be stored with another global variable, message value. So we have message sender, who is the person who's calling the smart contract. And then we have message value, which is the amount of Ether or cryptocurrency sent in whenever you call this function. Okay. So what we're saying is message value, the amount of Ether that's sent in, send it or transfer it to the owner, which is this address here, which we've made payable. Now, one other thing we need to do this function in order to make this work, where we can actually work with message value, is also make this function payable. All right, because we had the address, the owner is payable, and then now we have the address. Now we also need to have the book function payable, so we can actually send Ethereum cryptocurrency under Ether and then use it inside the function here. All right, so now that we have paid the owner, we want to update the status of the hotel room from vacant to occupied. Okay, so I'll put some comments here. All right, and that's basically going to let us know whether somebody's in the hotel room or not, or whether somebody has booked it. So we're going to use something called an enum to track this. So what is that? Well, let me just write it out and then I'll explain how it works. We'll say enum statuses, and then we'll use these curly braces like this. We'll say vacant or occupied. All right. So an enum is really is a data structure inside of Solidity, and we can give it a name. So what is it? Well, basically an enum is just a collection of options that's never going to change. So we have these options that we've coded out inside of here. So vacant and occupied. You can think about, it's perfect for keeping track of statuses or states. A hotel room occupancy is a perfect example of this. Is a hotel room empty, or is it, somebody in there, vacant and occupied? And that's a status of a hotel room. It's the state. So an enum is the perfect data structure for this. So we can say enum and give it a name, statuses. And then we can also create a variable that keeps track of the current status. So we'll basically just say statuses and then current status. Okay, so basically current status is going to use the statuses enum to find out what the current status is. And we can set the default status. We can set current status. Whenever we deploy the contract like this, we can say current status equals statuses vacant. All right. So this is how you read the value from enum. You just say status is vacant, which is this, and then current status equals status is vacant. These are the options, and then this is the current status. So this is really the thing we're checking against and setting. But these are all the options that we have to choose from, so that you can't use like some other option, and it'll always correspond to the return value of the, vacant here. Okay. And now the next thing we do when we call the book function is we want to occupy the hotel room. So we can say current status equals statuses occupied. Okay. So that will handle the booking. So now I know that whenever you book a hotel room, it doesn't automatically occupy. Okay, so I know that's a little bit confusing, naming here, but we'll address that here in a minute. All right, so now what we want to do is add more features to this book function, or add more logic, I should say, to this book function. Because right now, there's some problems. Like this hotel room could potentially be booked twice, okay? We don't know how much it costs. We need to require some sort of price. So let's do that right now. So inside of here, what we want to do is check price, because we want to, assign a price to the hotel room so we can book it. And then we also want to, check the status. Essentially, we want to make sure that you can't book it twice if it's already occupied. So how are we going to do that? Well, let's do the status first. So essentially, Solidity gives us a special function called require. All right. That is, just provided by Solidity for free. We don't define the function require. It just comes for free with the programming language. And it has a special functionality. So anytime you put require function inside of another function like book, it just checks a statement to see whether it's true or whether it's false. Okay. So I can put some stuff inside of here like 1 + 1 = 2. All right, this is an expression, and it evaluates to true. And basically, it just says require that this is true. And if this satisfies, if it's true, it passes, then it continues execution on these other lines. Now, if I said 2 + 2 = 3, all right, that's going to equal false. And this is going to say, hey, that's false. So stop function execution and don't run these other lines of code. Okay, so if it's true, then the other lines of code run. If it's false, then the other lines of code don't run. So let's check that. We can check the status to see whether it's true or false and satisfies those conditions so that we can run this code or not. So basically what we want to do is if the hotel room is already occupied, we don't want to update the status to occupied, and we don't want to send money to the owner. So we can do that like this. We can say current status, and then we say equals statuses dot occupied. Or sorry, statuses dot vacant. Say statuses dot vacant. All right. And so basically, it's going to require that the current status is that the hotel room is empty before we run these other lines in the function. And if this is true, then these will execute. And if status is not vacant, then it'll just stop entirely. So we can give it one more argument here that gives it a message. So I can say currently occupied. All right. And so basically, you can see this is what will surface to the user if we don't have, like, basically this will surface to the user if, this fails. All right, so now we can check the price like this. We can say require, and we can say message that value is greater than or equal to 2 Ether. And then we can say not enough Ether provided. Okay, so what is this? So we're going to check the price. So we're going to say that the hotel room costs 2 Ether. You can literally just write that out in Solidity like this. Just give the number 2 an Ether, and it'll automatically convert it to the amount of cryptocurrency that you want to check. And message value, again, is the amount of cryptocurrency sent in with the transaction, which we saw right here. And we want to say, hey, make sure that's greater than or equal to 2 Ether, and that's the price. So if they have at least sent in the amount of the price, then we want to continue function execution, and if not, then we just want to halt execution and refund the Ether to the user that was sent in and stop calling the function, and then just tell them not enough Ether provided. All right, so now I want to show you how you can take these statements right here and create modifiers. So that's the next thing we're going to learn about. So let me just show you what that is and why it's important before we explain exactly what modifiers are. I think just demonstrating it will explain it itself. So just below this constructor function, we're going to create this thing called a modifier. We'll say modifier, and we'll say only while vacant. Okay, and inside of here, what we're going to do is copy this line of code. Okay, and then just do it like this, or cut it, I should say, and then put it inside of here. Take this out. All right, and then we're going to do an additional line here, do an underscore. This is going to return the function code. Okay, so what this is going to do is basically let us take this require statement out and then just add it to the function like this and say payable only while vacant. Okay, so it's a really nice way to, clean out the function code and then put it here. Okay, so you don't have too much stuff inside of your code. It doesn't busy things up, and you can also reuse this later on in the Solidity code, right? So similarly, we can do this with the price checking. We can say modifier costs, okay, and then pass in uint amount, all right? And then inside of here, we can just say require and then say message value. Well, let's just copy this, right? We don't need to write it again. Take this out, put it here. Okay. And then I'll show you a cool thing about this. So we can, of course, add, costs here. But what we want to do is actually pass in the amount. So we can just say costs, 2 Ether. All right. And then pass in the amount here. All right, so only while vacant costs 2 Ether, we can pass in an arbitrary amount. So message value is greater than or equal to the amount, not enough Ether provided. And then that will check to see if we put in enough right there. Then now I want to add a new line here and do this. Okay. So the last thing I want to do here, and then we're going to clean up some things inside this video. I want to emit an event anytime a booking happens. So what is that? Well, basically Solidity lets you emit events on a blockchain anytime a particular function is called or anytime that you want to do something inside the blockchain. And what it's going to do is create a log that this event occurred, and you could get an alert about it. So like if somebody booked the hotel room, they could get maybe like an alert on their phone, or, get some, message somewhere else. Okay. Or you could get a history of all the events which took place. Like anytime this hotel room was booked, you could see an entire list of those bookings. So that's the two benefits of events. So I'll show you how that works. We'll create a new event inside Solidity like this. So just above this, we'll say event occupy, and we'll say address occupant, and then uint, we'll say value. All right. And so basically what it's going to do is tell the address of the person who booked the hotel room and then the value that they paid. All right. And so we can call the event. So we just defined the event here, but we need to actually call it inside the function. So we'll do that here and say emit occupy message.sender and then message.value. So this will tell us, we can get an alert anytime someone booked the hotel room like this, and we can also see an entire log of the bookings when they take place. Okay, so there are a few things that I want to do to make this code better. All right, so the first thing is go to the top here. Let's just refactor, make this look a little cleaner. I can put these statuses on multiple lines so that we can kind of see the statuses here. All right, and then kind of refactor this. Okay, now one more thing that I want to do is change this line right here. So there can be some issues with the transfer function inside of Solidity. And what I want to do is show you how to use call. So call is another function that we can use to send Ether around like this. All right, we can just send a message, but we can also, you can send an arbitrary message to a certain recipient, but we can also send cryptocurrency this way. So what I want to do is say owner instead of transfer. I'm going to send it a message like this and say call. Okay. And then what call is going to do is we can pass in a value. Value is message.value. All right. And then, we could send in something else, but we're just going to leave it an empty string for now. Sorry. All right. And then we can say, we can get the status of that transaction. We can just say bool sent. So this is going to turn true or false of whether it was sent or not. All right. And then bytes, memory, any data that came back. Okay. And so we won't need the data necessarily, but what we're going to do is just make sure that that it actually is sent. And so we can say require true, that we actually we sent the funds to the user and that transaction was successful before we emit this occupy event. And if that doesn't happen, then we can basically stop execution of this transaction. That keeps you from just sending it to the wrong place or having some issue with the funds being delivered. That's a benefit of using call here over transfer. You can get the status of that and then require that it's true. All right. So that should be everything. All right, let's just kind of take a look here. I think that's it. Let's go try to compile this smart contract and demonstrate everything. So let's go to the compile step. All right, we do have a little bit of issue here. Let's fix this. So we don't need this semicolon here on line 8. That's my fault. It happens sometimes. So we'll just click compile. All right, let's just fix this as well. So basically we forgot to put, let's see here, public here. So public. All right, let's keep going here. And then one more thing is we need to make this payable as well. So this is another feature of Solidity. We want to make sure that this says payable. And then we convert this to payable before we save it as an address payable here. So that's another thing you have to do whenever we're doing that. And then one more thing here is I want to take statuses for current status and make it public because I want to check what the status currently is whenever we compile and deploy the smart contract. So I'm going to minimize some of the font here so we can kind of see the contract while we're, using it. So let's go to our compile tab here and then click compile. And you're going to see, as unused local variable from this. All right, that's what's telling you you're not using this. I wouldn't worry about it just for now. Let's just go here and go ahead and deploy. And let's use the smart contract. So let's check the status. So current status is 0. So that's another thing I want to tell you by enums is basically it tells you the position of each, option in the enum. So when you see status 0, that means it's this status. It's vacant. That corresponds to 0. And we're going to change it to occupied. It'll change the status to 1. So this is 0 and this is 1. And that's why we use status as vacant and then status as occupied. So we're not just saying like 0 or 1 throughout the code. It reads more like English. And then when you're reading information from the blockchain, it's going to give you zeros or ones or, numbers that correspond to however many statuses you have inside of here. So we can see the owner is, the owner is our smart contract. So let's change our address to the second address here. I guess I was already on the second address. Let's do a new address and let's try to book it. So let's try to book it and then, send in too little. So you can see the transactions reverted here. All right, that's because we didn't actually send in any cryptocurrency. So let me show you how to send in crypto. So right here, we have this thing called value. All right. You can see this amount is way. We can change this to Ether. All right. We can send in Ether with our transaction. So remember, we're calling this book function, but we want to send in cryptocurrency simultaneously. So we can put in, 2 Ether here to actually book it. So we can click book and then green check mark. It worked. You see the current status is now 1. So it's occupied. All right. So it worked. Awesome. The hotel room is booked. It's occupied. Now let's redeploy the contract so we can, make sure that our other conditions work. We want to make sure that, that if we send in too little Ether, it does not book the hotel room. So we'll just kill this. Oh, actually, that's fine. Let's click deploy again. And then now we have a new owner because we didn't change our account. That's okay. Let's see, current status is 0. Let's try to book and then send in, 1 Ether instead of 2. Click book. And we see that the transaction's reverted because we did not send in enough Ether to satisfy this. We only sent in 1 Ether. So now let's send in, 2 Ether and click book again. And we keep clicking book. You can't book it twice. So it worked the first time, which is good, but you can't actually do it twice. Now I realize that I didn't change addresses here. I'm just sending it to myself. But, if you really want to get ambitious, you can go through the whole process of redeploying, calling book. Well, actually, that's not what I meant to do. Let's go back to first account, redeploy. All right, and then, change accounts here, and then book, send in some 2 Ether. And it still works. Awesome. All right, so that's our hotel room smart contract. We demonstrated so many different concepts in this video, like modifiers, enums, how to send cryptocurrency. Congratulations, you've come a really long way. Let's jump into the next section. All right, so let's talk about some critical concepts that you need to understand in this lesson. So up until this point, we've basically just created a single smart contract that doesn't really talk to any other smart contracts. It has no relationship with them. It really just understands all the code inside of its own smart contract. So we're going to create some other smart contracts in this lesson, and we're going to have contracts interact with one another. One is through inheritance. We'll see what that means if you don't understand just yet. Basically, that's where you get one contract and you inherit properties from a parent contract. We're talking about factories, which is where you deploy other smart contracts within a smart contract, and then also how to talk to other smart contracts inside of smart contract functions to call other contracts on chain. So let's go ahead and jump in and get started. All right, so let's move this out of here, and then we'll just take it out. And so what we're going to do is create a contract that stores a state variable called a secret. So we'll say string secret. All right, what we're going to do is basically store this on chain and only allow a certain person to read the secret. So we'll set the secret like this. We'll say constructor, and we'll say string memory secret. All right, we'll pass it in whenever we deploy the contract, public. And inside of here, we'll say secret equals secret. Again, so this is the state variable secret that's stored in the blockchain, and this is the local variable that's passed in as an argument when the function is called. And we use an underscore here as just a convention so that we avoid naming conflicts. And so what we're going to do is also store an owner here. All right. So we could say address owner. Again, we talked about owners in the previous section. So owner equals message sender. All right, this is the person who deployed the contract to the blockchain, and we save that here. Okay. And so what we're going to do is basically say function get secret. All right. And we say it's public view. And then it returns string memory. And what we'll do is return the secret. All right. So now what we're doing is saving the secret on chain and having a function to get the secret. And we don't want anybody else to know what the secret is unless they're the owner of the contract. So, previously in the last video, we talked about modifiers. So we could say modifier, only owner. All right. And then we could say basically require message sender equals owner, and then say must be owner. Let's actually make those double quotes, sorry. All right. So basically, this is a really common pattern inside Solidity where you have an owner and then you require that they are the only person who can call a function. So we can take this modifier and add it to the function here, public view only owner. All right, so now only the owner can get the secret from the contract. And so if you're any other account and try to call this function, it's going to basically give you an error. So that's our basic contract. Now I want to show you how to use inheritance in Solidity. So what is that? Well, basically inheritance is a way where you can put, behavior and logic and data inside of a different smart contract, and then you can basically link your contract to that other contract to absorb all that data, behavior, et cetera, functions, whatever you want to. I'm trying to define inheritance without using the word inheritance. Basically, you can have a parent smart contract and a child smart contract, and anything that you have in the parent contract, when you inherit to this child smart contract, you can basically get all that for free. So I'll show you what that looks like. We'll just say contract ownable. All right, and this is really popular in Solidity, where basically you can have an address, you can have an ownable contract, and you put all the ownership behavior in this contract, like this. So you take the state variable of the owner, you put it here, and then you take the modifier of only owner and you put it here. And then basically to get all that for free, you just say is ownable. Right, that's how you inherit. You just have the contract in view in the same file, and then you say my contract is ownable. Okay, that's how you do inheritance. All right. So one more thing here, we need to do underscore. All right, now one more thing I want to show you is how to deal with constructors when you have multiple smart contracts that you're inheriting from with another constructor. So what we can do is copy this constructor and then, put it here inside of this contract. Okay. And of course, we don't want to have any arguments because we don't want to do the secret inside this constructor function. We just want to assign the owner as the sender. Okay. And then inside of here, we do not want to set the owner because we've already done that up here. But now we have two constructors. So how do you call this constructor inside of here? Well, one way to do it is like this. You can just call super. And so what that does is calls the constructor from the parent contract at a specific spot, which is right here. Okay, now you can put super here, or you could put it here. It doesn't matter. Sometimes the order does matter, and that's why you want to specify where you're calling it. But for now, we'll just do it like that. All right, so now we've talked about inheritance. And the last thing I want to cover is how to talk to other smart contracts inside of a smart contract, and also how to essentially deploy new smart contracts from inside of a single smart contract. So we're going to do that all in the same go. All right, so I'm going to minimize this so you can see a little bit better. What I'm going to do is create this new contract here called contract, let's see here, secret vault. Okay. And then inside of here, what we're going to do is basically move this logic for storing the secret inside this vault. Right? It's like a safe where we keep the secret. And then my contract is going to, what it's going to do is going to create the secret vault inside the constructor. And then we're going to actually fetch the secret from the secret vault inside this function. Okay, so basically this is where all the secret logic will go, and this will be the contract that, interfaces with the secret vault. So we're going to move this constructor, okay, up here, and we'll say constructor string memory secret is public, and then we'll just store the secret. We don't need to call super because we're not inheriting with this smart contract. And then we will do get secret like this. Okay. And so we're not going to make it ownable because we don't have an owner here. All right. And now I'm going to show you how to create the secret vault whenever my contract is deployed. So this is what's called a factory. So a factory is a smart contract that creates other smart contracts. And really a factory creates like a multiple, like on demand. Uniswap is a really popular decentralized application that uses factories to deploy new liquidity pools. It's like anytime you want to create a new trading pair, you put new smart contracts on the blockchain. So we're just going to do one in this case. So it's not a true factory, but you'll get the idea of how it works. So I'll show you how to do that. We're going to deploy the secret vault here. Okay. So basically we're going to call secret vault. We're going to take it like this, take out this secret, and we'll say secret vault underscore secret vault equals new secret vault. And then we're going to pass in the secret. All right, so what is that? Well, how you create a new smart contract inside of a smart contract is you take the name of the smart contract, which is this secret vault, the same capitalization. You give it these parentheses, okay, which means, you know, you're calling the constructor essentially, and you're passing in any arguments, which is the secret in this case, because the constructor takes a secret. And you also call new here. So you're saying create a new smart contract that's, you know, got this code secret vault. It knows about the code here. And then give it the argument that it requires, which is this secret. And then basically you assign that to a variable here called secret vault, a local variable. And because Solidity is statically typed, we tell it the type, which is just this contract called secret vault. So it'd be just like if you said, you know, uint my number, 1, 2, 3, 4, 5. You're just saying create a new, create a new variable of the secret vault, and then create the new secret vault here. Okay. And so now what we want to do is save the secret vault's address for reuse. So we'll create a state variable here, say address, secret vault. Okay, and we can save that. And then we say secret vault equals address secret vault. Okay, then we can call super here. So now we're creating a new secret vault. We're creating a new contract whenever this contract is deployed, and we're saving the address here so that we can reference it. Now let's actually get the secret from the secret vault. So inside of here, instead of returning the secret, because we don't have it anymore here, I'll show you how to call the other smart contract from inside of here. So we'll just say return secret vault. And then basically what that's going to do is reference the deployed smart contract, here. But we have to give it the address because it doesn't know where it is on chain. So we can just give it the secret vault address, just pass that in. And then we can call the function like this, say get secret. All right, so secret vault, and then pass in the secret vault address, and then get secret, and then that's going to return that to the function. And so that's how you call another smart contract from within inside of a smart contract. You give it the name of the smart contract, you give it the address, and then you call the function directly on it like that. Now, you could store this to a variable if you wanted to and do it multiple lines, but this is a nice one-liner that makes it nice and easy. All right, so let's go ahead and try to compile this and run it. So a couple quick things. We don't need these visibilities on the constructor anymore. It's just sometimes that Solidity changes between different versions. Used to be required, it's not anymore. So let's just take it off. Okay. All right. So then we're going to compile. And then no warnings. And let's go ahead and deploy. All right, so we'll start with the first account. We'll put in a secret. We'll say my secret. Okay, click deploy. And then we can say get secret. All right, so it'll actually return it. Now, if we change accounts here, let's see what happens. Okay, so it's not really working. So let's just demonstrate it so that it makes more sense. Let's say my secret. Okay. You can see it in the transaction log here, but let's just show you, like when I change here, say get secret. Yeah, it's been reverted, but now you don't even see it come back and remix because you have to be the owner to get the secret. Okay. But if you are the owner, you can do get secret and it works. Awesome. So it's actually going through the entire thing, that it works because it's deploying the secret vault to the blockchain. It's ownable. And so we verified all the behavior in this lesson. All right, so that is an overview of how to work with inheritance and factories, and how to call other smart contracts from within smart contracts. So we are going to create a blockchain-based real estate website inspired by Zillow, okay? So we're going to call it Millo. And basically, this is going to let you, list properties online with the blockchain and let people buy them directly with their blockchain wallet. So you can see we have a luxury penthouse in NYC here. We'll click buy. Okay. We also have an entire process to go through a real estate transaction, like escrow, like lending, like inspection, all that type of stuff, where we streamline this entire thing with blockchain with non-fungible tokens or NFTs. And so let's take a look at a diagram of how this full stack application is going to work. Okay, so basically a user is going to connect with their wallet like MetaMask. Okay, you can see that on my screen here. And essentially they will talk to this website. All right, we're going to code this website out in, JavaScript with React.js. Okay. And then this website is going to talk directly to the NFT smart contract that we have created for this application. Okay. So this is our full stack React app, and it's going to talk to this. Okay, so this is the blockchain side of things, and each property is going to be represented by an individual NFT. And when we click the buy button here, it's actually going to put the property in escrow so that it has to be approved, by other parties and funded before it can actually finalize the transaction. And the ownership of the property will change based on the NFT. To the seller. And so let's dive in specifically to how the blockchain side of things works, okay? So we are fundamentally going to create an NFT to manage our properties, okay? It's going to be an NFT collection that manages all of the different properties, all right? So we're going to create that non-fungible token with Solidity, the primary programming language for Ethereum and other EVM-compatible blockchains, okay? We're going to develop that with the Hardhat development framework, okay? We're going to write tests for it. We're going to deploy it to the blockchain. And we're going to use the ERC 721 standard, which is the standard for non-fungible tokens or NFTs. Okay, so we'll create a fully ERC 721 compatible NFT in this video. But now let me also talk about the pictures for the NFTs. Okay, so whenever you look at the NFTs on here, you see like the image of the property, and you see these other things like the purchase price, the type of residence, bedrooms, bathrooms, all this extra information about it. So this is what's called metadata for the NFT. So all these, attributes are metadata. And then also this picture right here is a form of metadata. And so we don't want to put this information on the blockchain itself, okay? So we're going to use something called IPFS, and that's pretty standard for NFTs. That's called the Interplanetary File System, okay? So basically, IPFS kind of works. This is not the actual IPFS. Hold on. IPFS kind of works like a blockchain. Okay, it's not really. It's basically just a decentralized, file storage system. Okay, so basically, it's just a distributed network of nodes that store files in a censorship-resistant way. Okay, and so that's what we're going to use this for. Basically, put our pictures on IPFS. We're going to put the attributes of the properties on IPFS, and that's going to essentially store a reference to each of those inside of our NFT smart contract. I'll just show you a quick example of that, what it looks like. So here's an example of like some JSON data. This is the metadata for the NFT. You can see the purchase price, type of residence, number of bedrooms, bathrooms, all that type of stuff. This is for the actual IPFS metadata for this property that we saw right here, okay? And then for the image, you can see a link to it on IPFS with the link right here. And then here's an example of the hosted image, okay, on IPFS as well. All right, now finally, let's look at basically the escrow process and how a sale will work. So again, we're going to have this real estate NFT. All right, let me actually move this font down so you can see a little better. All right, that's the NFT we're going to code first, where essentially we just create a smart contract that governs the property. But we're going to create this second contract that actually facilitates the purchase. This will be an escrow contract, where essentially you have a seller, all right, that will put the property in escrow, and the buyer can put in a down payment. All right, then you have all these other parties involved, like a lender, an inspector, an appraiser, and they actually have to go through and sign off on this transaction that it's valid before the ownership of the NFT can actually be transferred, okay? So we'll code all this out, we'll write tests for it, we'll show you how it works, and we'll put in this full stack application so that all this can be done directly through their website in a decentralized way that can completely streamline this process. All right, so let's go ahead and get started here. So let's start coding. There's only a few dependencies that you need in order to get started on this. You, of course, need a terminal, okay, so that you can execute commands in your terminal. You need a text editor. You can use whatever text editor you'd like. I'm just using Sublime Text because it's my preference. You need a MetaMask wallet installed so that you can make transactions on the blockchain, okay? But in terms of actual developer dependencies, the biggest one you need right now is just Node.js, okay? So you can go to your terminal, see if you have Node installed, do Node-V, okay? I'm using version 16.14.0. You can use whatever version you'd like, but if you're, just brand new, I highly recommend sticking to my same Node version to reduce the possibility of any problems that you're going to run into, okay? So if you don't have Node installed, you can install it with the package manager, or you can just go to the Node.js website directly and then download it for your machine, okay? So let's go ahead and get started with the code. I'm going to put a link to this down in the description below. This is the GitHub repository for the final code solution, okay? I've created a starter branch for this particular project. So we're not creating every single thing from scratch, okay? We're going to start off with a little bit of a template here today so we can get moving quickly. The biggest thing is I want to show you how to do this with real estate NFTs and create this full stack website with React, okay? So go ahead and grab that link down in the description below, all right? Copy it. I'm going to go to my terminal, and I'm going to do git clone, all right? And then I'm going to say -b, so that's going to clone a specific branch. So Git has branches. It's just different versions of the code. I can see my branch here called starter code. So git branch -b starter code. All right. And then I'm going to put it in here. All right. And then that's going to clone into this Milo directory. So I say cd Milo. All right. Now I'm on this branch starter code, which is exactly where we want to be. So once you're inside of here, we can go to open it up in our terminal. Okay, you can see that it's got some placeholder for some contracts inside of here. So this contracts directory, we've got some front end already configured inside of our project here. Okay, so it's not created. It's just we got some configuration set up so we can get moving quickly. We've got a directory for the test. Okay, and we have our package.json, which is what we really want, which are all the dependencies for our project. So let's go ahead and install those. We can go to our terminal and do npm install. All right, that's going to populate our node modules directory here and then pull down all the dependencies that we need. So what are some of those dependencies that we're going to use specifically for this, okay? So we're going to use Hardhat for creating the smart contracts, okay? So you can see that down here in the dev dependencies, all right? So Hardhat is a smart contract development framework that's going to let us, create smart contracts. It's going to let us write tests for them, put them on a blockchain, and all that type of stuff. So Hardhat's a really great tool. We're going to use Ethers.js, all right, for talking to the smart contracts in JavaScript, okay? So Ethers, comes inside of Hardhat as well. Okay, it's pretty standard. So Ethers, I'll put that up here. All right, Ethers is our JavaScript library for interacting with Ethereum and interacting with smart contracts. So that's what we're going to use for that. And then finally, we're going to use React.js to build out this client-side website. Okay, and again, React is just a JavaScript framework for creating user interfaces. All right, so now let's get into coding our first smart contract, okay? So what we're going to do is create a smart contract specifically for the real estate NFT, all right? So we can go inside of this realestate.sol file, okay? So realestate.sol is our first smart contract file, okay? Capital R, capital E. That's the convention for naming Solidity files here. .sol is the file extension. And you can see here we have at the top our Solidity programming language version. We just do pragma Solidity with a caret version 0.8.0. And then we use the contract keyword here. And then we give it any arbitrary name that we want to. In this case, we're going to call it real estate, just like the file name. And so all the code for the smart contract will go inside of here. And of course, to say the obvious, this is the Solidity programming language that you are looking at right here. Okay, so what we're going to do instead of creating a complete NFT from scratch is we're going to use a third-party library to help us create the NFT quickly. So we're going to use the OpenZeppelin library for doing this. So OpenZeppelin is a great project for open source smart contracts. NFTs are basically a solved problem, and just for the sake of getting started quickly, we can essentially use somebody else's audited NFT code to get started quickly. That's exactly what OpenZeppelin is for. So we already have OpenZeppelin inside of our project. We installed it with our NPM packages. So we can just import the OpenZeppelin dependencies into our file like this, so we can import the smart contracts like this, and then we can inherit from them in our smart contracts by saying like contract game item is ERC721 full. We'll do a very similar type of process, okay? So I'm going to import them like this. If you want to grab this from the final code solution, you can. But basically, I'm just going to import Open Zeppelin contracts utils counters, okay? ERC721 and then ERC721 URI storage. So this is going to help us create our NFT. So we'll say real estate is ERC721 URI storage. Okay, that's the same thing as this right here. And that's basically going to let us get all the behavior that we need to create our NFT. So we'll do a little bit of boilerplate setup inside of here. Basically, we're going to say using counters for counters.counter and then counter.counter private token IDs. Basically, this is going to allow us to create an enumerable ERC721 token so we can create them from scratch. So let me make a quick note of that. All right. So basically, whenever we create this NFT, we're going to mint them from scratch. So when we put the NFT in the blockchain, we deploy the smart contract out there. The smart contract out there. There's not going to be any properties whenever we create it. All right. We're actually going to create them manually from scratch, one by one by one, by calling the mint function. Okay. And that's going to create like property 1, property 2, property 3. And we'll do that after we've deployed the contract to the blockchain. That's why we're basically going to make this an enumerable contract where we can, create them. We're going to create a mint function. All right. And we'll also override the total supply to support that. But the first thing we need to do is basically give our contract some settings. All right. So ERC721 tokens, NFTs, take a name and a symbol. Okay. And we can configure those settings at the constructor function. Again, this is the function that's run once and only once whenever the contract is created or put on the blockchain. Okay, so we can create our constructor. We can just copy this from the documentation. All right, and you just use a constructor keyword, ERC721 full. Okay, game item, this. All right, so I'm going to modify this. So ours is going to be just ERC721. All right, just like this right here. And we're going to call it real estate. And we'll just use real. All right, we don't need this. We don't need the public. And we can just take off the function body because we don't need to execute any code inside of there. All right. And then next, we're going to create the mint function. All right. So this is what's going to let us, actually create tokens from scratch. We'll say function mint public returns UN256. All right. And basically what we're going to do inside of here is let somebody mint with a specific token URI. So this is going to be the actual metadata. All right. And then essentially inside of here, we're just going to create the NFTs from scratch like this. Okay. So we're going to update the token IDs. That's why we use this right here. Basically, the token ID is going to start at 0, and then we're going to increment it. We're going to add 1 each time. And then we'll turn a new item. All right. We'll mint it with the internal minting function from the library here. We'll set the token URI and return the new item ID. And then finally, we'll need to reflect that in the total supply, which is here. We'll override the total supply function to basically see how many NFTs have been currently minted. So I know I went through this part kind of fast. All right. And that's really to be intentional because I want to focus on the actual real estate escrow contract, which we'll focus on next. Okay. So, NFTs are kind of a solved problem in this case. I want to focus on the actual purchase behavior, and we'll code that out much more step by step with tests. Okay. But for now, I just wanted to get an NFT up and running quickly. All right. So that we can just have that NFT to work with. Because again, we're going to go back to this process where, we have, our NFT contract here, and then we have this escrow contract that facilitates all of these different purchases. So let's go ahead and get started on that now. All right, so now let's move on to the second smart contract, the escrow contract. And this is where we'll get a little more in depth, a little more step-by-step, and actually the coding of the Solidity, because this is way more custom, from scratch, okay? So again, what we're going to do here is create this escrow process where, a seller can list a property, a buyer can basically, signify their purchase intent and create a down payment. Lender can get involved, an inspector can get involved, an appraiser can get involved, and go through all this process to actually transfer the ownership. Okay. So what we're going to do first is create some settings in this smart contract. We're going to create some state variables. Okay. So opening up the file here again, what do we have? We have the programming language version at the top. Okay. We have this interface for an ERC721 token. We'll come back to this. Don't worry too much about it right now. We'll explain interfaces when we get there. But right here, we have the actual smart contract itself, the contract keyword escrow. Okay. So this is the contract we're going to create. We're going to put all the Solidity code inside of here. So what we're going to do first and foremost is store some settings. Okay. So we're going to use state variables for this. And we're going to keep track of some different blockchain addresses. Okay. So like the lender. We want to know who this is, who the seller is, okay, who the inspector is, all right, all that type of stuff. So at the top, we're going to say address, okay, public, lender, all right. So what is this? So, basically Solidity is a statically typed programming language, which means you have to declare the address type. You have to declare the variable type whenever you're declaring a variable. And that's why we use address here. That's just the data type of a blockchain address like you'd see in MetaMask. Lender is just the name of the variable we're creating. Again, this is a state variable, so it's going to get saved inside the smart contract on the blockchain. So once we set it, it's going to stay that way on chain. And then public just means that this variable is now visible outside the smart contract, and that Solidity is going to give us a special function for free where we can access this value and we'll be able to see it outside the smart contract. So we can do the same thing for the inspector, all right? All right. And then we can do the same thing for the seller. But we change this to address payable type because the seller is the person who's going to receive cryptocurrency in this transaction. So we must make their address payable here because we're actually going to transfer Ether to them. And then essentially we're going to say address public NFT address because we want to store the smart contract address for the NFT for this particular real estate transaction. Okay. So next what we want to do is actually set all these variable values. So we're going to do that inside of our constructor function. Again, this is the function that's run once and only once whenever the smart contract is deployed to the blockchain. We can create a constructor like this, a constructor. Okay, we say address, NFT address, address payable, seller, all right, address inspector, and then address lender. All right, I'm gonna kill my sidebar over here, and then we'll do some curly braces here. All right, and then open up a new thing. And what we're gonna do is set these function arguments, these variables that are passed in to these values here. So again, these are state variables. All right, and these are function arguments, which are going to be local variables inside this function. So I'm using underscores as a convention just to prefix those so that there's no naming conflict. All right, so how we set this is like we just say NFT address, which is the state variable here. We can access this value and also set it inside of here. So we can say NFT address. Because it's a state variable, it's accessible everywhere inside the smart contract. Whereas this, function argument's only accessible inside this function, so we can read it right here. And we basically are just saying, hey, take this NFT address we passed in and assign to this NFT address here. And whenever we do that, it's going to save it, forever on the blockchain. So same thing for seller, inspector, and lender. We'll just do those like right here. All right. So basically seller, we're going to set to this seller. All right. Inspector to this inspector, and then lender to this lender. And while I'm here, I'm going to format this code, all right, to be a little more readable instead of having it being way long ways like this. We're going to break it up in multiple lines. All right, so I'm going to do this. All right, and then I'm going to do that. All right, and so that's going to be our first bit of functionality, is just creating the contract with these specific settings and then actually passing in the NFT address that the escrow contract keeps track of it, okay? So we're going to test all this out as we build the smart contract. We're going to write tests in JavaScript, okay? That's the great thing about Hardhat is it comes with the testing framework already installed. So if you open up this escrow, if you go to test folder, look up Escrow.js, we can actually write tests in JavaScript that automatically check all the behavior of our smart contract, okay, without having to check everything by hand, all right? So I've already set up a testing environment here. I've got this expect from Chai, which is an assertion library. You'll see that we've got ethers pulled in. We have a helper here that helps us convert currency to tokens. All right. And then we have this function called describe escrow. And this is really where we're going to put all the tests for the escrow smart contract itself. So inside of here, what we're going to do essentially is we're going to start off with something called describe. We'll say, well, let's just do this. Let's start with a simple test example. We can say it. We can just say returns, NFT address. We'll just say it saves the addresses. All right, so this describe is describing the smart contract, and we can write a test example with this it function, and we can just tell it the behavior that we're looking for. We can say it saves the addresses. All right, and we can just pass in a function here. I'm gonna use the async await pattern inside JavaScript, so we're gonna make asynchronous function calls, so we need to do that. I'm gonna call await on those. So what we're gonna do essentially is we're going to deploy the real estate contract. All right. So we'll do that first. Basically, this is the real estate contract here we created. We can do that with Ethers.js. All right. So essentially, Ethers lets us just get the real estate contract factory from Hardhat like this. We can just say Ethers get contract factory. All right. Real estate. We can say that to a variable like this, a const real estate equals await. All right. And then that's going to basically get this compiled contract inside of Hardhat, but now we need to actually deploy it to the blockchain like this. We say real estate, equals await, real. Let's do this capital. Await real estate dot deploy. All right. And then essentially, we're going to, check, we're going to just, first, let's just check the address. So we can say console, or we can, let's do it this way, console.log. Let's just say real estate address. All right. Let's do a quick smoke check, make sure that's all set up and working properly. All right. So let's do npx hardhat. So this is how we run hardhat commands. So we can basically run hardhat like this, hardhat tests, and then it'll run the tests. But because we installed hardhat inside of our package.json file here, we actually want to run it with the hardhat version that's saved to our node modules directory, and that's what we're using npx for. So we'll say npx hardhat test. Hardhat test. Okay, awesome. So that's how we run the test. It'll pick up that file automatically, run the test runner, and we can see our contract address was logged to the console here. So that's it's working for now. Okay, so it saves the addresses. Basically, all we've done is deploy the real estate contract and logged the address here. All right. So now what we want to do is essentially mint an NFT first. Okay. So we saw this here. Where we can call this mint function, and we want to pass in a token URI. All right, so we can actually create an NFT once we've done it for a property that we want to list on our Millo website here. So we can use this IPFS URL right here. All right, you can grab this from the final code solution if you want to. I'm just going to copy this and put it in my file here. All right, so I'm going to go to I'm just going to put it here for safekeeping for 1 second. Take out this console logging statement. But in order to mint it, what I'm going to do is say, mint here. And here we can say, deploy real estate. All right, I'm going to say let transaction equals await real estate mint. All right, I'm going to paste in this URL for the metadata, all right? Because that's what we need to do whenever we mint the property. It takes in a token URI, okay? And this is going to be the URI for the metadata that has the image inside of it. It's got all the attributes, okay? So that's how we'll mint it, just like this, all right? We'll do real estate mints. But from Hardhat perspective, we only want to do the minting from the seller's perspective, okay? So we want to basically call this mint function as the property seller. So how do we do that? Well, Hardhat will let us essentially act on behalf of specific accounts in this list. So basically, we can get all the accounts saved to our Hardhat project like this. We can do await Ethers get signers. Okay, and that's going to log out all the addresses that come for free inside of Hardhat. Okay, so basically, whenever we run our Hardhat tests, we can essentially get an array of signers. So let's just log that. So say const counts. Or just say const signers. All right, I'll say console log signers, and then let's comment out this for a second because we don't want to do it just yet. But let's run the tests again. You'll see what's inside of there. All right, so you can see Ethers returns these 10 different signers. So signers are really just like people, like fake people on the blockchain. Actually, it's 20 signers, and it's like 20 different MetaMask accounts. Okay, that Hardhat gives us for free behind the scenes, and they all have cryptocurrency inside of them. Okay. So I can do like console signers.length to prove that it's 20 here. I believe it's 20. Yeah, 20. Okay. And so each of them has an address as well. All right. And they'll let you sign transactions, put them on the blockchain. So what we're going to do is we're going to set the buyer and the seller in this case. So we could just say, or const buyer, and we could say, you know, signers 0. All right, this is a 0-based index array. We say const seller. We could say signers 1. All right, because it's returning an array when it's reading out each account one by one. All right, and setting the buyer as the first one, the seller is the second one. Again, 0 index, so 0 is 1, 1 is 2. And so we could do that like that the long way, or we could essentially do parallel assignment inside of JavaScript like this, and just do it like this. We just give it an array and say buyer, seller. All right, that's going to assign them inside the array. Okay, that way we don't have to do it one by one. And then we can essentially save these at the top like this. We can do let buyer seller. All right, let's actually do it outside of here, because we'll change these and we'll access it out later. All right. And then also we can do the same thing for real estate like this. We can say let real estate. All right. And so the reason I did this is because we want to actually mint the NFT on behalf of the seller. So if I want to do it from the seller's perspective, I can say connect seller. All right. And then that's going to actually do this mint function on their behalf. Okay. So transaction equals await real estate connect seller, mint the NFT with this metadata. All right. And then we're going to say await transaction wait. All right. And then we're going to do npx hardhat tests. All right. So it's still working. All right. Nothing to really see yet here. But then now we have put a real estate NFT on the blockchain. We've minted a single property. All right, we have a buyer and a seller that we set up here. Now we actually want to deploy this escrow contract and then save the NFT address. Now that we have it, it's actually put in the blockchain, save the seller, inspector, and lender. So let's create some more accounts here. So buyer, seller, let's do inspector, lender. All right, and then do inspector, lender here. All right. And then let's deploy the escrow contract. So we have the real estate contract. We've minted it in an NFT. And then now let's do const escrow equals await Ethers get contract factory, just like we did here. And then let's do escrow. All right. And then we can do, let's set a variable for escrow here. And let's say escrow equals await escrow.deploy. And then let's put in the values we need. All right, we need the NFT address, the seller, inspector, and lender. All right, so what we're going to do is just pass those in, and we'll say real estate address. For the seller, all right, we'll do like this. We'll say seller address. Okay. So whenever we do this, this is the entire signer. It's not the actual blockchain address itself. You can get the address by doing seller.address. All right. So inspector.address and then lender.address. Okay. So now let's do that. Let's do NPX Hardhat test. All right. So that's still working. And then finally, let's just make sure that it checks the NFT address. So we can check that like this. We could say, let me just give myself some space. You can see it. Let's do const result equals await escrow.nft address. Okay, so basically what we're doing is we're reading this variable value right here, NFT address. Again, it's a blockchain address. It's public, so Solidity gave us a function called NFT address. And we can call that on the smart contract like this. We do await escrow NFT address. We save that to the result. Again, we're using the async await pattern in JavaScript. It's an asynchronous function. So instead of using like some crazy like callback function, we're just awaiting the result. Okay. If you didn't do this, it would return the promise, but you want to get the actual answer. So we wait for the promise to resolve. Okay. And then we can check it. We say expect. All right. We're pulling in expect here from Chai. Okay. Expect result to be equal. All right, real estate address. All right, and then we can also check that it returns the seller. It's basically the same thing here. We could say, const escrow seller. We want it to be equal to the seller address. Let's not do const. All right. Let's see here. Let's do let. All right. And then, so that we can check both of those. So I want to do a little bit of refactoring because I don't want to do all this inside of one big test. All right. So let's actually move. Let's reorganize this. So basically how we should do that is this should be its own, like this is one test example right now, like describe escrow. It says it saves the addresses. And what we want to do is actually have a specific test example for this and a specific test example for this. So instead of saying it saves the addresses, we're going to create a test example that says like, let's do it like this. We'll say it. Well, first of all, we're gonna have a special test example that says like it returns NFT address. All right, and we can say async. All right, and then we want to have a special function that basically says it returns the seller. Okay, which basically we're just checking all this stuff. We're saying in terms of NFT address, seller, inspector, lender. All right. Seller returns the inspector. All right. And then, it returns lender. All right. And we want to put all these inside of a special describe block. So we said describe escrow. We're going to say describe deployment. All right. And that can be a function like this. All right. So we're going to move all this stuff inside of here. Okay. And in each of these, instead of, we want to do all this stuff to set up these tests. And so we're going to take all of these and then basically put them inside of a before each function. All right, so we'll say this before each. Okay, say async. And what this is going to do is essentially run all this code before each of these test examples run inside this deployment description here. So you can basically take all this stuff. We've got all this stuff set up here, we can just copy all this, all right? Or just cut it all out and then put it inside the before each. Oops. All right. And basically here you go. So we've done all that. And then now we can say describe deployment. And for returning the NFT address, basically we can just cut this out. All right, move it inside of there. And say we can say const result here. All right, see what I'm doing? I'm just organizing the code we already wrote into a much better test suite. And then we can say returns the seller. We can cut this and just say const results. Let's go ahead and take that out. All right, let's just run the tests and make sure the exact same tests are passing, but it should be 2 test examples now, all right, instead of the first one. To npx hardhat test, see if we got any issues. All right, still working. Now let's go ahead and add the other ones. So I'm just gonna copy this, put it inside of here. So this should be inspector, and then inspector, and then lender. All right, so let's save that. And boom, it passes. All right, so now that we've created the basics of this escrow smart contract, really just the constructor function that, tracks the settings for the smart contract. It also, we've got some basic tests set up. We're going to be, positioned to move more quickly throughout this because now we can write tests to make sure that the code that we're writing in Solidity is actually doing what we expect, okay? So now let's go ahead and work on the first bit of functionality, which is listing a property, all right? So essentially what we can do is create a function here called list. We'll say function list, all right? We'll call this public, all right? And inside of here, what we're gonna do is essentially just take the NFT out of the user's wallet and move it into escrow. And we're going to do things like, set the price for the NFT or the property in this case. We'll put in the escrow amount, which is required, essentially like, a down payment or earnest money, okay, whenever the transaction is going to get completed. All right. So let's start off with the first bit of functionality, which is moving the NFT out of the user's wallet and actually putting it into escrow, because that's the whole point of a real estate transaction with escrow is that the ownership is put in by a neutral party and then everybody else has to sign off and do what they're supposed to in order to, make this happen. Again, if you have seller, basically the seller lists the property, they're going to put it into this escrow contract. And this is not perfectly how a real estate transaction happens in the real world. We're just kind of modeling this so you can see how it works in a simple fashion, okay? Typically the buyer deposits earnest money, and then you have this appraisal, inspection, all this type of stuff, right? So let's start off with the first thing, which is actually taking the NFT out of the user's wallet. So what we're going to do is use an, first of all, we need to know the ID of the NFT. So again, we created an NFT right here with this mint function. This is going to be the NFT with the ID of 1, all right? But you could have multiple properties like property 1, 2, 3, 4, 5, 6, okay, from this collection. And we need to know which NFT it is. So the first argument inside this list function is going to be uint 256. And we'll say NFT ID, all right? That's going to be the property that's getting listed. And the first thing we can do essentially is just transfer the NFT out of the seller's wallet into this escrow contract, and it'll stay there until the sale is complete. So we want to say, so how do we do that? Well, we coded this NFT in a different file here, okay? So we could import this file into our contract and call the transfer from function, which is the function that is part of the ERC 721 standard that moves NFTs between wallets, okay? You can see that here, all right? So all ERC 721 tokens, including the one that we have created because it's the Open Zeppelin version, has this transfer from function, okay? Which basically says, here's the from address, here's the to address, and the token ID, all right? And because we know the seller's address and we know the smart contract address, we can just move the token out of the seller's wallet into our wallet once they've approved it. And then now we will have the thing in escrow. So we need to talk to our real estate contract, call this transfer from function that was provided with this library, and move the NFT into our escrow contract. So how do we do that? Well, again, we could try to import this, okay, but we're going to use something called an interface. I said I would come back to this earlier, and I am now. So essentially, an interface is sort of like a skeleton for a smart contract that just tells you the types of functions that are on side of it, okay, in Solidity, so that we can talk to those types of smart contracts. So really, we just want to say, hey, we use this I prefix as a convention for interfaces, and we're saying, hey, here's the basic interface for an ERC-721 token. This is not the complete smart contract code, but we're going to tell you there's this smart contract out there that has a transfer from function on it. And so we're going to use this thing called an interface to just communicate with that. We don't need to know anything else about it like any other functions. We just care about this particular function right here. So what we can do is basically say ERC20, all right? And then we can pass in this NFT address, right? And now what this is going to let us do is get a version of this NFT inside of our project where we can call the functions, in this case, the transfer from function. All right, we can actually call the transfer from function on our NFT because we have the address and the interface, all right? And then we can pass in basically the seller's address. So in this case, that's going to be the person calling the functions. That can be message.sender. All right, and then who's it going to go to? It's going to go to this actual smart contract. That's who's going to get the ownership. So we can get the address of the contract that we're coding inside of with address this. Okay, so this is literally the smart contract in this case. It's a global variable inside Solidity, and we just make sure that's an address like this. Okay, and then we're going to pass in the NFT ID, which is going to be what we passed in right here. Okay, so you can see that again. The NFT ID is this. This is the address from, our address to, and token ID. All right, so now let's write a test for this. Okay, let's write a test to make sure that this basic functionality of listing works. Okay, so inside of the test, we're gonna go down here, and after describe deployment, we're just gonna copy this block and then say describe listing. All right. And so I'm going to take out all these test examples. I'm just going to start with this first one here. And what I'm going to do is say it, I'm going to say it updates the ownership. Okay. And so here what we're going to do is we're just going to check that the owner of the NFT is now the smart contract instead of the previous owner. And so how do we do that? We can say expect wait real estate owner of one. That's the first NFT we created. And we can say to be equal and then pass an escrow.address. That's going to be the address of the smart contract for the escrow contract. Okay, so let's just run the test, see if that passes. Okay, so we got a little issue here. We got a compilation issue. So I said ERC20. That's my fault. It's a stupid mistake. I'm thinking of ERC20 tokens. Sorry, everybody. ERC-721. All right. Run the test again. Okay, so it didn't work. That's okay. And I'll tell you why in a second. But let's just go back and look at this. Okay, so how do we get owner of, first of all? All right. So owner of comes from the ERC-721 spec. Okay, again, we're going to get this function for free because we just pulled in a library, but you can see the, owner of address, owner of function. Basically, you can put in the token ID. It will return the Ethereum address or the blockchain address of the wallet that owns it. Okay, so in this case, the ownership hasn't changed. All right, so why is that? Well, you can see, we run our test. The test is correct, but the behavior isn't actually working. Well, that's because you can see inside the contract, we're doing this transfer from function, which moves a token from one wallet to another. But, we haven't done a critical step on the other side of things, which is approving the token. Okay, so transfer from lets you move tokens from one wallet to another. But really, anybody can theoretically call this transfer from function. I mean, that's what we're doing inside of this smart contract here, okay? So we have to have the owner's consent to move tokens out of their wallet to this smart contract, okay? So how do we do that? Well, the owner of the token itself can call this approve function right here, all right? So the owner must call approve before we can actually call this transfer from function and move the tokens out of their wallet into this contract. So that'll be a required first step. So we can do that in our, our before each function here. So essentially what we'll do is we'll have the seller, approve the property. We'll just say approve property, and we'll say transaction equals await real estate connect seller, and we'll say approve, and we'll say escrow address, and we'll do token ID 1. All right. So await transaction await. All right. And then now we need to actually list the property as well. So we'll say list property. And now we can say transaction equals await escrow connect seller lists. So this is going to have our list function here. We pass in the NFT ID. All right. And we'll say await transaction dot wait. Now it should pass if I didn't make any mistakes. All right. So it updates the ownership. So now after on listing, it updates the ownership. Okay. So owner of 1 is now the escrow address. All right. So awesome. So next thing we want to do is actually, so I'll put a comment inside of here first of all. Put a comment and basically just say transfer the NFT from seller to this contract. Now we want to do is update the listing status. So basically we want to store a special place inside of our smart contract to say like, hey, this particular NFT, is it actually listed? So what we can do is create something called a mapping inside Solidity. So this is like stores key value pairs. So we can say mapping. All right, we can give it a key value of uint 256. And then bool, which is a true or false value. Say public is listed. So I'll dig into mappings a little more. So the key, it's just a data structure. This is a key and a value. So a uint is an unsigned integer. So basically it's a number greater than 0, all right, with no decimal places, all right? So sign means like a minus sign, right? So it can't be negative. So basically, yeah, that's what a unsigned integer is, of 256 bits. And then a Boolean is just a true or false value. So basically, this will be like the NFT ID, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this will just be like true or false. And that will basically tell us, is the property listed? Again, this will be public. All right, so we'll have a function for free called isListed that we can check for outside the smart contract. We can update this mapping right here. It's kind of like a little database where we'll just say, is listed. All right, and then we say NFT ID, and then we say true. All right, so that's how we assign values to a mapping. We give it the mapping name, we give these brackets, all right, pass in the key, which is the NFT ID. In this case, it's just 1, and then we assign that to true. All right, now we can check for that inside the test. We can say, it updates it as listed. All right, so instead of updates ownership, above that, we can just say, updates as listed. Okay, so basically we can just do this. All right, and basically just say const result equals await escrow is listed 1, and then expect result to be equal to true. All right, so it updates it as listed. Okay, next we're going to store some other values on the smart contract. Basically, we're going to store the purchase price, the escrow amount, and the buyer ID. And we're going to store those inside of a mapping, just like we did here, because we want to do this on a per NFT basis. Okay, so essentially, we're going to create some more mappings like this. We're going to say purchase price, escrow amount, and buyer. So purchase price can be the amount of cryptocurrency and ether that it cost to buy the house. So the UN256 is the ID of the NFT. The price is going to be the price of the home. The ID of the NFT and the escrow amount and the ID of the NFT and then the address of the buyer. Okay. And so now, what we're going to do is put all this here. We're going to basically say purchase price, NFT ID equals purchase price. Okay, we're going to pass that in here. That'll be UN256. Okay, we're also going to pass in a buyer. All right, and then also an escrow amount. Okay, and we're going to break this up in multiple lines here. Okay, so we're going to do this. All right. And then we're going to save those inside of here. Save the purchase price like that. We're going to add the escrow amount like this. And then we're going to save the buyer like this. Okay. And now we can check for those inside of here. All right. So we can check that it returns the buyer like this. All right. Returns the buyer like this. Okay. Returns the purchase price like this. And finally, it returns the escrow amount like this. All right, so what we're going to do here, I'll just pause the video and in a still frame if you want to make sure that that's all correct inside your code editor. All right, let's just run the test first, make sure they pass before you start doing that. Okay, all right, so we got a little issue. Let's just save this really quickly. All right, so I forgot to pass in the new arguments here. So whenever we list the property, we want to add some more stuff here at the top. Okay, so basically, whatever we call lists, we want to add also the buyer address. Okay, and then the tokens. All right, 10. And then tokens, 5. Okay. So tokens, what that does is it takes we're going to say basically it costs 10 ether. Okay. To list the property, and we have this tokens helper here, all right, which basically takes the value and converts it to ether for the smart contract, and same thing for the escrow amount. All right. So now I'm going to run the test again, make sure it passes. All right, they pass. So now if you want to pause the video, make sure that this all looks correct, then you can do that now. Okay, so one final thing I want to do on the escrow list function essentially is make sure that only the property owner can do this, okay? Because you don't really want some random person to list the property, okay? So inside of here, what we're going to do is basically create a modifier, okay? Basically what we can do is put this inside of here at the top. We can create this thing called modifier here. And we can apply this to our function and say modifier only seller and require the message.sender is equal to seller. So only seller can call this method. And then we can add this modifier to it like this. Say only seller. And we also make this function payable so that they can send in, Ether with this function if they desire. Okay, awesome. So now let's rerun the test, make sure it still passes. If you want to write a specific test to check for this, that only the owner can call this function, only seller, you could do that. I'm not going to do it for now, just for the sake of time. But now we have our basic listing functionality finished. All right, so now we've listed the property right here. We need to go through the rest of the process in the life cycle, like buyer deposits earnest money. We update like an appraisal, inspection, okay. Appraisal, inspection, lender approval, like lender adding funds to the contract, okay. Transferring the ownership and the seller getting paid. That's the whole life cycle here. At least we're modeling that way, okay. So next what I'm going to do essentially is create a function to deposit earnest money into the smart contract, and that's going to be from the buyer's perspective, okay. So basically what we're going to do is have a way to deposit that, okay. So basically inside of after listing, we're going to minimize this, actually go to the contract first, and we'll create a function inside of here. It's just called deposit earnest, okay. So what we're going to do, I'm just going to go ahead and add it like this, okay. So basically we say put under contract, basically only buyer can do this. We get a payable escrow function. So we have this function called deposit earnest. We'll give it one argument to UNT56 of the NFT ID that's going for sale. Public payable, so they can send in Ether with the transaction, and we'll make sure the only buyer can do this. Okay, so we need to add in a modifier for only buyer with the NFT ID. All right. So basically we can go here at the top of our only seller, and then create our, this, and say only buyer, all right, and pass in an NFT ID. Say message at sender needs to be the same as the buyer of the NFT. Okay, so again, we store the buyers, we can, we got this buyer mapping right here, and then the NFT ID, and make sure it's the same as message sender, who's the person calling the function, all right. So public payable only buyer, and then require message value is greater than or equal to the NFT ID, the escrow amount. All right. So basically, essentially the escrow amount is the amount that you have to put in for escrow for the buyer, get skin in the game for the transaction. Sort of like a down payment in this case, sort of like earnest money. We're kind of blending those two concepts together. So if you're familiar with real estate, this isn't going to be like an airtight strategy here. We're just kind of modeling how you could do this with blockchain. So anyways, they're going to put some, down payment, earnest money, whatever you want to call it. I know there's different things, like I was saying before, but we're just kind of lumping those together as the same concept, even though they are different in the real world for the sake of this tutorial. So anyways, message at value is the amount of Ether that gets sent in with the transaction, and we just want to make sure that's greater than or equal to the required escrow amount to put the property under contract. Okay. So, let's just see here. That's what we're going to do here. We got everything that's required. So basically what they're going to do is send Ether just directly to the contract whenever that happens. And we want to make sure that it's the correct amount, and that Ether amount is going to get stored in the contract during this process. It's basically, the buyer does that. They're going to send their down payment directly to the escrow contract, and the real estate NFT is owned by this. Now the buyer's funds for the escrow amount is owned by the contract as well. And then what's going to happen is the lender will be able to add their funds to this contract later. And whenever the property is actually sold, the sale proceeds will go to the seller, and the NFT will go to the buyer. And this real estate contract, escrow contract, facilitates that entire transaction. So now we deposited earnest money. Let's go actually do that in the tests. Okay, so we can write, instead of describe listing, we can say describe deposits. Okay, and then inside of here, we can say it updates contract balance. Okay, and then we say async okay, and then what we're going to do is we're going to say const transaction equals await escrow connect buyer. Okay, deposit earnest value 1. And then I would say the metadata of the value is tokens 5. That's the actual escrow amount. We'll say await transaction wait. All right. And then we'll also say we're going to wait for it and check the balance. Say const result equals escrow get balance. And then that's going to actually get the balance of the Ether balance of the contract. And at this point, that should now be equal to 5 Ether, okay, that we deposited here. So save that, run the tests. Okay, so escrow get balance is not a function. Let's actually implement that. So on the contract at the bottom, what we're going to do is create a special function that helps us get the current Ether balance really quickly. So we can write it in our tests. So basically, we're going to do a couple things. We're going to do this. We're going to do get balance, all right, which essentially is just going to be a function, okay? And it's going to be public view. It's going to return UN256. And what it's going to do is just say return address this balance. So this address, this is the address of the current smart contract, and dot balance will just give you the Ether balance, and we can call this get balance function to just quickly return this. While we're here, let's also implement this receive function. Okay, so this is what's going to let the smart contract actually receive Ether. So like with the lender, for example, could send funds to the smart contract and increase the balance. You need this in order to accept Ether to the contract. Okay. So we'll go ahead and do those same two things while we're here. Let's rerun the test, make sure it still passes. And boom, there you go. Awesome. All right, so now we've got the ability for the buyer to deposit the earnest money or the down payment, depending on how you want to think about that. Okay. So now we want to talk about the actual, inspection, right? The appraisal type process. Okay. So what we're going to do is basically model the inspection. Okay. Property inspector wants to sign off that the property is okay and passes inspection before this can happen. So what we're going to do is essentially create a mapping for the inspection status, okay, at the top. So we have, just below the buyer, we're going to create a mapping called inspection passed. So that's going to have a key value pair. Essentially, like the UN256 can be the property ID, and then Boolean values can be true or false whether the inspection is passed. By default, it's going to be false because that's what mappings default to. So we can create a function to update it though, okay? And then we can basically do that like this. Basically, we'll just say, actually, let's do it up here. Update inspection status, that'd be a function. Okay, we'll give it NFT ID and then a Boolean true or false on whether it's passed. Be a public, only the inspector can call this, and basically we'll take that inspection pass mapping, passing the NFT ID here, and we'll just pass in the value whether it's passed or not. Now, we only want the inspector to call this function, so we need to make an only inspector modifier. Okay, so at the very top, we'll basically just say below only seller, we'll say only inspector. Okay, message.sender is going to equal to the inspector address, which we saved here. Only inspector can call this function, and we apply that to the function right here. Okay. All right, so now let's write a test for that. We'll go here. All right, and after deposits, we'll copy that and look for inspection. So we'll say deposits. All right, we'll say inspection. And basically, instead of this, we'll do this. Const transaction equals await escrow connect inspector. Update inspection status 1 is true. All right, we'll wait for that transaction to finish. Do await transaction wait. And then we'll just say const results equals escrow inspection passed 1. And we expect that value to equal true. All right, so let's save that. Let's go to our terminal, run the tests. Okay, so we got a little issue here. Unexpected end of input in the thing. So it's because we chopped this off. All right, save that. All right, there you go, it passes. So we can do deposits and it updates the contract balance for the inspection. So I think I need to change this, updates inspection status. Save that. Yeah, awesome. There we go. Okay, so now I want to do one final thing before we actually facilitate selling the property. Okay. We want to have basically an approval process. So like, if we want an inspector to sign off on the sale, an appraiser, a lender to just basically say, yeah, we approve the sale, we want to have a special function for that. So essentially what we're going to do is create a mapping called approval, all right? But it's going to be a nested mapping, so you can add it here. So we'll say mapping, the key of the NFT, all right? And then we'll say the approval, so you can put a mapping inside of a mapping. And so this is going to be the mapping of the address of the person who approved it and whether that's true or false. So we just on a per NFT basis, so we pass in the ID of the NFT. That returns a mapping, okay, of the address that, of the person who's approving and then whether it's true or false. All right, so we can create a function to update that mapping like this. We'll just say approve sale. All right, so say approve sale, pass in the NFT ID and message.sender will be the person who calls this, and then we'll just set it to true. And we can require this approval whenever we do the sale, which we'll see here in a second, but I want to go ahead and just test this out. All right, so then we'll go to describe inspection. We'll say describe approval. I'll say updates approval status. And then for this, we'll take this out. And then we'll replace this with this. Oops. Basically, we'll say let transaction equals await escrow connect buyer approve sale. And we can do the same thing for the seller. All right, basically, we can just do this. Do it 3 times. And then we'll say for the seller, and then also the lender, and we can check all those, okay? So we can just say expect, await escrow approval 1 for the buyer address to be equal to true, that the buyer's actually done it. Same thing for the seller, and then same thing for the lender. All right, so let's save that, go back to our terminal, run the test. Okay, so I've done let multiple times here, so that's not going to work. All right, so approval, that updates the value there. Okay, so now we've done pretty much all that we need to do. With one final exception, we need to actually facilitate the sale of the property. So basically, we've added the ability to list the property. We had the ability to deposit earnest money to do an inspection. We had the ability for approval for the lender to approve it. Now we need to go for basically like the lender sending the funds over and transferring the ownership so that the NFT goes to the buyer and the funds go to the seller. Okay. So we're going to do all that inside the contract with one final function like this. All right. Basically, we're going to go inside of here and then create a function called finalize sale. All right. This will be uint256, NFT ID, public. Okay. And so what do we want this function to do? Well, we want it to require the inspection status. Okay. You could add more items here like appraisal, et cetera, et cetera. Require the sale to be authorized. Okay, require the funds to be the correct amount. Transfer the NFT to the buyer and transfer funds to the seller. Okay, so we can require the inspection status like this. Basically, we can just say, require inspection passed NFT ID. Again, we're, doing that here, right? And then only the inspector can call this. Okay, we want to require that the approval from multiple parties. Basically, we're going to require that the buyer has approved this transaction. So you can require approval, NFT ID, then the buyer, okay, of the NFT ID. We want to require the approval of the seller. So we can say require approval, NFT ID, seller address, and then approval of the lender. So we can say require approval, NFT, lender. And then finally, we want to make sure that this contract is fully funded. So basically, we can do that like this. We can get the address, this. dot balance, all right, is greater than or equal to the purchase price, all right, of the NFT. All right. So that's basically going to make sure that all the funds have been sent to this contract, and we can require that. All right. And then that's going to check that all this stuff has happened before it will actually, do the transaction. So we're going to do more stuff inside of there, but let's actually make sure all this stuff happens before we do things like, transfer the NFT to the buyer and transfer the funds to the seller. Okay. So inside the escrow.js, let's do that. All right. I'll take a little more time on this one. Be very detailed. Say describe sale. Okay. And then we'll say async. And then inside of here, we can use it before each function, and we're going to go through all these steps. Okay. So the first thing we're going to do is go through this deposit earnest feature first. Okay. So we'll say let transaction equals await escrow connect buyer deposit earnest. Okay. We'll say value 5 tokens. All right. So, sorry, let's see here. That's going to make sure that we got the earnest deposit. That'll help us satisfy the condition of the balance. Okay. The next, we're going to update the inspection status. All right. So like transaction await escrow connect inspector. Update inspection status 1 is true. All right. We're going to approve the sale from the buyer like this. All right. We're going to say escrow connect buyer approve sale 1. All right. Then do await transaction wait. All right. That's going to satisfy this. We'll do it from the seller and then the lender. Okay. And then we'll say, let's just do here. We'll do connect seller, approve sale. All right. And we'll also do same thing for the lender. Lender, approve sale. All right. So that's going to check off all these boxes. All right. Now, finally, what we want to do is, essentially send, more money to this smart contract from the lender, all right, to fund the deal. Okay. And then essentially what we're going to do is we're going to send the transaction from the lender like this. We'll do await lender send transaction, like to the escrow address. The value is 5 tokens. So now we have deposited 5, and then we'll add, 5 here for the entire purchase price. And then finally, we'll finalize the sale like this. Say transaction equals await escrow connect seller finalize sale, and we'll pass in the NFT ID 1 and wait for that to finish. And now we'll check to see what happens. Okay, so we'll just say, it, just works. Okay, we'll change this in a second. But let's just run this, make sure the before function actually works properly and that we're satisfying those conditions. Okay, let's save that, go to our terminal, npx hardhat test. All right, so it works, so quote unquote. So really what we're doing is just putting these require statements, make sure that the property is going through all the proper conditions, that it's got all the inspections, it's got all the approval, and then we mimic those inside of this process here. Now we just say it works. What now we want to do is actually check for other behavior. So what we want to do is say that, on our diagram here, that it actually, transfers the ownership of the NFT to the buyer and it gives the funds to the seller. So how can we do that? Well, inside of our real estate contract, we'll essentially go inside of here and we'll say, we'll basically send the Ether to the seller. So we'll say payable seller. And we'll say call. So call is a function that we can use to send any message we want to that address, but we'll use to send Ether in this case. We'll say value address this. That's how much balance. And then we'll do it like this. Okay. And then we'll say bool success. All right, this is kind of a long-winded way of just transferring Ether from the smart contract to the seller. Okay. But it will return a success value, which we want to check. We'll say require success. All right, so that's going to send Ether to the seller. Okay, so we can check for that. Basically, we can just say check. We can just basically check that the escrow balance is now 0. So say updates the balance. Expect escrow balance to be equal to 0. All right. And then now what we want to do is actually transfer the NFT ownership to the buyer. So we'll do it like this. We did that with IERC20 transfer from. So we can literally just copy this same line here. Okay. And then paste it down here. But let's kind of change the operation. So instead of doing it from here, the NFT is going to own it. All right, I'll take off this comment. Or the escrow is going to own it. So we'll just say address this, transfer from address this. We don't require any approval because the contract already owns it. And then we're sending it to the buyer. All right. And then let's go ahead and update that in the tests to essentially check that. Say it updates the ownership. All right. Would say basically expect real estate owner of 1 now to be the buyer address because after the sale, it transfers the NFT ownership to the buyer. All right, so that works. Awesome. So that should be pretty much it for the behavior in the test that we want to check for. There's a couple of things I want to do in the contract before we wrap up here. Basically, we want to now say that the NFT is no longer listed. All right, so right here, we'll just say is listed, NFT ID is false. Okay, but then the finalizing should take place. We also want to go ahead and add some basic behavior for canceling the transaction. Okay, so I'm not gonna really code this out in depth. I'm not running a bunch of tests against it. You can do that for an exercise if you want to. But you want to handle cases where a sale gets canceled, okay? So basically, like if inspection status is not approved, you could refund the transaction or sell it, send it to the seller. Basically the stuff like that, right? And you could add your own custom logic to this. And if you want to do that in tests, you definitely can. But I'm just going to add these here so to get you some ideas going for you. And I'm going to move this code to the bottom here. Okay, just so we're a little more organized. All right, then I'm going to run the test again, make sure everything still passes. All right, and there we go. All right, so now that we have successfully completed the smart contracts and written tests for them, now what we want to do is actually put the smart contracts on a local blockchain. So what's cool is Hardhat gives us a way to run a blockchain on our computer without having to talk to the internet, okay? So basically, we can just say npx Hardhat node. All right, what that's going to do is start a local Hardhat blockchain on our account, on our computer. And that's going to give us these, 20 accounts with 10,000 fake Ether inside of them. So when we were running our tests before, essentially that's what Hardhat was doing behind the scenes every time we started our tests. But we didn't have to have this blockchain running, which is pretty nice. But now that we're actually going to put the smart contracts on this local blockchain so we can start building out our website, we actually want to have a blockchain running, and that's exactly what this npx Hardhat node command does. So now what we want to do is create a special script that takes these smart contracts that we created and takes them off of our computer and then puts them on our local blockchain. So we can do that with scripts inside of Hardhat. If you go to this Hardhat, so this file browser over here, you can look at this scripts directory. You can see deploy.js inside of here. So this is a boilerplate script that you can run inside of Hardhat, and we can put all the code for it inside this main function. And this is where we're actually going to take the contracts off our computer and deploy them to the blockchain. So let's go ahead and do that right now. Inside of here, what we're going to do is we're going to do something kind of similar from our test. Remember inside of our tests, we did this, get signers from Ethers, buyer, seller, lender, inspector. We're basically going to do that again inside of here. So we're going to paste that in here, set up accounts. All right. So buyer, seller, inspector, lender. Do Ethers get signers. Again, we have access to Ethers inside of here because we're using Hardhat. All right, and now what we want to do is basically get the real estate contract factory like we did inside the test. So const real estate equals await Ethers get contract factory real estate. All right, that's literally what we did here. Right, basically we can just even copy the same thing and then paste it. But we'll say const real estate, lowercase real estate. All right, and then now we want to get, wait for it to actually deploy for real. So we'll say await real estate dot deployed. And now what we want to do is actually mint some NFTs. So, I've got the metadata for those here. Inside the metadata directory, you can see like one.json. These are already uploaded to IPFS for you. So you don't have to upload this on IPFS. Again, you can just copy these links. You can see them right here, right? You can see this. All right, I've got this link posted in here. And you can see that it's, for one.json, you can change this to two.json, which would be the ID of the NFT here. Change to .3. Okay, so I've already uploaded these for you. And so I don't want to reinvent the wheel for you, make this a little bit easier, but these are already on IPFS. So we can just add them to our real NFTs whenever we deploy them, okay? So we're going to go ahead and log this to the console. We'll say, deployed real estate here. All right. And then now we're going to say we're going to mint 3 properties. So we're going to do this inside of a for loop. Okay. So for loop in JavaScript just lets you loop through a set of numbers and do something in that number of times. So we're going to say transaction equals await real estate connect seller, which we pulled out here, and then mint. And what we're going to do is paste in the IPFS URL, all right? But then we're going to basically take the I value, which is the current number that we're iterating over into this for loop. We're going to add 1 to it, and that's going to be the NFT ID. So basically, if we do that for 3, so JSON 1, 2, 3, ID 1, 2, 3, you can grab this IPFS URL if you want to from the final code solution. But basically, like you can, go to IPFS. .io and then put this into your browser and then do one.json and it'll pull up the metadata. You can see if you put in your browser and do 2.json, it'll give you the metadata for NFT number 2. Same thing for NFT number 3 because we've already uploaded them for you. Okay. So we'll mint 3 NFTs. All right. And then we're going to just deploy the escrow contract like this. Okay. So we'll say const escrow equals await Ethers get contract factory, capital E escrow. Then we'll say const lowercase escrow equals await escrow.deploy. Okay, real estate.address, seller.address, inspector.address, lender.address, and then get the deployed contract. Okay, and then we're going to approve the properties from the seller. So just like we did the for loop here, we're going to add a for loop here that basically just says let transaction equals await real estate connect seller, approve escrow address, and then the value of each property. So 1, 2, 3. All right. And then finally, we're going to list the properties like this. We're going to say transaction equals await escrow connect seller list property 1, buyer address tokens 20, tokens 10. And then we'll do that for 2 more like this. We'll just say seller list 2, buyer address tokens 15, tokens 5, list 3, buyer address tokens 10, tokens 5 for these different amounts. And then finally, we'll just say it's finished. Okay. So I know we went that kind of quickly, but if you want to study this script even more, you can check out the final code solution and look over that a little more slowly. I just want to go ahead and move on to the front end part, but this is required to get the contracts off of our computer onto our blockchain. And it's basically the same thing we did right here, okay, with a little bit of extra steps. Okay, so let's save that. Let's go ahead and give it a whirl. Let's go to our terminal here and then make sure our blockchain's running. And then a new tab, we're going to say, npx hardhat run scripts /deploy.js. We'll say -- network localhost. All right. So I think I misspelled Hardhat. I do that all the time. Hardhat, Hardhat. Try that again. All right, so tokens is not defined. Let's just do that. We need a tokens function here. So let's copy that from our project. We need to add it here. All right, time. All right, awesome. So it worked. So I'm gonna reset this again. I'm gonna restart my Hardhat node just to make sure I didn't do anything when I messed the script up. So I'm gonna clear all this out and run it one more time. So npx Hardhat run scripts deploy.js -- network localhost. All right, now it's minting 3 properties is finished. You can see all the transactions here. Here is the contract. Okay, here's the mint, escrow, approve, lists. So that was finished. Okay, so now you can see the deployed real estate contract is here. Okay, so now that we have compiled those and deployed them, I want to show you that, Hardhat has put your artifacts inside of here, your contracts, escrow.sol. It has an ABI, okay, like this. And then also the same thing for real estate. You've got an ABI inside of here. You've also got your addresses saved. So what I want to do is go ahead and update some of this for our front end before we start building out the front end application. So basically, if you go into our source directory, this is going to be for our client-side application we're going to use next. We're going to make sure those ABIs are inside of there. Okay, so this is going to be the exact ABIs for the smart contracts for the escrow. Again, it's the exact same ABI as is listed inside of this file. And same thing for real estate. So basically, we're going to create a React app in the next section. So if we need to make sure that their ABIs are inside of there. If you modify your code in any way, you want to update your ABIs from this directory. Again, this artifacts directory, contracts, real estate.json, basically taking this ABI and copying it and putting it inside of this ABI right here. All right. Same thing for escrow, right? So the other thing is we have this config.json here. All right. So inside of our source directory, we have the addresses for the smart contracts that are deployed to Hardhat. Okay. So the nice thing about Hardhat is it's going to give you the same contract addresses every single time. So you shouldn't have to update this. Okay. So you can see this right here. That's the same address here. And then you could log the escrow address if you want to as well. You could just go to your deploy script and then say, you could do this here and basically just say, deployed escrow contract at escrow address. All right, and let's do a teardown exercise. Let's restart the node, npx Hardhat node. All right, and let's redeploy the contracts. Oh, I misspelled that. Let's see here. All right. All right, so deployed a real estate contract here and an escrow contract here. So this should be A6E0 and 0FC9. All right, let's go to our config file. Let's do it again. Let's restart. I think it's because we already ran this. Hold on. Got a fresh node. Let's do it one more time. Oh, sorry, that's this npx Hardhat run scripts deploy. All right, yeah, AA3. All right, and then F0512, F0512. All right, so that's all ideas. You want to make sure that the real estate address here is here, and then the same escrow contract that's here is here, because we need to save all this stuff in our front-end application so we can talk to those smart contracts when we start creating out the React application in the next section. So let's go ahead and do that. All right, so now what we're going to do is go ahead and start building out the client-side application. Okay, so the first thing we want to do is go ahead and open up a new terminal tab here. All right, make sure your blockchain node's running. All right, make sure you deployed your contracts like we did in the last section. All right, but now we're going to start our web server with npm run start. Okay, and I've already got this running here, but this is the old copy, so this should reboot. You should have a new browser open automatically. All right, and then you should be able to see your website there. So this will take us just a second, but boom, there you go. You should see this white page pop up. This says welcome to Millo. All right, that's our Zillow clone here. All right, And you'll see all these kind of linter warnings inside of there. That's fine. That's because we have some boilerplate code. All right. So what we're going to do is keep that running, keep our blockchain running. We're going to open this in our text editor. Okay. And we're going to go to our source directory. And this is where all of our front-end files are going to live. So we have a React application inside of here. Okay. We've got this app.js file. Okay. This is some boilerplate code for the React app. Okay. We've got some libraries imported up here, like Ethers. We've got some React hooks imported, like use effect and use state. We've got these other components in the components directory. We've got a placeholder for the home for navigation and search. We'll dig into that. We got the ABIs for our smart contracts. Okay, the real estate ABI is here. All right, and the escrow ABI is here. And then our config.json file right here, which has the smart contract addresses that are deployed to the blockchain. Okay. And so we can see all that inside of our app.js. The app.js file is mounted inside of index.js right here. And we're also importing our CSS file, okay, which we wrote right here. So basically, we've already got some CSS preloaded. We don't want to spend a ton of time focusing on CSS in this tutorial. So I've gone ahead and just added the CSS for you so you don't have to write it from scratch, okay? Again, I just don't want to spend a ton of time on CSS. I'd rather focus on the blockchain side of things. So we've already got the CSS imported for you. And now we can basically go inside here in app.js and start editing things. So you can just edit this and see how it works. You can just add an exclamation point here at the end of welcome to Milo, exclamation point. All right. And you can see our changes were automatically detected here. So now what we want to do is also configure MetaMask, okay? So what I'm going to do is go to MetaMask and make sure that's installed and go to add a network here. And then you want to make sure that you add the Hardhat network. You can call it Hardhat, okay? You can do your localhost address. All right, you can literally copy this from Hardhat and put it in here. Okay, it's already in use, so it won't work. Chain ID is going to be, let's just see here. Oh, it's in the project. Let me find it. The chain ID is going to be this. You can see the Hardhat chain ID inside your config.json, so just copy that. Okay, go back to your MetaMask here, add it here. All right, currency symbol is ETH, and block explorer, you can just leave blank. Again, I've already done this, so it's not going to let me save it because I've got a conflict here, but just click save, okay? That should take you back to your MetaMask, okay? And then you should be able to see that new network Hardhat in your dropdown. Just go ahead and select it, and you should be connected to the blockchain. Now, let's talk about how to import your accounts. So you can go here to Hardhat, all right, where you started it up. You can see these errors here. That's okay. Go find your accounts. And what I'm going to do is I'm going to import them one by one. So I'm going to take this private key, okay? I'm going to copy it, and I'm going to go to my MetaMask here. I'm going to go to import account, all right? And I'm going to paste in the private key, click import. It's already done it, all right? So I've already done it. It's going to give me an error, but if you haven't, it'll import it, and you should see it here. Now, you can also go to your settings, and then let's do this. Account details, you can rename it. I've renamed mine to Hardhat 0 because it's the first Hardhat account in the list, right? It's called account 0. So I call it Hardhat number 0, all right? And then what I recommend, you're going to need to use multiple accounts in this tutorial. So go ahead and do this for the first 5 accounts on the list, 0, 1, 2, 3, 4. That's 5 different accounts. And whenever you've done that, we can look for like Hardhat. I've got 0, 1, 2, 3, 4, 5 even. So maybe go ahead and do 0 through 5. And you'll see all those accounts are inside of there, and you can switch between them, and you can see the Ether balance in each of them, okay? So now you got your project connected to the blockchain. You've got your Hardhat accounts installed. Let's go ahead and start coding out that front end. All right, so now let's go ahead and connect our project to the blockchain. So what I'm going to do is create a new function inside of my component here inside of React called load blockchain data. So let's say const load blockchain data. All right, that's going to be an asynchronous function. Okay. And inside of here, what we're going to do is we're going to go ahead and pull our connection from MetaMask. So MetaMask injects something into our browser called window.ethereum. All right, so you can even visualize that here. Let's see here, we got a problem. Let's just take this out for a second. All right, let's open our developer console so you can do inspect element or inspect, and you can see this pop up down here. You can click on the console tab, okay, and that will give you a JavaScript console. So we can see this global variable inside JavaScript called window, all right, and you can do window.ethereum, okay, and this essentially is our connection to the Ethereum blockchain that's injected by MetaMask. So window.ethereum in this case is the connection to the Hardhat blockchain that we have running right here, okay? So you want to connect to this so that we can pull in the smart contracts and start creating a Dapp. All right. So inside of here, let's go into our load blockchain data here. Uncomment that again. So basically, need to change this. All right. And what we want to do, let's just save this, see if we can look at the error. So really what we need to do here is just assign this. So essentially what we're going to do is create something called the Ethers provider. So again, Ethers is the library that connects our project to the blockchain. So by default, like our app is not going to talk to the blockchain on its own. That's what we need Ethers.js for. So we're pulling in Ethers at the top. And in order to create a connection to the blockchain, we can use something called the Ethers provider. So we do that like this. We just say const provider equals new Ethers providers Web3 provider. And we pass in this window.ethereum right here. Okay. So we can do that. And we can say console.log provider. Okay. And we can see it renders. And now, okay, that's not working just yet. Let's just do that. That's okay. Okay, so first of all, we're loading the blockchain data. We're not calling it yet. Okay. So essentially, how do we do that? Well, with React, we're using a functional component here, and we can use something called a React hook, all right, which is going to let us do that. So we're going to use the use effect hook, okay, which is essentially going to get called whenever this component renders to the page. So we can say use effect, all right, and then pass in a function like this. And inside of here, we'll call load blockchain data, because here we just defined the function. We're not calling it yet. And then essentially we want to do this at the end. Pass in an empty array. That's going to detect any changes, but we don't care about that. So let's just save it. And then now you can see that we're logging the Web3 provider to the console. And so this is going to give us everything we need in Ethers to talk directly to the blockchain. Awesome. So with that, we can do things like get the account from our MetaMask. So we can get accounts like this. Basically, we can say const accounts equals wait window.ethereum request. We can say method eth request accounts. All right. And we can essentially log those to the console. So console log accounts. All right. And then now we can see our account from MetaMask right here is logged to the console. All right. So great. Now we're cooking with fire. So what we want to do is basically save this account to the component state. Now let me talk really quickly about React component state. Okay, so React, uses components to organize our code. All right, so this here is a React component. We have some other components inside of here like home, navigation, and search. We'll get to those in a minute. But this is our main component. Basically, a component is just a place where you can, reorganize and reuse code and render them onto the page. But our components also have a state, okay? So a state is really just like, kind of like a little database inside of each component. So for example, you can see like this component here is a to-do list, and it has items on it, like item 1, item 2, item 3. All right, so where do those items go in this to-do list? Well, they go inside the component state. It's like a little database that exists inside of this component. Now, this example here is with a class-based component in React, but we're using functional components. So just like we did the use effect hook here, we can do a use state hook, which is here, and we can read and write from the React component state like this. So essentially we can do a component like this. We can do this. We can create functions for reading the account and setting the account like this. So we can say account and then set account equals use state null. So what it's going to do, it's going to fetch the component state and give us two different functions. One to read the account from the state and one to set the account to the state. And by default, we're going to say if the account doesn't exist, just return the null value. Okay. So then essentially we can write it to the state like this. We can do set account. All right, and say accounts is 0. Since it's an array, we can get the first item. And then we can do console log, account. Okay, and that'll actually read it from the state. So now we can prove that we can read it and write it from the state. So let's kill that. Back to our tab here. And now we can see, well, hold on a second. Let's do that. Let's just log it as account 0 first. All right, we'll read it in a different context in a minute. All right, good enough for now. Good enough for now. Well, let's actually create a component where we can use this account. So now we'll show you how to render another component onto the page and then use this information inside of there. So what we're going to do is take this navigation.js and build this out to actually handle the component and actually render the account on the page. So inside navigation, what we're going to do is we're going to sketch out some user interface here. All right. So basically, you can grab this in the final code solution below if you want to, but I'm just going to quickly sketch out some HTML inside of here. All right. So I've added some basic HTML for this navigation component. Okay. So we put a return inside of here for this function, and we've added a nav here. Okay. Inside there's an unordered list, UL, what's called nav links for buy, sell, rent. Okay. And then this div here that is the branding. So it's got the logo pulled in. We've got that here. We have Milo as a site title. And then we have this button here that's going to show the account. So let's go ahead and render that component onto the page. Then we'll pass in the real account in a second. Okay. So up here inside of inside the app.js, we're going to just below this div, we imported navigation right here. And so we're going to render it onto the page. We'll just say navigation, and we'll do a closing tag like this. All right. And let's go look at our page again. And then boom, there we go. We can see we've got buy, sell, rent. We've got Milo as a brand in the middle. And then this button with our account inside of it, but it's not the real account. So that's just a placeholder. Let's actually fetch the real account. So what we'll do, we'll take this account here that we have requested, and instead of doing it here inside of load blockchain data, let's actually do it inside of our component, okay? So we're going to go to our navigation, and we're going to do this. And instead of just doing it automatically, we're going to have a button that lets us, connect to the account. So what we're going to do is we're going to use this here, this account and set account. We're going to pass them in to the component like this. We'll say account equals account and then set account like this. All right. And we're going to take all this out. All right. And then we're going to create a function called connect handler. And we're going to put it inside of here. And it's going to do the exact same thing. It's say accounts await window Ethereum request, get accounts. And we're going to set the account to the first account in the list. And then that's going to set it in the component state of the parent component. And we're going to pass it back in here with this account like this. All right. And whenever that finishes, we're going to render it onto the page. Now, we only want to do that if the account exists and we want to have a button that calls this connect handler. So I'm going to take this out and then I'm going to do this. Okay. So basically, this is going to be a conditional inside JavaScript that says if the account exists, show the account on the page and let's truncate it. All right. We're just going to slice out the first few characters of it, use an ellipsis, and then do the last several characters of it. And but if it doesn't exist yet, we're going to let you connect to MetaMask. So you're going to click this button. All right, it's going to click the connect handler on click, and then it's going to load the account, save it to the component state here. It's going to pass it back down to the component, and it's going to show it on the page right here. Okay. So let's do that. Refresh the page, and then there's no account connected, but we have MetaMask installed, so we can just click connect, and boom, it will load the account, and you can see the first several characters of your account from MetaMask, just like they show you in the MetaMask UI with some dots in the middle, okay, and the last characters, and that matches the exact, format there. All right, so now that we have loaded the account into the Navbar, I want to do one more thing here, which is I want to change and update the page if you change your account inside MetaMask. That's one of the reasons we're storing the account here in the app level. So I'm going to do this inside load blockchain data. The last thing is going to be this. So it's a window.ethereum on accounts changed, okay, and pass in a function here. We're going to refetch the accounts just like we did, and then we're going to get the account and set account here, okay. So I'll pause that if you want to make sure that you've got the same code. All right, so basically you can see what that does is, we've connected, click connect. If we go to accounts inside of MetaMask, we go to Hardhat, hat1, and we click 1. All right, it'll automatically show the new account here. And then we can go back to our Hardhat 0. Okay, and then it will go back 226. Awesome. All right, so now that we are, done with the account section and the header, let's go ahead and look at our mock-up for our finished projects. We've got this part done. Now let's go ahead and add this search bar inside of there. So that's gonna be pretty straightforward. We already have a search component inside of here. All right, so this search.js. So really, this is just a placeholder for now, okay? This is kind of just a proof of concept mock-up, so we're not really gonna do any searching, but it's just gonna make it look like Zillow, okay? So you could add searching features here if you wanted to, but for now, we're just gonna add the search bar like this. Basically, just below navigation, we're just gonna type in search. Oops, search. I'm gonna close that. Okay, save it. And then, boom, there you go. Now, if I close this, it'll actually format correctly. But if I, load up the page, it's gonna overlap. That's okay. We'll just do that for now. So now we've got this implemented. And then finally, let's go ahead and scaffold out this section where we just show the homes on the page, okay? We're gonna go here and just create this div cards section, or I'd say welcome to Millo. We can take out the exclamation point from earlier. Okay. Let's, instead of saying welcome to Millo, let's say homes for you. All right, we'll do a horizontal roll here. Okay. And then we're going to have a div here. Div class name equals cards. And then inside of here, we'll just do this. We'll say div class name equals card. Okay. And then inside of here, we'll do a div. That is the card image. Okay. Close that div. And inside of that, we'll do an actual image tag. Sorry. Okay. And then we'll just give it an alt home. Okay, well, source, we'll just leave blank for now. And then we'll do a div. We'll say class name. It's going to equal card underscore info, 2 underscores. We'll give it a h4. And we'll just say, this will be the price. We'll say 1 ETH. We're going to hard code this. We'll change it later. Okay. Then we'll give it the attributes. Give it a paragraph tag. Okay. And then we'll give it a strong. Give it 3. And we'll just say, this would be like 1, 2, 3. And we'll do space, beds. Okay. And then bath. And then square feet. Okay. And then finally give it the address. We'll say 1, 2, 3, 4 Elm Street. All right. So that should be the placeholder. Okay, awesome. So we got one home there, just a placeholder. We could copy and paste this a couple times to show some homes there. But now we're getting a lot closer to our mock-up, okay? So we've got the nav bar here. We've got the search bar. We've got the placeholder for the homes section. Now let's actually wire up the smart contracts so we start listing the homes out on the page. All right, so now let's list the homes out on the page. What we're going to do is connect to the blockchain and get to the smart contracts and load them up into our app, okay? We've got the necessary pieces already. We've got the ABI. We've got the address from the config file. So let's connect to the blockchain like this. First of all, we want to, we've got the provider from Ethers. So we also want to create a hook to set the provider. So just above account, we can do provider and set provider as use state null. And we can say set provider. And then pass in provider, okay? And then next we can get the network, const network. We want to tell it what network we're connected to. In this case, it's Hardhat. So that's the network ID that you see here inside your config file. So config here, this is the network ID. So different blockchain networks have different IDs, like the Ethereum mainnet's 1, like Arinkeby, I think is like 4, et cetera, et cetera. So Hardhat's that one, 33, whatever. So we get the network like this, await provider, get network, okay? And we want to save that, okay? And then use it, save as the variable. We'll use it when we read the contract. So we want to get basically we want to get the network because we want to find where the contract's deployed with this config file. So this config.json's got our address. We want to fetch this based on this network. We can get the address for the real estate contract, okay? So, like the, basically we can read the config file already like this. So we can say like config, and then pass in network ID, .chain ID, okay? And then get the escrow address, the same thing for the NFT address. Okay, .real estate address. So these are the two addresses, and we can console log those. You can just console log these so you can see that they're there. Let's just comment these out for a second. You can see that they're logged to the console. So I pulled those straight out of our config file. Those are our smart contract addresses that are deployed to the chain. Okay. So let's actually create, JavaScript versions of this with Ethers.js. So we can do that with Ethers like this. We can say new Ethers contract, capital C. And we can pass in the address for real estate. So we'll just copy this, put it in here. We need the address. We need the smart contract ABI. Okay, so we have that right here from the real estate ABI. Again, we pulled this in from our ABIs right here, real estate.json. So we take this, we paste it here. And then finally, we give it the Ethers provider, which we did here. Okay, and then we just say const escrow. No, this is real estate, excuse me. Okay, I'll move this over so you can see it. And now we're able to actually get that as a JavaScript version of the contract so we can call its function. So the first thing we want to do is get the total supply of the homes, okay? So we can do that like this. We can just say const total supply equals await real estate total supply. And then let's just go ahead and console log that. It's going to tell us how many homes are in existence. Okay, so you can see this number here. Let's just do toString. All right, so there's 3. There's 3 total homes that we can list. All right. And so now what we want to do is load the escrow contract. Okay, so we've got the real estate contract. Let's do a JavaScript version of the escrow contract. 2 smart contracts in this situation. So we'll do this, say const escrow. So Ethers contract config network chain ID, this one, escrow address. And then we'll pull in the escrow ABI right here. Okay. And then this time we're actually going to save it to our state as well. So just below provider and set provider, we'll do escrow set escrow equals useState null. And then we'll load the escrow contract and do set escrow. Okay. All right. So now we've loaded both smart contracts. Let's just go to our page and make sure everything's still working. Yep, we're good. Don't worry about this right now. It's still working. So now what we want to do is list out all the homes on the page. Okay. So we have loaded the real estate, loaded total supply. And what we want to do is basically store all the homes so we can list them out on a page right here. So basically we're going to say, const homes. We're going to load them into an array. All right. So because we're stored, let's see, real estate. Because we basically have stored our NFTs inside of a mapping, we can't get them all. So we need to figure out how many there are and then loop through all the NFTs and fetch them out one by one. So we have the total supply, which we saved here. So basically we can say, we know there's 3 NFTs, ID of 1, 2, 3. So we can loop through those numbers 1, 2, 3 and fetch each NFT out individually and save them inside this array. So we're going to do that with a for loop inside JavaScript. So basically we're going to say for var I equal to 1. And then as long as it's less than or equal to total supply, we'll keep looping and then we'll increment by 1 each time after. So what we'll do is basically, we'll say const URI equals await real estate token URI. For I, this will be, number 1, the first time this runs, number 2, the second time it runs. We'll fetch the URI, okay? And then we'll get the metadata. So we'll get the response metadata from IPFS. And then we will push that into our homes array and we'll populate this for all the homes. And then finally, we'll set the homes with a useState hook, just like this. All right. And then we'll do set homes right here. Set homes, okay. And then now we can do console log homes to see if they've all been loaded. All right. So if I go back to the page, you can see here that there's an array, 3 different homes with all of the metadata. All right. So you can see here's home number 1, the address, got the attributes, got the description, luxury penthouse, heart of NYC, ID 1, IPFS, luxury penthouse, okay, et cetera, et cetera. All right. So we've actually successfully loaded this from the blockchain. So now what we want to do is loop through all these homes and put them on the page right here. So we've got all this loaded up. Let's take out the console log. All right. And down here, let's loop through them all. So underneath this cards, let's evaluate JavaScript inside of here with curly braces. So that's the cool thing about React is you can mix JavaScript and HTML in the same place. You can see we've done that here, but now we're going to evaluate JavaScript here. We're going to say homes.map. So map is a function inside JavaScript that lets us loop over the array. We're going to access each home like this, and then also the index, which is basically just the position inside the array. Okay. And we're going to render all this content onto the page. So we're going to take everything inside this card. Okay. Take that out and we're going to put it here. All right. And then we're going to essentially give each home a unique key. React requires that. So we'll say key equals index. All right. And now that's just going to show us 3 of these cards on the page with no data, no special data, but it's going to show 3 of them. All right. So let's kill this. Wait for it to load. It might take a second for it to load for you. Give it just 1 second here. All right, so I realized I made a mistake here. It's a subtle thing in JavaScript. We need to make this a parenthesis instead of a curly brace, because that's going to have an implicit return value. So let's just do that here. All right, so just convert that to a parenthesis and this to a closed parenthesis. So let's save that. Let's go back to our page here, and then boom, there you go. Awesome. So now we actually see 3 different cards rendered onto the page. Yeah, I was saying wait, don't wait around forever. That was my mistake. Yeah, I just had to change that little thing in JavaScript. Okay. So now let's actually fill in each of these homes individually to show the real home attributes. Like this is just hard-coded stuff here. But we are actually, rendering 3 homes. We just need to fill in all their data. Okay. So let's go to the image. So for source, we can do home.image. All right. And then boom, there you go. We see 3 different pictures of the properties we want to buy here. Okay. We can do for the price. Let's do curly braces here and say home.attributes. And then we say 0.value. Okay. And then boom, there we go. Say 20 ETH, 15 ETH, 10 ETH. All right. So that's working. Let's do for beds, we can do this same type of thing. Let's just copy this, paste it here, and then let's say attributes 2 value. All right, now we see 2 beds. Same thing. Let's just copy this here. And we'll change this to 3 and then 4. All right, now we can see these as unique values. So 2 beds, 3 bath, 4 beds, 4 bath, 3 beds, 3 bath, and the square footage is unique for each one of them. Now, finally, let's get the address, okay? So we'll just take this out and do home.address. All right, so boom, now you can see the unique address for each one. Okay, so we are pretty much finished in terms of the initial layout. So you can see, here's the mock-up, here's this. We got one discrepancy here. We need to capitalize for you so that it looks the same. For you. All right, so now it's looking the exact same as our mock-up. Slight sizing difference because this is a screenshot and this is a real website. Okay. But yeah, awesome. So now let's move on to actually finalizing the purchase and all that stuff. So what we're going to do is click on each of these properties. It's going to pull up a special tab for us to actually do the purchase. So let's go ahead and knock that out right now. All right, so now let's go ahead and work on purchasing the home. So the first thing we want to do is click on one of these homes, okay, and then have a pop-up that shows the home so we can go through the purchase, okay. So let's do that first. Let's click on a home, make a pop-up up here. So what we're going to do in order to make that happen is we're going to use an on-click handler. So inside of this card here, we're going to say on-click, okay, and then we say equals this, and then we're going to do this. Say toggle prop, and then we'll give it the home. Okay, so this is not a function yet. Let's create it. So up here, we're going to say const toggle prop. We'll pass in the home. All right. And then we're just going to say console log home for now. So let's just make sure it's talking to it. All right, let's click on a home and boom, it'll show us the home. So now what we want to do is actually have a special property inside of our a special state that tells us whether this is, open or not. So the first thing we're going to do is use a React hook, okay, to set the individual homes. We have set homes and homes here, but now we're going to do singular. So we're going to say home and then set home. All right. So what we're going to do here is basically just say set home. All right, and then we're going to have a toggle, which basically is going to toggle the component, whether it's open or not. And so we'll say, it's below home, we'll say toggle and set toggle, use state false, okay? And inside of here, we're going to say, if toggle, question mark, say set toggle, false, otherwise set toggle, true, okay? And then down here, what we're going to do is check to see if the toggle is active. So we'll say toggle, question mark, and this, and we'll just render home. Okay. And we already have this home component imported here. All right. And now you can see components home.js. We have a placeholder for the home right here. Okay. So let's go back here. And we already got a problem here. That was my fault. I'll take this question mark away. That's my fault. I made a stupid mistake. All right, let's do that. And then let's close this. And let's click on home. And now we can see this overlay has popped up. All right. And a home should appear. Now, it's not doing anything yet. That's okay. We can see our screen kind of goes dark. It actually is popping it up. We just haven't filled out any of the HTML inside this home component yet. All right. So you can see this home function accepts some different arguments, like the home itself, the Ethers provider, the escrow contract, and the toggle prop. So let's go ahead and pass those down. All right. So right here, we'll just add those like this. We'll basically just say home, and then, the lowercase home, and provider is provider, and account is account, and then escrow is escrow, and then toggle prop is toggle prop. Okay. And now those should be inside of our component. And so now what we want to do is start filling this thing out. All right, so now inside of here, let's start filling this out. First thing we're going to do is create a new div inside of here. Okay, we call it home details. All right, we'll close this as well. We'll put all the content inside of here. So next, we're going to add basically an image for the home. So we'll do a div for home image. Again, this is going to pick up the CSS we've already written in that CSS file, so you don't spend much time writing CSS yourself. And we're just going to go ahead and add an image tag inside of here with the home.image. Oops, right, this. So we'll just do image, source home.image. So we got home here. Okay, so let's just save that. Go back to our thing. So toggle pop is not defined. Toggle prop, sorry. Okay, let me just fix that. So I think I called this prop. This should be pop. Sorry, everybody. Yeah, toggle pop-up, basically. That's all I do. All right, so let's do that. Click on this, and now we can see we have a pop-up that's just got the home image right there. So now we can fill this out even more. Okay, let's go ahead and create a way to close it. All right. So down here, just below the home details, we're going to add this button that basically closes the pop-up. So basically we'll add a button down here like this. That basically just says, button toggle pop. Once we click it, it'll make it go away. And we can have an image here that just says close. Okay. And actually, we want to put this inside the home details as well. Like this. All right, so now we see this X here. And click it, and it goes away. Awesome. And that X is coming from this close, which is just an X that we've saved already inside the project, imported right here. Okay, let's keep going here. Let's figure out some more attributes. So below the home image, we can create a new tab, or new div, excuse me, called home overview. All right, and then we can close that div. And inside of here, we can give it an H1. We can give it the home name. So home.name, save that. Click on home. You can see luxury penthouse. That's working. Fill in some more details, like this. The home, just like we did on the home page. So we can give it a paragraph with some strong attributes, home attributes, 2, 3, 4, beds, bat, square feet. And then we can also give it the home address and a paragraph below that. And then just below that, we can give it the H2 for the ETH value. All right, so boom, there we go. We can see some description here. Luxury penthouse, 2 beds, 3 bath, 2,200 square feet, address, 20 ETH purchase price. Okay. Now we can let's give it a button to buy. Okay. So we're going to change this in a minute, but now we're just going to give it another div here. Right here, let's give it a div. I'll give it this button. Okay. So this button will basically just be the buy button for the, oops, sorry, home. Take out all this stuff. We're not going to do any on clicks yet. Okay. We'll just give it a basic button. All right. We're going to change this in a minute. So I'm going to give some space. That's obvious. We'll just give it a div, home buy. All right, you can save that. And then now you can see this buy button comes up where we'll click it and we'll actually do the purchase in MetaMask. Okay. And then we'll have a button here to contact agent, you know, just like you'd see on Zillow or something. By contact agent. And then we'll give it a horizontal rule and another H2 for overview. And then we'll give it the home description like this. Home.description. And we'll give it another horizontal rule. And we'll give it like facts and features. Okay, we'll fill those in a second, but let's just take a look at what we're doing here. Yeah, it's gonna look better. Luxury penthouse, buy, contact agent, overview, luxury penthouse located in the heart of NYC, facts and features. Let's give it an owner list here. So we'll say UL. And basically we'll map over each of the home attributes and add a list item like this. Okay. But basically we'll just do that in one go. We'll say home attributes, map attribute index. We'll give it an LI, key index, strong attribute trait type, and then attribute value. That's from the NFT metadata. All right. Boom, there you go. Facts and features, purchase price, type of residence, condo, beds, bath, square feet, year built. Okay. All the metadata you want to see on a Zillow property. Okay. So you can click buy, contact agent, overview, all the details you want to know. Okay, so now we have successfully wired that up for each property. You can see how those values change for each one. Now let's actually facilitate the purchasing behavior. Okay, so now for the complicated part, we essentially want, the different accounts with their MetaMask to come here and approve the transaction. So like the buyer's going to click the buy button, right? But the lender can come in here and fund it on the same website. The inspector can, sign their approval on the same website, all in one place with their MetaMask wallet. So in order to do that, we want to contextually show a different button here based on who's connected, okay? So the first step in that process is fetching the different accounts from the smart contract to determine what we want to show you if you're the buyer, seller, lender, inspector, all that type of stuff. So let's go ahead and create a function to fetch those values from the blockchain. Okay, so above the return function, or return right here, we're going to do const fetch details. Okay. And inside of there, we're going to get the buyer. Okay. So we're going to get the buyer's address like this. Basically, we're going to say const buyer equals await escrow buyer home ID. And this will return the Ethereum address. Because again, we did that inside the smart contract. Let me just show you. You can see, we have the seller address, the inspector, the lender, and the buyer in the mapping here. Okay. So the buyer's listed inside that mapping. So essentially we can just go here and do escrow buyer and then pass in the home ID and it'll tell you the buyer address. Okay. And then we want to save that to the component state. So we'll say buyer set buyer from use state. Okay. And also we want to also store the lender. So we'll do that there. Lender, set lender, inspector, set inspector, and seller, and then set seller. Okay, and we'll populate those right now. So we'll do the same thing here. We'll basically, do the same thing for the seller. So we'll do buyer. Also, we need to set the buyer like this. So buyer, seller, set seller. And we'll do lender, set lender. And then we'll do inspector, set inspector. Okay. And if you remember, we did all those in our deployment script here. So you can go to scripts, deploy, and you can see which account. So buyers account 0, account 1, account 2, account 3. And we save all those here. Okay. Let's go back to our site, refresh just to be double safe, and then no errors. Okay, nothing in the console. We have the same error from before. Don't worry about this. Code should be still working just fine. Okay, so another thing we want to do is we want to keep track of each of these people's actions. Okay, so basically we want to see if the buyers actually bought. Okay, so what we're going to do is do like this for the buyer. We're going to say, const has bought, await escrow approval, home ID, and the buyer. And we want to set that value. So we're going to say at the top, say has bought. Okay. And then we're going to say set has bought right here. All right. And then we're going to do the same thing for the lending, same thing for inspection, and same thing for selling. Okay. So do that for here. Has lended, set has lended. And then has inspected, set has inspected. And then has sold, set has sold. All right. And then we'll update all those for after the seller. We'll say has sold equals await escrow approval, home ID, seller. And then has lended, basically, we'll go here. Has lended, escrow approval, home ID, lender. And then inspector. All right. Has inspected, inspection passed, home ID, set inspection passed. Now, finally, we're going to fetch the homeowner so we can keep the status of that. Basically, going to do const fetch owner. All right. And inside of here, we're basically going to say const owner equals await escrow buyer and get it for the home ID. All right. And then we're also going to set the owner up here. Okay. So we'll have owner, set owner. And then we'll update the owner right here. Okay. And then one other safeguard condition we're going to do inside of here, basically, we want to make sure that the home is listed. All right. So we're going to return if that's the case. All right. And now finally, we want to call these two functions. So we've done fetch details and then fetch owner. We want to use effect. All right. And we want to call those two functions. Fetch details and fetch owner. And then we also want to detect is has sold changed. Okay. Which is here. And if has sold is changed, we want to fetch all this stuff over again. That's what this does. If this variable changes, then it'll recall these functions on use effect. All right, so now that we have loaded up all that information, we can show a different value here based on who's connected with MetaMask and what they should be doing in the transactions. Like if you're the lender, you can see like a lend button here, like approve and lend, approve inspection, all that type of stuff. So let's go ahead and make that contextual. All right, we'll go back to our code here. And right here where we see this buy button and contact agent, okay, we'll do this, all right? So basically we're gonna evaluate JavaScript inside of here. We're gonna say owner. Oops, sorry, not oner. Owner, question mark. All right. And then we'll give this a conditional. So that'll be the first condition, second condition. All right. So we'll break this up in multiple lines. So if they're the owner, we'll do this. Otherwise, we'll do this. Okay. So if they're the owner, we're going to give it this div. All right. Owned. Okay. And then basically we'll say, oops, sorry. Inside this div, we'll say, owned by this owner, right? We'll slice the address and display on the page. Okay. And then otherwise, in this other condition here, we're going to add a new div. Okay. And now we're going to see if the account is equal to the inspector, question mark. If that's the case, then we'll do this. I'm sorry. Okay. And we can do like, yes, if not. So if they're an inspector, we'll do this. All right. And then basically, otherwise we'll say, account equals lender, question mark. All right, and do a new condition here. All right. Oops, sorry. And then we can do another thing here and say account equals seller, question mark. And say, and if not, otherwise, we'll just do this condition. So now we can detect if it's the inspector, if it's the lender, if it's the seller, and everybody else will show, we'll show this buy button. So let's go ahead and take that buy button, and then let's put it inside of here. Okay. And then we'll put the contact agent here, take this out, get this div away. So just below this. Nest that inside of there. Okay. So if it's none of these accounts, we'll show the buy button. Now, if it's the inspector, okay, we want to have a button here that says approve inspection. Okay. If it's the lender, we'll say approve and lend. All right. If it's the seller, we'll say approve and sell. All right. So now let's go check our page, make sure nothing's broken. So account is not defined. Okay, so let's get the account here. So we need to pull it from up here. Basically, we need to make sure we're passing in the account here. So we'll do account at the top, component, home, provider, account, escrow, toggle pop. And then the same thing here, home, provider, account, escrow, toggle pop. All right. So now let's go back to our page. So we misspelled account on line 98. Let's fix that. All right. And then now it should work. Okay. So now we can see that we have the buy button. Okay. So let's look at our deployment script. So the first count in the list is a buyer, so they should be able to buy the property. That's fine. Second account should be the list, should be the seller. All right. So if you go to MetaMask and then go to Hardhat 0 or Hardhat 1, click on that. You can see it changed to approve and sell. Hardhat 3 or Hardhat 2. We can now see approve inspection as the inspector, and then Hardhat 3. approve and lend. All right. Hardhat 4 is let's connect, and then you can see it's buy. Okay, so basically every single account that is listed, the button is now contextual. Okay, awesome. All right, so now what we want to do is click these buttons with each individual MetaMask account to process the transaction. So again, we have to go through this to essentially, do every single step in the real estate transaction. So I'll pull this up on my whiteboard here. Again, we need to basically act as multiple different accounts, essentially to fund the deal, approve the inspection, approve it as the buyer and the seller, and then, in the smart contract, actually facilitate the purchase and transfer of the funds and also the NFT for the real estate. So let's do that. Basically, we want to click a button for the inspector, click a button for the buyer, for the lender, click a button for the seller, okay, and then click a button for the buyer. So we want to create some functions up here. So just below this, I'm going to drop these in. So we'll do a buy handler, an inspection handler, a lend handler, and a sell handler, okay. So I'll stop my screen there right there if you want to copy those down. And then now what we want to do is call each of those respectively, all right, down inside of the thing. So for this one, for the inspector, the button here, we want to say, on click, and we want to do inspect handler. I'm going to call that function. And also we want to disable this button if the inspection's already happened. So we'll say disabled. We'll say has inspected. Okay, so we're going to use this in our state up here. Okay, so we've got that for each different property. So I'm going to copy these and put them on each of these. All right, we're going to change that. So for lender, we'll say lend handler. Oops, lend handler, and then also has lended. And for sell handler, then has sold. And then inspect handler, or sell handler. Oh, sorry, buy handler, my fault. And then has bought. So now when we click these things, they should be firing off the functions, okay? So now we need to actually wire these functions up to do each phase in the transaction, okay? So for buying, what we're gonna do is basically do all the calculations underneath the hood. Basically say const escrow amount equals await escrow amount, home ID. So we're gonna see how much we need to do. And the buyer's basically gonna deposit the earnest money directly into the contract and approve the transaction. So it'll be two transactions. So the first thing we wanna do is get the signer, all right, from the buyer. Basically, signer equals await provider gets signer, all right? That's the current account we're connected with MetaMask. We'll let them deposit the earnest money first, okay? So basically, they deposit earnest like this. Transaction equals await escrow connect signer, deposit earnest, home ID, and the value in that transaction is going to be the escrow amount, which we fetch from the contract. They'll send that to the MetaMask wallet when we do the transaction wait, and then they'll call a second transaction, which is the approval step. So they'll approve the transaction, say await escrow connect signer approve sale, and then home ID transaction wait. All right, so I'm going to format this. I'll bump these over actually. All right. And then finally, we just want to set has bought to true so that it disables the button when they buy. Okay. So the same thing for inspection handler. Basically, we're going to do a similar process. We're going to get the signer, which is the first account from MetaMask. Okay. All right. And we're going to update the status like this. Basically, we're going to say transaction equals await escrow connect signer, update inspection status. And then we're going to set has inspected true. All right. And then we're going to do the same thing for the lender. Basically, we're going to get the signer. consigner equals await provider get signer. And they'll approve the transaction first, okay? So just like we did the approval here, it was a lender approves, transaction was await, escrow connect signer approves sale. And then they're actually going to send in the funds for the funding the deal. Like this. Say we get the amount, lend amount is escrow purchase price minus the escrow amount. All right, so basically we say how much did the buyer put down and what's the home purchase price. We factor in the difference, and then they actually send Ether directly to the escrow contract with this amount. And we say set has lended true. All right. And then finally for the sell handler, I'll just pause that in case you want to see it. Hold on. All right. And then finally for the sell handler, we'll do a very similar process. We'll get the signer. The seller will approve the transaction. All right. And the seller will actually do the finalizing the sale. So they will actually facilitate the transferring of the NFT to the owner and new owner, and then they will get the funds into their wallet, and we'll say it has sold to true. Okay, so I'll pause that if you want to see that as well. All right, so let's go through it. All right. So right now, we can see, let's go ahead and change the owner. So let's go look at our accounts in MetaMask, and let's look at the deploy script. So the current owner should be the seller, so it should be account 2. Okay, so if we go here, let's go ahead and switch that account. So the Hardhat 1. All right. Oops, sorry. Okay, so actually the NFT contract currently owns it, so we're not going to see that right now, so my fault. Well, we'll see that update after the NFT has been sold to the new owner. So let's go back to the buyer account. So we'll just make that Hardhat account 0. Okay. And let's go through each step. So we'll be the buyer of the account 0, click buy. All right. Let's, it'll ask us to deposit 10 ETH for Earnest, click confirm. And then next transaction will pop up to do the approval, confirm. And then we should see success inside of our Hardhat account. Okay, approved sale, contract interaction, awesome. So now let's go to the next account, which is going to be, you'll see here, we've done buy, let's do inspection. So let's look at our employer address. So inspector is the third account, so 0, 1, 2. Do this. 0, 1, 2. All right, let's see approve inspection. Click confirm. Well, let's make sure that was green. All right, contract interaction done. Now let's go to the lender. So 0, 1, 2, 3. All right, so approve and lend. Let's approve first. All right, confirm. And then second transaction comes up. This will be fund 10 ETH. All right, so both those were successful. And then let's finally go to the seller account. Hardhat 1. All right, approve and sell, 2 transactions. First transaction to approve. All right, and second transaction to finalize the sale and transfer the ownership. All right, boom, done. Now we can see that the transaction has taken place, and now it is owned by this new account. So we can go to our account here and make sure that this is the right one. And we can see that 2266 has now the address. It's owned by that. So we have the NFT. Our balance has gone down, and we can check the seller account. Received the Ether. So yeah, the seller received the Ether for the sale. So boom, we've done it. We've successfully done a real estate transaction on the blockchain with smart contracts with cryptocurrency. So that brings us to the end of our tutorial here. So I hope you like this video. Of course, there's a lot of things you can do to improve upon this. You could add searching functionality. You could, deploy this project out to a test network. You could deploy the website live to the web so that other people can do this. But this gives you an idea of the power of smart contracts and how you can completely automate this process with blockchain. So we're going to create an e-commerce website inspired by Amazon.com called Dappazon, okay, where you can list products on the blockchain and people can purchase them with cryptocurrency. So you'll be able to connect your wallet with MetaMask. You'll be able to view a product, click Buy Now, and that will create an order for the merchant to fulfill, and they can deliver it to you on chain. So let's take a quick overview of the architecture we're going to create today. Again, we're going to create a smart contract to handle the marketplace for purchasing things with cryptocurrency and modeling the products, okay? And essentially what's going to happen is a user is going to connect with their browser with a blockchain wallet like MetaMask. They'll have some cryptocurrency in their wallet. They'll connect to our blockchain-based website that we will create in React.js. They'll purchase their product this way because this website will talk directly to a smart contract created in Solidity on the Ethereum blockchain or any other EVM-compatible chain that you want to. And the merchants will receive the Ether that's contributed by the end user, and the smart contract will create each individual product order that needs to be fulfilled for the customer here. And another thing I want to mention is that in addition to the blockchain, we're going to be using the interplanetary file system, or IPFS, in this tutorial to host the images. So what does that mean? Well, basically, you see all these different products here that are on the blockchain, and we can transfer the ownership of those products with smart contracts and cryptocurrency. But we have images that are associated with this, like the shoes have a picture of shoes, sunglasses has a picture of the sunglasses that you're going to buy, et cetera, et cetera. So these pictures should not go on the blockchain themselves, okay? It's not really good to store pictures on a blockchain. In some cases, you can't even do it at all. So that's exactly what IPFS is for. This is the Interplanetary File System, which is a file storage protocol, a decentralized file storage protocol that works kind of like a blockchain, but not really. Basically, we'll get into that more in depth as we see this, but essentially that's where the images are going to go. We're going to store a reference to those images on the blockchain inside of our e-commerce smart contract, and we will be able to distribute those orders to individual wallets and let people purchase them that way. All right, so let's go ahead and start coding. I'm going to put a link to this down in the description below. Okay, this is the GitHub repository for the project. So what you're going to want to do is go to this website, copy this link, all right, and go to your terminal and type git clone, all right, then paste in this URL, and you're going to do -b, all right, and then starter code. Actually, let me just make sure that's correct. What I'm doing here is I'm cloning the starter branch. So let's just see, it's called, starter code, which you can see right here. All right, and you're going to hit enter, and we'll do cd, which means change directory, into starter code. Oops, sorry. CD into Dappazon. And so, long answer short is once you're inside of here, you'll be right where you need to in order to start coding. Now, really quickly, let me explain what this is. You can see this starter code thing here. That's because Git supports the idea of branches. If you're just a brand new programmer, you're not understanding how this works. Basically, Git is a version control protocol, and you can create multiple versions of your code with branches. You can see the master branch here is the final code solution. We've got smart contracts inside of there, right? But the starter branch, if you change right here, just has the starter code. It's the final code solution, just with some of the stuff taken out of it, right? So we can create the actual code so that we actually are writing it, right? So here's just a starting template, which we'll see in a minute. Now, you can see what I have here in my terminal. I've got it configured to show you what branch you're on. You can see all your Git branches like this, Git branch. You can see that there's starter code here. We don't actually have the master branch configured locally because we just only cloned the starter code, all right? And then one more thing I want to do before we jump into the code is people tell me all the time they can't push their code to GitHub. Well, that's because you cloned your repository from my repository, and you need to take my repository away from your code. So what I'm going to show you how to do that really quickly. If you type in git remote -v, that's going to show you the link to this repository here. It's what's called the origin repository. So that's the Dapp University GitHub organization, and you're never going to be able to push your code to this thing here. So what you can do is type git remote remove origin, and that will remove that. Type git remote v, you can see that it's gone, and then you'll be able to push to your own GitHub repository later whenever you create a new repository on GitHub and follow those setup instructions. All right, so really quickly, before we get into the actual code itself, let's just make sure that you have all your dependencies installed. The good news is you really only need Node.js to get started. Okay, this is going to let you download all your other dependencies, all right, inside of our package. So just make sure you've got Node.js installed. If you want to see what node version you have, you can go to your terminal and type node-v. All right, I'm using 14.16.0. And so that's what I'm going to use to install my other packages. So we can do that like this. We say npm install. All right, with that to finish. And if you're an experienced developer already, you can use whatever node version you want to understand which is going to be compatible. But if you're brand new and you don't know which node version to use, I highly recommend using the exact same version that I'm using in this tutorial, just to make sure, just to eliminate any possibilities something might be different. All right, so now that that's finished, let's go ahead and open up the code. And I'm going to use Sublime Text. That's my text editor of choice. But you are welcome to use whatever text editor you'd like, as long as it works for you. So I'm going to open up the package.json file first. We'll take a quick tour of everything inside of here. But this is basically what just installs all the dependencies for our project with a few other specifications. So a minute ago, I was talking about how Node.js is really the only system dependency that you need to install. Node.js is what installs all the other project-specific dependencies that you need. Things like Hardhat, which is the smart contract development framework that we'll use for this tutorial. Okay, so you can essentially take a look at that right here. Let's look at Hardhat. So this is a framework for creating Ethereum smart contracts and for other EVM-compatible chains with Solidity. This is what we'll use to create the smart contracts, write the tests, etc., etc. All right, so this is structured like a Hardhat project. Inside of here, you can see the smart contracts directory, so called contracts. This is Dapp is on. This is the first one we'll work on. You can also say a source directory, for the front-end website and React. We'll get to that in a second whenever we start coding at the front end. We're going to do the smart contracts first, then go to the front end. You can see the test for this placeholder here inside of dappizon.js. And so the test directory, this will create the tests for the smart contract. We've got some scripts for deployment, and that's sort of the highlights here. One of the things is the Hardhat configuration file, which is hardhat.config.js. We won't really need to do anything with this, but I just want to let you know that that's there if you need to. All right, one more thing I want to do before we get started is I want you to take this command here, npx hardhat test, and put it into your terminal and see what happens, because you might see an error message that looks like this. Okay, it says it requires all these dependencies to be installed, okay, etc., etc., etc. So if you see this, then just go ahead and do this. It says, it tells you the problem, but it also tells you the solution. It says, please run npm install -s save dev. Okay, so go ahead and just take this and then copy it and then paste it in there. And that should satiate the error. Okay, so wait about it to finish. Let's rerun the test command and see if it passes. And now that's done, let's just try running the test again to see if it works. Okay, all right, it does work. It says 0 passing. That's because there's no tests inside of there, but you just want to see that it's actually responsive to your commands, and before it was not. It was just blowing up and giving you an error message. So I just want to get past that before we get started. Okay, so now let's go ahead and open everything back up into our text editor here. We're going to go ahead and creating these smart contracts for the project. Again, going back to our diagram, these smart contracts is basically going to be the back end for our e-commerce website here. So we're going to have a web browser and the website, which we'll connect to, in the second half of this. But first, we're going to create these smart contracts that way people can, model the products in the blockchain, process the orders, and then distribute those to people one by one. Okay, and also give the proceeds to the the developers or the merchants in this case. Okay. So we're going to create these smart contracts in the Solidity programming language. Again, this is the main programming language for creating Ethereum smart contracts. You can also compile these smart contracts and put them in other EVM-compatible chains like Polygon Binance Smart Chain, etc., etc., any Ethereum layer 2. You can also use Solidity. So the nice thing is it's a high-level language. It's pretty beginner-friendly on the grand scheme of things. It looks a lot like JavaScript or Python. So if you're familiar with either of those languages, you're going to come up to speed pretty quickly with Solidity. And even if you don't know either of those languages, it's pretty beginner-friendly to learn. All right, so let's go ahead and jump in and get started. So I'm going to open up this file here inside of contracts, Dapp is on. And this is going to be the place where we code out the smart contract. We've got a placeholder inside of here, inside of our starter code, so we can get started quickly. So we don't have to create everything from scratch, but we're going to do, everything else step by step. So you create a smart contract like this. You put the programming language version at the top. This is Progma Solidity version 0.8.9 or anything greater than that. That's what this caret means. And then we create a smart contract with this contract keyword. We say contract. We give it any name we want to. We're going to call it Dappazon, all right, just to play on Amazon and Dapps. And then we use these curly braces, open and close curly braces. And then we put all of the code for the smart contract inside these curly braces. Code goes here. All right. And then I use a new line that in my files is a character return as a programming convention. But yeah, so we're going to put all the code for the smart contract inside of these curly braces. All right, so let's go ahead and create a smoke test to make sure that everything's set up properly. So let's go ahead and write our first line of code inside of the contract here. What we're going to do is create a state variable that just stores the name of the smart contract. Okay, so I'll just show you what that is and I'll explain it. I'm going to say string public name equals Dappazon, and then followed by semicolon. So what is this? So this right here is a variable. All right, and it's something called a state variable. So let me just explain the syntax one by one to explain what it is. So what is string here? Well, Solidity is what's called a statically typed programming language, which basically means that anytime that you create something like a variable, you have to tell it what the data type is going to be for that variable, and you can't really change it to a different, type, okay? So the whole idea here is that you're saying that this variable here called name is going to be a string when you create it, and it's only going to stay a string, okay? And so we give it the arbitrary value here, name, all right? But we also give it this visibility, which is called public, which means that you can read the value of this variable outside of the smart contract, let's say on a website, for example, or inside of a test file, which we'll see here in a minute, okay? And then in line, we just assign it to the value of this thing called a string, which in programming is just any collection of characters inside of this, a quotation marks right here, okay? So other possible values might be like an unsigned integer, which is basically just a number without a minus sign in front of it, a positive integer basically, or something like an array, which is a collection of items. It's like an ordered list, okay? But string right here is just what it sounds like. It's just a string of characters. And you can give it human readable things like Dappazon, which we're going to do, which is perfect for name. So anyways, what does it mean to be a state variable as well? So it basically means that this value is written to the blockchain itself. So whenever we put this value, deploy the contract out there, this variable value is going to stay forever on the blockchain, the name Dappazon, unless we change it inside the code. But basically nobody else can change it unless we give it access to. Okay, so let's go ahead and check that. I'm going to go to the test here and open up this file here, dappazon.js. All right. And so what is this? Well, this is a testing file where we can write automated tests for the smart contracts. So if you're not familiar with automated testing, what is that? Well, basically, what we could do, let's say that we want to check the name of this state variable here, Dappazon. We could check that a couple different ways. We could go ahead and deploy this smart contract to a blockchain of some kind, and then connect to that blockchain, maybe in a console in our terminal, and then check to see that the value of name was present, okay? We could, get on a website like remix.ethereum.org and, hand test this in our browser. Either way, you're looking at hand testing. But automated testing, what it does is it lets you write code that checks your code, okay? And that's really helpful as you're creating more and more behavior into the smart contract, because you don't have to keep doing the same things over and over and over and over and over again by hand testing, all right? You write it once in your tests, and then it just checks it every time you run the tests, okay? So a couple quick things I'll say about testing here is that we're going to test in a different programming language called JavaScript, all right? You'll notice we're writing Solidity for the smart contracts, and we're writing tests inside of JavaScript. And the last thing I'll say about testing before we move on here is basically testing is incredibly important in smart contract development because, basically there's a lot of risk whenever you're putting smart contracts out there. They might handle lots of money and you want to make sure they're bug free. And, testing is an important part of that process. Also, smart contract code can't change once you put it on the blockchain. So you really want to make sure that it's right before it goes out there. So anyways, let's write our first test like this. Inside of this Dappazon file, we're going to basically create our first test example. All right. So inside of this, we're going to write all the tests inside of here. We're just going to say it. All right. Has a name. Has a name. And so that it function, we're going to pass another function. All right. We want to make this asynchronous. So async. And so inside of this, what we're going to do is deploy the smart contract like this. We're going to say const Dappazon equals await ethers get contract factory. And I'm going to pass in Dappazon. And then we'll say Dappazon equals, Dappazon.deploy. And that should be capitalized here. It should be capitalized as well. All right. So then what we're going to do is just say expect await Dappazon, lowercase. And I realized this is misspelled as well. Dappazon dot name to equal Dappazon. All right, so let's just run the test and see if that passes. So we'll do npx hardhat test. That's how we run our tests at Hardhat. All right, boom. It passes. Dappazon. It has a name. So let me explain what we did here. So Hardhat test is the name of Hardhat. It's command for running the test. It's going to take whatever files are in here and run the tests. npx lets us execute Hardhat commands from the Hardhat version that's downloaded to our node modules directory that's specified in our package.json file. Okay, you can see that here. That's different from the Hardhat that you might have globally installed with npm. This is the project-specific version. It's really nice because if I specify the Hardhat version inside of here, everybody who's watching this tutorial will be using the exact same version and shouldn't have conflicts. So that's nice. And then let me describe the test a little more, talk about this. So our test is written in something called the Mocha testing framework that comes inside of Hardhat, also the Chai assertion library. So these are how we do things like, write things like should, should be equal, should have, should not be, things like this. These things that read like English. So, expect, await Dappazon name to equal Dappazon. What we're doing is you could have done this, right? You could basically say const name equals await Dappazon name and say expect name, to equal Dappazon. Let's just rerun the test and see if that passes. Yep, it works. So, and then what we did here was we actually fetched a copy of the smart contract with the Ethers.js library. So basically, Ethers is a library that connects your project to a blockchain, all right? So we're going to use this on the front end as well, but we can also use it inside of our Hardhat project. We can use it inside of our tests. So basically, it's connecting our test to the blockchain. It's basically saying, hey, go fetch that smart contract that we're working on here, call it Dappazon, and then deploy a copy of it to this test blockchain that's running in the background, which you actually don't see whenever you're running the test, but it does. And then essentially we can get a name for it, and we can check that this name variable has changed. So we can call it Dappazon1. You can watch the test change. It's going to fail. All right. And then you change it back, save it, and it passes. So that's the advantage of having tests. You can just continually rerun them and check to make sure that your code is doing what it is supposed to do. Okay, so that is a quick smoke test to make sure that everything's set up properly. Let's go ahead and start actually coding for real. So what I want to do now is show you about a constructor function inside Solidity. So this is a function that's run once and only once whenever a contract's deployed to the blockchain. We could say constructor, okay? And then we can basically say, instead of assigning the variable value here, we can basically just say name equals Dappazon. All right, and then we can basically just take this away. And we can assign name right here, name Dappazon. And then we can rerun the test again, make sure it still passes. Yep, still passes. Again, you're seeing the beauty of tests. Anytime we make a code change that's Solidity, we can just rerun that test and it still checks it. So one more thing I want to show you inside the test before we continue on here is how to use before hooks, okay? So basically, we're gonna need to deploy this. We're gonna need to write a lot more test examples than just this, okay? We're gonna write like probably about 12. And so what we want to do is take this code. We don't want to rerun it before every single test. So we're going to create something called a before hook. So we can say before each. And it's a async function. And what this is going to do is going to create some setup steps that are going to run before every single test example that we create. All right. So what we're going to do is basically take this part out and put it here. Okay, so basically this is going to deploy the contract. All right. And then we're going to save this to a variable here. Say let Dappazon. So basically we want to access this variable down here. All right, so we're going to save it right here. So we declare it here, we assign it here, we read it here. Okay. And then we're going to take these tests and organize them into a specific place. So we're going to say describe deployment. All right. And then I'm going to pass this in here. And we're basically going to group our tests by sort of different categories. Okay. So we'll say like describe deployment. We'll describe like listing products. We'll describe, purchasing products, all that type of stuff. But for now, I just want to organize the test a little bit so we can continue on with this. Run npx hardhat tests, and it still passes. So now you can see in the tests here, it also organizes the test with the output. Here is just Dappazon, has a name. So Dappazon describe deployment, it has a name, right? Okay, so we've added this constructor function, and now what I want to do is basically create something called an owner of the smart contract, okay? So what is this owner and what does it mean? Well, basically, the owner of this smart contract is essentially going to be the person who owns the e-commerce marketplace. So you could think about it more like a Shopify store, maybe than Amazon. You could definitely modify this to be more like Amazon, where third-party people could list their markets, a little more decentralized. But this is more like your own e-commerce store where you're going to receive the funds of those purchases, okay? Because people purchase them, like the orders are going to go there. You can also think about a centralized entity where they, give products to third-party merchants if you want to. There'd still be some point of centralization. But anyways, the whole idea is you have an owner here. That's who's going to receive the funds if they withdraw them. And so we can save this basically to a blockchain wallet. So what we're going to do is essentially create an owner here as a state variable. All right, we're going to say address, public, owner. Okay, we're not going to assign it. We're just going to declare it here. So again, we did string right here as a data type for the name. All right, here's a name. But owner, you see, is address data type. So it's going to be a blockchain address, a lot like you see, here inside your MetaMask wallet. So this is, a blockchain address, a Ethereum address. And so that's like what the owner address is going to look like. So we're going to assign the owner here into the constructor. We're going to say owner equals message.sender. All right, so what does that mean? Owner equals message.sender. Well, owner here refers to this owner state variable, okay? Whenever you have a state variable, you can access this value throughout the entire smart contract. So inside of other state variables, you can reference them inside of functions. Constructor is a function here. Whenever we create our own named functions later, like listing product, you'll be able to access the value of the state variables and also update them, okay? So what we're doing is saying that the owner's message.sender, this is the person who's deploying the smart contract to the blockchain. So Solidity has a global variable called message. And anytime that you're making a transaction, you can also see who's sending that transaction, who signed it, and that's the message.sender in this particular case, okay? There's some nuances with that, but that's who it is in this particular case, okay? So that's going to be the person deploying the smart contract to the blockchain. Again, whenever you call this constructor, this is called once and only once whenever the contract's put on the blockchain, and the person deploying it is paying a gas fee, and that's whose wallet we're going to capture here and save it to the owner. So we can track that inside of our test. Basically, we go here into dappsline.js and we say, let's just see here. We're going to say, we need to fetch the deployer address first. So we can do that with Ethers.js. We'll just say set up accounts and say await Ethers.get signers. Okay, so I'm just going to do this. Say console.log. I just want to show you what this is first. All right, so you can see I did a console log that await Ethers get signers. What it's going to do is return a bunch of different objects. And what these are is like 10, I think it's 10, maybe 20 different accounts that are provided by Ethers. Again, whenever we do these tests, you can see that it's going to spin up a blockchain in the background with a bunch of different accounts with fake Ether inside of them. So I'm going to open up a new tab here and show you this NPX Hardhat node. I'm skipping ahead a little bit, but you know, you can run a test blockchain on your computer with like these 20 accounts with like all 10,000 fake Ether in them. Okay, that's the Hardhat development blockchain. You don't have to have that running in order to run the test. I'm pretty sure what Hardhat does is it spins up a virtual copy of that every single time that you run your tests, okay, maybe a lighter weight version, and then gives you these fake accounts like I'm talking about. And you can see that that's what we're doing when we do Ethers.get signers, is we're getting those fake accounts that are in the thing. So we could see how many there are. We could say .length. All right. There's 20. All right. So we can do, it returns an array. So what we can do is basically just say like, hold on. Ethers get signers, const signers. Well, let's do this. We don't want to assign to a variable. We want to break out each individual account. So we just say like deployer. It returns an array, so we can do this inside of JavaScript to assign each individual account. So we're going to go and set up 2 accounts here. So do a deployer and a buyer. Okay, so that'll be the first 2 accounts in the list. And then we can console log deployer, buyer. All right, and we can save those here. Say let deployer, buyer, and then run the tests. All right, so you can see the deployer and the buyer are logged. Now, these are big objects with a bunch of different behavior in them. That's because they're signer objects inside of Ether. You can actually sign transactions with them. In many cases, you're just going to check on the address in your tests. So you can do like, you know, call .address on each of these. And you can see what their addresses are. All right, so 226679C8. Let's see if that's actually the same. No, they're different. But yeah, I think it works basically the same. So anyways, now we saved the deployer and a buyer. Now the whole point of that is to show you that how to set up accounts in here, but we also want to compare this deployer with this owner of the smart contract, which we want to send right here. So basically, we're going to have a new test example like this. So just above name, we're going to do this. So it sets the owner. And we say expect await Dapp is on owner. All right, to equal deployer.address. That's what I was talking about right there, deployer.address. You have to call it deployer.address because it's a entire signer object and you want to get the address off of it. Okay, so it sets the owner. All right, so now we have basically set the contract up. We have created the tests. I'm going to go ahead and take this name thing out of here. We don't really need that in the code. I was just doing that to set things up to show you a simple example. So let's take out this test example. Let's run the test again. All right, so name Dapp is on, It's in the constructor. We need to take that out too. All right. So now we have our test set up. We're ready to continue off coding each individual feature. This should move a lot faster now that we have some understanding on the table. All right, so let's look at the main things we need to create inside this smart contract. We need to list products. All right, list products. We need to buy products. And then we need to withdraw funds from the person who owns the marketplace, okay? So let's start with listing products first, all right? And what I'm gonna do is go ahead and collapse that file tree on the side, that sidebar. And I'm gonna put the tests over here, okay? So that way we can kind of see two things at once. But let's just kind of move this over so that we're not too focused on that. Yep. So let's go ahead and work on listing products. I'm gonna create a function inside Solidity to do this. So we're gonna say function, that's the function keyword. That's different from the constructor function because that's a special function which uses its own special name. But if you wanna create a named function with any arbitrary behavior you want to, you start with the function keyword, you give the name, we're gonna say list, you use these curly braces, okay? Not curly braces, open and close parentheses to put any arguments inside of there, we'll get to that in a second, and then use open and close curly braces, and then the code goes here, all the step-by-step instructions that you want to execute line by line inside of the function goes here. So that's the basics of a named function inside of Solidity like this. So what we're going to do is first of all take some arguments for this function. Basically, someone outside the smart contract is going to call this. So we can give it a visibility for Solidity, just like we had visibility for our state variables. We can also give functions visibility. All right. And we can say public. So basically that means anybody outside the smart contract can call this function instead of it being internal or something like that, where only somebody maybe inside the smart contract could call it. So we want to be able to call it on the website, for example. So inside of here, what we're going to do is list a product, okay? So it's going to take some function arguments inside of here. We'll say an ID, all right? We need to give it the data type, which is uint256. So basically, I'll explain that in a minute, but uint ID, string, memory, name, string, memory, category. Okay. Now, we need to add some more arguments here, and this is getting kind of long. So I'm going to go start breaking this up on multiple lines. You can do that inside Solidity, which is nice. All right. And then that'll make it a lot easier. And we're going to say string memory image. All right. And then uint 256 cost, uint 256 rating, and then uint 56 stock. All right, so let's go through this one by one and explain it. So whenever we're creating a product, okay, we need several different things. The product needs a unique identifier, which is an ID, which in this case is going to be a number. All right, again, inside Solidity, we're talking about a variable. It's statically typed, so you have to give it the data type. Uint 256, what that means is this is an integer, okay? So a number, right, that does not have a minus sign in front of it. So that's what unsigned integer means. So like, -1 is different from 1 because this has a sign in front of it. It's a minus sign. So this is unsigned. There's no sign in front of it. That's what it means. Okay. So it could be 0, it could be 1, it could be blah, 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 all the way up to the maximum allowable value of an unsigned integer of 256 bytes. Okay. So, or bits. So basically, 256 is the largest size. It's a really big number. You probably won't have to worry about it for the sake of this tutorial, but there are different versions like uint 8, 16, 32, etc., etc. So the next is the name. Of course, we want a name for the product. This is a string. We already talked about strings in the beginning. Memory is just the data location. All right, string memory category, or product category. Like, we'll just see, our example here. ID, category like clothing and jewelry, or electronics and gadgets, toys and gaming. All right. Image, of course, is going to be the image URL for the product. Okay. That's why it's a string. So UNT56 is the cost. This will be the cryptocurrency cost, like an Ether, for example. You can see that here. The rating, okay, which is the rating, which you see here, the number of stars. And then the stock, which is basically going to be, are there actually anything in stock? So our website can say it's in stock or it's not. Okay, you can see it ships from Dapp, sold by Dapp. And then buy now will be the functionality that we actually use to make the purchase here in a minute. All right, so now that we have created all the arguments for this, whenever we list a product, we can call this list function and pass in all these different, pieces of information. We need a place to save that information and also model it. So how do you model a product on a blockchain? Right? What do you use to do that? Well, the cool thing is Solidity has something called structs, which lets you create your own arbitrary data types. Again, Solidity is a statically typed programming language. It's got all these built-in types like, string, unt256. But you can also just do this. You can just say struct, which is a keyword, and say item, all right? And then you can create your own arbitrary data type, which is not native to Solidity. So that's what an arbitrary struct is. It's just this data structure. So basically, arbitrary, data structure. So basically, uint256 ID, which give it some attributes, exactly what we're saying here. String name, all right, so on and so forth. I'm just going to go ahead and speed this up, so I'm not typing them all out one by one. And then like this. So ID, name, category, image, cost, rating, and stock. And I'll go ahead and stop that there in case you want to pause the video and copy that down. All right. So we can basically take all these parameters that we passed in and add them to this struct. We'll create a new one like this. So first of all, this defines the struct and the structure of the struct, and it's horribly confusing. But this just defines what the struct looks like. It doesn't actually create one. So we can create a struct right here. So there will be a couple of different things: create, product, struct, or item struct. And then next we need to save item struct. All right. So that's two steps. One is take these arguments and construct a struct, create a struct. And then step two will be save the struct, save item struct to blockchain. All right. So we create an item struct like this. So now that we've defined it up here, we can basically just say item. All right. So first of all, we do like this: item, memory, item equals item. And then we can pass in all of these things right here, like ID, name, category, image, cost, rating, stock. Okay. So let me explain this code. Now, first of all, let me go ahead and break it up onto multiple lines here. Well, this is fine for now. We'll do that in a second. So again, inside of Solidity, you see this here, like we created a variable, okay? We said address public owner. We declared the variable here inside the smart contract, and then we assigned the variable in line like this to message sender. Now, anytime you're doing something, before we had, you could say like, string public or string, name equals foobar, right? Inside Solidity, the whole point is you're basically giving the data type, the name of the variable, and then you're assigning it to something here. Okay, so we're doing the exact same thing. The type in this case is item. All right, we created an item data type with the struct keyword here. So we're going to create a new variable called item, and it's an item type because that's what we defined here. And then memory is just the location of the information of the data here. So item, memory, item equals, and this is how you create the new item. All right, so this is assigning it to a variable, but this is actually instantiating a new item, creating a new one. So you just do item by open and close parentheses, and then you pass in all of the attributes that you need, which we defined here, like ID, name, category, image, cost, rating, stock. ID, name, category, image, cost, rating, stock, which are passed in from the variables here. We just pass them directly down into this item that we created, save it to a variable, okay? So I'm just going to break this up on some new lines just to format it. All right. So that's step one, is to create the item struct. Now we can save the item struct to the blockchain. So this just creates it in memory inside the function. We haven't saved to the blockchain yet. How do you actually save it to the blockchain? Well, we're going to use something called a mapping to do this. All right. So let me just pull up something really quickly that'll help explain this. All right, so mapping is something that's Solidity that works as a key value store, which I'll put this up on the screen. We'll reference this here in a second. All right. So let me just show you the code syntax and we'll explain what it does. Up at the top of our file here, we're going to do this. Just below this item struct, we're going to say mapping uint256 item, then public items. Okay. So this is a mapping. Mapping is data structure inside Solidity that basically lets us treat the blockchain like a database. So I'll explain what that means. So mapping lets us save key value pairs on the blockchain. So what is that? Well, you can see an example of a key value pair here. Basically, you have something where you have a key, which is a unique identifier, and then a value, which corresponds to one and only one key. All right. So the whole idea, it's the idea of a unique key. So in this case, you have K1 corresponds to value A, B, C, et cetera, et cetera. K2, A, A, B, B. K3, A, A, D, D. All right, K4. Okay. So you can think about this like a traditional database. If you come from another programming background where you have a unique identifier in the database, like, record number 1, and then you say, hey, go find record with the ID of number 1, and it returns a unique record. So that's like what we're doing here. Basically, we're saying mapping, and then that's going to create a new mapping. Here's the key. We give it the data type of the key, which is uint256. It's just a number that's not negative. All right. And then we give it the value is going to be an item. So basically, this is going to let us save an item to the blockchain inside this mapping, and each item is going to get a unique ID here with the key so that we can put it in the mapping and also retrieve it from the mapping later. So then we save that to a public state variable called items so that we can access the value of this, from outside the smart contract and do things like display the products on our website, for example, and also read them inside the tests. So that's how we're going to save this item struct to the blockchain. So how do we do that? What's the syntax for that? Basically, you just say items, and you add a new item to a mapping like this. This is the items mapping. It's the keyword, the variable name items. All right. And then we just say ID. All right. It's going to be the ID of the new product that we've listed. You just pass it in here. And then we say equals the item that we just saved here to the variable. It's pretty simple. All right, that's it. You just use the open, close brackets, pass in the ID, and then assign it with the equal sign, and then pass the item that you did here. Okay. All right, so that should be enough to write some tests to check for this behavior. Then we'll add a couple more things. Okay. So, inside the test, what we're going to do is I'm going to copy this, describes deployment. Say describes listing. All right. And then as I say, sets the owner, I'll say it returns item attributes. Okay, we'll take this off here. And then I'm also going to take this before each up here. I'm going to copy it. I'm going to put it inside of here. Okay. And I'm going to take all this stuff out. I just want a new before each inside of here. Because what I'm going to do is call the function for listing inside of here, and then we'll write multiple test examples that check for the behavior afterwards. So I'm going to say let transaction like this. And then in order to call the this, I'm basically going to say await Dapp is on. Connect employer list, call the list function. And then we're going to need to give it some different variables. So let's just do this here. Let's say ID is 1. You can see him here, name, we'll call it shoes. All right, let's say category is clothing. All right, let's say image. Let's just call it image for now. Cost, let's just call it 1 for now. Rating 4, stock 5. Okay, we're going to change some of this stuff, right? But then essentially inside of here, we're going to check for that. After we do that, we're going to say, let's see here. Await transaction wait. All right. So we got a transaction here, and we'll say const transaction. Well, no, it's just transaction. All right. And then in the return item attributes here, what we're going to do is say const item. I'm going to fetch it back out equals await Dapp is on items. Pass in 1. Okay. And then first of all, let's just check the first thing about it. We're going to say const, we'll say expect item.id to equal 1. All right, so that's the entire test. Let's just run it really quickly, make sure it passes before we start explaining stuff. All right, so it returns the item attributes. Now, this is just the beginning of the test. We're going to do a lot more here, but I want to just get this on the page so you can see the basics of what's happening, okay? We're calling this list function over here. Okay, it's got, we're just passing an ID, name, category, image, cost, rating, stock. And we're just passing those in straight, just like this, ID 1, category, name, et cetera, et cetera. And so let's talk about this transaction thing. So the transaction is basically the transaction that's being submitted to the blockchain. What we're doing inside of here, we're just waiting for that transaction to finish its full life cycle before we run this test. So after that, we just go fetch the items. Okay, you can read items from the mapping with this public variable here. Solidity exposes a special function for us called items. You could just pass in the number 1, which is the ID. That's how you read stuff out of the mapping. You give it the ID, and then it returns the actual item itself. And you can call its attributes with dot on side of here. So like if you did console log.item, if you did console log.item, you'd see everything on there. But you can just dig into each thing individually, like ID, et cetera, et cetera. Okay, so let's do a little refactoring here. Instead of just passing in all this stuff here and checking it here, let's create some variables. Okay, so I'm going to create these variables right here. All right, I'm actually going to do these with constants. So we're going to move them up in a second. We'll just say const ID equals 1. All right, so then we'll make this ID in a second. What we're going to do is basically define the constant here. We're going to replace it here, and then we're going to use it, here. All right. That way we don't have to keep changing stuff, everywhere. We have these variables that really help us out. So let's just save that, and you can see the benefit, and now we'll refactor the entire code to do that. All right, so it returns the attributes, it gets the item correct. All right. So now let's do that for the other attributes as well. We'll say, I'm just going to go ahead and toss these in there, and then I'll explain them one by one. All right, so here's the new values that we want to do. All right, so let's explain these one by one. All right, so ID, pretty self-explanatory. We just did that. Now, name, of course, is pretty self-explanatory. We just give it the name of the product. Category is pretty self-explanatory. It's clothing. It's just a string. Now, image might be a little less self-explanatory. So earlier in the tutorial, I was talking about how we're going to save these images in the blockchain. So you can see these images here. All right, this. This is decentralized. We're not putting these images on, a web server somewhere. We're putting them on the interplanetary file system, or IPFS. That's this thing right here. So we're going to put the images there, and then we store the URLs for those images inside of our smart contract, okay? So instead of having to do a bunch of crazy stuff with IPFS for this particular tutorial, what we're going to do is basically just give you IPFS images that are preloaded. All right, we've already uploaded them for you, and then put them on the blockchain, and that way you can code out your project without having to learn how to do everything on IPFS and do that from scratch. I got plenty of other tutorials on my YouTube homepage that will show you how to do that if you want to do that part yourself. And another quick thing is you can actually paste that link into your browser here, and you can see an example of this image file that's hosted on IPFS right here. All right, so let's keep it going through here. So next, let's look at the cost, okay? So the cost is going to be the price of the product expressed in Ether, okay? So you can see here on the website, we have a human readable name like 0.25 Ether, which is basically, we price the products in Ether, we use decimal places on the website. One thing you have to understand is inside of smart contracts, we don't really use decimals, okay? So if you're going to store the price of a product, you do it in what's called the Way value. All right, so what does that mean? So basically, Way is the smallest subdivision of Ether. All right, so basically, it's kind of like the penny for Ethereum if you're talking about, US currency, US dollar. So like a dollar is looks like this, 1.00, and a dollar is 100 cents. Okay, so there's 2 zeros after the decimal place. So with Ether, there's 18 zeros after the decimal place. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So basically 1 Ether, just like $1 is 100 cents, 1 is this many Way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right, that's how many Way equals 1 Ether. So this is the unit that we use inside of smart contracts. So like when we store the cost, let's say the cost is 1 Ether. Well, it's this number right here because we're doing it in Way. You don't pass in 1. You don't pass in 1 with decimal places. You don't use decimals. You use this. All right. So we need to be able to convert that. Okay. If you want to see that, you can look at a website like Ethereum Unit Converter. You can do 1 ETH is this many Way. You can also say if it's, if you want to do 0.25 Ether. All right. Just like we do on the website, you can convert it to Way. This is a pretty good, unit conversion for doing that. Okay, so we have a helper for this in the test already. You can see this tokens. You just pass in the big number, and it will convert it to the smaller number for Way. So basically, for this would do tokens 1. That's 1 Ether is going to convert it into that big number like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right. All right, so then rating is pretty self-explanatory, and stock is pretty self-explanatory. It's just how many items are in stock. Rating, of course, is the product rating. So now we're going to take all these variables. We're going to put them down here. ID, name. We'll replace this with name, and then category. We'll replace it with this. An image. Replace it with this, and then cost. Replace it with this, and then rating. Replace it with this, and then stock, replace it with this. All right. And also lastly, what I'm going to do essentially is just take all this stuff, and we're going to put it at the top of the file because we're going to use it through multiple tests, and then put it up here. All right. And then just save that. And then let's run the test, make sure it still pass. All right. So now that those pass, we can also dig into multiple other things. We can also not just check the item ID. We can also check the the name, category, image, cost, rating, and stock. So I'll pause the video there. I'll let you pause the video if you want to and copy that now. All right, let's run the test. And boom, it passes. All right, so a couple other quick things I want to do before we wrap up this list function is I want to emit an event on the blockchain. Okay. So what does that mean? Well, Solidity lets you create your own events that can be emitted inside of functions. And this has two primary benefits. One is that anytime this function is called, somebody could subscribe to the event in order to get a notification about it. All right, maybe it's a push notification on your phone. Maybe it's an alert that pops up on your website. Maybe it's an email alert, whatever it is. You could subscribe to that event with something like Ethers.js and then, program it to do whatever you want to do. So that's the first benefit. The other benefit is you can look at every single time this function was ever called on the blockchain very easily by fetching the event stream and looking at every single time a product was listed. All right. So you can define your own events inside Solidity, much like you can define your own structs with the event keyword. All right. Let's just say right here, say event. All right. We'll call list. And then we'll just tell it the information that we want to include in the event. We'll say string name, UNT256, cost, UNT256, quantity. All right. And then that just defines the event right here. Now we can list it right here. Or sorry, we can trigger the event or emit it right here. Emit, lists, pass in name, costs, stock. All right. Now we can check for this in our test like this. We can add a new test just below returns the item attributes. We could say it emits list event and say expect transaction, which we created here. All right, to emit Dapp is on and then list. That's the name of the event. Save that, run the tests, and it passes. Okay. So the next thing I want to do, the last thing I want to do for this function is restrict listing to only the owner of the marketplace. So again, in this case, our simple example is just somebody who deployed the smart contract, the owner in this case right here. And then they're going to be the ones that list the products, and they're the ones that receive the funds for each individual order as well. Okay. So if that's the case, well, you don't want somebody else to list the products. So what you can do inside Solidity is use a require function. So Solidity has a special function called require, all right, which basically says require like this. And then what happens is anytime you put something inside of this function, it has to evaluate to true or false, okay? So like true or false. That's Boolean values, one or two options, okay? And so if it evaluates to true, then Solidity will continue executing this function, all right? But if it evaluates to false, it will just like stop on this line and then, it'll just stop. Yeah, it'll just stop working. It'll just blow up. The transaction won't finish. So I'm just going to run this, require true. Let's rerun the test. You see it still passes, but if I do require false, it'll just stop. Yeah, boom. Transaction reverted, right? So you don't really use require true or false. That's kind of pointless. That doesn't make any sense. What you do is you create statements that evaluate to true or false. So like, require 1 plus 1 equals 2. All right. That's going to work. All right. Does it equal 3? No, it doesn't equal 3. If I use the false function, I'm going to keep going. But that's also pretty useless too. But I'm just illustrating that. What we're going to do is require that the message.sender, the person who's calling the function, is equal to the owner. Okay. So basically this is the address that owns the smart contract. And then that way it still passes. All right. So we could say, equals to somebody else. You could write a test that checks for this. But we just want to make sure that the owner is the only one who can call this function. All right. So now, you could leave it this way. It would be just fine. But what I'm going to do is create something called a modifier inside Solidity. So I'm going to take this line here and then create something called a modifier up here. So we'll say modifier only owner. Okay. And then I'm going to take this line, cut it out, and then put it here. And then I'm going to do this. And I'm going to take this and apply it to our function like this. Run the tests. And it still passes. Okay, so let me explain what I did. So this modifier is something you can apply to your functions inside Solidity. It's a custom modifier, okay? So basically what that means is we create and use a modifier keyword here. We give it any name we want to and say only owner. And what that does is it modifies the behavior of this function to say only the owner can call this function. But because it's a custom modifier, we have to actually create the logic that checks for only the owner being able to do it. So that's pretty simple. It's one line of code. We just use this require function inside Solidity. We inspect the message.sender, who's the person who's calling the function, and we make sure that it is equal to the owner. All right. And then we use this underscore here, okay, followed by a semicolon. That just represents the function body. And what it's saying is, do this before the function body. You could do it after the function body if you want to, but that's kind of pointless and not very gas efficient. So we do it before the function body. All right. And then once we put it here, it applies it to our function that only the owner can call it. Now, I'm not going to write a specific test to check for this. We've got plenty of other examples of that inside other tutorials on this channel. I'll let you hunt those down and do that as an exercise if you want to. All right, so now let's get into the section on purchasing products. So we have first create the ability to list products. Now let's actually let people buy them. Okay, so I'm just going to take this, right here. I'll give ourselves some space at the bottom of the code here. All right, so we're going to create a function called buy. It's a function buy. It's be pretty simple. We're going to pass in the product ID, UNT56 ID. It's a public. Okay. And then what's going to do is they're going to send in cryptocurrency to this transaction, and then it's going to actually make the purchase on the blockchain. Okay. So let's look at what we need to do. We need to receive the funds, crypto. We need to create an order. And then we need to subtract stock. And then we need to emit event. All right. So let's start off with receiving crypto. So let's talk about the workflow here. All right. Inside of Solidity, inside of the project. So what's going to happen is somebody's going to go to a website and they're going to send Ether in when they can purchase products with Ether. Okay. So what's going to happen is those funds are going to go straight to the smart contract. They're going to stay in the smart contract. And then the owner can withdraw the funds from the smart contract. And whenever they pay, it's going to create an order for their products. And of course, we can fulfill those products and deliver them to them. All right. So let's talk about, how to do that. So in order to send Ether into the smart contract, you can do that in a variety of ways. But we're going to do it with this buy function, all right? So what you can do is send Ether to the contract this way. You can call payable. That's a modifier that's built into Solidity that you can apply to your functions. And what it's going to do is allow people to send in Ether when they call this function. So let's look at an example of that. All right, let's test for it. And so right now, somebody calls this function. All it's going to do is just, call the function. It's not going to run anything inside of here, but it is going to let them send Ether into the contract and it'll get stored into it. We can go ahead and check for that. So let's go into our tests. And then down below here, let's, describe listing. Let's just copy everything basically. Copy that, minimize it. And then let's just take out one of these Okay, and then let's take out this, and we'll say buying. All right, so let transaction equals await, Dapp is on connect deployer, and then instead of, well, sorry, we want to still list a product. Hold on. We still want to list a product here. But we can take all these and put them up on its own line. All right. And then we want to do await transaction wait. And then next we want to do transaction equals await, Dapp is on connect. We're going to do buyer. So again, we got deployer up here and then buyer. All right, and then buy ID. All right, that's the function, that's the argument that it requires. All right, and then value cost. All right, so what does that mean? So basically, ID is the argument that's required, and then you can put in these curly braces in here to put in function metadata like value. Okay, so value is the amount of ether that's getting sent in. We can only do that because we've got this payable modifier on the function. And the cost is the value that we're going to send in. So this cost that we defined up here, which the product price is just 1 ether. Basically, we're going to just pass in that value here. And then let's just save that. Let's just run the test. We're not actually checking for anything. Let's comment this out for a second. Let's just run it. All right. So make sure nothing breaks. All right, nothing breaks. But let's actually run a test example. We're going to say, let's just say it updates the contract balance. I'm going to do this and I'll explain it. All right. So if you want to copy that down, I'll let you pause the video. All right. So what we're doing here, it says it updates the contract balance. That's result equals await ethers provider get balance. It's just how you check the balance of anything with ethers. And then we pass in the address of the smart contract itself. So we're checking the smart contract balance. We get that here. And then we say we want to make equal to the cost. Okay. All right, boom, awesome. So we successfully sent in ether with that transaction. If you want to see this, you can just do like console log result. All right, yeah, here's the value. It's 1 ether. That's 1 followed by 18 zeros. All right. So anyways, it updates the contract balance. That's what we're doing here. Okay. Now, what else are we doing here? Well, you want to do things like receive crypto. That's done. Check. You can also see if you take off payable, it's not going to let you do it. All right, see an error there. All right, so you need the payable modifier on the function to receive crypto. So receive crypto, check. Now we need to create an order. Okay. So how do we do that? Well, basically, we're going to create a new struct, just like we did with the items. Okay, we're going to create a new struct called order. Like this, boom. So order, struct order. We're going to give you 256 for the order time. And then the item is actually going to be the nested struct for the item that's in the order. So we can create a new order in there like this. All right. Basically, I'm going to say order, memory, order, just like we did with the item here. And then I'm going to say order, okay, order, memory, order, block.timestamp, and then item. All right, so let's explain exactly what's going on inside of there. So first of all, I explained this order, memory, order, just creating a new order named variable order. Memory is the location. Order is the data type, which is this struct that we just created here. And then we instantiate a new struct like this, and we give it two attributes it needs. The time, which is this. I'll explain that in a second. And then also the order item, which is this, which we also need to fetch that from the blockchain. So how do we do that? We do it like this. We say fetch item. All right. And we say item memory item equals items. We read it from the mapping like this. Items underscore ID. All right. And that becomes our item that we include right here. So this is how we put an item into a mapping right here. We assign it. We do items ID item. We give it the key. We assign it to the value. Here we can just fetch it. We're doing the opposite. We're assigning it. We're retrieving an item from the mapping. We just give it, this, and then we're putting it on the opposite side. You see what I'm saying? So, order matters. This is on the other assignment, the other side of the assignment, and this on this side. All right. So let's also explain this. So each order needs to have a unique timestamp so we can understand when it was created. Okay. So I'm gonna pull this from my screen here. So in Solidity, we use timestamps with epoch time. So what does that mean? So you see this number right here? This is a number that represents the current time in seconds. So basically, epoch time is a timestamp from, I believe it's, I always get the date wrong. January 1st, 1970. I can never remember if it's 1969 or 1970. January 1st, 1970, midnight, all right, is the number of seconds since this point in time. That's what epoch time is. So we save this number in seconds as the current timestamp. Now that the blockchain uses that, and each block that's included into the chain has a timestamp. So we're just using the timestamp of the block to grab that timestamp and say, hey, create a new order with the current time in seconds. And that's what it does. This is a globally available variable inside Solidity, just like message.sender is. We can do block.timestamp. It'll fetch that for us, and we save it to a timestamp so that we can create this order, and we give it the item. All right. Now, we need to save this to the chain. So say create order, save order to chain. So what we're going to do is create a couple different mappings for this. All right. One is we're going to create a mapping for the orders count. Say mapping address U256 public order count. All right. And so what that's going to do is basically understand the address is the key. That's the user who created the order, and then the U256 is the number of orders that they have received. And the next thing is the total orders. All right. So this is going to be a nested mapping. So we can have a mapping of mappings inside Solidity, which is kind of crazy, but it's pretty useful. So address is going to be the key. This is the user who placed the order. And then that's going to return a mapping of the quantity of products, for each individual thing or each individual order, right? Like basically, like if they have order 1, order 2, order 3, that's going to return each individual order right here. And we select public orders. So we can use both of those down to the smart contract like this. Saving order to chain. We want to essentially increase the order count for the user. We can say order count, okay, message.sender, this is the person calling the function, equals, we could do this +1, all right, but that's kind of longhand. The cool thing inside Solidity is you can just do this, orders ++, and it will just increment the count by 1 for you, all right, so we can basically just say, add order for user, and then give it the order ID right here. And then we can essentially update their orders like this. So orders message sender, orders order count message sender is equal to the order, and that will save basically their order number corresponding to their order in this particular mapping. All right. And then let's just see here. And we can also subtract the stock while we're at it. We can basically fetch the item from the mapping. This, the items ID dot stock, and go ahead and update it. Items stock, -1. All right. And now we can check for this behavior inside of the tests. So over here, we're going to basically create a test here that just says it updates the buyer's order count. Updates buyer's order count. Say result equals await. Dapp is on order count buyer.address. Result to equal 1. Just save this. Let's make sure nothing's broken. All right, works. And then we say it adds the order. Like this, order equals await, Dapp is on orders, buyer.address 1. So expect the order time to be greater than 0. We can't get the exact time unless we freeze the blockchain. And then expect order time item name to equal name. Save that. All right, works. I'm going to reorganize this. Let's move the updates contract balance down to here. And then lastly, let's check for it to emit a buy event. Let's write the test first and then get it to pass. So we'll say it emits a buy event. So expect transaction to emit Dapp is on buy. All right. And then let's do that. It's going to fail. Uh-oh, shouldn't be emitting a buy event yet. Let's hope that our thing is actually working. So I think this might, let's see here. All right, let's change this first of all. Let's say listing, this should be buying. Let's make sure our other tests are actually passing. Hold on. Let's just say, let's say 2. Just make sure it's still working. All right, so that's actually failing. So let's see, let's make sure. Yeah, let's make it actually emit the buy event. The test passes properly. So what we're going to do is go up here, create a new event. All right, just above the lists, say buy. So buy, it's address buyer, UNT56, order ID, and then item. I'll pause that if you want to copy that down. And then down here, we're going to emit the event like this. Emit buy, message.sender, order count, message.sender, and then item ID. On the tests. All right, and everything is still passing. So you can definitely grab the test from the final code solution if you want to. I'll also just pull this up, and then you can make sure that that looks like your code. Okay. So now what I'm going to do is I'm going to change a couple more things inside of here. Now, we want to add some requirements to this function to guard it before they get deployed. So, before we talked about, require, we talked about this require function inside Solidity. Basically, it takes an argument, accepts it as true or false, and then, lets you continue executing the function body or not. So in my case, what I'm going to do is basically, I'm going to add some requirements on my own. So just below this, I'm going to say, make sure that they are sending in enough Ether to actually purchase their product. So like this. So require message.value is greater than or equal to the item cost. All right. We'll just save that. We're on the test. It still passes. If you want to check for this specific behavior, you can write test for failure cases. I've got other tutorials that show you how to do that, but I want to get through to the front end so that you can see how to do that. We require the items in stock. Okay, like this, item.stock is greater than 0. All right. And that's going to make sure that, this is a valid entry. All right, they still pass. Okay, so the last thing I want to do is show you how to withdraw the funds, all right? So I'm going to go ahead and slap this function on here. It'll be a simple function for withdrawal, like this. All right, I'm going to pull this over. I'll let you copy that down if you want to. Pause the video. All right, so let's explain it. So inside, so we're doing is creating a function called withdrawal. All right, we're creating that from scratch. We're saying public. All right, and say only owner. So, only the owner can call this function. Only owner is the one who can actually take these funds out of the smart contract. Okay. And so what we're doing here, Solidity has multiple ways for you to transfer Ether inside of smart contracts. Okay. So you could use the transfer function, which we're not going to do in this case. We're going to use call, okay, which is this is a preferred pattern that I see among many Solidity developers now. So what you're going to do is say owner, which is the person, you're going to say call. So call, what it does is it just sends them a message, and we can give it value, just like message.value, like we see, up here, all right? Message.value, which is the amount of Ether getting sent in with the transaction. And we can say message.value is going to be addressed this. So this is the address of the smart contract that we're coding inside of. And then we say address this balance, which is the total balance of the Ether inside the smart contract. Then when we call the function, we just pass in this empty string, okay? And then that returns these values. So success just means that it was successful. And then we can just make sure that it was successful, true or false, before we make sure that withdrawal is finishing properly. So this is one of the reasons we use this pattern, is because we can check for the success pretty nicely, just like this, okay? So we withdraw funds that way. All right, we can test for this. I'm just going to go ahead and throw in the test example in the final code solution for checking on withdrawals. You could code that out yourself if you want to before I show you this. Give it 2 seconds to pause the video in case you want to do that. I don't want to give you a spoiler. I'll give you a spoiler alert, I should say. All right, but I am going to go ahead and throw in the final code solution here. And you can grab that from the code down in the description below the master branch, or you can just copy down what you see on the screen here. I just want to speed up so we can actually deploy the contracts and get to coding the front end. But here is the test example that we'll use for this. I'll pause it. If you want to pause the video, you're more than welcome to do that. I'll just do that. Okay, so basically we have this before each function that essentially sets up the scenario. We have balance before. So we list an item just like we did before. We buy the item just like we did before. And then what we do is we get the deployer balance before we withdraw. So Ethers provider, get balance, deployer.address. And then we actually do the withdrawal here. Transaction await, Dapp is on connect, deployer, withdraw. And then we wait for that to finish, and we say it updates the owner balance. We just check for the balance of the deployer right here. We want to make sure it's greater than the balance before, okay? And then we check the balance of the contract. We say result equals await, Ethers provider, get balance, Dapp's on address, expect result to equal 0, because you did drain the entire balance. Let's save that, go to our terminal, and boom, there we go. Awesome, so we have successfully coded out the smart contract for this Amazon clone Dappazon tutorial. So I wanted to get to that last part pretty quickly so that we can, move on to the front end side of things. Okay, so let's just make sure that we're all squared away, good to go. Now what we want to do is take our smart contract and take it off of our computer and actually put it on a blockchain. All right, so now let's take the smart contract that we've created and put it on a blockchain. So this will be a multi-step process. The first thing that we want to do is actually start a local blockchain on our computer so that we can actually deploy the contract to it. Now, if you go to your the GitHub repository that we were working with before, all right, or even your your README file below, you'll see this command here, npx hardhat node, okay? And you can open up a new terminal tab separate from your workspace and paste that in, all right? And what that's going to do is basically start a development blockchain. And so you can see this has got 20 different accounts inside of here, account 0, account 1, account 2, account 3, account 4, account 5, all right? And then essentially what that's going to do is give you all these accounts, and they're each going to have 10,000 fake ether inside of them. You can see the public, the account address here, which is a representation of the public key, and then the private key, which is like the account password right here. Now, I should always give you a warning. If you're going to use these accounts, you definitely should never use these accounts to hold any real money, because anybody who's watched this tutorial has seen these private keys. And if you're using the default Hardhat configuration, everybody's using the same private keys. So you're going to lose all your money is the whole point if you try to put real cryptocurrency inside of here. This is fake. It's not worth anything. Don't get excited. All right. So that's our development blockchain that we're going to use. Next thing we want to do is create a script inside of our Hardhat project to put the contracts on the blockchain. So you can see inside of here, this test file, there's, the scripts file, there's a deploy.js file, okay? So the scripts directory, there's a deploy.js file. So Hardhat lets you write scripts, which are just like instructions in a single file, written inside JavaScript in this case, that tell it to do anything you want to. You have access to the Hardhat runtime environment inside of here. But in this case, we just want to create one that deploys the smart contracts. It takes them off of our computer and then puts them onto a blockchain. So we're going to call it deploy.js. We've already got this file named for you, and we've already got some setup inside of here. We got Hardhat pull in here. We got some items, which we'll see in a second. And then we've got this tokens helper that we had in the test, and then we have this main function, and then this thing that calls the main function. This just comes from the boilerplate setup. This is what Hardhat recommends for us to do. But the whole point is, code goes here. All right. So what do we want to do inside of here? Well, remember inside dappizon.js, we did all this like setup where we like use ethers to deploy the contract, et cetera, et cetera, et cetera. And we get like ethers get signers. We basically want to do the same type of stuff in our deployment script, okay? So we're going to set up the accounts like this, all right? First, we're going to say, const deployer with brackets around it. Goes await ethers get signers. That just gets the first account from the list, okay? As a visual, that's going to be this account right here, all right? And then it's account 0. Then we can deploy the smart contract like this. This is just like our test setup. Say deploy dappizon. So dappizon equals await HRE ethers. So HRE is because Hardhat is pulled in. We have to do HRE.ethers instead of regular ethers. Get contract factory dappizon, and then we deploy it, and we get the deployed copy like this. We just wait for it to finish. All right, and then we can console log that, console log deployed dappizon contract at this. So this is just using string interpolation inside JavaScript to get the address and put it on the screen. Okay, and then we could just stop there and be done, okay? But what we want to do is actually create a website that, lists all these products on the page. So we don't want to just deploy the smart contract, okay? We also want to seed the website with some actual products so we don't have to list them manually, all right? So what we're going to do is go ahead and do that inside this. So you could create a separate script to do this, all right? Or you could basically just do it inside this deployment script, which is just fine for the sake of this tutorial. So what we're going to do is say list items, all right? And you can see I've got this items, source.items.json file here, and we're saving that as items. And so you can go to source items.json, and you can see this, all right? And basically what this does is it creates some products for you. So you can see it's already got ID1, camera, electronics, IPFS.io. You can copy this URL and you can go see that it actually corresponds to, an actual camera. All right. You can see this drone actually corresponds to an actual drone. All right. And so basically, if you want to upload your own products to IPFS, you could go through that, get the URL back. All right, if you want to create some unique products, you can basically just change this. You can just copy and paste these things. Just make sure you separate them by a comma. Okay, and you increment the number each time. All right, and change the values here. Okay, so that's the items that we're going to list in the marketplace. So how do we do that? Well, I'm just going to go ahead and throw this in there. All right, explain it. You can grab this in the final code solution if you want to. I can also explain it. Actually, let me just do this. So what we're doing is using a for loop inside of JavaScript. So a loop is something that executes multiple times based upon a certain set of conditions. So basically, this is the content inside the loop, and this is getting run over and over and over and over again on loop. So how does it work? Well, basically, we create a variable called I, which starts at 0, and we say as long as I is less than the item's length, so items, which is all the items in this array, it's got like 10 products or something. How many items is it? It's 9 products. So as long as this is less than 9, then keep running the code inside this loop on repeat. But after every time you run this code, do this, which is basically add 1 to the variable I. So I starts at 0. The first time this runs, I is going to be 0. Is it less than 9? Yes. So run this code. And then once you're done running this code, increase the value of I to 1. All right, so second time it goes through. 1, is it less than 9? Yes. Okay, run this and then increase it by 1. It's 2. Is 2 less than 9? Yes. And repeat until you get to 9. All right, is 9 less than 9? No, it's not. So then just stop and don't do it anymore. Okay, that's how it works. So anyways, so 9 times we're going to do this. We'll say transaction equals await Dapp is on connect deployer list product, and then we're basically going to dig into this item. So items I, and then we're going to get the ID, name, category, image, price, rating, stock off of this. Okay, so ID, name, category, image. Price, we're converting it to tokens. All right, so it can be stored in way into it. And then rating, and then stock. And we're going to save it straight into the contract. We're going to do wait transaction wait, and then we're going to log it to the console just like this. All right. So, and when in doubt, you can just take the deployment script from the final code solution and save it to your project just to make sure that it works properly. But now we can go ahead and run that. So back in my workbench terminal tab, I'm going to run this command, which you can find in your documentation here. You can basically say npx hardhat run. That's how you run a script. And then you give it the current directory, which is /scripts. And look for the deploy.js file. But then you need to make sure you do -- network localhost, because that's going to say run it against this localhost blockchain that you're using. If you don't do this, it's not going to work properly. All right, it worked. So compile 1 Solidity file successfully deployed. Dapp is on contract with this address. List in 1 item camera, list item 2 drone, etc., all the way through item number 9, which is the robot set. Okay, and then you can see that here, all those transactions went through successfully. All right, so now let's go ahead and set up the front end application. Okay, so one dependency that I did not mention previously when we created the project is the MetaMask extension for Google Chrome. Okay, so in order to access the blockchain from your web browser, you need a special extension outside the box. Because blockchains, most web browsers don't support connection to the blockchain outside the box. That's what I'm trying to say. So you need a special browser extension, and that's what MetaMask does. It's also going to let people hold cryptocurrency in their wallet so they can pay for transactions whenever they're connecting to their browser, to talk to the smart contracts. So we talked about Ethers.js a minute ago inside the test. They're going to see that more to the front end. So you think about Ethers.js basically connects your application to the blockchain and makes your app a blockchain app. MetaMask makes your web browser a blockchain web browser. All right, so just Google MetaMask for Chrome. It'll take you to the Google Chrome Web Store. You can just click install. I've already done it. Okay, so mine says remove, but you're say install or add to Chrome, something like that. And whenever you've created it, you'll see a little Fox icon up here. It'll walk you through some setup steps to set that up. Now, a couple other things we want to do to set up MetaMask before we proceed is you're going to go to your terminal here and look at, make sure your blockchain's running, okay, and that you deployed your contracts. But we want to add this blockchain, which is the Hardhat node, to our MetaMask. So you can see MetaMask lets you connect to multiple networks here. You're going to do add network, all right? You're going to call it add network manually. You're going to call it Hardhat. RPC URL is going to be this, all right? Just copy this and then paste it inside of there. Chain ID is going to be, sorry, I have to cheat and look it up. Let me just look at this. Hold on a second, I'll tell you the chain ID. Is 31337. I'll say that 31337. Currency symbol is ETH, and then we'll leave Block Explorer out. So now, it's not going to let me save it because I've already added this to my MetaMask wallet. But just click save, and whenever you do, you should see Hardhat as an option. It'll probably automatically select it for you once you've added it. Just switch away from the Ethereum mainnet or whatever else you're using, and then just do that. Okay. Now, the next thing we want to do is go ahead and import some accounts from MetaMask, all right? So you see this account here, account 0, account 1, account 2. We're going to import the first 2 into our project. So take the private key, all right? And then go to your Hardhat, and then, sorry, your MetaMask, and then here, go to import account, okay? And then paste in your private key, click import. I've already done it, so it's not going to let me do that. Whenever you do that, you can edit the name of it, all right? You do account details, and then just edit the name. I'm going to call mine Hardhat 0, okay? Because I'm gonna make it correspond to the actual way that Hardhat names the accounts. So it starts with 0, goes to 1, goes to 2, goes to 3. All right, and then I'm gonna repeat that step for the second account on the list. So private key, copy for account 1. I'm gonna import it, and then I'm going to, see I've got account 1 here. I go ahead and do this since I use Hardhat a lot. I've already done it for basically 5. I've done it for, let's see, 5 or 6 total Hardhat accounts. You don't have to do all 6 for the sake of this tutorial. But if you're developing the Hardhat regularly, every time you start that node and restart it, it uses the same account. So it's nice to go ahead and have those saved in MetaMask. One consequence is you need to learn how to reset your MetaMask with the Hardhat account. So I'm going to show you how to do that right now. Go to just account details. Or actually, no, go to this, settings, advanced, and go to reset account. Okay, it's going to clear your account history. Doesn't delete any data off the blockchain, but I do that every single time that I restart Hardhat. So Hardhat 1, there's some errors that you run into inside of your development environment that deal with this problem. So I'm going to reset it, and I'm going to stay on account number 1, okay, for purposes of developing our front-end website. So you got MetaMask set up. So now we want to go ahead and boot up the front-end application. So if you go to your code here, you see this here. So start the front end, npm run start, all right? So you'll go here, and this is our workbench. I'm going to open up a new terminal tab. Okay, we've got one for the blockchain here. Now I'm going to do one with the web browser. So let's do npm run start. Okay, and that's going to start the web browser. It'll automatically load up the project here. All right, it won't show you all this stuff because that's the final code solution. And then whenever that's done, you should see that here. Okay, so you just see this initialized page. Welcome to Dapp is on. We'll fill this page out with everything. I'm going to keep this screenshot here. All right, this is the final screenshot of the actual project, just so that when we fill out the code here, we can kind of compare it to the final thing. We can kind of begin with the end in mind, and go from there. All right, so let's get the text editor set up to start working in the front end. I'm going to close down a lot of this stuff. I'm going to keep the dappizon.sol file open so we can go back and reference sort of the back end side of things whenever we're coding out the front end, because that's the whole idea, is basically our website is the front end, right here, and then the smart contract's kind of the back end on the blockchain. So the contracts is sort of where the back end goes. And then the source directory here, this is where all the front end stuff goes. Now, why is it in the source directory? Because we have two projects fused into one. Okay, we have a Hardhat project, like I was showing you before, which is like a folder that has all your files for the smart contracts. It lets you, write the smart contracts inside there, write tests. But we also have a React project inside of there. So if you're not familiar with React, what is it? It's a JavaScript library for building user interfaces. So JavaScript is the programming language that we use to write the front end. And then React is the framework. So React is not a programming language. It's a framework, which is a set of tools that lets you create front-end applications very quickly. It's component-based, so you can put your code into reusable files called components. And you can do things like have component state. We'll see that when we get to it. You can mix HTML and JavaScript inside the same code. So you can see this is JavaScript render and return, but then you can see some HTML code inside of here. And then you can even mix in JavaScript inside of those inside that HTML code with the curly braces as well. Okay, so you'll see React in action. The best way to learn about it is just start writing React. So let's do that. Let's go to our project here. You go to source. You can go to app.js. And here is your initial top-level React component. And you can see that message, welcome to Dappazon. That's exactly what we see inside of this right here. So we could change that to, put an exclamation point on it and save it. If you go back to your web browser, you'll notice that the change has taken effect, which basically means that you don't have to refresh the page in order to, see that code change. The web server hot reloads the page for you, that's what's running here. Now, you'll also see all these warnings inside of here. That's okay. These are just warnings from the server, from the linter. These aren't actually errors. It's still compiling. It's still showing you on the page. But these will get addressed as we continue developing out. They're only there because we cleared the code out for a starter branch. All right. So you'll see this is a React component. We're using functional React components in this tutorial, okay, as opposed to class-based. If you don't know the difference, it's not a big deal. If you're learning React for the first time, just learn it this way. It'll all make sense. So we give it a function called React. We do return. This is the HTML that gets returned on the page, and then we can put whatever we want to inside of here. We can define functions inside of here. We can import other files just like we do here in libraries. We're importing the Ethers library. We're importing some React libraries. We have other components that we're importing right here. So you can see these components in the component directory. It's in a subdirectory for navigation. All right, this is going to be the Navbar on the page for each individual product, for each individual rating. We've got some templates inside of here, right? We'll customize these templates, right? But you see these other components. They have a name, const rating, and it returns some HTML. And then we wire it up, const section, and then we wire that up, right? Const navigation, wire that up, okay? So let's... we can see the ABIs for the smart contract, and then also the config. All right. So we'll get into some of these details here in a minute, but let's just start, adding some stuff to the page. All right, so let's work on our first feature for this front-end application, which is really going to be this navigation bar up here. Okay, so let's go ahead and create this nav bar where we can we can connect our wallet to MetaMask and display the account on the page. So the first thing I really want to do is essentially show you how to retrieve the account from MetaMask. Okay, so what I'm going to do is have this app component here. I'm going to create a function here called const load blockchain data. All right. A function. All right. And then what we're going to do inside here, I'm going to say console.log, say loading, and I'll just do that, right? So now I've created a function there. Boom. Awesome. Done. You can put functions inside your React components. You can put HTML on the page inside this return here. All right. But if you go to the actual thing, if you do inspect, all right, and then you look at your console here, click over to console, you don't see anything logged to the console. Okay. So why is that? Well, because we have, defined this function, but we're not calling it. So we're going to use something in React called use effect. All right, you can see this here. This use effect is a hook from React. And so what it does is it lets us, call a function whenever this component is rendered on the page. So use effect. All right. And then we pass in a function like this. And then basically we call load blockchain data. And then I'm going to pass an empty right here. And then now we can see that it is loading on the page. So now what I want to do inside of here is show you how to retrieve the account from MetaMask. Okay. So we're going to start with this thing called window.ethereum. Okay. So inside of your console here, well, let me just take this out. It's probably not going to let me do that yet. So inside our console, let's do window. All right, so window is just the object inside JavaScript that corresponds to the actual window you're looking at. So you can see the window.ethereum, all right, is this. Okay, so this is the connection to the Ethereum blockchain that is provided by MetaMask. All right, and specifically, it's the connection to the Hardhat blockchain itself. Okay, so we can use that to we can do this. We can do window.ethereum.request. All right. And then we can say like method eth request accounts. All right. And then you can see, we could say await const accounts equals await accounts. Okay. And we can see the accounts that are provided by MetaMask right inside of there. Okay. So I know it's kind of small font into my terminal here or inside the console. We can do this exact same thing inside of, here. So we can basically say console log. Instead of that, we can basically do all that code, which is this. Const accounts. Let me just pull this over. Equals, this. And then instead of loading, we can console log the account. All right, so what I do. So accounts equals await window.ethereum.request, method eth request accounts, and then get the individual account. Account equals ethers, utils, get address, accounts, 0. It's the first account in the list. And I'm going to console that log on the page. Okay. And then boom, you can see it logged to the console on the page. Now, what if we want to show it on the page? Well, we can use something in React called use state. Okay, so what is that? Basically, React lets you have component state. All right, so you can see here, like this to-do list example, item 1, item 2, item 3. So if I have a to-do list inside of React, how does it know where these to-do items are? Well, it saves them to the component state. All right. So the state is like a little database inside the component where you can put information and you can retrieve it later. So if you're going to create a to-do list, you'd save them on the state. So we want to save the account to the state and then read it out of the state. So we can use a hook called use state inside of React. All right. And then we can basically do this at the very top of this. We can do this const account and set account equals use state null. So what does that do? Well, use state's going to return an array. It's going to return an array of two things. The account itself that's retrieved from the state. In this case, it's nothing yet. It's null. It's the default value here. We haven't assigned it, but then it's going to give us a function to actually update the account and set it. So basically, we can just call set account instead of console log account. We can say set account, pass in the account here, and then we can call this account variable anywhere inside of our component and then show it on the page. So let's just say like paragraph account. So basically the curly braces is what lets you put JavaScript inside of the HTML code here. So you need to do this, and then we're just going to call the account variable. All right, let's go back to our file here, and then boom, you can see the account listed on the page. Doesn't look like much. It's kind of ugly. It's no good formatting, but we can still see it. Okay. All right. So that's the first sort of thing here. All right. But we want to actually show this on the navbar, not right here. All right. So let's take that out and let's go ahead and render this navbar out on the page so we can make it look more like this and actually show the account here. All right. So what we're going to do is open up this navbar navigation file here. All right. You can see that navigation component's already there for you as a placeholder. And what we're going to do is essentially render that onto the page like this. So right here, we're going to have this thing say navigation. All right. That's how you create a component inside of React. We just say navigation. And it's like putting an HTML element inside there with a special name that's capitalized. That's what the React component name is here. Navigation. And say account equals account. So we're going to pass in that value. That's how you pass variables down to components. You say navigation account is equal to account. And then we're also going to say set account. We're going to pass in the function to set the account as well. So we can pass in variables, we can pass in functions, it doesn't matter. And we'll be able to access these inside of the account component here. So we can see account and set account are already arguments that it accepts. And now what we can do is, like, for example, we can just show the account here and just make sure that it accepts it properly. All right, let's do that. And then we go back to the page here. I think it's up there. Yeah, if you highlight it on the page, you can see it. Now, that doesn't look like much, but we can guarantee that the navbar is actually there, okay? Because we see something new on the page, it's black, there's black text, which doesn't look right, but we can see that we're actually passing data into it. All right, so we're just checking to make sure that works properly. Okay, now, with the navbar, what we want to do is make it look like something. Like, we want to make it look like this. There's a lot of work to do, but the good news is we've sort of got some templating for that, and we also have the styles generated for you. So I don't really want to focus a ton of time into like writing CSS in this, course, this tutorial. So we have this index.css file right here where we've pre-written all the CSS for you so that you don't have to spend time worrying about that. You want to focus on getting good at the blockchain side of things, not the styling side of things, but you're going to get a nice thing that looks cool out of the box without having to focus on this. So you've already got the CSS inside of here. We're just going to create the appropriate HTML with the CSS classes inside of each component, and that will automatically absorb the CSS for you, okay? So let's go ahead and fill that out. So inside of here, what we're going to do inside of this, nav, and do is take out this account here, and we'll replace it with this, all right? So div is just an HTML div tag. We say class name. You have to use class name instead of class inside of React because it's a naming conflict. We say nav __ brand, and we say h1 Dapp is on. H1 is just a level 1 heading in HTML. All right, so we'll go back here, and then boom, there we go. We see Dapp is on. Looks just like the mock-up there, all right? And so next we want to do is add, an input for the search field. It's going to be a dummy search field for now, all right? So we'll say input type equals text, class name equals nav __ search, all right? And then, boom, there you go. We got a search field. And the next we want to do is we're going to go ahead and add a button for the account. We'll just show on the page. Say button. I'll do this. All right, button. And we're going to say, basically, all right, button, type button, class name equals nav __ connect, and we'll just show the account in there. All right, just do use the curly braces and pass the account in here. And then, boom, we can see the account there, but you can see it runs off the page, right? It looks terrible. So the cool thing is we can shorten this, like MetaMask shortens all the accounts just like this. And so instead of doing that long ways, we can shorten it or abbreviate it with something called slice. So we do that like this. So account.slice basically takes the first few characters and then adds in this ellipsis, this 3 dots here, and then adds the last few characters just like this. Okay, so save that, and then boom, we can see the abbreviated account there, right? And then the last thing we're going to do is create this unordered list right below here, which is going to have the dummy categories for each of the things. So it's an unordered list, class name, nav links, electronics and jewelry, electronics and gadgets, toys and gaming. You'll be able to, it'll automatically go to those sections once we have those on the page. Okay, we don't have them yet, but these little things, once you click on them, they'll actually navigate to those sections. Okay, so I'll let you pause that if you want to copy that down. All right, so let's go back and check it out. All right, boom, that's looking a lot better, a lot better. Now, one final thing here. We want this thing to request our account from MetaMask. So when they come and check on it, we want to click the connect button to actually fetch the account. We don't want it to automatically load because somebody may not have MetaMask installed, all right, whenever they go, or they may not want you to automatically get their account out of it. So we're gonna let them request it. So what we're gonna do is basically do this. We're gonna take out. We're gonna create. We're going to do this. Like, I'm going to do some logic on the page, and then we'll just explain how it works. So take this out. And we're going to do this. All right. So do some conditional logic in here. Basically, see account, if it exists, all right, we're going to add a button, all right, and we're going to show it on the page just like we had it a second ago. And if not, we're going to have this button that says connect handler and then connect. Okay, so let's just show that on the page. All right, it's still going to show you the same thing. All right, connect handler is not defined. Let's go ahead and create a function at the top of the file called connect handler. Let's do const. All right, so const connect handler equals async, and then pass in a function, and they're assigned to a function. And then say console log connecting. So let's just go back. And then now it should look the exact same, okay? So let's explain what we're doing. So right now, we're loading the account inside of here, okay? So what we want to do is basically take all this and cut it, all right? And then put it inside of here, all right? So take this out. All right, and then now if we go back to the page, we'll see that it does not, you refresh, it doesn't actually show the account here, but if you click connect, boom, it'll load it, and it works. So what happened? So basically we were loading the account previously in the app component and then passing it down through here, okay? But now what's happening is that account doesn't exist yet, so we use this conditional logic, says the account exists. If it does, you know, go ahead and show it on the page. But if it doesn't, show this button that's called connect, and it has this thing called on click. And anytime you click this button, it's going to run this function because it's an on click handler called connect handler. And inside connect handler, we're going to do that exact same routine that we had on the top level. We just move that code down here, and then it knows how to set the account, okay, up here inside the parent component, and then it'll pass that account back down in here. It will notice that the account exists, and then it will show it on the page. All right, so now the nav bar is working and it looks just like the mock-up. So what we're gonna do is continue on to the next section, which is listing the products on the page, just like we see in the mock-up here. So what we're gonna do is go to our app.js file here. Okay, we're gonna edit the content on the page. So instead of welcome to Dapp is on, we're gonna replace that with Dapp is on best sellers. Okay, save that. See that copy looks the same as the mock-up. And now what we're going to do is load all the products. Now, we can't do that yet because we are not connected to the blockchain. All right. So, well, we are, but we're not connected. Well, kind of. There's lots of stuff we got to do. We have to make a connection to the blockchain, and then we have to load the smart contracts in there and then fetch the products from the smart contract and put them on the page. So, let's do those things one by one. Let's first connect to the blockchain. So connect blockchain, connect to smart contracts, load products. All right. So let's start with connecting to the blockchain. Basically, what I was saying before is, just like MetaMask turns your web browser into a blockchain browser, we use Ethers.js to turn our application to a blockchain application. Now, this is a React app. It's written in JavaScript. It does not talk to blockchain natively. So we have to use Ethers for that. So basically, Ethers uses something called a provider in order to do that. And it's going to connect to that window.ethereum object, okay, that we saw when we connected to MetaMask to fetch the account out, okay? So what we can do is basically use this syntax, new Ethers, which we've imported here, providers, Web3 provider, and then we pass in window.ethereum, and that basically takes our MetaMask connection, which we can save to a variable called provider. Basically, this is the thing that's providing the connection to the blockchain inside of our app, okay? And then just like we did set account, we can copy this and then set a variable up here and say provider, and then set provider. All right, and then use state null, and then we can set the provider like this. All right, and then we'll be able to use that anywhere we want to inside the application. All right, so now what we want to do is fetch the network ID because we want to know which network we're connected to inside of here. That's important in a minute. All right, so you can see we're on the Hardhat network, but we need to know the number that corresponds to that. So Ethers gives us a function for doing that. We can do const network equals await provider get network. Say console log network. We can make sure we're working properly. And here you go. Here's the network configuration. Chain ID 31337 and the name unknown. That's okay. So now we want to load these smart contracts and create JavaScript versions of the smart contracts. I'm going to say create JS versions so we can call their functions. So inside the test before, we were using JavaScript versions of the smart contracts just like this, right? Get contract factory, Dapp is on, deploy, we call the functions like connect, we call the functions like list, all right? And then, buy, all the type of stuff, right? What we're going to do here is essentially create an Ethers contract. All right, so let me pull this up in the Ethers documentation. Okay, all right, so here's an example. So here is how you create a new contract instance inside of Ethers. You go new Ethers, capital C contract, and then you give it the address of the smart contract in the blockchain, the ABI, okay, of the, of the smart contract, which I'll show you that in a second, and the signer or provider. So let's just go ahead and copy this. All right, I'm going to copy this directly from the documentation. I'm going to put it inside of here. Say const diapason equals this. New Ethers contract address. What's the address? Well, where is the address? Okay. So I have created something for you, which is a config.json file. Okay. Which has the chain ID of where the contract is deployed, the name of it, and then the address. Okay. And then that's the address right here. So let's just hard code it for now. And then let's just do that. All right. And then the ABI, which is where we'll fill in ABI in a second. And then we know the provider or signer. In this case, it's going to be a provider. We fetched our provider here from the blockchain. The provider. All right. And then, so he fills in 2 of the 3. Here's the address. Here's this. Now, where's the ABI? Well, if you look in this file here, the ABIs, I've also preloaded the Diapason ABI for you. So what is the ABI? So it is the abstract binary interface. That's what ABI stands for, which is basically just a JSON file that describes like how the contract works. It describes the functions that are available to call, what type of functions they are, whether they're read or write functions, and whether, what arguments that they require, et cetera, et cetera. Like you can see the buy function, okay? It shows you what's inside of there, okay? Inputs, outputs. It's got the events in there. I've imported this, but you can find them here inside of the contracts, the artifacts, contracts, Diapason, and then Diapason.json. You can see this ABI inside of here. If you make any changes to your contract, you need to copy this stuff and then put it inside of this file here. But I've already done that for you. Okay, and likewise, if you have a different smart contract address, you need to update that inside this config.json, which is here. Okay, you can check your you can check that here whenever you deployed it. All right, it'll say Contract deployment, contract address is this. Let's just make sure it's the same. Yeah, it's the same because Hardhat's always going to use the first contract as the same, but if you have a different address, you want to make sure it's the same. All right, so the ABI is in this file, and we've already imported it here. So ABIs import Dappazon from ABIs Dappazon.json, so we'll just replace the ABI here. All right, and then let's go to our page and see if everything's compiling properly. All right, so we still got a little bit of an issue here. Oh, I see. It's because I have a trailing parenthesis there, but now it should be working. All right, awesome. So, yeah, there you go. We've loaded the Dappazon contract. But now what I want to show you is I want to load this address dynamically. So what we're going to do is read it from this config.json file here. So we're going to load this into the project. All right, but you can see that this is like nested inside the network ID for each blockchain that you're using. So we're going to dig into this, all right, and then let's do this and then this. All right, so basically we're going to say, instead of just reading the address directly, we're going to read it from that file. We're going to say config, and then let's just pass in the network ID of, what is it? Let's do this network, and then say .dappazon .address, all right? And then you'll see it should still work. Okay. But I don't want to just hard code this value in here. We just got that from here, network. You can see that logged to the console. We can see 31337s here. So what we're going to do is say network.chain ID. All right. And then that will load it dynamically. All right. Awesome. Okay. So we've got a JavaScript version of the smart contract. And now we need to save it to a variable in the state. So just like provider, we're going to say Dappazon and then set Dappazon. And then we're basically just going to say set Dappazon right here. Okay. All right. So now what we're going to do is we're going to list the items from the smart contract. So we're going to start off and put them in an array. We'll just create a new array here. So load products. All right. We're going to say const items equals this empty array here. And what we're going to do is loop through them like this. We're going to use a for loop in JavaScript, just like we did in the deployment script. We'll say for var I equals 0, and then I equals less than 9, I plus plus. We're going to say const item await Dappazon items, okay? Then I plus 1, and then items push, and then we can do console log items. Let's just see if that works. And boom, there we go. We can see the items there. Camera, electronics, this is all the stuff from the blockchain, right? Here's the URL, et cetera, et cetera. So what do we do? So we use that for loop, and then we said await Dappazon items. Again, inside the Solidity smart contract, we have this items mapping. And so what we do is we just give it each ID 1 through 9, and then it returns the item, and then we can put that item into this array, which we added here, okay? So now what we want to do also is organize these items on the page, okay, in categories like clothing and jewelry, electronics and gadgets, et cetera, et cetera. So what we're going to do is filter through each of them, and you can use a function inside JavaScript called filter to filter through an array. We'll say items.filter. And we'll pass in each individual item with a function. And we'll say item.category, which is this right here, our electronics, right? We'll say if it's equal to electronics, then we're going to return that to this subset. So you say const electronics equals these items. Okay, so I'll do that. All right, then we'll console log that. And then boom, you can see the electronics are just 3 different things: drone, camera, headset. That's exactly what we see here. Drone, camera, headset, all right? And then we can do that again for the other categories. We can do it for clothing and toys. So we just copy that and then duplicate it. So clothing, clothing, toys, toys. All right. And then we can essentially save those up here. So we'll have our categories. So below set account, we just do this. Electronics, set electronics, clothing, set clothing, toys, set toys. And then I'll just let you see that if you need to. And then down here, we're just going to set them. Set electronics, set clothing, set toys. Okay. Let's just reload the page, make sure nothing's broken. So good. Okay. So now we've got those loaded up into categories. Let's show them on the page, just like this. What we're going to do is basically render out each section. All right. So what I'm going to do is just have a section here called, I'm just going to do a placeholder. I'll just say paragraph. Paragraph. And we'll say products. All right. So we can see that on the page. What we want to do is we only want to show this if the products are actually loaded from the blockchain. So what we're going to do is create something in here that waits for them. So we're going to say, basically, if the electronics are loaded, then we want to show this. Well, let's electronics and clothing and toys. Okay. And then we're going to do products. Okay. You see kind of flash on the page. That's because the stuff isn't loaded from the blockchain yet. We want to wait for it to load before we show it. Okay. So what that's going to do is it just waits for these variables to be populated, which initially they're null, right? And then when they're loaded, they have something there. So this is kind of confusing, but what this is doing in JavaScript, this and is just checking for logical truthiness. So in JavaScript, you have like, true, false. You have things that are implied truthy, like they exist. And then you have things that, have implied falsiness to them, right? Like null, right? So basically, electronics, if it's not loaded, you're just saying, is this true? Is this true? Is this true? And then is this true? So if there's something inside of here, of course it's true, but it's just going to load it on the page. If this is present, if this is present, if this is present, then do this thing. It's just a really common thing people do inside of React. It's a little bit confusing. I don't want you to get too hung up on it, but that's what we do in order to check for those being loaded. Okay. So what we're going to do is create a section. Okay. You see this section component here. All right. So this is going to be the section. We'll fill this in. We're going to create a section for each individual product. So we've got section imported here. Okay, section. What we're going to do is create a section like this. We're going to take out this products and say section title is going to be clothing and jewelry. Okay, and then items is going to be clothing. And then we have this thing called, let's just leave that for now. Okay. Well, we have this thing called toggle pop. We'll fill that in a minute. We'll just say equals toggle pop. And let's just see, we can make that a placeholder for now. We'll just say, we're going to come back and fill in toggle pop in a minute. We'll just say const toggle pop. We'll just make it an empty function for now. Sorry. Say console log toggle pop. Okay, we'll come back to that in a minute, but basically we just need that as an argument. Okay. And then let's just see if we, okay, let's see here. Let's just check that here in a minute. Oh, I see. It's because I don't have this closing line here. All right, save that. And then, okay, we don't see anything yet, but that's okay. Let's just duplicate this for all 3 sections. And then we'll put this in there like this. So this will be, electronics and gadgets, items, electronics, toggle pop, toys and gaming, toys, toggle pop. Okay. Okay, so inside of this section component, what we're going to do is basically, add a title here. Okay, we're going to have this H3 called ID title, and then we're just going to pass in the title. That's the title that got passed in. And then we're going to see that on the page. All right, so we got a little issue here. What's going wrong? So something doesn't have a close tag. I see what it is. Okay, so sorry. So back here, what we need to do is take all these and wrap them inside of an empty tag for React. So basically, we're going to do this and then do this. All right, and we're going to take all these and put them inside of it. Okay. So that should fix that problem. Sorry, everybody. All right. And then boom, there you go. Awesome. Now we can see we've got the sections: clothing and jewelry, electronics and gadget, toys and gaming. Okay. So then inside the section, we're going to fill this in some more. We're just going to give it a horizontal rule. It's going to be a little bit of space for each section. All right. And then boom. And then we're going to give this new section here called cards. So div cards. All right. And so what we're going to do inside of here is we're going to loop through each of the items that's passed in and show them on the page. So basically we can just say, we're going to do JavaScript inside of here. So items, map, item, index. And then we can do this. And then we can just for now, let's just return a paragraph on the page. And we'll say, item.name. Okay. For now, just to see if it's working. Okay. So let's see. I made a mistake here. Let's see. Oh, I see. There you go. Sorry. And then, all right, there we go. All right. Shoes, sunglasses, watch. Awesome. We see names, and that's the same as the names here. Boom. Okay. Now let's go and start filling this sucker out. So what we're going to do is create this section like this. We're going to take this away. And then we're going to basically do this. Okay. With this div class name card, index is key. Okay, because we have to have unique items inside of React. And then on click, we're going to do this toggle pop, which is passed in. We're not going to do that just yet. We'll fill it in a minute. Okay. And then we're going to pass in this, which is the image. So we say div class name card underscore image. And this image tag source image. All right. And then we'll give it some details like this. We'll say div class name equals card info. And then H4 is item.name, rating, which have imported this in a second. We pass in the item rating. I'll show you that in a second. And then we put in the cost. We format the cost to string like this, and we show it to ETH. And boom, there you go. That's looking nice. Now, when we click it, it doesn't do anything yet. Okay. You can see, we could just see this toggle pop is coming up. All right, toggle pop, toggle pop. What we want to do is click on these and then actually show the pop-up so that you can do things like see the details and purchase the product. But now we've successfully listed everything. Let's just go back and make sure that's working properly. All right. And let's look at the rating component. So rating is already done for you. So basically it just says, what's the rating of the product? It just says, is it 1? It shows you what the stars look like. And then we have these images inside of there, and it adds the value of the stars to the page for you. Okay. All right, so the next thing is let's go ahead and work on getting the pop-up to work. All right, so let's show the product details. What we're going to do is fill in this toggle pop that we did on click. So whenever we click it, we're going to call this function that we created earlier inside of app.js, which right now all it's doing is saying console log toggle pop. And so what we're going to do is basically tell it which item to select and then show a pop-up on the screen. So whenever we do that, we're going to pass in the item itself. All right. And then we're going to save the current item to the component state inside of React. So we're going to create a new thing right here. Say const item set item equals use state. And we're going to use an empty object as the default value in this case. So we'll take this out and say set item and an item. And that's going to be the item that shows up whenever we click on this. It'll show you the details for that particular one. Okay. And then we're going to have this thing called toggle, okay? Say toggle and set toggle. And this is say use state false, so the default value is false. All this is going to do is tell you whether or not, the product modal should be visible on the page, all right? So basically, we'll check that here. If it's false, then we'll set toggle to false. If it's true, we'll set toggle to true, all right? So this just basically like does the, just changes. So now let's just click it and it's not going to do anything yet. All right, I don't think, not going to do anything yet. But now let's create the component that actually does that, okay? So what we're going to do down here is basically check for toggle, say toggle, and we're going to parentheses here. And we're going to show the product component on the page. So we've got this product component here. We're going to put it down here. Oops. We're going to close it. Say item equals item provider account equals account. And then Dapp is on equals Dapp is on. And then toggle pop equals toggle pop. Okay. That should work. So let's just do that and click it. And then boom, you can see the page goes gray. All right. Then refresh and it goes away. So what we want to do is actually, it's showing the component now, but we want to fill in the details so that it actually shows the stuff on the page. So now let's go to the product component and then fill this in so that we can actually show the data on the page. All right, so inside of here, we're going to fill in some details. I'm just going to put in some boilerplate HTML code like this. Okay, so we can div class name product and then div class name product details. All right, here's the product image. All right, we're going to put the image in there, and then we'll put the overview of the product inside there. So I'll let you pause the video, copy that down if you want to. Okay. And then save that, go back to the page, and then, okay, it looks like we got an issue here. Let me just see what's going on. Undeterminate JSX content. So I believe that's it. We need an additional div here. Sorry, everybody. All right. Now that should be the correct solution. Let me just check it. Yeah. Okay. Hold on. Yeah. Okay. Now, if you want to copy that down, that should be the proper boilerplate code. Okay, and click that. Now we can see there's just a pop-up and it's got shoes there. Okay, again, it's absorbing a lot of the CSS from the index.css file that we have. But let's go and start filling this sucker in. So in the product overview, we're going to have an H1 item.name. All right, we're going to use the rating system. So we got the rating component filled in here. We'll just say rating equals value item.rating. All right, we'll give it a horizontal rule. All right, And then we'll give it the address. Item.address. And then we will give it the cost in Ether, like this. All right, we'll give it another horizontal rule. And then we'll do the overview. And then we'll give it a paragraph with the item description. This. So we do item.description, and then I put some lorem text in there. This is placeholder text. It's just standard Latin that people use for placeholders on websites and things like that, blogs, magazines. You don't have to put this in there. If you want to grab this lorem text from the Final Code solution, you can. But what I'm going to do is basically just, you can pause and copy all that down if you want to. You can leave this lorem text out if you want to. It doesn't matter. Let's just save that and see what it looks like. Okay. So if I go back to product overview, if I don't refresh, you can see all this stuff starting to fill in. Okay. You don't even have to refresh, but if you do, you can just refresh and then pick up a new product, right? You can see the sunglasses rating 1 ETH, 0.1 ETH overview. Okay. Then we're going to do this, have a new div here. So we'll say div product order, and then that's going to let you actually purchase the product. Okay. We're going to have this, the cost. So H1 Ethers utils, format units, item cost to string Ether, ETH. All right. And then we're going to show you that. Okay. And then actually what we want to do is move this up one because that needs to be in its own section. Sorry, everybody. Yeah, that looks better. Yeah, boom, there we go. That looks more like our mock-up. Okay. And then I'm just gonna toss this in there. We're gonna do this next. This is free delivery. All right, it's in a paragraph tag, and use a break. This is a line break, and we use a strong tag, and we're gonna put in the date. So this basically is just gonna show you the time, okay, for delivery, plus a certain amount of time, how long it'll take to get you, and it formats the date just like that. So it's just some JavaScript. You don't have to understand everything inside of there, but that's just formatting the date. So free delivery, Saturday, January 14th, okay, which is like 2 days from the time recording, 3 or 4 days. It's like 3 days. That's 4 days. So that's delivery time of 4 days. You could calculate this in seconds if you want to, milliseconds, for the amount of time you want for your shipping time. Okay. Now, if the item's in stock or not, we're going to show that. So item.stock is greater than 0. In stock, out of stock. So it's in stock, but if it's out of stock, it'll go away. And then we have a button to buy it now. Buy now. We use a buy handler on click. We don't have that yet, but for now we're just going to do const buy handler. Just an empty function for now. Okay. And we'll make this async. Okay. And then we're going to add this below it. We're going to say ships from Dapp is on, sold by Dapp is on. All right. If you want to copy that down, you can. All right. Click buy now. You can see that it's buying. Okay. So we know that's wired up. And then at the bottom, we're going to create this button to close it. So you have this, see here, actually, we don't want to do that in here. We want to do that right here. So we only want 2 divs below us. We're going to do this button. On click, toggle pop, class name, product close, image source close, alt close button. So if you want to copy that down, you can. And then if you go here, you can see that we see this X. You can take that X and it'll close away. Okay, if you click anywhere else, it won't do anything, but you got to click the X. And we have the buy button works. Okay. All right. So last thing we want to do is add this chunk of text to the page, okay? That's going to basically check for the order, and if it's been purchased, it's going to show when it was purchased. Now, we're not going to buy them yet. We'll do that in the next section. We're going to do this. So basically, we're going to check for an order. All right, and if it exists, then we're going to show this, item bought on, and then we're going to give it the date, and then we're going to show that on the page. Okay, I'll let you copy that down, or you can just grab it from the final code solution if you want to. I'll just leave that on the page. Okay, and so if I go here, so order's not defined. Let's just see here. We can go ahead and create a placeholder for that. We'll just go ahead and create at the top of the page here. We'll just do this as a hook. We'll do order and set order, use state null. And then boom, there we go. All right, so now we have come to the final boss on our project here, which lets us actually, which makes us want to buy the item, okay? And so what we're gonna do is wire this button up. So right now, we've got this, buy handler set up. We've got this on click tied to it, okay? And what we want to do is actually click it and then run a function in here that actually talks to the blockchain, okay? So inside of here, we just have to do a couple things. We've got our Dapp contract, which we can, connect to and then call the function. So we'll say let transaction equals, well, first of all, let's look at the test really quickly. You see how we did the purchase inside of the test? We just did Dapp connect buyer buy. We basically do the exact same thing. We said let transaction equals await Dapp connect buyer buy. We do the exact same thing here. Basically, we say Dapp connect. In this case, it's going to be signer. We don't have the buyer directly. But we do, but just going to call it signer and then buy. We pass in the item ID. All right. And then we give it the value, which is the ether value, which is the item.cost. Okay. And we're going to get the signer like this, which would be the buyer. So we say const signer equals await provider get signer. Okay. We did that in the tests too. You see, we did this, right? Ethers get signers. That's signers plural, which turns the array of all the accounts. In this case, we're just going to do get signer singular, which is going to do a single signer, which is the buyer, the account that we're currently connected to with MetaMask. Again, I'm using account, 1 here, which is the buyer in this case. All right. And then basically I'm going to say transaction and then, transaction await transaction dot wait. Okay. All right. And now, let's just see if it works. All right, I'm gonna go here, look at sunglasses, click buy now, and you can see a MetaMask confirmation pop up. It's gonna say you're buying it for 0.1 ETH, which is $134. Time to record this video. Click confirm, and let's see if it worked. It's buying, it's pending. Let's look at our blockchain there. Okay, and it worked. Okay, you can see the buy was successful, all right? And if you refresh the page, go back to sunglasses. Wait, what did we just buy? Yeah, I bought sunglasses. All right, we should see the order there on the page, so let's fix that. And now we need to update the code in order to essentially show this on the page that shows that it, actually was purchased and like reload in real time. So what we're going to do is create another thing. We need to create this order because if you look in our code, it's looking for the presence of an order, but before it shows this item purchased on. Okay. So basically, we're going to say, we're going to create another use state hook here and do has bought and set has bought. Okay. And then after this, we're going to say set has bought. And we're going to do true. And then here, we're going to create another function, const fetch details, which is going to fetch the details from the blockchain to see, it's basically going to reload all of the information from the order, okay? So what it's going to do is we're going to use the events from buy. So basically we can fetch the events from the contract like this, events await Amazon query filter buy. That's going to return all the events. And then we can filter through them to look for the order events like this. So say order events filter, just like that, a filter function that we use on the array to look for the categories. We just look for the event args buyer equal to the account, so the ones that we have, and then the item ID to string to see if the purchased one. And if that does not exist, then we're just gonna skip this. But if it does, then we're going to get that order like this and set order right here, okay? So let's say that lets you look at it if you want to. But finally, we need to call this function. So we're going to use effect. All right, like this. And we're going to do fetch details. Okay. But we're also going to recall this if has bought changes. That's what we do whenever we put something inside the array, has bought. So it's listening for a variable. If has bought changes, then it's going to fetch details again. So it'll automatically do it when the page refreshes. Save that. Let's go to our terminal. Let's go to our page here. Let's just refresh and should see this on the page. Let's just see here. All right, so I see what's wrong here. Basically, whenever I refresh, it's not connected with MetaMask. So let's just refresh again. Let's make sure there's no errors in the console, nothing important. Click connect. Now we have an account, and now we can see the item was bought at this time. Okay, so now we can see that. So if we go to another one, let's just, so it's in, so this is out of stock. So you can see there's no stock, so you can't buy it. But look, at shoes is in stock. Let's buy it and watch it happen in real time. Click confirm. And then boom, there you go. Item bought at this time. Okay, so we have just successfully completed our Amazon clone. So you've covered a lot in this tutorial. You've covered how to create the smart contracts, how to put them in a blockchain, introduction to IPFS, introduction to React, Ethers.js, all that type of stuff. There's a ton of stuff that you can do going forward. The best thing to do next would be able to put this project out on the live web, put it out in the blockchain so that other people can use it. But now you've seen how to create this step by step from start to finish. All right, so let's look at what we're going to code together in this tutorial today. This is a blockchain clone of Discord called Dapp. Okay, so Discord is a very popular application in the crypto space because it's one of the top ways that other crypto people communicate with one another, particularly NFT holders. So how this is going to use blockchain is basically people are going to become members of this channel by connecting their Ethereum wallet or their blockchain wallet. And then they have to hold an NFT in order to join an individual channel. Okay. And once they're in that channel, they can communicate, with other people who also hold those NFTs. Now, if they don't have an NFT, they can also purchase one directly inside the application whenever they want to join a channel. All right, so let's get an overview of exactly how this project is going to work. So basically what's going to happen is a user is going to use their wallet, okay, and they're going to connect, with a wallet like MetaMask with their browser, and they're going to access this website that you saw right here, okay? Let's just see this one right here. Okay, they connect their wallets to the website, and then that website is going to talk directly to a blockchain, okay, which is going to contact the NFT contract that we have created. And if they have, NFTs in their wallet, then they, of course, can view the channels and start chatting. Now, if they haven't, they can purchase the NFTs by minting them from scratch directly on the back end. Okay, and you can see these get minted 1, 2, 3, and they go directly to the user's wallet. And this will also keep track of each channel and that they have access to. Okay, so this is going to be a complete access control solution with these non-fungible tokens. Now, let's talk about the actual chat messages themselves. So, this, first of all, this website, okay, is going to be coded in React.js. And that's going to go, on a web server potentially. Again, this is going to be a hybrid application. It's not completely decentralized. But let's talk about the server itself for the messaging. So The messages are not going to go on the blockchain itself, okay? That would be very expensive. Every time you want to send a message, it's going to be super slow, not very performant. So we're going to use a server for this, okay? We're going to use specifically socket.io to do real-time communication where we can use WebSockets to send messages. And as soon as you send that, everybody who's a part of the channel will also be able to see those messages, provided that they have NFTs, and so that you can chat with one another. All right, so let's go ahead and start coding out the project. All right, so I put a link in the description down below to the code for this, okay? And so what you're going to do is copy this. All right, this is a GitHub URL, and you're going to go to your terminal. All right, you do git clone, and then you're going to paste in this URL here, but then you're going to do -- branch, okay, starter _ code. All right, and so what that's going to do is it's going to clone this repository. But if you look at that link that I sent you, this is for the master branch, okay? And the master branch contains the final code solution. I don't want to just download the final code solution. We actually want to code this project out. So what we've done is create a separate branch called starter code, okay? Git organizes its code into things called branches so you can create different versions very easily that you can swap between. And so we're going to use the starter code branch. That's what we did here. Okay, we did git clone Dapp University, /Dapp core -- branch starter code. And we're going to enter into that newly created directory like this, say cd Dapp cord, okay? And you can see my terminal here is telling me I'm on the starter code branch. So you can also say git branch, and it will tell you which branch you're on. So I'm on the starter code branch. I've verified that that's the exact version that we want. Basically, this has just, essentially got things started so that we have something. We don't have to code everything out from scratch, but we'll still be able to code a significant, the important parts so that you can see how this whole project develops. So once you've done that, we need to just install a couple of the dependencies. Pretty much the only thing that you need for initial setup is Node.js. So we're going to go to our terminal here and just do node-v. Okay, I'm using version 18.12.0. I highly recommend you use the same version as me. So if you're an experienced developer, you might be able to get by with a different version. But if you're brand new, I highly recommend you can download Node directly from the Node.js website. You can choose the version here, or you can use a Node version manager like N, all right, which is what I'm currently using. Make sure you got Node installed, and that's going to let you install all of the other dependencies that you need for this project. So we'll do that like this, say npm install. And whenever that's finished, you should see the success message. You might see some warnings here. Don't worry about that. They're just warnings. And then what we're going to do is go ahead and we're going to see if this worked by just doing npx hardhat test. Okay. And you won't see anything passing. That's fine. All we wanted to do is make sure that we can properly do this hardhat command, and that's going to let us know that everything was set up properly. So if you see a green message here, even if it says 0 passing, that's exactly what you want and expect. And once that's done, you know that everything has worked. All right, so now let's go ahead and start coding out the project. So you want to make sure that you open up your code in a text editor. I'm using Sublime Text. You can use whatever text editor you'd like. But let's take a quick tour through this project, okay? We'll get to some of the major parts later, but really the first thing you understand is we have this package.json file here. Okay, this is where we keep all the dependencies for our project. You can see things like, Hardhat's inside of here. That's the framework we're using to write the smart contracts. We're using, let's see here, React.js for the website. Okay, you'll see that. We're using socket.io for the chat server, okay? All that stuff's contained inside of here, okay? And we installed those packages whenever we did npm install at the beginning. So the next thing you want to take a look at here is the Hardhat configuration file. All right, so you can see that right here. Basically, this is just the configuration file that points your project to a blockchain. It's got some default settings in there, which you can't quite see right now, but it also specifies the Solidity version that we're using. Okay, this is the version that we'll use to compile our smart contracts. This is the Solidity compiler version. That's exactly what that is. All right, and then the next thing I want to point you to is the contracts directory, because that's exactly what we're going to focus on this section, is creating the smart contract for our blockchain-based Discord clone. Okay, so you've got a contract in here already called Dapp cord. Okay, this is really just a placeholder. Again, we're on a starter branch that has some stuff put in place for us, but we're going to fill all this out in this coding section. Okay, so we're going to create this Solidity smart contract. and you get the placeholder here. So at the top, you can see that it's already got the Solidity programming language version. That's how you do it. Pragma Solidity 0.8.9. And then you've got this contract keyword, Dapp chord, which is the name of the smart contract. And you got these curly braces. And we put all the code for the contract inside of these curly braces. Okay. So let's get a refresher on what we're going to create with this contract, okay? So ultimately, this contract is a non-fungible token contract that acts as the permissions for viewing our Discord server again, right? So a person's going to connect their wallet to a browser to the website, and then we're going to have an NFT contract that lets people essentially, buy the NFTs if they want to join a specific channel. And it'll give them an NFT so they can access this channel on the Discord clone, okay? So we need a contract that is a non-fungible token or is an NFT, and then one that actually manages the memberships for each channel that they are a part of. And that's exactly what we're going to create in this section. Now, we're going to use the ERC 721 standard for our non-fungible token, okay? So what is that? Well, basically, ERC 721 is just a specification that describes how NFTs should work so that they're compatible with wallets, with marketplaces, all that type of stuff. And really, it just describes the set of functions that are on it, all right, and what those functions do and the events, all that type of stuff. It just standardizes the behavior and the interface so that it's compatible with lots of different things, okay? You can see functions like balance of, owner of, transfer from. These are really popular NFT functions that are required by the ERC 721 standards. Basically, the most popular NFTs out there follow this standard, at least most of them do. So, because we're going to use this standard, okay, we don't have to reinvent the wheel on everything, okay? So we're going to use the Open Zeppelin library, which is a really popular library for creating common smart contracts quickly. Open Zeppelin is a security auditing company in the space. They put out these open source smart contracts. People can use them. They're highly vetted, widely used. So you can see the ERC 721 contracts are in here. And basically, we can just import these into our smart contract and then inherit from them. And that's going to give us a lot of the behavior that we want for free without having to code everything from scratch. Okay, we don't have to sit here and code out a balance of function. We don't have to code out an owner of function, all that type of stuff. We can get it from the library and then just kind of plug it into our smart contract. And then, it'll speed things up a lot. So that's exactly what we're going to do. We're going to import the Open Zeppelin library into this contract first. You can see we've already got it installed inside of our package.json file here. Let's just see here. You can see Open Zeppelin contracts is installed here. So that's going to be in our node modules directory too. Sometimes people ask me where these come from. I'll show you right now. It's pretty common for people to use the prefix on their node modules and puts their stuff at the top, but now everybody does that, so it doesn't really help that much. But let's just see here. Open Zeppelin right here. So Open Zeppelin, you can see the contracts directory, and then you can see the token directory. You can see ERC 721, ERC 721 .sol. So this is what we want to import, all right? We want to get this ERC 721 contract. You can see it's got like a name, symbol, it's got a constructor function. It's got all this stuff, balance of, owner of, all this stuff, so we don't have to code it out from scratch. Now, you could just like copy and paste that into this file, but that kind of sucks. So we're going to do it a better way, which is just to import it. All right, so Solidity has an import keyword that lets you just pull in stuff from a different file name, including your node modules directory. So it knows to look inside your node modules for this exact file right here. So Open Zeppelin, contracts, token, ERC 721, ERC 721 sol. That's what I just showed you right here. And now we've got that inside of here. All we have to do is inherit from this contract right here. So now we've got this in view inside of our file, and we can just say is ERC 721. All right. And now we have a smart contract that essentially, it just imported all that behavior into our contract here. So let's do one more thing to get this set up, and then run a basic test. So inside of here, let's go back and look at our Open Zeppelin contract. let's just see here. Let's see, opens up in contracts token. Sorry, everybody. And then ERC721.sol. So that's the IERC. Let's look at this. Okay. Notice this has a constructor function. So what is that? Well, a constructor function is a function that's run once and only once. And that's whenever the contract is put on the blockchain or deployed. And what we want to do is fill this in our contract too. This contract has a constructor function, so I want you to put in the name and the symbol whenever you deploy the contract to the blockchain. So we need to do that as well. So we'll write our constructor function like this. Basically, we'll just say constructor. Okay, we'll pass in a string memory name, and then string memory symbol. Okay, and then we'll pass, we'll just say more code will go here later. All right. But what we want to do is actually pass along this name and symbol to this contract that we're inheriting from. So Solidity has a special syntax for doing that. Basically, what you can do is you can call the constructor of this contract that you're inheriting from like this. Okay, you just say ERC721. That's the name of the contract. And then you can pass along these arguments that you passed in right here, okay, into this contract. So we'll say name and then symbol. All right, and it should look like that. So constructor, you pass in your name. Symbol, again, these are just strings. That's the data type of the variable that you're passing in. Memory is just the location. And then in order to pass these along to the parent contract, we just call the name of the parent contract here, which is ERC721, and we pass in that name and symbol. And that will call its constructor function like that, okay? So we can also just move this onto a new line to make it more readable. And then do that, okay? All right, so really quickly, I want to test this behavior out because, we're sitting here coding out Solidity, but we don't know if it actually works. You could do a basic check to see if it compiles. You could go to your terminal and do npx hardhat compile. I think that's the command. I come from a truffle background, so sometimes I forget the hardhat commands. That is correct. So npx hardhat compile worked properly. So hey, at least we don't have any compiler issues. Again, when you're building out the smart contracts, compilation is the first step, just to make sure that your Solidity code doesn't have any issues that won't compile. Okay. So anyways, that works. So now let's go ahead and write a basic test just to make sure that this is working properly. Okay, so I'm going to close down these node modules. We don't really need to look at that anymore. If you go to the test directory, we have a Dapp cord test file in here, okay? So what are tests? So basically, you have this test file over here that's written in JavaScript, okay? So notice these are different programming languages. This is Solidity. This is JavaScript. So it's pretty common to do tests in JavaScript. That's one of the reasons I focus on JavaScript for blockchains. You can do so many things with it. You can write tests, you can write scripts, you can write front-end websites, which we'll do here in a minute. And you really want to write tests for the smart contracts to make sure that they work properly while you're developing them, because it's going to save you a lot of time. This is automating this stuff. Like if you had to go, put this stuff inside a remix and hand test it over and over and over again, it would take you forever. But if you write tests, you can rerun those tests over and over and over again. It saves you lots of time, okay? So additionally, smart contract testing is super important because, smart contract development is so different from, regular development, either a web development or mobile app development or whatever it is, right? Because the cost of mistakes is really high. You can't just push out bug fixes. So you want to measure twice and cut once and make sure that everything worked properly. And testing your smart contracts is really crucial to that process to make sure they're bug free. Because once you put code on a blockchain, it really can't change. So inside of here, what we're going to do is write a basic test. All right. So we're using the Chai assertion library, the Mocha testing framework, which come bundled inside of Hardhat. All right. And what we can do is just write a basic test here that says describe and say deployment. Okay. And then we can pass in a function here. So what we're doing is we're just saying describe Dapp cord, which is the contract, and we're just grouping this into another section here that's just describe deployment. All right. And we write each test example like this. We just specify the behavior. We say like it sets the name. All right. We can say async. Okay. And then what we're going to do inside of here is deploy the contract. Okay. So basically what we're going to do is say const Dapp cord, okay, equals await. We're going to use the Ethers.js library for this, which we've got imported already. Say Ethers get contract factory. What that's doing is just getting the JavaScript version of this contract, basically. Okay. And then what we're going to do, I'm just going to put it on one pane here so you can see it better. Then what we're going to do is go ahead and deploy that smart contract to the blockchain. So we basically say Dapp cord equals await Dapp cord deploy, and then pass in, let's just give it a name, call it Dapp cord, and then a symbol. Okay. And so again, we're passing in the name and the symbol because this is in the constructor function. This is the function that run whenever the contract's put on the blockchain. We're calling the constructor function whenever we deploy it to the blockchain with this deploy function. So we need to pass in the name and the symbol, which is this right here. Okay. And then what we're going to do is just check that once it's deployed, the name is actually set. And so what that's going to do is basically make sure that, hey, this is actually inheriting from the library. We're able to pass in the name and symbol on deployment, and that it actually, it actually gets those. So we'll just say name and symbol. And so what I'm going to do is I can check the name here. I can say, let's just say let result equals await Dapp cord.name. And then we can use the expect function inside chai. Say expect result to equal Dapp cord. Okay. And then next we can check the symbol and say result equals await Dapp cord symbol. And we can just expect, let's just expect results to equal DC. All right. So we deployed the contract here. So I'll just do some comments. And then we'll say fetch name, check name, fetch symbol, check symbol. Okay. And I'll even give those some space so that make a little more sense. So if you want to pause that and copy any of that down, feel free. All right. So now let's go ahead and run the tests, see if it works. So what we're going to do is say npx hardhat tests. All right, it works. So it sets the name and the symbol. So we know that it's working properly. Now, again, this is really just a basic test to make sure that, hey, could we actually wire this thing up? Could we pull in the library? And once you add this test, okay, my code works. That's the value of this test. And once you write it, you don't have to change it. Okay. Now, small caveat, we're going to refactor this, which basically just means rewrite the code so that it's better. Okay. Because we want to write more tests and we don't want to have to do this every single time. So, for example, we want to say, let's just write, really, when you're doing a test, most of the time you just want to check for one thing at a time. So like we want to do, I'm just going to copy this and put it here. And so like this is going to be just sets the name. All right. And then this one's just going to be sets the symbol. We only want to do check the name in this one, symbol on this one. But, we can say fetch name and then fetch symbol. So let's take the symbol out of this one. And then let's take the name out of this one. Okay. And then we can say let result. Okay. And then we can run the test again. All right, now you can see that each test is on a different, example. So it sets the name, check, it sets the symbol, check. It's nice to see both of those in their own test rather than just it sets the name and symbol, because if one of these failed, you'd have to dig in and figure out which one was failing. All right. So you can see we have some duplication here, like we're deploying the contract inside of each test example. We don't want to do that either. So what we can do is use a before each function. So we can say before each, it's async. All right. And then pass in this. Okay. And what we can do is move this up here. So we can put this here. Excuse me. All right. And then what we want to do is, let's say let Dapp court up here. So we can check it throughout here. Now let's take this out. And then let's, all right, it looks like it's still working. So you see what I did here? Basically, we were calling this line inside of every single test example, and that's duplication, and it kind of sucks. So what we do is use this before each function, which is going to run before each of these test examples, okay? And so all it does is basically get the contract and deploy it to the blockchain, so we've got a fresh copy, okay? Now, we can also refactor this so that we're not just checking name and symbol. We can put this up here. We can say const name and symbol. We can save these as constants up here, okay? And we can pass in, name and then symbol. Okay, and let's just run the test real quick to make sure it passes, that it actually took those. All right, and that's the nice thing about tests. You can just change things and run them to see if it still works. And what we can do is then pass in the name here and symbol here. Okay. And boom. So that way you don't have duplication. You just define the name and symbol here, you deploy it here, you check it here. All right. So let's go ahead and do one more thing before we move on here. The last thing I want to do with this is set an owner for the smart contract. Again, so in our thing here, we want somebody to be able to receive money, okay? So let's say somebody purchases the NFTs with Ether, that's Ethereum cryptocurrency. Whenever they mint them to join the Discord server, we want to get paid for that, okay? And we want the owner of the smart contract, or the person who created it, to be the one who receives the money. So we need to define that person. We're going to call them an owner, okay? So what we're going to do is basically set an owner up here, okay? So we're going to use a state variable for this. So a state variable is essentially a variable that's going to get written to the blockchain. It's going to get saved on chain. Okay, it's a variable that belongs to the entire smart contract, so you can reference it wherever you want to, not just inside specific functions as local variables. So we can define a state variable like this. We just say address public owner. Okay, so this is going to be the person who owns the smart contract. So let's check out the syntax here. Address is the data type. Okay, so an address is like an Ethereum address, like your wallet address. Like, an example is 0xabc123 blah 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 kf1. Okay, like I'm abbreviating that, right? They're really long, but that's kind of like what an address looks like. But that's what the address data type is. It's basically a wallet address. Okay, Solidity is a statically typed language, which means that you have to define the data type, and it's not going to change whenever you do that for this variable. So public is the visibility, which means you're going to be able to read this variable outside of the smart contract. And that also means Solidity is going to give us a special function so that we can read this variable outside the smart contract. We can basically just call Dapp cord owner, and it'll tell us the address of the person who owns it, right? So this is just defining the variable. We also want to set it. So when do we want to set it? Well, we want to set it in here whenever the contract is put on the blockchain. Basically, we're going to take the owner as the person who's deploying the contract. So the developer that puts it on chain, that's going to be the owner. So how do we get that person? Well, we do this. Okay, so what is this? Well, basically, we're assigning this owner here, so we can reference this variable value inside this constructor function, and then we use this equal sign to assign it to message.sender. So what does that mean? Well, message is a global variable inside Solidity, which means it's available everywhere inside of any Solidity contract, okay? And it has several properties on it. One of them is sender, and sender is the person essentially who's calling this function, in this case, the deployer. So it's an address. And so basically we can take this address and assign it to the owner, and we save it as address type in the public, owner variable, and we'll be able to reference that out of the smart contract. And we'll, of course, reference the owner in a couple of different places for the smart contract, okay? So let's go ahead and check for that. Basically, what we're going to do is have a test here, all right? After it sets the symbol, that just does this. It sets the owner. So basically, we'll say const result equals await dappcore.owner. That's the function I was talking about we get for free. We expect result to equal deployer.address. Okay, so we want to save the deployer. All right, we do that like this. Basically, we can get some signers from Ethers.js. Basically, these are the wallets that are connected to Ethers with Hardhat. Basically, we just say await Ethers get signers. Okay. And basically what that's going to do is return an array of all of the accounts that are connected to Hardhat tests, okay? So we can, basically break those out like this. We can say deployer and then user. We can set up two different accounts, okay? And then essentially we can, create variables for those up here like this. And then that's going to save each one to an array. So this gets kind of confusing sometimes. Basically, understand that Ethers get signers returns an array of signer objects, not addresses themselves. They're objects, but it's an array. And if you want to pick out individual items from this array, you could just say deployer user equals await Ethers get signers, and it's going to do it. It's going to assign these variables to the first two items. It'd be the same thing as saying like, deployer equals, signers 0, and then user equals signers 1, if you had saved this result to a signers variable. So it's the same thing, it's just a shortcut. Okay. So anyways, we got a deployer, and so now what we're going to do is just check that the owner is equal to deployer address. You have to call .address on here because it returns a signer object. If you want to actually pluck the address itself, you need to do this. All right, let's see if the test passes. Yep, awesome. So it sets the name, the symbol, and the owner. All right, so now that we've got the basics set up, let's continue on with developing out our smart contract, okay? So first of all, what we want to do is take a look at this. Basically, someone needs an NFT anytime they want to join a Discord channel, okay? So what we're going to do is basically set up a way to save all the Discord channels inside of our NFT smart contract, okay? So what we're going to do is have a function inside of here called create channel. Okay, so you can create a Solidity function just like this. You give it the function keyword, you give it the function name. All right, we're going to call it create channel. That's just the name we came up with. And then you can pass any arguments inside of these parentheses here. And of course, you put all the code for the function body inside of these curly braces. I'll just say code goes here, okay? And so we're going to take two arguments for this function, which are just parameters that you can pass in whenever you call the function. So we'll say string memory name, and then string uint 256 costs. Okay. So basically, string is a data type string. It just looks like anything inside of quotation marks, like foo bar baz. Okay, and then a uint 256 is what's called an unsigned integer in Solidity. It's just a number 1, 2, 3. With no sign, so it's not negative, okay? A negative integer would be, a sign is a minus sign, okay? So this has no sign, which means it's positive. It's an integer, okay? It doesn't have decimal places. All right, and it can be 0. So anyways, the string name and the cost, this is the name of the channel. It's what it sounds like. And cost is going to be the cost of cryptocurrency to join the channel. And that's going to be paid in Ether. They're going to pay in ETH, they're going to get NFT, and they're going to create the channel whenever they're going to join the channel whenever they do that. Okay, so this is not the cost to create the channel, it's the cost to join the channel. So we want to call this, we give this function a visibility, which is going to be public, which basically means you can call this function outside the smart contract, maybe from a website, for example, or with your wallet. It doesn't mean that you can only call it inside the smart contract from another function. Okay, so what we're going to do inside of here is we're going to save a new channel. We're going to create one. So in order to do that, we need to model a channel inside Solidity. So Solidity has something called structs, which lets us create our own data types however we want to. And we can define them with the struct keyword like this. We can say struct channel. All right. And what that does is we create this new object, so to speak. That's not really a technical term. I'm trying to give you layman's terms to understand what this is doing. It's just this new structure, this new data structure, new data type called channel that we defined out of nowhere. And we give it some properties, okay? So one property is going to be an ID. So we'll say uint 256 ID, and then string name, and then uint 256 cost. So think about this in really simple terms. Like we get to create this arbitrary data structure called channel, and we just give it some properties like an ID. You can think about an ID as just like a unique identifier, 1, 2, 3, 4, 5, 6, 7, 8, 9. Which channel is it? Hey, it's channel 10. Hey, it's channel 25. Hey, it's channel 50, right? That's how you think about this. The name, pretty obvious. What's the name? New developers, welcome channel, general, Q&A channel, right? And then cost is how much does it cost to join that channel? Does it cost 1 Ether to join? Does it cost 0.1 Ether to join? Does it cost 50 Ether to join, right? Those are different properties that are on this channel, okay? So now this just defines how a channel works. It doesn't actually create a channel. So we're going to create one like this. Basically, inside the function, we'll create a new channel. We'll say channel, and then we'll pass in an ID, let's just say 1 for now. And then the name is going to be the name passed in from here. And then the cost is going to be the cost passed in from here. So that's how we create a channel. Here's defining how the channel works. Here's creating a new one inside the function call, okay? Now, where do we put that channel whenever we've created? Because all we've done is just created a new channel in memory. We haven't actually saved it to the blockchain, okay? So we're going to save it to the blockchain with something called a mapping. All right. So a mapping looks like this. Okay. So what did I just do here? Well, I created a mapping. A mapping is a key value pair. Okay. So what is a key value pair? Let me just show you. Basically, it's a way to store information where you have a unique key, all right, that maps to one and only one value. Okay, so let me just pull this up here. This is a pretty good example. So you can see this on Stack Overflow. So here's a key value pair in a table. You have a key, first name, value is bugs, last name, value is bunny, location, value is earth. So this is an example where you have a key that corresponds to one and only one value. All right. So first name, you can't have 2 first names. I guess you technically could, but in this case, let's say you can only have, like if you had a hyphenated name is what I mean. But like you only have one unique first name. Like you don't change your name. Okay. So it's always bugs. Last name, let's just say for example's sake, you can never change your last name, right? It's permanent. So then it corresponds to one and only thing, okay? So similarly, we can do that inside Solidity with this. Basically, we can give it a key, which is going to be the ID. That's just going to be the number, like, hey, which channel is it? 1, 2, 3, 4, 5. And then the value is going to be the actual channel itself, which we put in here. So you define the mapping by giving the data type of the key. In this case, it's an unsigned integer. It's just a non-negative number, okay? That's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, 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 blah. And then the value that it corresponds to is going to be the channel, which we created right here. And then we just saved that mapping to a variable called channels, okay? We just gave it an arbitrary name here. And then we made it public so we can read it outside of the smart contract. But even though it's public, we can also read it and write to it inside the smart contract as well, okay? So we can take this channel that we just created and we can save the mapping to it like this. It's pretty simple. All we do is say channels 1 equals channels. Equals this new channel that we created. So you save stuff to a mapping by giving it the mapping name and then using brackets to pass in the ID that you want to save it to, or the key, I should say. The key in this case is just 1 because it's channel 1. We just give an ID and we say, okay, so channel 1 is going to be equal to, that's the assignment, this new channel that we just created right here, okay? So that's basically how you do that. So, yeah, that's the gist. That's how you create a channel. Channels 1 is equal to this new channel. Now, there's one final problem with this, which is every single time that we call this function, even if we give it a new channel and name and cost, it's going to create a new channel, but it's going to overwrite channel 1 because we're just saying, hey, create channel 1 every time. What we want to do is create channel 1 the first time we call this function. The second time we want to create channel 2, channel 3, channel 4, blah, 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 and then increment that value in an intelligent way every single time we call this function. So what we're going to do here is create a state variable, all right, called total channels. We'll call uint public total channels right here. This is a uint 256, just like we saw right here, just like we saw right here. It's just a number, a non-negative number without decimal places that can also be 0. And what we're going to do is say, total channels. We're going to reference that value. All right, the first time that we call this function, it's going to be 0. Okay, it's basically like whenever you do this state variable, the default value is 0. So you could specify that here, or if you don't do that, it's just going to default to 0. So the first time we call it is 0. So what we can do is say total channels equals total channels, plus 1. Okay, and then you can take this total channels, which is now going to be 1 the first time we call it. And then you can replace the channel ID with total channels. And then you can replace the key here. All right. And so now basically every time we call the function, it's going to add 1 to it. And it will intelligently increment the channel count and just create channel 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, et cetera, et cetera. Okay. Now, what the last thing I'm going to do is basically take this function and refactor this, because there's a better way to do this in Solidity. Instead of writing this saying total channels equals total channels plus 1, you can just take total channels and just do plus plus, and that will add 1 to it. All right, that's a shortcut inside Solidity. You don't even have to use the assignment. You just take the variable value. This is called the increment operator, which just adds 1 to this number and saves it. Okay, and then now we can do total channels equals channel. All right, so now inside of our test, what we're going to do is check for this. So we're going to collapse this so that I can have some more space. Okay, I'm going to add some space at the bottom. And what we're going to do is have a describe here that says describe joining channels. And actually, let's change that to creating channels. Sorry, we'll describe joining in a minute. Yeah, okay. And so what we can do is basically in our before each up here, we can actually create a channel. Okay. So what we can do is basically create a channel like this. Say create a channel. All right. And then I'm going to say const transaction equals 08 Dapp connect deployer. All right, and then say create channel. Pass in a name, we'll say general. And then let's pass in a cost tokens 1. All right, and then let's do this, say await transaction wait. All right, I'm gonna pause that and check it. Let's just run the test to make sure nothing broke, and then I'll explain all that code. All right, so it still works. Now we're not checking for creating channels, but we just wanted to do this in our setup step to make sure it didn't break anything. Okay, so let's explain what happens. So what we're doing is we're calling the create channel function on this Dapp smart contract. But when we do that, we have to specify who's calling the function. So we do Dapp connect, which basically connects a signer, in this case the deployer or an account, if you can think about it that way, to the Dapp contract. Because what we're doing is we're calling a function. We have to use our private key to sign that function call. That's a transaction that's being submitted to the blockchain. And so we have to tell it who's doing it, okay? Because it's a write function. You have to pay gas to do that. It's going to deduct the gas from the deployer's wallet. So basically, you have to connect the deployer to the contract, so you can call this create channel function, okay? So we call create channel, pass in the name, all right, because it requires a name, right? Here's the name, create channel. And then the cost, we're going to say it costs 1 Ether, okay? And so we're just passing in 1 to this tokens function. Now, let me explain why we have to use this function in the first place, which we imported here, okay? So again, we're using this thing uint256 all throughout our smart contract. That's because Solidity doesn't deal with decimal places. Anytime you want to deal with something that has whole number, anytime you want to deal with something that has with decimals, you have to just express it as a much larger value and then basically convert it to decimal places later. So if you want to write 1 Ether as the cost, let's say you want 1 Ether, you can't just pass in 1 to the smart contract because you have to tell it how many. It doesn't know how to deal with decimal places after it. So what you have to do is express it in the way value. Okay, so basically, what is way? Well, way is like a penny in the Ether ecosystem or the Ethereum ecosystem. What I mean by that? Well, think about the US dollar. The US dollar has, is made up of cents. Like cents are the smallest unit of a dollar. So a dollar is equal to 100 cents. All right. So I'm just going to do this and say $1 equals 100 cents. So 1 Ether is equal to this many way. Okay. So is equal to okay. So basically there's 18 zeros after the decimal place. Is how you can think about it for, is how you can think about it for Ether. So you can see that on a website like Ether Converter. Okay. You can, basically you can say, 1 Ether is equal to this many way. And if you're trying to go backwards, you can do that. You can see the Gwei value. Okay. That's why we do that. So basically you could just write, this. Though that sucks, right? It absolutely sucks. Hard to read that. You have to go and count every single decimal. And every time I write that out, I'm literally counting in my head how many zeros I'm putting in. So that's a pain in the butt. So we use this tokens function to convert 1 to that big, long number that you saw right there, okay? All right, so anyways, that's working. I need to explain that part because that's a kind of a gotcha for most new people. And so for creating channels, what we're going to do is just create an example inside of here that it says it returns the total channels. So say it return total channels. Basically, we're saying const result equals await Dapp core total channels, which is this function right here. All right. And then once we've created the one here, it should return the number 1. Okay. Expect result to be equal 1. And then we're going to say it returns the channel attributes. So basically, you can jump in there and say const channel equals await Dapp core get channels 1. All right, you can say get channel, which is calling this function that we just created. All right, and you get the name. Well, actually, we don't have the get channel function yet. Let's go ahead and create it. Okay, so what we're going to do is once we've done create channel, we can do get channel like this. Basically, we just do function get channel, pass in the ID. All right, it's called public. It's view, which means it's a read-only function. Okay, it doesn't modify the state. But it can read from the state and do returns a channel from memory. Okay, and we just pass in the ID, channel ID. All right, and then inside of here, we can just say, we get that channel with the function, pass in 1, and say channel ID to be equal 1, expect channel name to be equal general, and expect cost to be equal to tokens 1 or 1 Ether. So that's all our tests. I'll let you pause this if you want to copy this down, or you can get it from the final code solution. And I'll go back to the smart contract in a second to see that other function that we quickly kind of threw in there. So I'll pause this first. All right, now if you want to check out this and pause the video, here's the get channel function. All right, so let's run the test, make sure it passes. All right, boom, it works. All right, now there's one more thing I want to do on this create channel functionality. again, we have this owner of the smart contract, and really we don't want anybody to create channels. You can kind of think about the owner like being a moderator for the Discord as well. So we only want them to create the channels, okay? So how do we do that? Well, we can use a function in Solidity called require. Okay, so require, what it does essentially is it checks that a statement is true or false. So if I said require if I said require true, basically nothing about this function is going to change, okay? And so what I can do is pass in expressions inside of here, like say 1 plus 1 equals 2, all right? That's a true statement. 1 plus 1 does equal 2. And so this expression will evaluate to true. And because it evaluated to true, everything in this function, like the function will keep running after this, okay? And we can actually create channel. But if I said 1 plus 1 equals 3, that's not true, all right? And what would happen is the function would stop at this line and nothing after this would run, and the function would revert and the transaction would fail, okay? So essentially, require, what it does is it puts a check in here that says, hey, require that this thing that I'm checking for right here is true before you do any of this other stuff. So in this case, what we can do is we can require that, let's see, message.sender, all right, the person who's calling this create channel function is equal to the owner, all right? So message.sender equals the owner, the person who created the smart contract. If that person if the owner is calling this function, then do all this stuff. If it's not the owner, then basically just revert the entire transaction and don't let this person do this, okay? So we can just run the test to see if it still passes. It should still pass. Yeah, it still passes. That's because inside of the test here, we're actually connecting to the Dapp core contract with the deployer who is the owner. And you could write a separate test to check for this, but just for the sake of time, I'm not going to do that. All right. And so that checks for the message sender equals the owner. Now, what we can do is make this better. We can use something called a modifier inside Solidity. So let's say we wanted to do this in multiple functions. We could not have to repeat ourselves so much. We can create something called a modifier up here, where we can basically say modifier only owner. And what we can do is basically copy this and put it inside of here. Run the function body, and then apply this to our function just like this. Okay, and then if I run the tests, it should still pass. Awesome, still passes. So what did I just do? Well, I created this thing called a modifier, and what a modifier is, it's just something that modifies the behavior of a function. So what this says is whenever you apply this to a function, you run this require statement before all the other code in the function, okay? So people ask me, what does this little underscore mean right here? That represents the function body. And what it's saying is do this before you do everything else. You can put it after, you can put stuff before and after. It lets you specify it however you want to. But in this case, we're saying before you do anything inside that function, check this first. Make sure that only the owner can call this function. And then we take this modifier and we just apply it to our function like this. Here's the function visibility. Here's the modifier, all right? And so what we can do is we can use that on another function at the end, which we'll get to momentarily. All right, so the last thing that we want to do, well, mostly the last thing we want to do here is we want to mint NFTs. So somebody has a NFT, we can check that so they can join a channel, right? We've created the channels. Now we want them to join a channel. And when they join a channel, basically they're going to mint an NFT every single time they do that. So we can call a mint function, which basically creates their channel access or their NFT from scratch and then sends it to their wallet, okay? And that's exactly what we're going to do right now. So basically, we're going to create a function here, all right, called mint, okay? And then inside this function, we're going to basically join channel and then mint NFT. All right, that's exactly what's going to happen. So let's fill this function out. Basically, what we're going to do is say uint 256 ID. All right. And then basically that's going to keep track of the channel that they're joining. That's the whole ID. That's the basically the channel ID, so I can think about it. And it's a public payable. So payable basically means that they can send in cryptocurrency with this transaction because they have to pay in order to get an NFT. So the payable crypto is going to be Ether itself, or if you're deploying this to the EVM compatible chain, the gas token for that chain. Okay. So inside of here, we're going to use our Open Zeppelin library, all right, which we've imported here. And if I show you inside of that, node modules, open contracts, Open Zeppelin, IRC 721, basically we've got a function in here called safe mint, all right? And so what that does is creates a token. It mints one from scratch. Basically, it gives it the wallet. You say who you're going to send it to, basically the wallet address, the token ID, and then any data that you want to have associated with that, okay? So we can call this safe mint function from their contract like this, okay? And then we can say message.sender. Okay, that's the person who's minting the NFT. All right, that's the wallet it's going to go to. And then basically, we can essentially give it an ID. For now, we're just going to say 1. We'll fill this in a minute. So, but that's the functionality to mint the NFT. All right. So, how do we basically get this number? Well, remember we hard-coded that before with channels. So what we want to do is keep track of the total supply of NFTs. All right. So at the top, what we're going to do is create a state variable called total supply. That's going to be just an unsigned integer. That's going to start at 0. But then every time we mint an NFT, we can just do total supply and then increase it by 1. All right. And just like we did with the channels, and then pass in total supply right here. All right. And this, I guess that's kind of all the same. I'm just going to take these comments out. But anyways, we're minting the NFT here. And then we need to join a channel. All right. So in order to join a channel, what we're going to do is just like we have a mapping of the channels, all the channels available, what we're going to do is create a channel, a mapping that says who's joined channels, okay? But this is going to be a nested mapping, and it's going to be kind of confusing. So I'm going to explain it, all right? I'm going to toss this in here. It looks kind of confusing, but let's talk about what it is. So this is a nested mapping, all right? It is a mapping that contains a mapping, okay? It's two-dimensional if you want to think about it that way. So what we do is we use a mapping keyword, all right, that takes a key of an unsigned integer, all right? And that's going to be essentially the channel. All right, so say for channel 1, what we're going to do is we're going to turn another mapping that's all of the addresses of the people who have joined that channel. And basically, the key is going to be the address, and a Boolean value is going to be true or false. So basically, how we could look at this is say like, hey, in channel 1, let's check for this person's address and return true or false. Are they a part of this channel? Okay. Or we say, channel 2, pass in somebody else's address, and it might return false, so they're not a part of this channel. And basically say public has joined. Now, by default, this is going to be false. So anybody who has not joined a channel, we check for the address, and then they haven't joined yet, it's going to return false automatically. So what we want to do is set that to true so that they can join the channel. All right. And we do that like this. We just say has joined. All right. We give it the first key, which is the channel ID. All right, so this is the ID that's getting passed in here from the function call. And then we just say message.sender, all right, which is the person who's calling the function. And we say true. Okay, that's how you join the channel. It's pretty straightforward. All right. So now they're going to mint an NFT. It's going to go to their wallet, and they're going to join the channel. Now, inside of the test, let's go ahead and check for this stuff. Let's just say it joins the user. I'm going to go ahead and toss this test in there so that you can see how it works. You can grab the final code solution if you want to. All right, so it says describe joining channels, and you can also pause the video if you want to copy this down by hand. say joining channels. So const ID is going to be equal 1. Amount they're going to pay is Ethers utils parth ether 1 ether. Okay. Do it before each, which basically is going to call Dapp core connect user, just like we did before. We're going to call the mint function we just created, passing the ID. Now this thing right here, value, is the amount of cryptocurrency that we're going to send in with the transaction. In this case, it's just going to be 1 ether. Okay. And so what we do is check that it joins the user. So we say, const result equals await Dapp core has joined user address, expected to equal true. It increases total supply. So we get total supply should equal to the ID. And then it updates the contract balance to make sure that it received the ether. So we say result equals await ethers provider get balance Dapp core address. Expect result to be equal to amount. All right, let's save that. Let's run the test, make sure that it passes. And boom, it passes. All right, so I'll let you pause the video here if you want to copy this down by hand, or you could, grab it from the final code solution if you want to. All right, so there's a couple last little things we want to add to this. Okay, we want to add some require function calls to make sure that everything works properly in this function. Again, you saw this a second ago when we did the only owner. We require that owners equals message.sender. So we don't need that because we want anybody to be able to mint it, but we want to have a couple things. So first, we want to make sure that when they're minting this, the ID that they're passing in does not equal 0. So bang equals 0 is important. All right. We want to make sure that the ID is less than or equal to the total channels, because you don't want to create some ID of a channel that doesn't exist. So it can't be 0 and it can't be more than the total channels. All right. We want to make sure they can't join a channel twice. Okay, so if they have joined the channel already, it is equal to false. All right, so basically we want to make sure it's false before they join it. And then last, we want to make sure that the amount of cryptocurrency they're sending in, message.value, this is message.sender, this is message.value, that's the amount of crypto that's getting sent in, is greater than or equal to the actual cost of the channel. So they're actually sending in the correct amount of ether. All right. So you can write tests for those specific things as an exercise if you want to, but for now, I'm just going to run the test and make sure that it passes. All right, it passes. So you can pause the video if you want to copy down those things, or you can grab them from the final code solution. All right, now there's one last thing that we want to do before we wrap up this smart contract. So right now, we've created channels. We let people join the channels. They're paying to get these NFTs every time they want to get it. And then what we want to do is actually send the money to the developer or the owner in this case. Now, in this workflow, when somebody sends in money to join the channel, the cryptocurrency is getting held in the smart contract, okay? It just lives inside the contract. What we want to do is have the owner be able to withdraw it from the contract, okay? So I'm going to have one final function here that I toss in there. You can grab this in the final code solution, or you can just copy this down by hand. I'll let you pause it, but let's explain how it works. So we have a function called withdraw. All right, it's public, so it can be called outside the contract, but only the owner can call it. That's important. Okay, we want only the owner to be able to withdraw the funds. So what we do is say owner.call. And so what call does inside Solidity is it just sends a message to the owner. Okay. And for any message call, you can send in metadata just like any other function call. You can specify the value. So basically you can send in money with this call to the owner. So message.value is going to be the address of this balance. So basically you can say address this, this is the smart contract that we're coding inside of. Address, just make sure that it's an address. And then .balance gets the actual ether balance of the entire contract. And we just say, send all this money to the owner. And we like do this call here and we're just passing in an empty string because we're not actually sending anything else with this message. We're just sending in value. And then this returns this tuple, which we can turn in. We can get the first part of it, which is just the success, true or false. This also got data that you can pull out here, but we just get the first thing is success, and we should require that they actually received it. This looks kind of weird. You could use a transfer function, but I'm seeing more and more Solidity developers use this for security purposes. So I'm going to leave you all with that strategy. Okay. So anyways, let's do a quick test for this. Again, you can grab this from the code solution if you want to, or you can copy it down by hand after you pause the video. So we're going to say describe withdrawing. All right. So basically, we're just going to set this up, say ID equals 1, amount is 10 Ether, balance before, and basically what we're going to do is basically get the deployer's address as the balance before. We're going to mint an NFT with that amount, and then we're going to withdraw those funds, okay? So basically, it checks the owner balance, checks the balance after, and make sure that it's greater than the balance before, and it updates the contract balance and makes sure that everything's been drained. Basically, the final contract balance should be 0. All right, let's do that. Save, go to the terminal, npx hardhat test. And boom, it passes. All right, so now we have finished the smart contract, okay? So the next thing we want to do is actually take what we've written here and put it on a blockchain so that we can start developing our app, okay? So I'm going to close this down, and I'm going to open up our file browser here, okay? And I'm going to look at this file called scripts deploy. So Hardhat lets you write your own scripts to do whatever you want to, but we want to use this specific script here to deploy the contract or put it on the blockchain. So we've got a placeholder here that basically just has our tokens helper has this async function called main, and then we call the function. And basically what we want to do is add deployment here. So basically we want to, get the smart contracts in JavaScript and then put them on the blockchain. So we're going to write a routine that looks very similar to what we did in here. Okay. So you can see that we got the Dapp core, Ethers get contract factory. We set up the signers, all that type of stuff. And then we created a channel. All right. We want to do this very similar type of stuff inside of our deployment script. All right. You've seen a lot of this stuff before. So what we're going to do is we're going to set up signers. We're going to do the setup at the top. All right. So set up accounts and variables. We're going to say deployer equals await ethers get signers. That's just like we did right here, but we're not going to worry about the user. We just want the deployer. All right. We want the name, Dapp core, and the symbol DC. All right. Just like we did right here. All right. It's the same thing. And then we're going to deploy the contract. All right. So const Dapp core equals await ethers get contract factory Dapp core. Const Dapp core equals await Dapp core deployed. Name and symbol, we just pass those in. And then we do await Dapp core deployed. All right, that's the exact same thing we did right here. All right, with a slight difference. Instead of doing deploy, we're saying await Dapp core deployed after. Okay, so we do deploy, which we did here, but then we do await Dapp core deployed because we actually want to wait for the deployment to finish before we actually do more stuff. Okay, so we can log that to the console like this. We can say console log deployed Dapp core contract at, and then we can pass in the Dapp core address. Okay, and then we can create some channels. All right, so we're going to create 3 channels in this case. I'm going to just kill that test. I'm going to say create 3 channels. And what we're going to do is, call the create channel function, but we're going to do it 3 times. So we're going to do it in a loop. All right. So we can basically use a for loop inside JavaScript. So we can basically write this. We can basically say for var I equals 0. So let me explain this for loop in JavaScript because it can be confusing people sometimes. So what is a loop? A loop is just something that says, hey, do a certain routine in code over and over again. So I'll say code goes here, channel creation. So basically what we want to do is create a channel 3 times. And basically we can write a loop that does this 3 times. So a loop just does something over and over and over again until you tell it to stop. So we give it the parameters for the loop right here. Basically, we create a new variable called I, and we set it to 0. And basically, we say, okay, here's your variable I. It's called an iterator. We set it to 0. And then basically, as long as I is less than equal to 3, then run this code inside of here. So in this case, I is 0. It's less than 3. That's true. Run this code. All right. And then after this code finishes, add 1 to I. Okay, and the next time this code runs, I is going to be equal to 1. Is I less than 3? It's true. Go ahead and run this code. Then increment to I is going to be equal to 2. Do that. And then the last time, is it going to be less than 3 once this is equal to 3? No, so it does not run this anymore and the loop stops. Okay. So that's how that works. All right. And so how do we create a channel? Well, we're going to create some parameters here. We're going to do this. We're going to create some variables, channel names, general, intro, jobs. This will just be arrays, and then costs, tokens 1, tokens 0, tokens 0.25. So this will be free channel for the intro channel. General will cost 1 Ether, and then jobs will be 0.25 Ether. Okay, this is just the Discord channel names. And then inside of here, we're going to do this. Okay. I'm going to zoom out. So basically, we're going to say transaction equals await Dapp Core Connect deployer, create channel. We do channel names I. So basically, every time this runs, this is going to be 0. So channel name 0. The first time it's going to get the general channel, and the cost is going to get from the costs. Cost I is a 0. It's the first one, so tokens 1. And then we wait for that to finish, and we console log that channel is created. Second time, it'll do the intro here, and then the cost is 0 here. And the third time, it'll get the jobs name here, and then the jobs cost from here, pass it in here, and it'll log it to the console. Okay. So that's it. That's our deployment script. That's going to put these contracts in the blockchain, and it's going to create the channels for us. And then that way, whenever we boot up our website, we'll have some data already in the smart contract, which is awesome. So the final step on this is to actually run the deployment. So we're going to open up a new tab here. We're going to go ahead and start our blockchain. So we're going to run the Hardhat node. We can do npx Hardhat node. All right, now we've got a development blockchain running that has, 20 different accounts, all with 10,000 fake Ether in them. You can see the public keys and the private keys, or excuse me, the account addresses and the private keys. Definitely don't use these accounts storing your real money. Anybody who's ever started Hardhat before could steal that money because they all use the same accounts unless you change the mnemonic. Don't use this seed phrase. Okay. All right. Don't use the private keys, et cetera, et cetera. Okay. So anyways, that's our blockchain running. Now we need to run the script, and you can do like this, npx Hardhat run. Okay. I'm going to pull this up so you can see it. Deploy scripts, deploy.js -- network localhost. You got to make sure you put the localhost flag in there. Okay, awesome. So deploy Dapp Core contract to this. You can see the address is logged to the console here. You say create a text channel general. All right, text channel intro, and then jobs. And you can see that was, these transactions actually went through here on the, on our Hardhat node. Okay. So the last thing you want to do to clamp the deployment is basically take this thing and go to the source directory and look at the config.json and make sure that your address, matches what's here. So whatever this console logged address here is, take this and paste it inside of here. It should be the exact same. Sometimes it'll change, but like most of the time, Hardhat uses the exact same contracts every time you deploy in order. So if you deploy 2 contracts, the first and second addresses usually be the same. I've seen it occasionally change. I don't know if that's just node versions or something, but typically speaking, this should be the same. But you want to double check and make sure in your config.json file that your Dapp Core address is the exact same as what was deployed and logged to the console there. And that inside of here, you take your artifacts and go to the contracts and go to dappcore.sol and look at this JSON file and then get your ABI. So ABI is the abstract binary interface. This is essentially just describes how the contract works. So it describes the interface so that you can create a JavaScript version of it. You're going to want to collapse this and then take it, copy what's in the array only, okay? And then make sure that that is the same here inside your ABIs, your dappcore.json. So as long as you didn't make any code changes, this should be the exact same thing. As long as you had the exact code that's in the final code solution, then this shouldn't change. But if you changed anything, you want to make sure and update whatever ABI was in here into this ABI. Again, these are the things that we need to build out the front-end website, which we'll do next, but I just wanted to cover that deployment step just to make sure that once you've deployed and every single time you deploy, you need to make sure that these things are actually updated, because the last thing you want to do is make a change and then not tell your front end about it, and you're stuck wondering why your project doesn't work. So I wanted to include that in the section, and that's it for this part. All right, so now let's start coding out the front end for the project, okay? So, up to this point, we've created the smart contracts. We've put it on the blockchain. So you need to make sure you got your blockchain running here. Okay. And then you also want to open a new terminal tab here. And we want to go ahead and start our front end server. Okay. So we're going to create a React application. There's already some placeholder code in there. And we can start that reapplication like this. We can say npm run start. And you should see your app start in a new window here. All right, so now that this is loaded up, you can see we got our basic website code here. Okay, this doesn't look like much. Don't worry, we're gonna fix all this and make it look more like our mock-up. So I took a screenshot of the final code solution. You can see what it's going to eventually look like, and we just gotta make it look a little bit more like that, okay? So our first step is, of course, make sure you have MetaMask installed. This is the browser extension that's gonna turn our web browser into a blockchain browser. Okay, most web browsers don't support connectivity to the blockchain out of the box. You need to have a special extension for it. That's what MetaMask does. So what you're going to do is open MetaMask and make sure it connects to your Hardhat blockchain. Okay. So if you've already done Hardhat before, you should have a Hardhat option saved here to your network dropdown. Maybe you're on the Ethereum mainnet. You want to switch to your Hardhat connection. But if you don't, you've never connected to Hardhat before, you need to click add network. Okay. And then what you can do is, see if they have a Hardhat one. They don't. So what you're going to do is add network manually. You can call it Hardhat. Okay. For the RPC URL, you're going to just go to your Hardhat blockchain, your node here. Okay. And you're going to essentially find this here, put it in here. Okay. The chain ID, you can see it in your project. The chain ID is in your config file. Okay. So source config.json, this is the chain ID. All right. And the currency symbol is ETH, and the block explorer doesn't exist. So you can click save. I've already done this. It's not going to let me add this, but that's how you add Hardhat. And once you've done it, okay, you can just go up here and select Hardhat in the network dropdown. All right, next you're going to need to import your accounts from Hardhat. So you can see these accounts. You can just copy the private key here. You can go like this and go to import account. All right, you're going to paste the private key in there. I've already done it, so it's not going to let me do it again. But I did that, and then I'd go to account details, and then I usually rename the account right here. I call it Hardhat number 0 because Hardhat accounts are zero-based index, so 0, 1, 2, 3, 4, 5, et cetera. And then I can see easily which Hardhat account it is with a label right here. Now, what I would do is go ahead and repeat that step for multiple accounts. I've done it for 6 total Hardhat accounts, and that lets me just really quickly switch back and forth between these accounts whenever I'm developing stuff. But at a minimum, you need to import the first account here. Now, the nice thing about the Hardhat node is every time you restart the blockchain, these same accounts will exist. Okay, so you don't have to keep adding them to MetaMask. All right. But that's the first step. Make sure you have MetaMask installed. Make sure you're connected to Hardhat, and make sure that you are, got your accounts imported. So now what we're going to do is go ahead and do the first step, which essentially is to connect our wallet to the application. You can see there's a thing here where it's got the header, it's got the name, and then your wallet address with a connect button. We want to do that before we do anything else. In order to do that, we're going to go ahead into our front end application. Okay, so all our blockchain stuff's in the contracts directory, but all of our front end stuff is in this source directory here. Okay. So you can see source app.js. All right, this is the main file for our front-end app. So if you look inside here, this is all JavaScript. This is React.js, okay? So if you're not familiar with React, it's a front-end framework for building user interfaces so that you don't do everything yourself. You can mix in HTML and JavaScript all in the same file, okay? React organizes its code into components, which are just reusable modules, essentially, where you can organize your code and then reuse them. So you can see multiple React components here. You can see this app component is a function right here. Here's the app component. We've got other components here on the side, like the navigation component, which we're pulling in right here. All right, navigation.js. All right. And that's exactly what we want to customize right now is this navigation so that we can make it look like, this screenshot right here. Okay, so let's go ahead and do that. So inside the nav component, we're going to look inside of here. So this is a function for the component navigation. Then we have this return for the function, which returns some HTML. So this nav is actual semantic HTML. So it is an element called a nav, okay? And inside of here, what we can do is code a div, all right? And then we can say h1, we call it Dapp chord, okay? And then we can also give it a class name equals nav_brand. All right, and let's go ahead and take a look and see what was done there. All right, so we got some progress. All right. And the next thing we want to do. All right, so we're not actually seeing this come up on the page because we're not actually rendering this component. So my fault. So basically what we're going to do is you can see this welcome to Dapp chord thing here. All right, let's go put an exclamation point here. That's what we're actually changing. Okay, now you can see welcome to Dapp chord. It's got the exclamation point on it. And if you take it off, then boom, it goes off. All right. So we don't want this anymore. What we want to do is take this navigation component from here, which we've imported, navigation. All right, and you can see it here. And what we do is just lay it on the page like this. Just say navigation. And then do an ending tag just like that. All right, now that looks a lot better. Dapp chord. We can see the text that we just added inside of there. Again, you can put an exclamation point or something like that just to make sure that it looks right. Yeah, awesome. Okay, awesome. So one thing I want to mention here is that we have a bunch of style sheets written for you. So this CSS, all right, index CSS, the project is already styled. Okay, I don't want to spend a bunch of time writing CSS in this tutorial because really we're going to focus on the blockchain side of things. So whenever you do stuff like do nav brand, it's going to automatically pick up the styles that are pre-done for you, and it's going to automatically start looking a lot more like this sort of mock-up of the final project. Okay, so we're getting close. So the next thing we want to do in terms of layout is put a button here. All right, we're just going to do a button. All right. And then we'll call it type button. And then class name is going to equal nav_connect. All right. And then it's actually not going to have a closing tag. We're going to do it like this. And then we're going to have a closing tag like this. And what it's going to do is say connect. All right. And then we'll put it like this. Yeah, it's looking a little bit better. We need to fix this. It's not looking quite right, but that's some good progress. All right, so you'll notice that whenever we close this, that it'll show the right size. Okay, it'll look a lot more like the actual final mock-up here. Okay. All right, so that's looking better. So now what we need to do is actually click this connect button and make it work so that we can pull our wallet in. And so what we're going to do is go ahead and load our account inside of this app.js file. Okay, so I'm going to show you how to do that. All right, what we're going to do is create a React hook. All right, which is basically just a function that's going to let us run whenever our component is loaded. We're going to call this. We're going to call a function here, okay? We're going to call it const load blockchain data equals async. All right. And then inside of here, we're going to say console log loading. All right. So I've defined this function, but if you go to our page here, you're going to see it doesn't actually show you that there's any console logging. All right. In fact, it's showing a bunch of errors. We'll clear out those errors here in a minute. But let's actually make that work. So we're going to use something called use effect, all right, which is a React hook. All right, we've already got use effect imported here. This is a part of React. And so you can just say use effect. And inside of here, we can call load blockchain data. All right, now if you go here, you can see it's loading. All right, so let's explain what that does. It's basically use effect is a function that's going to get called whenever this, component renders onto the page. All right. And then inside of use effect, we can do whatever we want to. In this case, we want to call this function, which we defined here, called load blockchain data. And inside of here, we can basically boot up our app and make it connect to the blockchain. So the first thing that we're going to do is get our accounts from MetaMask. All right. And I'm actually going to show you how to do that in your terminal. or not your terminal, but your console here. If I put this inside of here, this const accounts equals await window.ethereum request method ETH request accounts. You don't have to do this. I'm just going to show you. It will actually show the accounts that are returned from MetaMask right here. And this is really noisy. If you want to kill the noise on this, one really easy way, inside your app.js files, just take this socket line here and just comment it out. Okay. And then if you refresh the page, all that should go away. Okay, so basically, well, I say that you might have to do it in another thing. We'll get to that part later. For now, we probably won't do much in the console. All right. So, but I'm going to do that line here. Const accounts equals await window.ethereum request method ETH request accounts. All right. If you want to pause the video and copy that down, you can. And what I'm going to do is do this next line, const account equals ethers.utils.get address. And then I'm going to get the first account, all right, from the list, account 0. And then I'm going to do console.log account. All right. So if you want to copy that down, you can. All right. So now if I go back to the console here, and it's going to be kind of noisy, but you can see that the account was logged right here. That's the one that came in from MetaMask. Okay. So what we want to do is get this, all right, and then we want to set it to the React state. So what is that? Well, the React state essentially is the thing that lets us save information inside of our app. So if you look at the to-do app right here, you can see like, hey, what needs to be done? You know, item 1, item 2. How does React know where these items go on this to-do list? Okay, they get saved into the React state object. That's what it's for. It's like a little front-end database for your app. Okay, so basically we can just add those like that to the React state. So how do we do that? Well, we can use other React hooks from this. We can do use state. So we use effect here in React. We can also do this use state, which is imported, which we can get things from the React state and write to it like this, okay? So we can just use this, we can use this thing called use state right here. All right, this is a function, all right, right here. And we can assign, if the function is going to return an array, okay? And what we can do, it's going to return an array of 2 different things. One is going to be a variable of the current value, and the other is going to be a function that's going to let us set the value. So I'll just show you what that looks like. We say const account and then set account equals use state null. So what this does is React gives us a variable to read the account from the state and then a function to write the account to the state. And we use default value as null if there's no account in the state. Okay. And so down here, instead of console logging the account, we can just do set account as account. Okay. And then now if you wanted to access that on the page, right, down here, you could just do like, navigation, H1, and then you could say account. All right. And then if you go back to your page here, you can see the account listed on the page. All right. Looks terrible, but that's showing you that you can basically get your account from MetaMask, save it to the React state with set account, and then you can use the variable, like this here. All right. So what I'm going to do is not do this here. I'm going to do it inside the navigation, because what I want to do is go into navigation, click connect, and then that's going to pull our account from MetaMask and then show it on the page. So what we want to do inside of here is create a handler to do that. Okay. So I'm going to show you how to do that right now. It's pretty straightforward. I'm going to do this. So button, type nav connect. We're going to do this thing called onClick. onClick. This is an onClick handler. It's going to just say connect handler. This is going to be a function that we create. All right, like this. So basically, connect handler is going to do this. Say const connect handler. All right, equals async. And then what I'm going to do here is just do console log clicked. All right, let's go back here. Let's see, connectors undefined. Let's just copy and paste. So this should be capitalized as Y. All right. And let's just see here. If I do that and click connect, you can see it's clicked. All right, so it actually console logged that. It's kind of annoying with all this output. Sorry about that, everybody. But that's how it works. All right. So now what we want to do is, if we've connected, we want to go through this routine of, connecting to the blockchain. So we need to do a couple things. So let's take this account off the page. We don't need that anymore. All right, you can see it's gone. And then in navigation, what we want to do is pass down account and set account like this. So we actually want to pass down these functions, this variable in this function. We can do that like this. It says account equals account, and then set account equals set account. All right, and then those are going to get accepted right here and saved as, these named variables. So account and then set account. We've already got that pre-populated in the function, and we'll have access to those down here. Okay. Now, what I'm going to do is take out this from the low blockchain data. All right. That's going to be empty for now. Okay. And we can go inside of here, and on the connect handler, we're going to put that same code inside of here. So instead of click, we're just going to replace it and say const accounts equals this, and then set account. And then actually, if you really want to, you could still show the account on the page. You could just say H1. All right. All right. And then we could do this and then click connect, and then boom, there you go. Your account's on the page. Refresh, connect, account's on the page. All right. So that works. Let's take that off, because ultimately what we want to do is show our account up here in the URL bar. So how we're going to do that is basically inside of here, we can do some conditional logic that just says if the account exists, like this account, question mark. This is called a ternary operator in JavaScript. It's just checking for true or false statements. If it's true, do this thing right here. If it's false, do this other thing right here. Okay, so if the account exists, what we're going to do is show one button, all right? And if it doesn't exist, we're going to show a different button. All right, so you could say like, button 1 and then button 2. So if the account does not exist, all right, we're going to put this button that says, hey, connect to MetaMask inside of there. And if the account does exist, what we're going to do is copy this, put it in there, take off the on-click handler because we don't want to click anything. But we're going to show the account on the page. All right. All right, say that. Go back to the thing. And now you can see the accounts there. All right, so click connect, and you can see the accounts there. Now, it overflows off the button, which we don't want. So we can abbreviate it like this. Basically, we can use the slice function in JavaScript and say account slice 0 through 6, and then use ... in the middle and say account slice 38 through 42. All right. And you can grab this from the final code solution, or you can pause the video and copy that down. All right. And so now that looks correct. So now one final thing I want to do is inside of app.js, I want to add this to the low blockchain data and basically say whenever you change accounts, we want the page to change. So I'm going to add this function here that says window Ethereum on accounts changed, async, add this function, window.location.reload. So what this is doing is window.ethereum is injected by MetaMask. That's the same thing that we're looking for right here, window.ethereum request. This is listening for the event on accounts change. So anytime we change an account inside of MetaMask, this is going to run, and then window.location.reload just refreshes the page. All right. So basically, if I go here, and then now I change to Hardhat 1. All right. You can see that I get the connect message again, and now it connects my new account. All right. So that's a nice bonus. All right. Awesome. So now we are all done with the Navbar. All right. So now what we're going to do is work on the channels. Okay. So we have essentially worked on, getting the Navbar done. Now we're going to actually lay out the channels. So let's do some basic scaffolding first. what we're going to do is go to our, main section here. All right, you can see this main, and we want to keep the navigation outside of that. But we're going to cut a couple components and just go ahead and lay them out. So we see servers, channels, and messages. Let's just copy all these. Okay, and we're going to paste them down here. Okay, and then we're going to just do this. And we're going to lay the components out on the page. Now, they're just placeholders. Okay, there's nothing really that's going to work yet, but I just want it to look more like our mock-up so that we can see kind of where we're going, all right? Once you've got that in there, you'll see something that looks a little nicer than what we've been working with, okay? Just placeholders, nothing actually worked. If you click on something, nothing does anything, okay? We're going to fill all this stuff in. All right, so servers, channels, messages. We can see these components are here in this components directory. All right, servers, messages, and then channels. And then we got navigation, which we just finished. So for servers, you can see this is like sort of the Discord like servers right here. These are the channels inside the server, okay? So essentially, like this is just going to be like kind of placeholder. We won't actually wire these up to do anything. If you want to create a full-on Discord app, of course, you could wire the functionality up for this. But for now, what we're going to do is just kind of keep you on this server. And then you have NFTs for each channel inside of here, okay? And for the text channels. So you don't see any text channels yet. That's because we're actually going to get them from the blockchain. Remember, we created the channels in the script. So let's go ahead and load our blockchain stuff up, okay? We already have this load blockchain data here. But what we can do, essentially, is go ahead and connect to Ethers.js. So what we're going to do is get an Ethereum provider, right, from MetaMask, just like we did in our tests. So we're going to do that like this. We're going to say const provider equals new Ethers providers, Web3 provider, and then pass in window.ethereum, which we use for the MetaMask accounts. So again, Ethers is the library that's going to turn our application into a blockchain application. It's the JavaScript library. We used it in the test. We can also use it on the front end. So we say Ethers providers, Web3 provider, and then now we can use this to actually talk to the blockchain. So we're going to save that to the React state, just like we did with the account. All right, we're going to do provider and set provider at the top, just like this. All right, and then we're going to call set provider right here. And the next what we're going to do, we need to actually fetch our smart contract Dapp cord. This is the NFT that manages the channels, and so we need to talk to it and make sure people have the NFTs before they join the channels, and then also let them buy the NFTs whenever they want to join it, okay? So in order to create that smart contract, make sure that you have filled in your config.json with the appropriate address from Hardhat, okay? And then make sure that you've got the appropriate ABI here in the ABIs section again, okay? I talked about that in the deployment step. Go back and check that if you haven't already. So if we have the address and the ABI, that's all we need in order to create a JavaScript version of the NFT contract and start talking to it. So if you look at Ethers contract, the docs, this is how you create a new Ethers contract. Basically, you give it the ABI, abstract binary interface, and the address, okay? And then essentially, you give it the provider as well, and that's how you create a new contract. So new Ethers contract, address, ABI, signer, or provider. Okay, so let's just copy that and put it in there. So we'll say const Dapp cord equals new Ethers contract. So the address, where's that going to come from? I'll show you in a minute. Signer or provider. So provider, we have that saved to a variable from here. All right, where's the ABI coming from? Well, if you look up here, we've got the ABI imported. So ABI is dappcord.json. We just call it Dapp cord. So we put that right here. All right. And then how do we get the address? Well, basically, we just get the address from this config file right here. So you can see inside this config file, we could just get this address and then paste it in here. Right? But really what we want to do is read it from that file. So essentially what we're going to do is say this config, and we want to dig into this chain ID, which is this. All right. So config 31337 dappcore.address, and then pass in the rest. But we also want to fetch this network ID directly from MetaMask. Okay, so we can fetch that network ID like this. Say const network equals await provider get network, and then just pass in this network right here. Okay. And then once that's done, we can do, we'll have a JavaScript version of the smart contract. Okay. And we can just do set dappcord and get dappcord just like this. And then we can do set dappcord. And then let's do this. All right. So let's do a quick smoke check. I know I went through a lot of stuff right there. Let's just do a smoke check in the console. And what I want to do is do console.log dappcord.address. Okay, to make sure that this worked properly and that you can actually log the dappcord.address from this variable, which we've set, okay, like this. So let's go to our app. Let's open up our console and let's see here. All right, cannot read properties of undefined reading dappcord on line 32. All right. All right, so let's pull this over. Let's make sure this looks right. All right, so I think what's going on here. Let's do that. All right, now we can see the dappcord address on line 35 right here. So I had just a little error in this line. If you want to pause and record the, pause the video. I passed in network, I believe, and didn't call the chain ID. So you had to do network.chain ID. My fault. Okay. So Ethers contract config, you're reading the network.chain ID from that, then you're getting dappcord.address. Again, you're going the chain ID, dappcord address. That's what we're doing right here. Okay. And then passing in the dappcord API and provider. It's kind of confusing, but that's what's happening. But anyways, we've logged the thing to the console here, so you can see that's working. Okay. And then what you're going to do is load up the channels. Okay. So what we can do is we can get the channel from the blockchain. We can say await dappcord get channel, because again, inside of our dappcord, we have a get channel function here. We can pass in the ID. So let's go ahead and get channel 1. All right, say const channel, and let's console log. All right, so you can see it here. It's a struct from Solidity. So you can see here's the thing. It's the general channel. Okay, the name is general, and the length's 3. All right. So it's actually doing that. We can do the same thing for channel, 2. All right, and then there you go. It's the intro channel. So we're able to successfully get channels back from the smart contracts. We know it's working. We're calling this function get channel. So what we're going to do essentially is we're going to use a for loop to loop through all the channels and get them one by one. So how we do that? Well, basically, I'm going to clear this out. But the first thing we're going to do is get all the channels. So we say const total channels. All right, then console log that. Basically, we're just fetching that total channels. Again, that's on the smart contract. Total channels is a function right here. All right, so that tells us how many channels there are. You can see that's here. It's a big number. You can call it toString if you want to. All right, and then see it's 3. Okay, and so it knows there's 3 channels. So what we're going to do is put those into an array. All right, so we're going to do an array called channels. And then we're going to use a for loop inside JavaScript and call get channel for each item in that. So we do that like this. All right, and you can pause the video if you want to copy this down, but I'll explain it. So basically, we're using a for loop just like we did in our deployment script. So you can see we used a for loop to create channels. So we did that 3 times, right? Boom, boom, boom. And then we create the channels. Here we're doing 3 times, and we're fetching the channels and pushing them into an array. Channels push, that's how you add new items to the end of an array with the push function. All right. And then we're going to save those to the React state. So at the top, we can do, just below dappcord, we can do const channels, set channels equals use state, and then pass in the empty array. All right. And then essentially below here, we can just do set channels. All right. And that's going to set the channels inside of there. We can also do console.log channels just to see that it actually worked properly. All right. So it worked. And here's our console log. Sorry, that output's really annoying. We'll fix it shortly. But general, intro, and jobs, it got all 3 channels. All right, so now what we're going to do is we're going to, we've loaded all the blockchain data. Now we're going to use the channels on this sidebar. Okay, so in the channels directory, or in the channels component, what we're going to do is pass in several things, just like we did here with the account. We're going to say provider is going to equal to provider. All right. We're going to do several things. We're going to say account is going to equal to account. All right. So Dapp chord, we're going to pass that in lowercase. That's the contract. We're going to pass in the channels. And then, yeah, we'll just start there. Provider, account, Dapp chord, and channels. Now if I go to this page, nothing's really changed. But the next thing we want to do is list out those channels we just loaded here on the text channels page. So let's go ahead and go into this channels.js. All right, we see that the voice channels are listed here, channel 1, 2, 3. Those are just sort of fake channels, placeholders. But now let's actually go ahead and list out the text channels right there. So what we're going to do, we have the channels here. So we can basically loop through these. We can do this inside of React. We can say channels.map. Okay. So this is a function that lets you loop over an array. Okay. And what you can do is list them all out like that. Okay. So what we're going to do is inside of an unordered list, so a UL, and then basically we'll have a list item for each channel like this, like list channel 1, channel 2, channel 3. All right. But we want to create this dynamically. So basically what we're going to do is, let me just show you. Take this out. And we're going to put this inside of here. Okay. And we're going to do li. And then we're going to say channel name. And they're also going to do this key is index. All right, let's go see if that worked. All right, if you want to pause that, you can see. Check that out. Okay, all right, let's see if it worked. All right, it did not. Well, let's connect first, sorry. All right, I don't think that it worked yet. Let's just give it another shot. Okay, all right, so it looks like it's not working. Let's see what's going on here. All right, so I know what it is. So basically, we just need to change this curly brace to a open and close parenthesis. All right, and that should work now. All right, there you go. Awesome. Now I can see like the general intro and jobs. The channels are actually listed. So let's kind of explain that. So first of all, when you're doing functions like this in JavaScript, there's an implicit return versus not one. In this case, we weren't returning the list item. And if you use, this parentheses for one-liners like this, you'll be able to do that implicit return. You don't actually have to put a return here. So we created an unordered list. We mapped over the array inside JavaScript. You can use these curly braces to put things on the page. And then we put this new thing inside of here. We use the channel and we call .name on it. And then because these are going to render multiple list items, React requires that we have a unique key for each of those. And so we just use the index of the item in the array to do that. Whereas if we take it away, React's going to yell at us. Okay. All right. So now what we're going to do is let the user choose the channel. Okay. So for this list item, all right, what we're going to do is we're going to break this up. Let's do it like this. All right. And what we're going to do here, let's just see, actually, let's do it like this. Hold on. Gets kind of confusing sometimes. We're going to have this on-click handler. All right. And so what we're going to do is say on-click. And we're going to say channel handler. Say channel. Okay, so this is a new function that we're about to create. We're going to pass in this channel. And so at the top of our function here, we're going to say const channel handler equals async, and then channel. Okay, I'm gonna say for now, I'm gonna say console.log clicked. Okay, and let's just make sure that when we click this button, we call this function, and that's gonna log it to the console. All right, so general clicked, intro clicked, jobs clicked. Awesome. All right, so it's working. So what do we want to do? Well, we want to join a channel. Anytime this happens, we want to change the current channel. But the first thing we want to do is, essentially make sure that the user has joined, okay? So if they have not joined, if they don't hold an NFT, we're going to make them purchase it, okay? So we can connect to the blockchain just like this, and we can see if they have joined the channel, because inside this Dapp cord, we have this, has joined. Right here, has joined. We can pass in their address to see if they've joined the channel. If they have, we'll just let them view the channel. But if they haven't joined the channel, then we're going to require them to buy an NFT for that channel. Okay, and then once they do it, they can view it. Okay. So inside of channels, what we're going to do is basically check the status at the top. We're going to say const has joined equals await Dapp cord has joined, and then pass in the channel the ID and then the account. So the channel comes from here. We get the ID and then the account, which comes from here. So basically, then what we're going to do is say, let's say if has joined, say console log joined, else, console log has not joined. All right, so when I click on these channels, it should show me that I have not joined. You can see if I click general, it's like has not joined, intro has not joined, jobs has not joined, okay? So that's fine. So what we're gonna do is basically make it buy an NFT in order to join the channel, okay? So how do we do that? Well, basically we call the mint function just like we did, in our tests. So in order to do that, we need to get our wallet. So we can do const signer equals await provider get signer. That's going to return the signer from MetaMask, which is going to be the, the account that we're connected with. And then basically, we can say await dappcord.connect signer. Okay, so that's the person that's calling the function that's paying the gas fees. And then we can call this mint function, all right, right here. So we just got to pass in the ID. It's called mint. Pass in the channel ID. Okay. And then we, of course, need to pay some cryptocurrency to do this. So say value equals the channel.cost. Again, the function metadata value is the amount of ether that's getting sent in with the transaction. And we just hard code that to the channel cost. Okay. So we can say that to a transaction, say const transaction equals this. And then we just say await transaction wait. Okay. So now if I go here, click connect, and when I join the general channel, it's going to have a MetaMask confirmation pop up, and it's going to show me the cost, which is 1 Ether. Click confirm, and then now I have joined the channel. Okay. And now if I go back here and refresh the page, connect my MetaMask, click general. Actually, hold on a second. Let's just do that. Hold on. All right, so it failed to mint. So here's an issue. Sometimes whenever you restart this, okay, you're going to want to reset your account. So I'm glad I saw this on screen because I want to show you this. So if I go to advanced settings, restart account, click reset. And now if I see my transaction history is clear, it didn't actually delete anything on the blockchain, but it refreshes the cache so that I don't have this problem. So sometimes this happens. So I just reset my account, click general. Let's click mint, confirm. And then now I should see a successful mint in my wallet because before it was canceled out. And now if I click the general channel, it's going to see joined. Okay, that's important. It's joined. All right. So now the final thing we want to do is update the current channel. Okay. So basically in app.js, what we're going to do is get the current channel. And then we're gonna create this with a React state like this. So like we have channels and set channels, we're gonna have a new one that just says current channel, and then set current channel. But we don't want to make it an array. We just want it to be, you know, null by default, right? So boom, call it current channel, and then set current channel. A current channel, set current channel. All right, and then we want to pass these down here. So we want to add just below this. We want to say, all right, current channel equals current channel, and set current channel equals this. And then while I'm here, I'm going to improve this spacing a little bit. Okay. All right. And then now inside of channels, we're going to update that. So if we do has join instead of join, we're just going to say, you know, set current channel. And then we're going to pass in the channel. All right. And then what we're going to do is show or not whether or not this channel is active. Okay. So below this onClicked, we're going to evaluate the class name. So we're going to apply a special class to it. So let's say class name. Okay. And then basically what we're going to do is say if current channel and current channel, the ID to string is equal to channel, the ID to string. Okay. And we say active, or it's just empty strings. Basically, what it's going to do is going to check if this channel is active. If it is, it's going to apply this active class. And if not, it's going to apply any class. Okay. And now we can see if I click general, I'm going to click connect. Hold on. And click general. Now it should be active. So let me just make sure this looks a little better. Hold on. Yeah, it looks better. Class name, current channel, and current channel ID string. Okay, awesome. Now that looks better. Okay, so now I can see that it's actually active. Connect. All right, click general. Now I've joined it, and you can see the general stays highlighted, and that's the exact code for this line. Okay, if you want to pause the video, you can do that, or you can grab it for the final code solution. Okay, so the last thing we want to do here is whenever we join a channel and it's successful, we want to set the current channel after we mint the NFT for that. Okay, so for example, like we haven't joined this intro channel, but when we do, we want to actually pay the cost to do that. And then whenever it's finished, we want it to highlight and join that channel. So that's what set current channel does here, all right? So let's save that, refresh the page. Let's connect our wallet. Okay, we can join general, but now what we're going to do is join intro, and we have not joined that before, so it should ask us to mint, and then once we've minted, it should join it for us, all right? So let's do that. There's no cost because it's free, but we need to add it to our channels, and then boom. All right, now that it's finished, you see this automatically highlighted here, okay, general, and then if you want to join jobs, you know, you can pay the cost to do that, and it should also buy the NFT, And then boom, there you go. You've paid the cost for each thing. So there you go. So our NFTs on a per channel basis, right? You can always modify this to be a per server basis where you just buy the NFT. You get access to the entire server, but this is sort of like permissioned access to each individual channel on that server. All right, so now let's get to the fun part, which is chatting, okay? So just a quick review of how our website works here. You know, a person uses their wallet, they connect to the browser, they go to this website, and it's going to talk to the blockchain for the NFTs, but it's also going to talk to a separate server that allows us to do chat messages. And so how do we do that? Well, we're going to create a server in a second, okay? And we want a server that meets our capabilities. So first of all, we're going to use Express.js, which is a JavaScript server framework. You can basically create any type of server you want to, all right? And so we're going to create a server with Express.js, but we also need a server with real-time capabilities WebSockets. And so we're going to use the socket.io library for that. Basically, this lets us use WebSocket communication with our servers so we can stream messages and, you know, post messages to it. And this is perfect for like a chat room, because what you don't want to do is like create a chat room. It's always like trying to look for new messages and then add new ones and go refresh the list. Basically, it's going to have a live stream of all the messages that are coming in through this type of thing, okay? And so that's exactly what we're going to create right now. So if you go into your project here, let's just close down some of this. All right, we don't need all this. You're going to see this server.js file here, okay? So our blockchain stuff is inside the contracts directory. Our front-end stuff is inside of the source directory. And this server.js script is literally the done-for-you script that's going to let you do chat messages, okay? So I'm going to collapse this messages here so you can see how this works. Basically, this is just a single file that imports Express, saves it to this variable here. That's the JavaScript framework package. App basically just calls the Express function so you can create an app. It does some basic configuration, like tells you the port, which is going to be running on port 3030. All right, that's different from 3000, which is what our blockchain is running on. So we want to change that, do port 3030. And then basically, we say server equals app listen on this port, and then we do console log listening on this port. And then we have some messages, which I'll show you in a second. And then we, you know, import socket.io right here. Okay, we do a capital S server. And then we create a new socket.io server from their documentation, just like this. We just say IO equals new server. And then we do on IO, which is what they tell us to do. And then pass in the connection. Once you get connected, it's going to have these different things. Okay, so basically what it does is it listens for events. And whenever certain events are emitted, it will do other things. So basically, like when it gets a get messages thing, it's going to emit get messages, and it's going to pass in all the messages which you saved here, okay? And then when it receives a new message from the chat room, it's going to take that message and add it to these new messages and then return the list of the entire messages, okay? So we have created some messages pre-populated for you, okay? It's going to be basically just a big array, and each one has a messages object, which just has a channel, okay? An account that sent the message, and then the text for the message, okay? And so we've got these pre-saved already for a bunch of different channels, channel 1, 2, 3, et cetera, et cetera, et cetera, all right? And then what it's going to do is this array is we're going to save all the messages. And so when we load this up, we can just load all those up into our respective channels. But then whenever we have a new one come in, this new message, it's going to add the message to the end of this array. We're going to create a new channel right here, okay? And then it'll return the entire thing so we can, you know, refresh and make sure that we are showing our messages properly, okay? So this is basically done for you, but I want to explain how it works, all right? So we can open that in a new terminal tab. All right, we can do to our starter code. You got your front end running here and your blockchain running. All right, and then we're gonna do npm. Actually, let's do our script here. Let me see what the command is. We're gonna do node server.js, and then now you can see listening on port 3030. The user is connected. Okay, so we can see a user connected. It works. All right. And now we want to make sure our app is connected to the server. And so if you go into app.js, we've imported this socket right here. So we've imported IO from socket IO client. And we basically just say const socket equals IO, and then we pass in the WebSocket protocol for localhost port 3030, which is the exact port that we're running on right here. You can see listening on port 3030. All right. And that's really the only basic configuration that we need to connect to our socket. Now, what I'm going to do is I'm going to show you this link. All right. So I'm going to put this in here. Here's the documentation on Socket.io and how to use it with React hooks. So this tells you how to use your Socket.io and connect it to your React component inside of use effect. So we're using use effect, so we can do like, socket on connect, socket on disconnect, socket on pong. All right, so we're going to use that exact configuration. All right, and then adapt it for our use effect function here. So I'm going to paste that inside of it so you can see it later if you want to. All right, and then what we're going to do is do exactly what they say. We're going to say like on socket on connect, and we pass it a function, and then I'm going to say console.log socket connected. All right, we go to our terminal, our console, and then look at this up here. Let's just refresh, and when I refresh, I can see that socket connected. Okay. So we want to duplicate that for all the other things we want to wait for. So I'm just going to copy this. All right. We want to look for a connection. We want to look for, let's just pull this up here, the server.js. We want to look for a connection. All right. We want to look for get message, right? So it's IO on connection, on get message, IO on new message. And we're going to perform actions anytime we do that. So on get message, or new message, sorry. All right. And then on get message, messages plural. All right, and we're going to say getting messages. All right, and then on new message. Okay. So let's just save that. We go to our terminal again. Let's just refresh. I keep saying terminal, I mean console. Okay, so you can see the socket was connected, and we're not getting anything else because we need to join a channel, and then that's when we need to actually do it. Okay. So what I'm going to do is one last thing here. We need to do this configuration, which is return, all right, at the end of use effect, because this is exactly what the documentation tells us to do in this link. So we introduce socket off. When it goes off, click connect, socket off, new message, socket off, get message. All right, let's save that. And then let's refresh. Make sure we don't break anything. All right. All right, it's looking good. Click connect. And we don't see anything yelling at us in the terminal. In the console, it's way more quiet. All right, so next we actually want to fill this in. So after socket connects, we're going to do socket.emit get messages. Okay, so the whole idea is once we've connected, we actually want to get the messages from the server. All right, and now we should see those logged. All right, so let's go to our thing here. All right. So socket connected, and then boom, you can see getting messages is logged. Okay. So actually, instead of getting messages, what I want to do is actually log the messages. Okay, I do that here and then do that here. And then instead of getting the messages, I'm going to actually log the messages themselves. All right, so let's refresh. And once I've refreshed, I can see that the messages are actually logged to the console right here. You see the channel, the user, and then the message itself. Okay. Awesome. So I've got the messages. Now, instead of logging this to console, I want to save them. All right. So we're going to save it to the React state, just like we did the other stuff. So at the very top, I'm going to do just below channel and current channel, we're going to do messages and set messages, and to use state, it's going to be an empty array. So we're going to store everything in an array inside the state. Okay. And so what we're going to do is basically, whenever we get the messages, we're going to set the messages right here, set messages, and then pass in the messages. And then likewise, whenever we chat a new message and it returns all the messages, we're going to update that list right here. Okay, so set messages. And that should be everything for our socket.io configuration. Okay. So now we're actually going to code out, doing chatting inside this messages box. So the next thing we want to do is pass in some, parameters down to this messages component right here. We want to pass in the account, the messages, and the current channel like this. Okay. We're going to say account equals account, messages equals messages, and then current channel equals current channel. All right. You can pause that if you want to check that out. And then inside the messages.js, we're going to fill this in to start doing some chatting. All right, so let's go ahead and start filling out this messages component, okay? So the first thing that we're going to do is actually put the messages, inside of there. Okay, so what we're going to do is basically just, let's just do this first. All right, so we're going to say messages, and we're going to say map. Okay, we're going to say message index. And then we're going to do this. And we're going to put the messages on the page. Okay. So we're just going to do div. We're going to say class name equals message. And then key equals index. Okay. And then we're going to do, for now, let's just do message.text. All right, let's see if that works. Let's go here. All right, click connect. And then, yeah, boom. I can see welcome to Dapp Cord. You can see all this type of stuff, right? But there's a problem with this. If I can also show you, I can show you the channel. And we're showing you, like, if I was going to do this, I did message.channel. It's going to show you all the channels, like, from different ones, right? This is channel 1, this is channel 2. And we want to filter through the messages so only the messages in channel 1, show in general, right? So how do I do that? Well, basically, I can use a filter inside of JavaScript. So I can say messages.filter. And what I can do is make sure that it only does from the current channel. So basically, message and then message.channel is equal to the current channel.id to string. Okay. And then now you can see only channel 1 pops up. All right. So I'm going to take out this, channel number here. I just wanted to show you that that's the case. All right. I think I might have blown something up here. So let me just... So uncaught property null reading ID. Just do that. All right, so we're good. General. And so to fix this problem, we also want to make sure that the current channel exists because we're checking for the current channel ID before it's loaded. So basically we could say current channel. All right, and once that exists, we can then filter by the current channel. All right, so then if I go back here, first page, it doesn't absolutely blow up on me, okay? So click connect, and then once I join a channel, it's gonna show me the messages from that channel, okay? And then messages from intro, and then jobs, etc., okay? All right, but if I just refresh the page and I haven't connected my wallet yet, it's not gonna show me any because I haven't actually joined the channels. And if I go, like to another account, Hardhat 1, for example, it doesn't have any NFTs, I can't see the messages, right? It's going to make me mint the NFT, all right? All right, it doesn't show it to me yet because I haven't set the current channel. So reject that transaction. It's going to change back to our other account here. All right. All right, so now I'm going to format this message and make it look a little bit nicer. You can grab this from the final code solution if you want to, or you could just copy it from pausing the video right here, okay? But this is basically what we're going to do, okay? So basically, we're just going to, make that look better, all right? And then I need to put this over inside better. Okay. And then we're going to say messages, key index. We have an image here, source of a person, which is already imported up here. And then class name, message content. And then we're going to, get the account, show it inside of there, truncate it, and then show the message text. And now if you go back to our site here, click connect, go to general, these messages look a lot better. Okay. You could upgrade this even more. You could put like identicons inside of here for each Ethereum address if you wanted to, but for now we're just doing a little placeholder. That's a great homework assignment. It would basically be look at my other tutorials where I've put like blockies or identicons inside of there that are generated from each Ethereum address, and you could easily do that to sort of give everything some uniqueness to it, right? So last thing we want to do is use a ref to do the message end, all right? So we're going to create this at the top. Basically, a ref is something in React that just lets us store a reference that we can add later, okay? And then we're going to use this div at the end to store that ref for the message end. And then we'll see that here, okay? Because what it's going to do is automatically scroll when more messages come up. All right. And so now what we're going to do is create a form for chatting. All right. So we're going to do a form right here. All right. And then it's going to have an input. Let's say on submit. It's going to be send message. We'll create a function for this in a second. But really what we're going to do is have an input, type equals text. Okay. And then that's going to be, the channel itself. And then we'll have a button to submit this. And then button, type submit, send, send message. All right. And then, okay, send message is not working. Let's just say it's on submit, send message. Obviously, we've got to create a function for that up here. So we're going to do, const send message. All right, it's going to equal async. Pass in an event here. And we'll call the function here. And we'll just console.log. Sending message. And then we'll just pass in, let's do that for now. I'll take this out. All right, now let's go to our thing here. Now we can see this nice thing. I don't know if I'm clipped off the bottom of my screen, but you can see that. And I'll say, hey, everybody. And then I click this and it pretends to send it. So the first thing we need to do inside of here is prevent the default behavior, because HTML forms by default send a post request and refresh the page. So we're going to say e.prevent default. Okay. And so if I go back here and then click connect and do, hey, everybody, we need to join a channel first and hit enter. Okay. Well, let me make sure it's saved. All right. All right. So send message. Let's see on submit. Okay. Let's try it again. Let's just say, hey. Let's just see what it's doing here. Not sure why it's still refreshing. Let's see if we can kind of debug here. Click hey. Click that. And so I see what the problem is. I have a typo here, so it's not on some bit, it's on submit. All right. So let's try that again. Sorry, everybody. It happens. I like to leave these on screen because that way you see what it's like to be a real developer. And then let's click on general. And then I'll say, hey. All right, now it says sending message. Okay. So now we want to keep track of the message. So inside this input, what we're going to do is basically have an on-change handler. Okay. So basically on change, we're going to say E, and then we're going to pass in set message e.target.value, which is just going to be the I did this on the wrong thing, everybody. Sorry. Let's do this. This got really out of hand really fast. Let's try that again. Wow. I meant to put it on this input right here. So we're going to do that on change, set message, e.target.value. Okay. So e.target.value is going to be the value that the user inputted here. And we call set message, which is a function that we're going to create right now. Basically, it's just going to be a hook. So at the top, we're going to say message and then set message equals use state, and it's going to be empty string is the default value. And then inside of here, we can reference that message like this. We can console log the message. Okay. So on submit, like on anytime we type a message in, it's going to set the message. And then when we submit it, we can capture that message right here. All right. So let's just refresh, click connect, do this and say, hey. And then that should be logged to the console right here. All right, so that didn't quite work. All right, let's just click connect, let's refresh. All right, we're on. Somehow I lost that again, on submit. The typos abound. I'm not even sure how that one happened. I think I might have bumped something in my text editor. Let's click connect, general. All right, then hey, and then hit enter. And then now, boom, awesome. I can see sending message, hey, that's working. So we're talking to the server. So one final little piece of thing, we're going to send the message to the server. That's going to be the most important final last task. But I want to do a couple things. I want to basically make sure that we have a current channel set. All right. And if it's not, then we want to connect to MetaMask. So let's see here. We've got current channel and then the account, all right? We also want to make sure they have an account connected. So we're going to replace our input with this, and you can find this in the final code solution if you want to, but I'm just going to kind of paste it in for now. It's kind of hard to see completely on screen. Maybe I can, bump this over, but you can definitely find this in the final code solution if you want to. Basically, what we're saying is we want to check that there's a current channel and there's an account. If so, we want to basically do that same input with the value of the message, okay? And then the placeholder is going to be message current channel name, and then we do that. But if not, then we want to have this placeholder, please connect wallet to join the channel, and it's going to be disabled and you can't type in it, okay? So let's do that. Let's refresh here. We're not connected, so you're not joining the channel. You can't go into this and type, okay? So once you've connected, you still can't go into it and type. You actually need to join a channel before you can see the messages, and now you can start sending them the hey, all right? And of course, it's not going to do anything yet. It's just going to say, sending a message, hey. All right. So there's one more thing we want to do, which is basically have a scroll handler so that when you have more messages come in, it will automatically scroll those. So after set message, we're going to do a scroll handler, which looks like this. Scroll handler set timeout message ref end ref. That's this thing right here. Basically current scroll into view behavior smooth. So as more messages come in, it will continue to scroll down. All right. And then we want to call that inside the use effect hook like this. All right. You can grab this in the final code solution. So there's a couple little just optimizations from the UI perspective. But now we want to do the final most important thing, which is post the message to the server, okay? So inside the server.js, you can see what that looks like. Basically, we want to build an object that looks like this and send it to the server so they can get stored in this array, and so that you can essentially do it on new message. And when that new message comes in, it's going to push it into that array, and it's going to emit a list of all the messages to make sure that we have all the most recent messages. So what we can do is basically create a message object. We can say const message object equals this. All right. And we say channel. We want to give it the three properties from what we see in the server, the channel, the account, and the text. Okay. So channel, account, text. All right. So the text is the message that's getting passed in, right here. This is the message. We can take that console logging statement out. The account is going to be the account. Okay. And then the channel is going to be current channel. ID to string. All right. And basically, we also want to make sure that the message is valid, that there's actually a message inside of there. So we want to say, well, first of all, let's not do that yet. Basically, what we're going to do at the end of that is just do socket.emit, new message. Okay. And whenever it's done, we want to set the message so it's blank, and that we clear out the chat so that we don't have a message still sitting there in our form. Okay. And that should work. But finally, what we want to do is make sure there's actually a message so that we don't send a blank message to the server. So what we're going to do is if message is equal to empty string, okay. If it's not equal to empty string, then we're actually going to send it to the server and then, do that. Okay. So that should be everything that we need right here. Okay. So now let's give it a shot. All right. We can actually observe it in the server. User's connected. And then we can go here, click connect, go to the general channel. Hey, everybody. All right, boom, there we go. We could see our user address was stored. Here it is from here. Here it is in here. Go to the general channel. Our message is not there. Go back to this channel. It's still there. All right. You always see it in your server. That's okay. You need a console log in order to do that. We could always add that later. Go to jobs. We can say, hey, everyone, here's a great job. Okay. And then it's there. All right. And then we can also, change wallets. And then go to, Hardhat 1. And then, they're going to connect. They need to pay to join the channel. Once they do, all right. I think I might have to reset this account, so let's do that. Settings, advanced, reset account, reset. Okay. And now let's try to do the refresh, connect, intro. Let's confirm. All right, boom. There you go. And we can see it. All right. You can do this channel. All right, boom. We've joined it. We can see the message from the other account. We can say, hey, this is my alt account. Boom. Awesome. There we go. So you have just coded a fully fledged Discord clone with blockchain. All right, so let's take a look at the application that we're going to build together today. So this is a blockchain-based ticketing application called Ticketmaster, which of course is a nod to the world-famous Ticketmaster platform, okay, where you can purchase tickets for any type of in-person event, whether it's a concert, whether it's a sporting event. And so it's completely blockchain-based. So basically, a user just visits the website, they connect their MetaMask wallet, okay, they find the event coming up that they want to purchase tickets for. All right, they find one that has seats available. They can view the seats on a map. All right, pick where they want to sit. And they can purchase these with Ether or Ethereum cryptocurrency. And whenever they make this purchase, they'll receive a blockchain-based digital ticket for the specific event in the form of a non-fungible token or an NFT that's going to get held in their MetaMask wallet. So when they show up to the event, they'll have the NFT ticket that proves that they, made this purchase, that they have a claim on whatever seat they picked for the event. So why do this with blockchain? Well, I've made several different videos on my YouTube channel talking about the benefits of using blockchain-based event ticketing. Okay, one of the examples is a problem with the current ticketing industry. Okay, this kind of came to a head at the end of 2022 with Taylor Swift concerts, where basically all the tickets were purchased out from the pre-sale by bots, and basically people who weren't their actual fans, and the actual fans were livid. Okay, and the entire industry is moving in the direction of using NFTs in some way. Okay, so basically, we've already seen this with Ticketmaster debuting NFT-gated ticket sales, starting with Avenged Sevenfold. Okay, they had a successful launch of this where basically you had to hold an NFT to purchase the ticket. Now, the ticket they received wasn't an NFT like we're going to create in our project today, but the whole idea was you had to hold an NFT in order to buy tickets to prove that you were an actual fan, not a bot. And Ticketmaster, the actual company that we're modeling today, has rolled out this feature to more artists than just the initial pilot project. And while that's not the exact use case that we're going to cover in our application today,
like I was saying, the entire industry is beginning to experiment with ticketing for NFTs. It's one of the use cases that I'm most excited about for blockchain that's really yet to be tapped into. And today I'm going to show you to create this application where essentially you just purchase tickets for events with NFTs and they get held in your wallet. So let's kind of get an overview of the diagram for this project. Basically, you are going to be a user. You're going to have a MetaMask wallet that's, got some Ether in it. You can use your browser to connect to this website that we're seeing right here. Okay, this is a JavaScript application built in React.js, all right? And then you are going to essentially talk straight to the blockchain with an NFT contract. And this NFT contract is going to essentially mint each token, or in this case, each NFT to your wallet whenever you purchase it. You're going to create the tickets from scratch with this mint function, and you're going to pay money to do that. The contract will receive the Ether, and then, of course, the developer can withdraw that from the contract for getting the proceeds for the tickets. All right, so now let's go ahead and start coding out the project. So I'm going to put a link to this GitHub repository down in the description below, okay? You're just going to copy this URL, all right? Go to your terminal, and then type in git clone, all right, then paste in this URL, all right? I'm not going to hit enter. I've already done this step. But once you do, you'll just see a message that says, hey, the repository was successfully cloned. All right. And then whenever you do that, you want to enter into the newly created directory. All right. After you downloaded the project with GitHub or cloned it, say cd Tokenmaster. All right. And then now we're going to install our dependencies for the project. Now, in order to do this, you need Node version manager. It's not version manager, Node package manager. Okay. Which comes with Node.js. Really, the initial thing that you need to install is just Node.js and MetaMask. So what is Node.js if you're not familiar? Basically, it is a tool on your computer that lets you run JavaScript. All right. So normally JavaScript, its native environment is a web browser. And so if you want to run JavaScript outside your web browser, you need Node.js installed on your computer in order to do that. All right. So you can just download the latest version here. All right. I'm using version 18. So I highly recommend you use the same version as me to ensure the best results. And then, of course, you also need MetaMask installed. You can just grab that from the Google Chrome Web Store. So anyways, you can see if you have Node already installed by doing node-v. Again, I'm using version 18.12.0. And once you verify that's installed, you're just going to do npm install. Okay. So similarly, I've already done this step. That means you're going to see basically... you're going to see a smaller message here. You'll have a more verbose message than me. It'll take longer, but you just want to make sure that all your project dependencies are installed once that's good to go. All right, so really quickly, let's just look at the other dependencies that are going to get included with the dependencies we just installed, okay? So we're going to get Solidity, the Solidity compiler for writing tests in smart contracts, okay? From Hardhat, all right, this is the smart contract development framework that we're going to use. It's going to let us write the contracts themselves, compile them, put them on a blockchain, and write tests for them, okay? We're going to get JavaScript with Node.js so we can run on our computer for React, okay, which we're going to use on the front end, all right? We're going to create the website that you see right here with React.js. And then finally, we're going to use, of course, MetaMask and then Ethers.js for connecting our project to the blockchain with JavaScript. All right, so let's go ahead and start coding out the project. All right, I've opened my code inside of Sublime Text. That's just my text editor of choice. You can use whatever text editor you'd like, but we're first going to go ahead and start coding out these Solidity smart contracts for the NFT. So if you go to your contracts directory, you're going to see a file in here called tokenmaster.sol, okay? This already has the final code solution in it. I obviously don't want to just run this, but let's go ahead and clear this thing out so we can code it out and you can see how it's going to work. So I'm going to take everything inside of here and just delete what's inside the curly braces, and we'll start off with this mostly blank slate and go from there. All right, so what we're going to do right now is start coding out this smart contract in this diagram. Again, the user is going to connect with their browser to the website. It's going to talk directly to this contract that we're about to code out together. And this is going to be an NFT that lets people mint tokens from scratch. These tokens are going to be the tickets that they use on the blockchain, okay? And then, that ETH is going to go to the developer who created it. So we're going to use the ERC 721 standard for non-fungible tokens or NFTs. So what is that? Well, ERC 721 is just a specification that says, hey, NFTs all should work about the same way, okay? So they can be supported on websites like OpenSea so that you can hold them in your MetaMask wallet, and so that we have a standard way of doing this so that everybody, is doing the same thing, that everything's compatible. So really what ERC 721 does is it defines, specific functions that you have to have on your NFTs and events, and that those functions are named the same thing, that they accept the same arguments. Basically, they have the same function signature. It's kind of the advanced way of saying that inside Solidity. And then that those functions do certain things. So like you have to have a balance of function, and that balance of function is going to return the owner, how many NFTs a specific owner has. Same thing for owner of, you should pass in a token ID. It should tell you who the owner of that NFT is. That it specifies how to transfer tokens between wallets and all that type of stuff. We'll see all these things in action as we continue coding out the project, but I just want to make a note that we are going to create an ERC 721 token for these NFTs. Now, because ERC 721 is a standard, all right, lots of ERC 721 tokens work basically the same way. We do not have to reinvent the wheel, okay? So we are going to use a library called OpenZeppelin, all right, which gives us most of the behavior and functionality of ERC 721 tokens basically for free. All right, OpenZeppelin is a really popular Solidity library where you can do things like create tokens without a ton of coding. So we're just going to get an ERC 721 library, import it into our smart contract, and then we're going to customize it, okay? So we won't have to code out a balance of function. We won't have to code out an owner of function, okay? We'll get all this stuff for free, and then we'll create the important parts that are relevant to our ticketing process, which we can see right here. And if we go back to our code, you can see that that's really what we're doing at the state of the contract right now. This line right here, all right, it imports the OpenZeppelin library for ERC 721. All right, this is the ERC 721 library, the OpenZeppelin. This is how we import it in Solidity. So where is it coming from? Well, it's coming from our node modules directory. All right, Hardhat knows how to pull this file from our node modules directory because it's got this at OpenZeppelin. And if you have your node modules visible in your text editor, you can scroll down here. You can see, at OpenZeppelin. All right, right here. And you can see the directory at OpenZeppelin contracts. All right, you can see token, go token, and you can see ERC 721. And then you can see ERC 721.sol right here. All right. This is the file that we're importing, and you can see it's got all these functions inside of it. Like, let's look for balance of. All right. Here's the balance of function already. We don't have to code it out. We're going to import it into our contract. All right. So that's what this import statement does at the top of our file. And then in order to actually make our smart contract inherit this behavior, we do this line right here. So we create our smart contract list like this. We say contract token master. All right, that's the arbitrary name we've given our smart contract. But in order to inherit from this library and actually use it, we say is ERC 721. Okay. So if we don't have this, if we just do contract token master, it's not actually going to use any of the behavior that we imported from this library. We have to say is ERC 721. All right. And with that being said, we could just deploy this smart contract to a blockchain right now, and we'd have a basic ERC 721 token. All right. We'd have to add some additional parameters like the name, the symbol, all that type of stuff. But as is, this is pretty much a fully functional ERC 721 token. However, we want to code out the specific functionality for creating the tickets, and that's what we'll do right now. All right, so the first thing we want to do really is just create the NFT so that it has all the final necessary components to make it a complete ERC 721 token, and that's creating the name and the symbol. Because again, every single ERC 21 token has to have a name and a symbol so that you can read it from the blockchain what the name is, what the symbol is, so you can trade it. Okay, so we're going to do that like this. Inside the ERC 721 library that we get from OpenZeppelin, it shows us that we need to create that we need to set this inside the constructor function. Okay, so let me show you how to do that right now. We can create a function inside Solidity like this called constructor. all right? And this is a special function with a special name. And what it does is it's a function that's run once and only once whenever the smart contract is created. Or said another way, whenever we put the smart contract onto the blockchain, whenever we deploy it, it's going to run this special function, okay? And this function can have arguments just like any function inside Solidity. So what we can do is pass in the name, and we can pass in the symbol, okay? And because Solidity is a statically typed language, we must specify the data type for these. So a string, name, and then string symbol, okay? Basically, a string is just, a collection of characters inside of, quotation marks like this. This is a string up here. A string looks like this. A string could be apple, banana, carrot. A string could be your name, Gregory, or it could be anything, any human readable text inside of quotation marks like that. So string name, string symbol. We also must tell it the location of these. We're going to say memory. All right. And then we want to pass these into the ERC-721 contract. All right, if we go back here, we can see how that works. Sorry, let's just open it. All right, you can see it takes a string, memory, name, and symbol, all right, just like we did here. So in order to pass these along to the smart contract above, we need to use a special notation inside Solidity that looks like this. If we want to pass the arguments that we're passing in here to the parent constructor, all right, the parent smart contract that we're inheriting from, well, you want to use the parent contract name right here, ERC-721, open and close parentheses, and then we want to pass in the constructor arguments that it requires. So the name and the symbol, and we'll do that like this. We'll say a name and then symbol. And these two, this name is going to get passed in here, and this symbol is going to get passed in here. Okay. Go ahead and close that so you can see it. All right. Now what I'm going to do is format this code a little bit so that it's not taking up so much space. Basically, you can use multiple lines inside Solidity like this, and I'm going to just, format the code to look a little nicer so it's not just running off the page like that. All right. Okay, so let's save that. And now really we've got everything we need to create a basic ERC-721 token. Okay. Now, let's check let's just make sure this works. Okay, let's create a basic smoke test to make sure that we actually created the smart contract properly, that we can put it on a blockchain, and that we can read this name and symbol that we passed in the constructor. So how are we going to do that? Well, basically, we can go to the test directory. All right, so test directory, this tokenmaster.js, okay? This is the complete test for the smart contract that we're going to create in this tutorial today. But we don't, obviously we want to code out these tests together. This is the final code solution. So I'm going to initialize this really quickly, and we'll set up the basics ourselves. All right, so I have cleared out my test so that we can start, writing them together. All right, so I would recommend pausing the video if you haven't done this already, and just clearing out your test so that it looks exactly like mine. I'll give you 1 second if you want to pause the video and capture that. All right. So what we're going to do here is write tests inside of JavaScript. So testing is really important with smart contracts because it doesn't work like Web 2 development or, mobile development, where you essentially can just create smart contracts and put them out into the wild and then fix bugs as you go. Smart contract code is immutable, which means the code cannot change, out of the box. So that means it's really important to test your smart contracts so that they work properly before you put them on the blockchain. Now, testing is important in many aspects of software development, but it's particularly important with smart contracts, and that's one of the reasons I focus on it so much with Dapp University. So we're going to run our tests with Hardhat. It comes bundled with a couple of libraries that help us do this. So the Mocha testing framework, that's where you get this describe Tokenmaster function from. And then the Chai assertion library, which gives us this function called expect, which is going to let us just write, test to check for certain parameters. All right. So go ahead and make sure your tests look like this, and we'll write our first one. Okay, so the first thing we want to do is create another describe block here. All right. We're going to say describe deployment. Okay. And then we're going to put some examples inside of there that just make sure that the name and the symbol are correct. All right. And then how we write a basic test is we use the it function. All right. So we're going to say it. This is just a function that takes a couple different arguments. The first is just the test example that we're going to see in our terminal. Say sets the name. All right. And then the second argument is going to be a function. So we'll use an async function. And what that's going to do is it's going to run this function to check to see if the test passes or not. So what we can do is just check that the smart contract name is what we expect. So we can say expect. All right. And then I'm going to put some pseudo code in here, and we're actually going to fill it out. So we're going to say that, token master dot name, all right, to equal, let's just see here. What do we want to call it? We'll just call it token master. All right. So that's what a basic test looks like. It just say expect token master name to equal token master. All right, that's what a basic test would look like. Now, this is not going to work because we haven't actually set up the smart contract for deployment yet. All right, so we want to do that. All right, what we can do is just write that line before this. All right, so basically what we want to do is deploy the contract first and then fetch the name to make sure that it was set properly. So how do we do that? Well, inside of Hardhat with Ethers, we can say const token master, all right, equals await Ethers. Get contract factory, and we can pass in token master, which is just the name of the smart contract. All right, and then we can deploy it like this. Let's see, token master. Sorry, lowercase token master. Say let token master equals await token master dot deploy. We can give it a name. Token master, and then a symbol. Let's just say, what do we want our symbol to be? Let's say just TM. All right. And then here we say expect await token master dot name. All right, let me actually do this in multiple lines. Let's just say let name equals this, and then expect name to equal token master. So let's just run it, make sure it passes. All right, and then we'll explain the code. So you can run your test like this. You can say npx hardhat run tests. I'll bump that up so you can see it better. So excuse me, that's not the correct command. I have a little bit of brain fog here. npx hardhat tests. npx hardhat run runs your scripts. And then the test command just runs the tests from your test directory. All right, so it works, it passes. It is setting the name properly. So what do we do? All right, we just have this describe token master, describe deployment, and then one test example that says it sets the name. All right, you can even see that it sets the name, right here, it sets the name, and it check that test worked, it's passing. You can see one passing. We have one total test. It's just one test right here. So what we did was we just did const token master equals await ethers get contract factory. That's just getting the contract that we created already from Hardhat. This is a special function that comes with Hardhat and Ethers, okay? And then we deploy it like this. So token master equals await token master dot deploy. Again, this is lowercase token master. This is the deployed contract. This is the undeployed contract. We deploy it like this. Give it the token master name and symbol. Those are the constructor arguments. So name and symbol right here. That's what it corresponds to. And then we can read the name from the blockchain like this. We just say name equals await token master name. And then we just set the name to equal token master. So now what we want to do is check the symbol. Okay. So we want to say checks the name, and then, it sets the symbol. All right. But the problem is, we could do that like this. I mean, we could just copy this and paste it. All right. And then, symbol, let's just rename these. All right. And then set it to TM. And if we run that, it should pass, assuming that I did everything properly. Yeah, 2 passes, sets the name symbol. But this is duplication in our code. We don't want that. So how do we reduce the duplication? Well, we can use something called a before each function, which basically lets us run common code before certain test examples. So before this described deployment, I'm going to use this function called before each. That's going to accept a callback function. All right. And then that's going to let us run this code. All right. Before each test example. So we can take this out. All right. And I'm going to put this like this. And then I'm going to declare the variables here. Say let Ticketmaster. All right. Take this off. Okay. And then now that should work. Let's just run it. All right, still passes. And now we can see we've reduced the duplication in our code. We can also clean this up a little more. We don't have to keep these as separate variables. We can make this a one line. So we can just take this out, put it here. I just made it separate variables so that you can see what's happening a lot easier. All right, save that and then run the tests. And boom, it still passes. Okay, so we have checked the basics of our smart contract. We've created an NFT that's got a name and a symbol, and boom, we've got a fully fledged ERC-721 token. Now, it doesn't exactly do everything we want to do in terms of the ticketing. We're going to code that out in a minute. But we have this working. We've got our testing process set up. I want to do a couple of things here just to optimize our tests. And one more change in the smart contract before we move on, okay? So I'm going to refactor the name and symbol up here as variables. So we'll just do const name, capital, and const symbol, all caps. And then we're going to, do this. We're going to put in the name here and then put in the symbol here. We'll replace those. And then we can reference these variables later. This is, basically drying up our code, which stands for don't repeat yourself. Dry is a software principle. Don't repeat yourself if you don't have to. It makes your code much easier to maintain, easier to read, all that type of stuff. All right, let's run the tests. And they pass. Now, we also want to do one other quick thing, okay? We want to set up the accounts. So we're going to have a couple different scenarios in this. We're going to have a developer, all right, who receives the Ether for the tickets, all right? And we're also going to have a user who buys the NFTs. And so we're going to reference those people throughout our testing scenario, all right? So we want to create them at the top. So right here, we have, let Tokenmaster. We're also going to create some accounts here. So let deployer and let buyer. So this will be the deployer and this will be the buyer, all right? And we're going to model those people inside of here with Ethereum addresses or signers. And what we're going to do is use a function inside of Ethers.js that lets us pull those accounts out. So we'll say await Ethers get signers. So signers are a concept in Ethers, which basically just represents a user on the blockchain that can sign transactions. It's not an address itself. It's a key pair with a lot of other functionality associated with it. You can get the address, you can get the private key, you can get all that type of stuff. But that's how you do it. Now, this returns an array, all right? And what we can do is we can reference each item in this array or each signer with parallel assignment. So basically, we can just save the buyer and the deployer like this. Basically say deployer buyer equals await Ethers get signers. We save them to these variables, and now we can reference the deployer and the buyer throughout the rest of our test examples. Now, why did I do this now and not later? Because finally, we want to add one little piece of functionality to our smart contract, which is to save this developer right here, okay? So we're going to do that inside of our smart contract like this. We're going to create an owner variable at the top, okay? So let me show you how that works. So basically, we're going to create a variable, all right, up here. It says address public owner. That's going to be the owner of the smart contract, the person who has all the permissions to do things with the smart contracts, like get the money. That's going to be this person right here. And we just create a state variable, which gets saved to the blockchain like this. It's an address. It's public, so we can read that information outside the smart contract with Solidity. Solidity is going to be a special function to read this owner variable value. We make it public. And then we can just save the owner inside the constructor function like this. We say owner equals message.sender. So what does that mean? So message is a global variable inside of Solidity, all right, with multiple different values that you can access. One of them is sender. So message.sender is the address of the person who is calling this specific function right here, or the person who is calling any function. In this case, it's just the constructor function. So we're going to say owner equals message sender. We'll save that right here. It'll get written to the blockchain, and we can read it from the blockchain with the owner function because this variable is public. So what's that look like on our test? Well, we went ahead and, got the deployer address here, okay? And so we can just create a new test example that says, hey, it sets the owner, all right? And then inside of that, what we can do is basically say await tokenmaster.owner. Again, that's this function that's exposed by Solidity when we made this public, is equal to the deployer.address. Okay, this deployer right here, and then you call .address. Okay, you have to call .address. That's not going to work. It's going to return the entire signer object, say address. Let's save that, run the tests. And boom, 3 are passing, okay? So I want to show you this gotcha. This is something that's pretty common inside, testing with Hardhat. People forget to do this all the time. If I do just deployer and run it, it's going to fail. You can see expected this to equal signer with address. That's because you have to call .address here. All right, but if I save that, then boom, it passes. All right, so now what we're going to do is code out this functionality to create different events that people can purchase tickets for. So this is the mock-up of our final application. I'll revisit this through the rest of our session here. But you can see, for example, like here's an event on May 31st. This is UFC Miami. It's sold out. Or, on June 2nd, ETH Tokyo. You can view the seats and purchase the events. These are different events, all right, that you can buy tickets for. And now what we want to do is create a way to create these events inside the smart contracts and store them on the blockchain so that the tickets can be referenced for each of these events. So inside of the Solidity smart contract, we're going to create a new function to do this. All right, a new function. That's the function. That's the keyword that we use to create a named function inside Solidity. And then we give it the name, which is list. All right, and then we can write all the code for this inside of these, curly braces, like step 1, step 2, step 3. On multiple lines, okay? So with this list function, we want to make it public, all right? And this public visibility basically just means that this function can be called outside the smart contract, from our app, for example. If we didn't put this on our function, our app would not be able to call this list function, all right? So what this function is going to do is, create a new event. And it's going to have a name, a cost, and some other settings like the date, the time, location, all right? And we're going to pass those in as function arguments. So we can say the string memory, all right, name, all right? And what I'm going to do is break these up into multiple lines and list out all of the function arguments right here. All right, so here's all of the arguments that we're going to have. An event can have a name, all right? That's what you see like right here, like UFC Miami, all right? You can have a cost, all right, which you can see right here. It's like 1 ETH, okay? It's going to have the max number of tickets that can be sold for an event, right? So if you click on the view seats, let's say there's 100 seats, then you can only have 100 tickets, all right? The string for the date, that's going to be the actual calendar date, which is right here, like June 9th. And then the time is a separate argument, which is like, 10 a.m. TRT or 2:30 p.m. Central Standard Time, which you can see right here. And then location, of course, is going to be, American Airlines Center, Dallas, Texas, for example. All right, so inside this list function, we need a way to model the events themselves, okay? So we're going to use something in Solidity called a struct. So a struct is something you can create like this, struct, my struct, I'll choose this name. And Solidity is a statically typed language, but we can create our own data types with structs, which basically are just these kind of like objects that you can give arbitrary parameters. Now, we want to create one of those inside this list function, all right, to model the event. And now, normally in an application, I would use terminology that corresponds to the exact same thing that we're creating here. These are events that we're seeing on our page. So normally I would say like a struct event. But that's not going to work because this is going to have a naming conflict inside Solidity, all right? So Solidity has events in the code, all right? You can see like, this keyword right here, event transfer, event approval. So this is a reserved keyword inside Solidity, and we're not going to have something called event inside of our smart contract. So we'll use a different word that kind of means the same thing. We'll call it an occasion. Okay. So struct occasion, this is, the keywords in Solidity create a struct. We're just going to call it occasion just to have our arbitrary name here. And then we can give it all these different parameters like this, okay? We can give it an ID, a name, cost, the tickets, the max tickets, the date, time, location, which is really just going to correspond to the arguments that we're passing in to our list function right here, okay? Now, this simply defines the struct. This has not created any type of occasion. This just tells us what the what the ingredients for an occasion are, or the different attributes that belong to an occasion. In order to create an occasion, we're going to do that inside of our, list function like this. There's an occasion. All right, you can create a new event just like this. You want to follow by a semicolon. All right, you need a semicolon for each line inside your function inside Solidity, and then we can just pass in all of the attributes. Like ID, name, cost, symbol. So for ID right now, we're just going to hard code the ID of 1. We'll change that in a minute. And then we'll pass in these other ones like this, like name, and then cost, and then max tickets, and then the date. Actually, let's see. We need name, cost, the tickets, and then max tickets. All right, date, time, occasion. So I'm just going to copy these, and let's put them on new lines here. Let's just do this. All right. So for now, we're just going to make it look like this. So occasion, ID 1, name, cost, max tickets. We'll just pass in max tickets again, the date, time, location. All right. And that's going to create a new occasion. All right. So, this defines the occasion. This creates the occasion inside of the list function, okay? Now, let's talk about how to compute the ID. So each struct occasion is going to have a unique identifier, okay? Like 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what this uint is inside Solidity. This stands for unsigned integer, which basically is just a number that's not negative, all right? And we can create the IDs dynamically with something called a counter cache. All right. So what we're going to do is at the top of our contract, we're going to create this variable here called total occasions. All right. This is going to be the occasions count or total occasions. So we say uint 256. Again, this is a number that's not negative, public total occasions. And inside of this function, what we can do is every time we call it, we can just add 1 to that number. So when we start off, it's going to be 0. Okay. So that Solidity knows it's going to be 0, but it's going to start off as 0. That's explicit. This is implicit. And what we can do is just say occasions equals occasions plus 1. We can add 1 every time we call this function to use our counter cache to increment the ID. All right. And then actually that wouldn't be occasions. It would be total occasions. Sorry. All right, and then we would just do total occasions here. Okay, and then that's basically going to be our ID whenever we create a new one. Every time we call this function, we'll just add 1. It's just going to start off with 0. So the first time we call this function will be 1. Second time it'll be 2, 3, 4, 5, 6, 7. And then that number is going to get updated and stored right here on the blockchain. Okay. Now, the last thing I want to show you is that you can simplify this line. You don't have to do total occasions equals total occasions plus 1. There's a shortcut inside Solidity that looks like this. Okay, so this is called the increment operator, which basically takes a number you call plus plus after it, and that just adds 1 to the previous value and saves it. It'll automatically update it and save it on the blockchain right here. Okay. All right, so the next thing we want to do is actually save this occasion to the blockchain. So inside of our list function, we're passing in all these attributes for the occasion. We're creating one right here, okay? But we're not actually saving it to the blockchain. All we've done is instantiated an occasion in memory inside of our function. We actually want to write to storage and put it on the blockchain. So how do we do that? Well, we need a special place to put it. All right. And so we're going to use a mapping for that. Okay. So I'll show you that right now. At the top of our file here, we're going to use the mapping keyword, say mapping, say uint256. Okay. And then we'll say occasion, say public. Actually, we're not going to do public, we're going to say occasions. All right, so let me explain what this is. So what's a mapping? Well, mapping is a place where you can store key value pairs. So what is a key value pair? So you can see a simple example here of a key value pair where you have a key, which acts like a unique identifier, and it corresponds to one and only one value. So for example, a key is first name, and then value is bugs. And, for example, this person doesn't have more than one first name. It's only one first name. The key is first name, and then the value is bugs. Last name, one and only one last name. So the key is last name, and the value is bunny. Location, only one location at a time. And the value is earth. Okay. So we can use key value pairs like that. We can also use them like traditional databases, where traditional databases have IDs. So an ID is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the value is the record, okay, that it corresponds to. So that's similarly what we're doing right here. We're creating a mapping, which is just this key value pair. The key is a number, so an unsigned integer of the ID that we're doing right here. So ID like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the value is going to be an occasion struct that we are saving to the blockchain. And then we just give our mapping a variable name, which is going to be occasions right here, all right? So right here, we have simply just defined the mapping. We haven't actually added anything to it yet. There's nothing in it. Just like we defined the struct here, we had to create one. So inside of our function, we need to use this mapping we just created to add the struct to it, all right? So we'll do that like this. Basically, we can do it several ways. We could say, we could save this to a variable, but I'm just going to do it shorthand like this. You write stuff to a mapping like this. Basically, you say occasions, which is the name of the mapping. You use open close brackets. You give it the key. So it's going to be total occasions. And then you assign the value, which would be, the occasion. All right. And then you would put in all the stuff that you've created right here. Okay. That's all this stuff right here. But I'm just putting pseudocode for now. So that's the name of the mapping. Use the brackets. For assignment, you pass in the ID, which is the number right here that we created, and then you give it the value, which is the newly created occasion. All right. So I'm just going to backspace this thing right here and put it right here so that you can see it easier. I'm just going to backspace this, and then that's what it would look like. So occasions equals total occasions equals occasion, and then you pass in all the attributes, and now it is going to be saved to the blockchain. And there you have it. That is our list function, okay? And really quick, while I'm looking here, I realize it needs an S, so I'm going to add that. That's my fault, everybody. Okay, and so now let's write a basic test to make sure this works. We're going to go to Tokenmaster.js, and we're going to create a new section, all right, called occasions. So we're going to say, we've already described the deployment, so we're going to minimize that in our text editor. We're going to create describe occasions, all right? We're going to close that out here. And we're going to say it updates the occasions count. All right, that's the first thing that we're going to do. We're just going to run this, make sure that it basically works. And so what we're going to do is say const total occasions equals await token master total occasions. All right, that is this total occasions right here. And then we should expect total occasions to be equal 1. All right, whenever we created it, we need to make sure that it's 1. Now, we haven't actually created an occasion yet, so let's do that. All right. Let's do it in our before each function. We're going to say await token master connect employer. And I'm going to call this list function that we just created. Okay, we're going to pass in the arguments in a minute, but let me talk about this. So token master is, of course, the contract that we've created here. And we need to use this connect function right here. So what is that? Well, we are doing a transaction on the blockchain, okay? And we need to specify the account that we're doing that transaction with. In this case, it's the deployer, okay? The deployer is this character right here in our scenario, the developer who's creating the contract. That's who's going to get the ETH. And essentially, we want to make sure that they are signing this transaction. So the way Ethers works is we must specify the signer. This is the signer from get signers, okay? So we do Ticketmaster connect deployer, and we're going to call this list function right here. Now, we need to give it all of the variables that they're going to get passed into this constructor function right here, okay? So let's see what those are going to be. And we're going to save them to the top of our file. So what I'm going to do is put those right here. All right. So it's a const occasion time equals occasion name is ETH Texas. All right. Occasion cost will be this, be 1 Ether. All right. The occasion max tickets will be 100. Occasion date will be April 27th. Occasion time will be 10 a.m. CST. And then occasion location will be Austin, Texas. So if you want to pause the video and copy those down, or you can grab them from the final code solution, just copy and paste. All right. And so now I'm going to add those to our list function like this. All right. I'm just going to take this away and put it in list right here. I'm going to pass in the occasion name, the cost, the max tickets, the date, time, location. All right. And then finally, we're going to save this to a transaction, say const transaction equals await. And then we're going to say await transaction wait. So basically, this is the function call. It's going to return a transaction. And we want to wait for this transaction to get included into a block before we test for it. Okay, because this will basically send the transaction to the mempool. Okay, but if we call this function before it's actually included into a block, this test may not pass. So what we want to do is wait for the transaction to get included into a block and then run this test. Okay. So let's save that, see if it passes, make sure I didn't miss anything. Can't guarantee that. Let's just see if it works. Okay, so I did make an error, looks like, in my Solidity smart contract. I'm not perfect, and honestly, I like leaving these errors on the video because it shows you that I'm not perfect. You know, no developer is, and you have to troubleshoot your way through these types of things. It's part of being a developer. This is real life here. So I'm just going to intelligently read this error message. So inside your contracts file on line 21, that's what this is, the mapping occasion, this right here. So identifier not found or not unique. So what I'm going to do is go up here, occasion, and it's not the same name. I've got a typo. So I've got 2 S's in there. Occasion. Sorry, everybody. You might have caught that before me. Good job if you did. All right, now it passes. So it properly updates the occasion count. All right, so now we have successfully tested that we have created an occasion, right? We just saw that the count changed by 1, that now the total occasions is 1, the occasion was successfully created. But now what we want to do is actually test to see that the occasion was created with the right information, okay? That the name that we passed in is correct, that the time is correct, all that type of stuff, okay? And so let's talk about how to do that, okay? So I want to create a special function, all right, inside of here. Let's just see here. Inside of our Solidity smart contract, it's going to look like this. I'm just going to toss it in there and you'll see how it works. Say function get occasion. So this is going to be a reader function. So it's going to be public view, and it's going to return the actual occasion itself. And so inside of this, we're just going to pass in the ID, and we're going to read the occasion from the occasions mapping. So here's how we wrote occasions to the blockchain. We just did the occasions mapping. We used open and close curly braces, passed in the key, and then we assigned it with the assignment operator. That's the equal sign. But we can just read the information for the blockchain just by giving it the mapping name, giving the ID, and no assignment after it will simply return the occasion record for us. And then we can use the return keyword in our function to expose that to our application because it's public. And then we specify the return value is an occasion struct from memory. Okay. All right. And now instead of our test, we're going to create a new test example in this block right here that updates this and actually checks for the attributes. So I'm just going to throw that in there. I'll explain it. You can pause the video or grab this from the final code solution if you want to do that. Okay. So what we're going to do is say const occasion equals await token master get occasion, and then passing the ID of 1. Okay, that's this function we just created, get occasion. It accepts an ID of 1. We know that 1 was just created, so we can use the ID 1. And then we can say expect occasion.id to be equal 1, expect the name to equal this occasion name that we set up here. Okay, that's why I use these variables, so it's easy to check stuff. All right, same thing for the cost, same thing for max tickets, the date, the time, and the location. All right. So now let's run the test, see if it passes. All right, and boom, it works. So we're almost finished with the functionality for listing out these events on the page, like you see right here, these different occasions. But there's one problem with our smart contract as it is, okay? At this point, anybody can create a new event on our Ticketmaster smart contract or our Token Master smart contract, okay? But really, what we want to do is only the developer who's getting the money for these events, only that person should be able to create an occasion. So we can use a special function inside Solidity called require. All right. So what we can do is inside of here, we can say require. All right. And this is a function that basically is going to check for a value. It's going to check that an expression returns true. Okay. And if the expression returns true, then everything inside this code is going to run just fine. But if the expression evaluates to false, okay, then none of these lines are going to run and the transaction is going to get reverted and like nothing's even going to happen on the blockchain. Okay, so this is basically a check that says, hey, require that something is true before you do all this type of stuff. So what do I mean by expression evaluating to true? Well, you could be, make sure that 1 plus 1 equals 2, all right? And of course, 1 plus 1 does equal 2, and therefore this code's going to run, okay? But if you said require 1 plus 1 is 3, this is always going to evaluate to false, mathematically speaking, and these lines will never run, right? You can do arbitrary things inside of here, like require name equals Jim, or something like that, right? But what we're really going to do is make sure that the owner of this contract is the one calling this function so that nobody else can add these occasions. So we do that like this. Basically, require message.sender is equal to the owner, all right? So what is that? Well, the owner, again, is this address that we saved as a state variable, and we assigned it here with message sender instead of our constructor function. So in the constructor, message sender is the person calling the function, right? That's what message.sender is. It's a globally available variable inside Solidity. Sender is just the address of the person calling the function, and we assign it to the owner here. Likewise, we just want to make sure that this person is the same as the owner. So message sender is the person calling the function. We want to make sure it's equal to the owner. All right, and one more tidbit is this single equal sign is assignment. This is saying make the owner equal to this person. This one is just evaluating whether the message sender is the same as owner. So this is assignment. This is checking for equality. Those are different things. 1 equal sign, 2 equal signs. So make sure that person calling the function is the same as the owner address, which is saved here. All right. So now we can save this, rerun our tests, and it still passes. Now, I'm not going to create a special test for this. You can do that as an exercise if you like. I just want to make sure that this is in there. Now, finally, I want to clean this up. We can refactor this a little bit because, we want to have some other functions that only the owner can call. Like we're going to have a function that lets the owner withdraw the Ether from the smart contract. Okay. So we'll get to that later. But what we're going to do is move this into something called a modifier inside Solidity, so that we don't actually have to have this inside of our function body. So modifier is basically just something that lets us change the behavior of a function. I'll show you how that works. So basically, I'm going to create this modifier up here. All right. Just below this mapping, I'm going to say modifier equals only owner. Okay. And inside of here, I'm just going to copy this line or cut it. Okay. I'm going to paste it. Okay. So require message.sender is equal to the owner. And then I'm going to put this underscore here. And then we can copy this and just apply it to our function. So we can say public only owner. That's what a modifier is. Basically, it's this special code that we can add to our function like this that's going to run before all this other code. Okay. Now, it's going to run before the other code because we use this underscore after this require function. So what is underscore? This underscore corresponds to the function body. So this is the function body. This is all the other code inside the function. So for example, if we did it here, we would require that the owner is message sender after. Doesn't really make sense because we want to check it before. And if it fails, we want to stop there. So basically we're saying, hey, run this before you run all the function. And then we just copy this and then put it here. And that's automatically going to be applied to our list function. All right. So we can check it still works. Go to our tests and it still passes. Awesome. All right. So now what we're going to do is create the functionality to let people buy tickets. Okay, so going back to our mockup, we've now created the way to create events, or occasions in this case, like these different events you might want to buy tickets for. And then, we're going to click this button when we create the front end that says view the seats, and then you can click on a seat, and then you can purchase the seat at ticket cost, so like 1 Ether, for example. Okay, so we're going to create a new function inside of here that's basically going to just mint the NFTs. So going back to our diagram, when the user connects to our application, they're going to buy the NFT, which is going to call the mint function. Okay, so the mint function is going to create the tickets or the NFTs from scratch. Okay, like 1, 2, 3, and it's going to send them to their wallet. And of course, the developer can get paid for doing this. All right, so inside of the smart contract here, just below the list function, all right, we're going to create a mint function. So we'll create a function like this, function called mint. All right, let's be public. And then inside of here, we're going to mint the NFTs. Now, we're not going to code out all the behavior from this from scratch because, again, we're using this library from OpenZeppelin. All right, and OpenZeppelin has a mint function already. Okay, you can see it. It has a function called mint and then safe mint and then all that type of stuff. Okay. So what we're going to do is use this safe mint function inside of our function to get this behavior, and then we'll write all of our custom behavior on top of it. All right. So we've already got this because we've inherited from this library right here. But inside this mint function, what we can do is just call the safe mint function like this. All right. And then pass in the arguments that is needed to create the NFT from scratch. All right. So what arguments does this safe mint function take? Well, you can use this one right here. It's going to take the address of the person who's going to receive the NFT and the ID of the token, all right, that's created in this case, okay? So for the safe mint, what we can do is basically pass in the owner wallet of the person, sorry, not the owner wallet, the address of the person who's calling the function, which in this case is message.sender. All right. And in terms of the ID, all right, we must compute the ID. So we basically created a counter cache in our list function for the occasions to, store how many occasions exist, all right? And then we, wrote them the mapping like this. We can do a similar type of thing in our contract by creating a total supply counter cache. So just below total occasions, we could say uint256 public total supply, right? And that's going to be the number of NFTs that exist. So total supply is the total number of NFTs, right? And we'll use that as our ID scheme. So just like we incremented the total occasions, all right, we'll do the same thing here. We'll just say total supply plus plus. All right, and we'll pass in the total supply here, which will be the new ID. All right, so anytime somebody calls this function, we'll add 1 to the total supply. Whenever it starts off, it's going to be 0. So the first time somebody calls this function, it'll go from 0 to 1. All right, and then basically the safe mint function will be called, and it'll create an NFT with the ID of 1, and it will assign it to the wallet of the person who is calling this function. Okay. Now, that's the basic functionality for minting. Like, we could just leave it there, and then people would just be minting NFTs to their wallet. Now, it wouldn't be very useful because these NFTs, would not really correspond to, it would not correspond to any of the different tickets, okay? But you would at least have an NFT. It wouldn't have any special data. It would just have an NFT with an ID. So we need to add some behavior. The first thing we want to do is make sure the developer is going to get paid, okay? So what we can do is make this public payable, all right? What it's going to do is let somebody send in Ethereum cryptocurrency or Ether with this function call, where they call this. They can say, okay, call the mint function, but also send in the money that's required to purchase the NFT. That's going to be this cost, okay? And then so they'll send in Ethereum cryptocurrency, which will get stored in the smart contract, and we're going to let the developer withdraw it later. But we must have this payable modifier on our function so that someone can send in cryptocurrency whenever this function is called, okay? So that's the basic functionality. Now we need to add several things to it, all right? Let's start off with essentially assigning this to different occasions. All right, we need to make sure we're buying NFTs for the right event, essentially, or occasion in this case, and then also for the correct seat. So let's do those things one by one. All right, so first thing we want to do is make our function aware of the event or occasion that they are purchasing the ticket for, and then which seat they are getting. Because again, with our mockup, they want to click on the event and then, view the seat. All right, this is not actually going to work because I turned the project off. But basically, they're going to click that, they're going to see different seats, they're going to click the seat, and, they're going to be able to specify which seat they want. So first of all, it needs to be aware of the event. So we can say uint ID. This is going to be the occasion ID. So are they buying tickets for the UFC thing or, a concert? Say uint 256, long way. And then we're going to have the seat number, uint 256, and then seat. So this is the occasion ID and then the seat number, okay? And so the first thing we want to do is whenever someone purchases a ticket, we want to reduce the number of tickets that are going to be available going forward. Because if you buy a ticket and there's only 100 available, whenever you purchase this, well, now there's 99 available, and then subsequently 98, 97, 96. And if you remember, on our occasion struct, we have a max tickets, all right? Whichever we create our last one, let's say it's 100, it got saved here as 100, okay? And so we're going to decrease that value. So basically what we're going to do, we're going to fetch the occasion from the mapping, say occasions. We're going to pass in the ID, which comes from here, all right? And we're going to say the number of tickets, all right, that are available, all right? And let's say it's 100 in this case. Well, now we want to do is subtract one ticket. So we can do that like this, minus equals 1. And what that's going to do is update the ticket count and take 1 away. All right, so whenever they call this function, let's say there's 100 tickets available, this line is going to take 1 ticket out of availability. So whenever this function's done, now only 99 will be available so that whenever someone calls this function, like we won't have run out of tickets, okay? Okay, so next we want to do is make sure that whenever the person, buys the ticket, that the seat is no longer available. So this decreases the number of tickets available, but we want to be specific about which seat was actually taken. Okay, so we've got a seat number in here. So we can use a mapping for this. So up here in our mappings section, what I'm going to do is create a new mapping like this. It says mapping uint 256 equals, it corresponds to the value of mapping uint 256 address and call it public seat taken. Now, this is more advanced than the mapping that we created before because it is a nested mapping. So what do I mean by that? Well, this right here is going to be the ID of, the occasion, okay? And then this right here is going to be the ID. So and that's going to return a mapping in and of itself. So the key is the occasion ID, and the mapping is going to be a mapping of all the seats with the ID and the address on whether or not the seat is taken. All right, and it's going to tell us the address on who the seat is taken, by. So basically, here's the occasion, here's the seat number, here's who the seat belongs to. All right, that's going to be the seat taken. Okay. So that tells you which seat that you're going to have access to whenever you buy this NFT. So then what we can do is just assign that, all right, below this like this. Basically, we can say seat taken, ID of the occasion, which is passed in here, the seat number that's getting taken in, and we can assign that to message.sender, the person calling the function. That's just going to assign the seat to them. All right. And then what we want to do is set up an array, okay, that's going to keep track of all the taken seats to make sure that nobody else can buy this seat in the future, okay? So we're going to create an array at the top of our file like this. Go up here and just below, actually, no, it's not going to be, it is going to be an array, but it's going to be inside of a mapping like this. So mapping, UN256, the ID of the occasion, and then the seats that have already been taken, okay? So we're going to call that seats taken. So an array is just a collection of items inside curly bracket, or sorry, brackets like this, so apple, banana, carrot, all right? It's going to be an array like this of unsigned integers, which is going to be the numbers of the seats that were taken, okay? And so then we can basically just add those here with the push function. So just below the seat taken ID, we do this, seat taken ID, that's going to return the array. We do push, which just adds an element to the array, and we just push in the seat number. So basically that just updates the seat that is currently taken. All right. Now there's one last thing that we want to do is we want to make sure that the NFT is not purchased twice. We want to keep track of who has purchased this particular NFT for this ticket before. So we're going to create a final mapping here. We're going to be done with our mappings after this. That basically is just a mapping on whether someone's bought already, okay? So just below this, we create a mapping. That's the unsigned integer of the occasion, and then the mapping of the address of the person buying it, and a Boolean, which is just a true or false value to see if they have bought, okay? And so then I'm gonna scroll down here, and we're gonna actually use that right here. And then just above this, we'll say has bought, ID. That's going to be for the occasion, and then message.sender is the person calling the function, and we're just going to say is equal to true. All right. And so now we've basically done all this. We've got the occasion. We have created the decreased number of tickets. We've updated the buying status. We've marked the seat as taken. We've given it the address of the person who's taken it. We've kept an array of all the IDs of the taken seats. We've increased total supply, and we've minted them the NFT. Now, that's all the basic functionality that we're going to need in order to run this. We're going to add some stuff to this function here in a minute, but I want to go ahead and write some tests just to make sure that this is working properly. Okay, so now let's write some tests to make sure that this actually works as we expect, okay? So I'm going to go into my Tokenmaster.js file, okay? And I'm going to scroll down here. I've got the deployment minimized. You can see that here. I'm going to go ahead and minimize the occasions description. And then I'm going to create a new one here that says describe minting. Okay. And we're going to close that out right here. Okay. And so inside of here, what I'm going to do is, let's just see here. We're going to do a before each function to set up our minting. Okay. And then we're going to add some variables to this that we're going to pass into our function that we'll read later in the tests. Say const ID equals 1. So this will be the first NFT. We'll say, the first occasion. The const seat will be seat number 50, just an arbitrary number between 1 and 100. And the amount is going to be the cost of the ticket. So we're going to use 1 ether here. So amount equals ethers utils parse units 1 ether. All right. And then we're going to reference those variables inside of here. Basically, we're going to do this. So let me zoom out so you can see this. Const transaction equals await token master connect buyer. So again, up here we connected to the deployer account, okay? But here we want to connect to the buyer account because in this case, it's going to be the buyer who's connecting their wallet and then buying the NFT, all right? We do token master connect buyer. We call the mint function. That's what we just coded out here inside the smart contract, this mint function. We pass in the ID and the seat, just like this. The ID and the seat, which come from this ID and seat. Now, in terms of the cost of the ticket, again, this is going to be paid with Ether or Ethereum cryptocurrency, and this function is payable, okay? So we're not going to pass in the cost with a function argument like this. We're going to pass it in with function metadata. Okay, so you put metadata inside these curly brackets. So like here's the regular arguments. So a function can take lots of different metadata. So you just do a comma, and then you put the metadata inside these curly brackets like this. And the metadata in this case is value. Okay, the value is the amount of cryptocurrency that we're sending in terms of Ether. And we just say the value is the amount, which is 1 Ether. Okay. So then we want to create a simple test that just makes sure that we're updating the ticket count. Okay. So basically, whenever we do the occasion, we're going to get the occasion and make sure that the ticket count has decreased by the maximum number from 1. Okay. So do that like this. So it updates the ticket count. All right. So we say const occasion equals await token master get occasion 1, just like we did up here. All right. We did get occasion number 1. All right. And we're going to check on this line right here. So the occasions ID tickets, we took 1 away. We update the ticket account. We just want to make sure in our test that the original ticket account, which is the max tickets, which we set way up here, which was 100. Okay. We want to make sure that it is that number minus 1. So really it's 99. You can even play that in the test. I'll show you in a minute. Let's just run it and see if it passes. Make sure I didn't make any errors in my coding. Probably did. All right. I didn't. So I'm actually surprised. But it does update the ticket account. It passes. So you could even change this to, 99. All right. And then run the test again. Still passes. You can change 98 to make sure that it's actually working. It fails. Okay. So you can see on the failure, it expected it to be 98, but it got 99. So it's working. All right. Now I want to add in some more, functions here to make sure that this works properly, or some test examples, I should say. We're going to check the buying status like this. So you could just copy this from the final test example if you want to. Basically, token master has bought ID buyer.address. That's going to just read that from the mapping. So we're checking the buying status here. Has bought. All right. Run that test. Okay. We're going to check that the seat is taken. Oops, sorry, that's the wrong one. Or that's the buying status. We want to do the seat status. Like this. So wait, token master, seat taken. All right. Run that test, make sure it passes. Again, you can grab these from the final code solution if you want to. I'm just going to test them quickly so we can move on to the other parts. Now, in order to do the next thing, we need to add another function to our contract. We want to get the overall seats taken. So we're going to add a function down here that just gets all of the seats taken and then, reads it out from an ID. So just above below get occasion, we're going to create this new function called get seats taken. We're going to pass in the ID, and it's just going to read, the true or false status from the array. Okay. So you can grab that from the final code solution if you want to, but that's basically what it does. It just returns this. Okay. So inside the test, we'll check for that like this. We'll say updates overall seating status. We're going to just get the seats taken, passing the ID. All right, it's going to return an array. We'll make sure that array length is equal to 1 and that the first element is equal to the seat ID. All right. And then we'll run the tests. All right, passes. And then finally, we want to check that whenever they sent the money in with the transaction that is currently stored in the smart contract. Like this. So updates the contract balance. Basically, we just check the balance of the contract like this. Await Ethers provider get balance token master.address and make sure the balance is equal to the amount. And boom, it passes. Okay, so we've done most of the work on the minting function. However, we want to add some functionality so that we don't have problems. Okay, so for example, we're passing in the IDs in the seat here. We want to add some safeguards to make sure that it's valid information. So they're not like buying seats twice, that they're buying the correct seats. Okay. So the first thing we want to do is use these require functions, just like we did up here with only owner, right? Require the message.sender equals only owner. We want to do things like, add some more requires here. Okay. And we want to pass in, for example, we want to check this, make sure this ID is valid. So the first thing is like, we want to make sure that the ID is not 0, because we're never going to have a occasion number 0. All right, so we can like check that, run the test, and make sure it still passes. I'm not going to write specific test examples from this. You could do that as an exercise if you'd like. I'm just going to add them in here and show you that it works. Okay. And we also want to make sure that the ID is less than or equal to the total occasions. We don't want them, basically, if there's only 10 occasions, we don't want them to pass in ID number 99, because that's not going to be a real occasion that they can purchase tickets for. Okay. So I'll do that and then add this comment here to explain this code. All right, then we'll run the test. All right, so it passes. Now, next, we want to make sure that the amount of cryptocurrency they're sending in is the correct amount. Just do it like this. So basically, we'll say require message.value is greater than or equal to the cost of the occasion. So let me explain that. So message.value right here is the amount of cryptocurrency that's getting sent in with the transaction. So you can see message.sender, again, this is the same globally available variable inside Solidity message, or MSG, okay? And then we could call .sender to see who's calling the function, but we can also call .value to see how much cryptocurrency is getting sent in with the transaction, okay? You can even see that here. We specified value in the function metadata with the amount. Well, now that's in JavaScript. So in Solidity, we can read that value that's sent in with the function metadata right here with message.value, okay? And what we're doing is making sure that's greater than or equal to, it's at least the cost of the occasion, which is stored, right here, all right, on the occasion struct. We just read the occasion struct out of the occasions mapping, the ID, and we get the cost and make sure that the amount of cryptocurrency that are getting sent in is greater than or equal to that amount. All right. Save that, run the tests. Still passes. All right. And then finally, we want to require that the seat is not taken and that it actually exists. Okay. So we'll do that final check right here. Basically, we'll just say, make sure that the seat taken, ID in the seat, is not equal to the address 0, okay? And then also that the seat is less than the max tickets. Okay, so you've already made sure that it's a valid seat amount, but if there's only like 100 seats, we don't want to, look at, number 150 or something like that, okay? So let's save that, run the test. And it passes. All right, so we are almost finished with the code for our smart contract. Okay, we've got the ability to, list events or occasions that people can purchase tickets for. We've got the ability to purchase tickets right here. We've got tests for all this stuff. The last thing we want to do is make sure that the developer who created this contract can get paid. Okay. So let me explain what I mean. Right now, whenever someone buys a ticket, the money that they're sending in with Ether is getting stored into the smart contract itself. Okay, it's not actually going directly to the developer, all right? But what we're going to do is let the developer withdraw the money from the smart contract to their wallet whenever they want to, and only the developer, not somebody else, okay? So you can see in our test, whenever we checked the minting functionality, the last thing we checked for is that it updates the contract balance. So you can see the balance equals await Ether's provider get balance token master, which is the contract address, that it's equal to the amount of cryptocurrency getting sent in. So our tests know that the Ether is currently held in the smart contract. Now we want to create a function to get the Ether out to their wallet and then run a test for that. Okay. So it's pretty easy. We're just going to create one final function here. I'm just going to drop this in here. You can grab it from the final code solution if you want to, or you can copy it down by pausing the video right now. Okay. So we have a function called withdraw. It's a public function. That means it can get called outside the smart contract. But we apply the only owner modifier to make sure that nobody else but the owner can call this. Because if they could, then anybody could just drain the smart contract of the funds. Okay. So what we're going to do is transfer the Ether like this. There's multiple ways to send Ether around inside Solidity. This is the way that I prefer, is using the call function. So call just sends, a message to any arbitrary address on the blockchain, whether it's a smart contract address or an externally owned account like a user wallet. But what you can do is you can send in, a message, but then you can send in the metadata, which is the amount of cryptocurrency that you're sending. So I'll break down call and what that looks like. So basically, call requires a recipient. In this case, it's the owner. You can do call, okay, to send a message. And you can just put in whatever, you can put in different data here. But right now, we're just going to leave this blank. We're just going to pass an empty string because we don't really want to send in anything with that. We just want to send cryptocurrency. And so we do that with the function, with the metadata. So kind of like we did up here with this value metadata inside JavaScript, we can do a similar type of thing inside Solidity. So just before the open and close parentheses, we can do open and close curly braces. All right. And then we can pass in value, which is the amount of cryptocurrency you want to send. All right. And we basically just say address. This. So what is that? So this is the smart contract that we're coding inside of right now. All right. That's what this references to inside Solidity. We make sure it's cast to an address type. So it's going to get the address of the current smart contract. We don't know what this address is until it's deployed to the blockchain. So that's why we have to use this, notation right here. And then we just get the balance. So basically it's saying, take the smart contract as an address, get the Ether balance, all right, and then use that as the amount of cryptocurrency that you're going to send in this line right here. So we're doing owner call with nothing, but that call is going to have a bunch of cryptocurrency, and it's going to be the exact amount of Ether that's currently stored in the smart contract balance. Okay, that's what owner call does. Now, call returns some arguments, and we can get reference to those. The first one's bool success. We don't care about the second one, so we should do comma and leave it blank. And then when we're done, we just say require success. And that's just going to make sure that this cryptocurrency was actually successfully transferred to the wallet. Otherwise, we don't want this function to actually operate. Okay. So I just reconstructed that, so I'm going to delete it, but that's everything that's happening here. All right. You could use the transfer function inside Solidity, but that's not the way I like to do it. I like to do it with call, just like this. Okay. All right. So let's do a test for this. I'm going to just use the test in the final coding solution. You can grab that from there if you'd like. All right. We're going to do describe withdrawing, and we're going to set this up. Basically, we're going to redo this test example right here, but enhance it. Basically, we're just going to store the ID of the occasion, the seat number, the amount. We're going to track the balance before. Inside the before each function, we're just going to get the balance before. All right, just to check what it is compared to the balance after. Basically, we're going to take a snapshot of this person's Ether balance, which really should be 0 before they withdraw the funds. Or not 0, it's going to be whatever it currently is, because inside Hardhat, you have cryptocurrency already in your account. But anyways, we mint an NFT, and then whenever that's done, we connect to the deployer's wallet and we call the withdraw function. And we finish. And whenever it's done, it should update the owner balance, which basically says, hey, the balance after we did this transaction, it should be greater than the balance before. I'm not going to test for an exact number here because, again, whenever you are running the Hardhat blockchain, you get like 10,000 Ether, and the deployer has essentially been doing some transactions, so their balance is going to be decreased. It's hard for me to know exactly what that number is going to be. And all the Ether that's getting sent here. So all we're going to do is check for that it's going to be greater than, the balance before. All right, and then lastly, we want to check that it updates the contract balance. So basically, whenever we call this function, it should give the Ether to the wallet of the developer or the deployer, but it should completely drain the smart contract balance. So basically, it should be 0. All right. So that's what we do. We check that the balance of the token master address, which is the smart contract, okay, we expect that balance to equal exactly 0. All right, run those tests, see if it passes. And boom, it passes. All right, so now we have completely coded out this smart contract for our app here. Okay, we've got the NFT contract that manages all the tickets. We've got everything on this back end that we need to start coding out the front end website. Now, we need to do just a little bit of housekeeping to prepare ourselves for building the front end. Up to this point, we've essentially just, coded out this smart contract with tests. We haven't actually put it on a blockchain yet. So that's what we need to go ahead and do. All right. So I'm going to show you in a new tab here how to start your blockchain with Hardhat. All right. We go to our tab here, and we are going to essentially just do npx Hardhat node. Okay. Let me just try that again. So I made a typo here. I did Hardhat. If you've seen any of my other tutorials before, you've probably seen me make that typo at least once. I don't know why. I just forget that second H for some reason. But anyways, if you start it correctly with npx Hardhat node, you're going to see that a blockchain has started. Okay, it's going to give you 20 accounts. All right, starting with account 0 all the way through account 19. And they're each going to have, account address and a private key, and they're each credited with 10,000 fake Ether. Now, don't get excited. This Ether's not worth anything in the real world. You didn't just instantly become a multimillionaire, okay? And also, I'll say, you should never use any of these accounts that I'm showing you on the screen to store any real cryptocurrency, because most of the time, whenever you start a Hardhat node like this, it's the same key pairs for everybody, basically the same private key, the same account address. So you can check that on your screen. Is your private key for account 0 the same as mine? Probably is, if you're using the same Hardhat version as me. So you never want to store any real cryptocurrency in any of these accounts, because your funds are going to get stolen. Okay. Same thing with the seed phrase. If you see the mnemonic seed for these accounts, you never want to use that to store any real cryptocurrency. All right. Just a word of caution there. But anyways, we have our blockchain running. Now what we want to do is take this smart contract that we just finished and put it on the blockchain. So what we're going to do is use this script inside of here. So go to scripts directory, deploy.js. And I've already created this script for you. I'm not going to code everything out from scratch here. I'll explain what it does. Okay, I want to kind of speed past this part so that we can get moving to the front end application. Okay. So what this does is it executes code that's very similar to our Tokenmaster.js before function, where essentially we're just getting the accounts, we're getting the smart contracts, we're deploying them, putting them in the blockchain, and then we're doing these other things like, creating some occasions, and then, basically having stuff in our application that we can go ahead and use whenever we start the front end. So you could go through here in your MetaMask account, okay, and then create a bunch of occasions manually, but that's a real pain in the butt. I would rather do it with code. That's the whole benefit of code, is you can automate tasks that would take you a long time to do by hand. It's one big benefit of code, especially with scripting, and that's what we're going to do right here. So essentially, inside of our deploy script, we just set up the accounts and the variables. We just get the signers from Ethers, just like we did in our tests, like right here, okay, get signers. And all we need in this case is just the deployer address, okay? So we create the NFT name and symbol, Tokenmaster TM. We deploy the contract like this. We do get contract factory. It's the same line as this, okay? And then we deploy with the name and symbol, and then we wait for the contract to be deployed. And then we log to the console. Hey, it was deployed, okay? Now we're going to get 6 different occasions so that we can sort of see the application, so that when we boot at the front end, we actually see some different, things here. And we're going to use the exact ones in the mockup, like UFC Miami. The cost is going to be 3 Ether. The tickets is going to be 0. It's going to be sold out, basically. The date's going to be May 31st. Time is 6 p.m. Eastern Standard Time. So if you're watching this tutorial later, past these dates, you could change these. You could say, August 31st, for example. Okay. You can manipulate this date if you want to. I'd probably just run it the first time with the exact information in case you experience some bugs. You don't want to be trying to follow a tutorial where there's some discrepancies, but if you want to manipulate it later, that's how you can do it. So same thing with these other ones, ETH Tokyo. We've got 1, 2, 3, 4, 5 different events or occasions that we can buy tickets for. So then what we'd use is a for loop inside JavaScript, and we just create them one by one. So we just do Tokenmaster connect deployer. We call that list function that we created inside our smart contract right here. Sorry, this list function. All right. And we just list with the occasion name, cost, tickets, date, time, location. We wait for the transaction to get included into a block before we continue on to the next one. All right. And then we just log out of the console that it has created an occasion. Okay. So you should have that in your final project already. If you don't, you can just copy that from the final code solution from the GitHub repo. Okay. So now we've got our blockchain running, and we're going to deploy our contracts like this. We say npx npx hardhat run, do scripts, deploy.js, and do -- network localhost. Okay. And you can see it worked. So deploy the Tokenmaster contract with this address. We listed the event 1, UFC Miami, listed event 2, ETH Tokyo, Privacy Hackathon, Dallas Mavericks, ETH Global Toronto. So it was successful. Now, the final thing I want to do is save our smart contract information so we can start coding at the front end. This is really important that you do this whenever you're coding a front end app that's not totally aware of your Hardhat project. So inside of our project here, we have this source directory. That's where we're going to put the front end application. We have this config.json. Okay, this is where we're going to save the address of the smart contract that we just created. Now, you want to make sure that this smart contract address matches what's logged to the screen here. So the safe way to do this is just to copy it and then paste it inside of here. Okay. Now, you can notice for me, it didn't change. Most of the time, Hardhat's going to generate the same address every single time for the first contract that's ever created. I have seen discrepancies from time to time. I'm not exactly sure why, but you just want to make sure that this address that's logged to the console is the same one that's inside your config.json here. Okay. Now, the next thing that you want to do is take the smart contract ABI. Okay. Go to let's just see here. Go to ABIs and see tokenmaster.json. We've already saved the Tokenmaster JSON ABI inside of here, but you want to make sure that it matches exactly what you just coded out in your application. So what's an ABI? Well, an ABI is really just a JSON representation of your smart contract, what the interface is like. So what are the function names like list, mint, et cetera, What are the function arguments like, name, cost, max tickets, date, time? It's basically so you can create JavaScript versions of the smart contract when we code out the front end application. And you want to make sure that this matches, what you just coded out, okay, in case there's any discrepancies. So if you ever make a code change to your smart contract, you need to update this, and you also need to make sure that this is the same, okay? So because your front end application is not going to be aware of the changes that you made inside your Hardhat application, okay? I'll get to that when we start coding that out, but just want to make sure this is right. So you can find the ABI that's generated by Hardhat up here. You can go to the artifacts directory, go to contracts, and go to tokenmaster.sol, and look at tokenmaster.json. You can see what's in the ABI, okay, and minimize that, or just copy from line 5 to 582, and then go inside your Tokenmaster, let's just see here, Tokenmaster.json, and then just replace that with what you had inside of your build folder here. You want to make sure these things are in sync. Your app's not automatically going to sync these things up. You need to sync these things up manually. But once you've got that done and saved with the ABI correct and the address correct, you're ready to start coding out the front end. All right, so now let's start coding out the front end. All right, so we just did this, but in case you're skipping ahead to this section with the chapter markers down below or something like that, I just want to reiterate, up to this point, you should have your smart contracts already created inside this contracts directory. You can find the complete code solution if you want to there. You need to have your Hardhat node running. Okay, that's just with npx Hardhat node. And then finally, you want to make sure that your contracts are deployed to the network. Okay, that's with npx Hardhat run scripts deploy.js -- network localhost. And you want to make sure that this address right here matches exactly what's in your config.json here, okay, and that you have updated your ABI, okay, inside of the ABI's directory. All right, so we've done all this stuff, okay? So what I want to do now is, you can go back and check the last section. What I want to do now is head over to the app, and we're going to code out the application from scratch, all right? The front-end application, I should say. So what you're going to want to do is go to source app.js, all right? There's a lot of stuff in here, but we're going to initialize this. Basically, what we're going to do is we're going to leave all these imported files here at the top, but inside this app.js here, what we're going to do is take out all this stuff, okay? All right, we're going to just leave this return function here, and we're just going to keep a simple div, okay? And then we're going to put a h1 tag here. Okay, that just says hello world. All right, I'll come back and explain what this is here in a second. But for now, that's what we're going to do to just initialize the application. I'll even give you some space. So if you want to just, if you want to pause the video and copy this down, okay, basically just a quick summary. Don't touch anything up here. You just want to make this function that says app look exactly like this. All right, so I'll let you pause the video and copy that down if you want to. All right, so now what we're going to do is go ahead and boot up the front-end application. Okay, so if you go to your terminal, all right, make sure you got a separate terminal tab here. I'm just going to clear all this stuff out. We've got our blockchain running, and then we want to have a tab where we can still run terminal commands, but we want to have a separate one where we can run our web server, and we can run our web server just like this. We do npm run start, okay? And now you should see this web page automatically pop up in your browser just like this, okay? And you can see this text, hello world, which we just added a minute ago right here inside this app.js file. So let me quickly give you a tour of the front-end application, okay, and explain what we're doing here. So, we're working on the front-end side of things. And so if you're brand new, if you're not familiar with what front-end is and what back-end is, the front-end is what the user sees and interacts with on their web browser, okay? And the back end is what's happening, in this case, on the blockchain with the smart contract. So the blockchain is the back end with the smart contract. The front end is the user-facing website that we're creating right now. Now, for web development, you use HTML, CSS, and JavaScript. But what we're going to do is use a JavaScript framework called React.js. If you're not familiar with it, that's what we're going to use. It's basically just a library for creating user interfaces. Okay, so basically you can write HTML and JavaScript all in the same place, and also CSS, all right, inside the same file, and mix them together. React just gives you a really nice way to do that, to make reusable components that are very modular. You can read more about it here. It's also got the React state object to do front-end data management, which we'll see here momentarily. All right. I use React in pretty much everything that I do on this channel and in some of my training materials. So just a quick introduction to that if you don't know already. It's widely used in the blockchain industry. Okay, so this is a React component. All right, this is the main component we're going to code inside of today. You can render sub-components, which you can see in this components thing, like the card, navigation, seat, etc., etc. We'll get to those one by one as we continue on the tutorial. But this is what a component looks like. Okay, you can see importing these other components and files at the top. You have this main function. We're going to use React functional components in this tutorial. So you should define a function called app. You can put a bunch of different JavaScript up here. But then inside this return, okay, this is where you actually put your HTML code that gets rendered onto the page. And you can also, evaluate JavaScript inside of it, which means that you can mix HTML and JavaScript inside the same code here by, doing that inside of these curly braces, which we'll see as we continue building this out. And then finally, you just need to export the function that you created here at the bottom, like export default app, and that's going to get, rendered to your browser. So one quick thing to mention here is that we are using CSS, all right? That's going to make our app look really nice. So we've already got the CSS written for you. We're not going to spend a lot of time on it. Again, here's our final mock-up that we're heading towards. You can see that we have an index.css file, which basically writes the CSS for the application. I'm not going to make you write all this in the tutorial. I want to focus on the blockchain development side of things. So we start adding classes to our HTML, it's automatically going to absorb these styles that we've pre-generated, okay? And yeah, so normally I have this branch, zeroed out by the time we get here, but we'll just delete the code that's in the files and, write it as needed. So the first thing we want to do is connect our app to the blockchain. And actually say that before that, there's one prerequisite step. We have got, our website running, but you need to make sure that you got MetaMask connected to the correct network, okay? So the first thing you want to do is inside your MetaMask, all right? You're going to want to make sure you have the Hardhat network, okay? So by default, you're going to be on the Ethereum mainnet. You want to do add network, okay? It's going to take you to a page that looks like this. You just do add network manually. You can call it Hardhat. RPC URL, you got to go to your Hardhat node here, and you're going to see what's running on. Mine's running on this, so I would copy this, okay? And then for chain ID, you can get that from your config.json file here. You do this, all right? And then currency symbols, ETH, and then block explorer, you can leave it and click save. So I've already done this. It's not going to let me do it. All right. So it won't let me click save, but you can put all this information in there and click save, and it should create a Hardhat network for you. Whenever that's done, go back to your web browser here and then select the Hardhat network. You can search for it. Well, actually, you can't search. You can search for accounts. Click Hardhat. And then it should switch to the Hardhat network. Now, obviously, a prerequisite for this is installing MetaMask. I don't really walk you through how to set that up. It's pretty straightforward. You can just Google it and look up the Google Chrome Web Store, or whatever browser you're using. But yeah, you need to have MetaMask installed. That's how you add the Hardhat network. That connects us to our development blockchain. Now, the other thing is you want to import the accounts that are coming in from Hardhat. So I'm just going to import the first or second account. I'll just do the first one for you. So what you're going to do is copy this private key, all right? And then you're going to go here and you're going to do import account. Let's see here. Import account, paste in the private key, click import, all right? I've already done it. It's not going to let me do it, okay? So I click cancel, but you could click save. You can switch to that. Go scroll down, find it, go ahead and switch to it. I've renamed mine, so you can go to account, let's just see here, account details, and then edit this. I just named mine to Hardhat 0. I call it 0 because Hardhat uses a zero-based index to name its accounts because they come in arrays, and that's the programming convention. So you can see account number 0 here, like account number 1. So the first one's 0, second one is 1, third one's 2, fourth one's 3, so on and so forth. There's 20, but you see the last one's number 19. So I just use the same naming convention inside my MetaMask to eliminate confusion. So like I just renamed this to Hardhat 0. You can repeat these steps for the first several accounts if you want to, 0, 1, 2, 3. And every time you boot up your Hardhat node, you should have the exact same accounts over and over again. That's the beauty of it. Then you can permanently have those saved inside your MetaMask. Now, one last thing that I would do while you're here is go ahead and reset your account. So go to go to settings, go to advanced, and do clear activity tab data. Okay, click clear. Because if you've done anything previously with those accounts, like you saw had some activity, you're going to get an issue with the cached nonce in your MetaMask. You might see some funny errors with that. So I'm not going to go in depth and explain that. Just make sure you do those steps right now, and you should be good to start developing and get MetaMask set up properly. All right, so now what we want to do is go ahead and connect our application to the blockchain. We'll do that by just checking our MetaMask account and showing it on the page. That's a good, easy first step, okay? So what we're going to do is inside of our app, we're going to create a function here. So go inside this app function above the return right here, all right? And you are going to create a function called useEffect. So useEffect. All right, so this is a special function inside React, all right, that essentially gets run whenever the component like changes, okay? So if it receives some new data or something like that, new user interaction, then this is going to get run, okay? So this accepts two arguments. One is a function, a callback function, which basically gets run whenever, like you do stuff inside here, okay? whenever you have use effect run, like here's where your execution code goes, and then it takes a dependency array that it watches for things to change. Don't worry too much about this. In fact, I think we can probably get away with leaving it out if we wanted to, but let's just leave it for safekeeping. All right. So what I want to do here is go ahead and console.log. It's working. All right. And you can go back to your terminal and you can do inspect. Okay. And you can see in your console, this statement here, it's working. All right. So you can see basically the use effect function is run whenever it's run twice here because two different things happen inside the app. All right. So use effect is wired up properly. Okay. So what I want to do here is actually speak to our blockchain side of things. Okay. The first easiest way to do that is to go ahead and get the account from MetaMask that we're connected with. Okay. So I'm going to do that like this. Basically, I'm going to use the code that MetaMask tells us to do this with, okay? Just above this, I'm going to do this. Await window.ethereum requests, and we're going to pass this in method eth request accounts, okay? So what is this? So basically, window.ethereum is something like window is the globally available variable inside JavaScript that is, it's just the window inside JavaScript. That's what it is. You can see window. It's got all this stuff on it. Okay. And we got window.ethereum. Okay. This is something that MetaMask attaches to your browser window so that you can talk to MetaMask. Okay. And so what you can do is window.ethereum, you can do make a request. This is an RPC request to your Hardhat node, basically. Request accounts, or this is an RPC calls, what I mean to say. This is an RPC method, method eth request accounts. And what's going to do is return the current account that you're connected with MetaMask, so we can save it. Say const accounts. It's going to return an array, and then you can pass that array in right here. Okay. Okay, so I did realize it's not going to let me do that here. Can I do this? Let's see. Yeah, it won't let me do that. So let's do this instead, everybody. I tried to do this for simplicity's sake, but this was a failed strategy. So let's move this up into a new function, all right? We're going to do this function called load blockchain data. Okay, and we'll say async. All right, what we're going to do is take this async off. We're going to move this code up here. And I'm going to call load blockchain data. All right. So I tried to make it simple, everybody. Try to reduce the complexity, but that was a failed strategy. And this works now. Okay, so we can see our accounts logged to MetaMask. You can see it's just one account. That's the only one that's going to provide us because that's what we've connected with. And $17 million. It is logged to the console with an array. Okay, so just notice that. All right, so we add this load blockchain data function. I'll let you pause the video right now if you want to. Copy this down. All right, so next thing we want to do is show this account on the page. So in order to do that, we need to use a React state. So what is the React state? Well, essentially, it's like a front-end database for each component. So where if you want to take some data and save it inside the component so that you can use it in other places, that's what it's for. So for example, you can see like, you've got these videos, right? If you got 3 videos and you want to save that in your component, well, where does it go? Well, it might go in the component state, all right? And you want to see like, what's the status? Like, is this video liked or is it not? Well, you can write that to the component state as well. Okay, same thing like a to-do list. If you want to know where the to-do items are coming from, like the state is a really great place to put that. It's just where you can store data. Now we can put blockchain data in the state as well. That's exactly what we're going to do. So in this case, we're going to use the account for that. So we're going to use a function called use state. So we did use effect here, which basically is going to let us run stuff whenever our component changes. All right, that's imported from React to the top of our file. Use state is also imported. So what we can do is basically do this at the top of our app. We can do const account and set account equals use state null. So let's break that down. Let's start off with just use state. So this is a function that lets us, create a new piece of data that we want to track in the state. So we can do null, which can be the default value for this. All right. So if we get the data back from the state and it's not there, what should it return? Well, null. All right. And then it returns an array that we can do parallel assignment with, just like this. We can get the account that's actually in the state, and a function set account lets us write that information to the state. So I think it's best to just show this in action so that it makes more sense. Basically, this is going to be a function where we can write information. So we can do set account is equal accounts 0. That's the first account. So when I do set account, it's going to write the account to the state because this is a function. All right. I'm going to mirror this. And then account is going to be a variable that lets us access this. And we need this because we want to show the account on the page right here. So I can just do a paragraph tag and then just illustrate this concept. I think that'll make it more sense. Curly braces lets us evaluate JavaScript instead of our HTML code, like I was saying before, with the return. So I say account. Now if I go back to my website, you can see the account listed on the page right here. Okay. Awesome. So now we're cooking with gas. We're talking to the blockchain. We've got the account saved to the state and shown on the page. So while we're here, yeah, that should be good. One other thing I want to do is basically show you how to format this. So basically, I'm going to do accounts, and I'm going to do this additional formatting, which is this const account equals ethers utils get address. That's going to format the account for us. I believe it's going to convert to checksum, give it to us in a string format so that it's nice. We can use it inside of our library. It's not going to throw any issues, and it looks nice on the page. Okay. And then I can do set account, and then just pass an account here, and then take this console log off. And then, boom, there you go. Now, one other thing I'm here, I want to show you how to automatically refresh the page if you change accounts. So I'm going to switch to Hardhat 1. All right, if I change accounts, it still shows me my old account address on the page, and I have to refresh in order to see the new one. So how can we change that? Well, we can add this code to the page, okay? So I can just say like, fetch account, and then we can say refresh account. And put this code in here. All right. So what this does is we did a window Ethereum request, but now we can have events. So window Ethereum on accounts changed. We can pass an async function, and we just run this entire block of code basically again. I believe if you just copy this and like do Command D, it's not perfect. I'm trying to see what the discrepancy is. Maybe it's a spacing thing. I think it's a spacing thing, maybe. It basically does the same thing, okay? So this is the same code as this right here. So basically we're saying, you can even abstract this to a function if you wanted to and call the same function twice. I'm going to move this in a second. That's why I'm not doing it right now. So now if we go back here and we do Hardhat 0, we can see the account on the page changes. Awesome. Very cool. So now what I want to do is go ahead and inject that account into our ready-made Navbar component, okay? So I'm going to show you how to render a new navigation element onto the page. So our new component onto the page. At the bottom, I'm going to do some HTML here that says header. Okay. And then I'm going to do this H2 element here that looks like this. It just says header title, strong, okay, event, tickets, okay. And then you can see event tickets here. That's looking like this part of our mockup. And now we want to do is add this Navbar up here that shows our account, okay. So now we've got some stuff coming up. Let's go ahead and add our Navbar, which you see right here, that will have the address in it. So I'm going to just go ahead and take the component that's imported from the top of the page here. So this navigation, if you go to components navigation, we'll just leave the code in there for now. Okay. And I'm going to render it on the page. So how do I do that? Well, you do it. It's pretty easy. You do it like this. You just give it the component name, navigation. All right. But if you look at the file, it needs some other properties. It needs the account and it needs set account. So like we have a function called navigation, which I'll go over in a minute, but you can see that it has arguments, right? Our app doesn't have arguments. There's nothing in here, so we don't have to give this any arguments. But how do you pass in, where do you give it the account and set account? Well, you do it like this. You just do account equals account, and then set account equals this, set account. All right. And you click save. And you can see this account is coming from this, and the set account is coming from this. All right. And now if I save that and I look at my web browser, you can see that if I close this, you can see that our Navbar looks exactly like our mockup. All right, it works. Okay. And now what I want to do here is take out one last thing, is this fetch accounts. I want to take this out because if you notice, whenever I refresh the page, this thing says connect and then it automatically connects for us. We actually want the user to consent to give the account to the application. So if I take out this fetch account block here inside low blockchain data to where it just looks like this, now I see this connect button, okay? And if I click it, it actually requests the account from MetaMask and it shows it on the page. But if I load it, you don't automatically have your wallet, okay? If I go to like Hardhat number 7 or something, you should see what it looks like. See Hardhat. Let's look at Hardhat number 5. Okay, so if I just refresh here and do connect, now it should, let's just do Hardhat 5. Let's do 5. Okay, so it's not connected. Let's refresh and see what happens. Click connect. And then you want to make sure you're on this one. Yeah. Okay, awesome. Okay. Awesome. Now you can see that this comes out. So where does that come from? How does that button click work? Well, again, I'm not going to code out the entire navigation component from scratch. But what it does is inside of here, you've got this button here to connect. It has an on-click handler, which basically means when you click this button, run this function, okay? And it has a connect handler, which basically does exactly what we just did, okay, in this app.js load blockchain data function that I just took out. It just does the wait for the accounts and then, set account. And then we're already reading account here. And then we're just showing the account on the page. Also notice that we are truncating the account so it doesn't flow off the page. We just take the first several characters. We include an ellipsis, and then use the last several characters to show the shortened version so it doesn't just run off the page, okay? And then we've got the other basic markup inside of here. Now, let's see here. That should be pretty much everything that we need for the initial account setup. All right, so now let's go ahead and load the smart contract into the application. Okay, so the first step is going to be to get our actual MetaMask connection loaded into our project so that we can create an Ethers.js provider. Okay, so we already have a MetaMask connection with window.ethereum like we talked about. What we want to do is create a full-on Ethers.js connection, which is called an Ethers.js provider. It's the thing that provides the connection to the blockchain to your application. It's what turns your app into a blockchain app. And we can do that, with the Ethers library we've imported here. And we can use the window.ethereum object from MetaMask like we showed a minute ago. So how you create a new Ethers provider is like this, okay? Let's just see here, like this. Say const provider equals new Ethers providers, Web3 provider, because we're using Web3 provider for MetaMask, and we just add that window.ethereum object from MetaMask that we've been using, okay? And again, this is your new blockchain connection. This is what provides the blockchain connection so you can sign transactions with MetaMask, all that type of stuff. And we want to save it to our state, just like we did with our account here, okay? So what we're going to do is do this at the top of our file, provider and set provider. And then we're going to set the provider right here. And we're going to use this in many other components down the road. Now, let's just see here. What we want to do is now create a connection for the smart contract. Let's look at the Ethers documentation to show you how to do that. So you can see inside the Ethers contract, this is all you have to do to create a JavaScript version of your contract. Do new Ethers contract, and then you need a few different ingredients. Number one is the address of the deployed smart contract, the ABI of the smart contract, and then the signer or provider. Okay, so let's show you how to do that. So basically, you can do new Ethers contract, just like from the documentation. Okay. And then you can pass in the address. I'm going to hard code this for now. You can find your address inside your config.json file. Okay, so I'm just going to hard code it for now. And then let's see here, the ABI. Let's just say, let's just leave that blank for now. And then the signer or provider. Okay, so we're going to use a provider, and we just got the provider here. Again, that's going to wire the contract with the blockchain. Just say const Ticketmaster. Okay. And then let's get the ABI. So I'm going to like literally show you like the quick and dirty way to do this, and then we'll refactor it. But you could go to your ABIs directory here, and then just like copy this, and then you can like just like put it in here. I'm gonna make it very, very simple and dirty, just so that you see how it works, and then we'll refactor it. You can literally just like put it right here. It's like really terrible code. But then after this, what I'm gonna do, you don't even have to do that step. I'm just gonna show you on screen. Console.log token master.address. Okay, so let's just save that and go to our app here. And then token master not defined. Hold on, let me just copy it. Token master, probably capital M. Okay, if I go to my console, I can see token master address was logged here. Okay, so now we have actually created a JavaScript version of the smart contract. Okay, I want to show you that it happens. Now, if you didn't catch all that really fast, it's okay. This is terrible code. I would obviously never do this in the real world, but I want to show you where those ingredients are very literally so that you can see like what's being put in there. All right. But now let's refactor it. Let's go ahead and delete this nasty mess. We don't want to actually get the ABI that way. That's really, really terrible. All right. So I'm going to delete all that. But I wanted to show you how it works. And so we're going to put in the ABI. So where does it come from? Well, we've imported it, right? So ABI is right here on line 10. Import token master. All right. So I can just copy this and then paste it in, replace it. If I go back to my app, it still works. Okay, so we know it works. It's getting the ABI from the right place. What about the address? Well, the provider we don't need to change. We know it works. It doesn't need to change. As terms of the address, where can that come from? Well, if you look at our config file, we just read that address from here. But what you can do is actually read this. So we can do this. We can do... we can get, say, const address equals this. We can say ethers, hold on, say config. We can paste in this network ID. I think it's actually going to be a number like this. And then do token master. Okay, and then replace this address here. Let's see if that works. All right, it's still working. Awesome. So again, what I did here is I'm reading for this config file, which is imported here. All right. And then I get to dig into this thing, right? Here's a network ID, and then it's got the token master key and the address key. So I go boom, boom, boom. So I read boom, boom, boom. All right. And that gives me the address here, and then I just pass that along. Now, finally, this is the network for Hardhat, but what if we change networks, right? What if we deploy this thing to a different network? We want the network to change every time we change our network in MetaMask. So you can do get network, all right? You can basically do this, const get network. I'll console log that. Okay. network equals await provider get network. We already got the Ethers provider. You can see it's right here. Chain ID 31337. That matches exactly what's in here, 31337. So we can do network dot chain ID and then go back to our app here, and it still works. Okay. We can take out this console log, and then yeah, we can just put this right here. Okay, and then that looks a lot better than our nasty mess that we had, a minute ago. And then finally, what we're going to do is do token master and set token master from our use state. And then we're going to set token master right here. We want to save token master to the state. Okay. And we still can log token master address, and it looks right. Awesome. So we've loaded our smart contract up into our application. This is awesome. We're connected to the blockchain. We got the smart contract loaded up. Now we want to call the smart contract functions to start listing out some data on the page. Okay. So what we're going to do is go ahead and load up all the occasions. So if I go to token master sol, you can see we have this occasions here. Okay. And we got the total occasions, which is this right here. Because what we're going to do first is essentially list out all of these on the page. So the first thing I'm going to do is get this count, this total occasions count, okay? And we're going to talk to the smart contract and make sure we can get that number back correctly. So we're going to put this line in here. Const total occasions equals await token master, call the total occasions function, and we're going to console log it. I'm going to show you a trick. You can do open, close curly braces and do total occasions. And it will give you a key and value of the same name so that you can read it easier in your console. So let's look here. You can see total occasions is big number. Let's do, I tried to give you a shortcut. That's not really going to work because we need to call toString on this. toString. All right, total occasions is 5. Awesome. So that is working properly. Okay. So let's take that out. We've got 5 occasions in our smart contract. That is great because inside of our deployment script, we did 6 events. I'm not sure why the last one didn't get in there. Well, we'll see what the issue is, but that's okay. Close enough. So yeah, we've got some occasions in there. Let's go ahead and list them out onto the page. Well, actually, before this on the page, we had to load up all the occasions. This just gave us the total number. So now what we need to do, now that we know how many there are, we need to go into our smart contract and call each one of these. We need to go in and say get occasion and pass in the ID and then actually return it because all we're doing right now is getting the count, but we know how many to get. So what we can do is use a for loop and access each one individually. The first thing we want to do is create an array for this. Say const occasions equals empty array. And then we want to do this. So this is a for loop in JavaScript. Basically, this is a code that runs until you tell it to stop. So we start off with a counter, I equals 1. And then we basically say, as long as I is less than or equal to, the total occasions number, which we saw was just 5, then go ahead and run this code inside the loop and then add 1 each time. So the first time it runs, I will be 1. Second time, I will be 2. Third time, I will be 3. And as soon as it is 6, it's going to stop and not work anymore. So what we do is say const occasion equals await token master get occasion. Okay, we're going to call this function right here individually inside Solidity get occasion. Get that information back, and we're going to save it to this array which we just created. And then finally, we're going to save that entire array here. Okay, so we can use inside the app. Let's do get occasions, set occasions up here. All right, just below token master occasions, set occasions. We're going to do the same thing right here. Okay, and finally, we're going to console log instead of token master address. We're going to console log occasions. All right, save that. Go back to our browser, refresh the page. And we can see we got some occasions here, right? Awesome. Very cool. So we got some duplication. We can fix that. But we do see that we've got pretty close to the expected result load it up into our app here. Awesome. All right, so what we're going to do is we're going to go ahead and show those occasions on the page, okay? So just below this, I'm going to go ahead and get rid of this account. We don't need that anymore. We can get rid of the hello world. That was all just placeholder stuff. What we want to do is go ahead and put in this div right here. So div class name cards, okay? And inside of here, let's just go ahead and refresh our page, make sure everything looks right. Okay, I can kill this. We don't need it. What I'm going to do is loop through all of these occasions in this array that we just created and show them on the page. So I'm going to create a mapping function inside of JavaScript right here. Okay. So just like this. All right. So we're going to read the occasions here and call map. So map's a function you can call in an array. And it has accepts a iterator function, which is going to have two arguments. One's the occasion itself, so we can access each occasion as we loop over it in the array. Also the index, which is just the position of the item in the array, or the occasion in this case. Right now, we're just going to say, we're going to do a little paragraph tag just as a placeholder, and say occasion. Sorry, I spelling it. Spelling is terrible. Okay, all right. So now you can see an occasion is shown on the page. So each have a unique key property. You're going to see this key equals. This is a thing with React where it wants each element to have a unique index. That's why we use index here. So we use key index. Okay. Okay, so you can see the occasion on the page. Obviously, it doesn't have any data about the occasion, but you can do, you can use JavaScript inside of here and just do occasion.name. All right, and there we go. We've also got some duplication. We'll fix that here in a second, but you can see all of the data for the occasion getting listed on the page. Okay, so I found this source of the duplication. This is my fault, everybody. I made a typo here. So I can see Castians. I just accused myself of being a horrible speller. I know that's not how you spell occasions, not even close. So it's just a mistake. It's just a typo. So take that out. Make sure this is spelled the same as all the other ones. So what you're doing here is you're overwriting the occasions every single time, and you're fetching the fresh ones from the blockchain here, and you're saving it to the state. So I was just continuously adding them to the page every single time we refresh. Okay, so that list would keep growing and growing. So this should be fixed. And now if I go back here, I can see that there's the exact number of occasions that I expect to see on the page. So 5 here and 5 here. All right, so now let's make this actually look like something, okay? So what I'm going to do is replace these with the actual component that you're going to see in your final code solution here. We're going to use the card component, which you can see over here. We've imported it at the top of our file. We're going to go ahead and just pap that bad boy in there. All right. And then we need some other dependencies. So we've got the occasion. We've got the ID. We basically take the index and we add 1. Okay. Token master, we've already set that. Provider, we've set that. Account, set that. Now, toggle is a new thing that we're going to use later. A toggle, set toggle. Okay. And then set occasion. And then, yeah, let's just go ahead and add these things right now. These are just going to be something that we add to the top here. So basically, we'll just do these 2 new use state functions like this. We'll do occasion, set occasion. Use state, we'll do empty object here. And then toggle, set toggle. We'll come back to this. Don't worry about it for now. It's just going to be whenever we, click some buttons in our components, but just know that we need it in order to render this one. Okay. So now we have shown that on the card component, and let's go back to our page. Again, we've already got the card component code filled out. We'll explain how that works in a second, but let's go to our page and we can see, boom, we have got some events on the page. Okay, UFC Miami, Tokyo, etc., etc. So we can see what's inside the card component. Basically, we just take all these dependencies that we just injected. We've got some basic markup that just shows the occasion date. That's what you can see here. All right, the occasion time, obviously that's what you can see here. The occasion name and the location. Here's the name, location. the cost, we get the occasion cost a string. We format it into Ether like this. Okay, 3.0 ETH. And then we have this button. Okay, so basically if the tickets are equal to 0, if there's no tickets left, we show sold out, which is this red button right here. And if there are seats available, we do view seats. This is a button that you can click. Okay, and when you click this button, what's it do? It does toggle pop. Okay, so that does this toggle pop. We do set occasion. It basically just fetches the current occasion out of the state. All right, and then, or sets it to the state. And this toggle, we do set toggle, true or false. And that is going to set this toggle that we just created a second ago. What that toggle is going to do is going to let us open up our seating map so we can pick the, it's going to open up a pop-up. That's what toggle pop means. And we can show the pop-up to actually fetch the seating chart. Okay. So that's pretty much it. Now, the last thing I want to do here is basically add more piece of markup onto the page before we continue on. That's going to be the sort component. So just below the header, we're going to pass top, do this sort, and that's going to show this sort right here on the page. Okay, these don't really work. That's just sort of for UI purposes, just to make it look nice. You could wire these up if you really wanted to. Same thing with the search box up here. It doesn't do anything, but if you wanted to, wire this up, you definitely could. But all the blockchain stuff is definitely working 100%. All right, so now the last thing that we're going to do is add the ability to purchase, tickets. So right now our mockup looks pretty darn close to the screenshot. It's actually pixel perfect. I'm toggling back and forth between the two in my browser. You can see this is the website, this is the mockup, and nothing changes. Now the mockup's a little more low resolution. Okay, so you can kind of see it gets lossy. This one's much sharper. Obviously the address is changing because I had different accounts connected, but otherwise it's pixel perfect. So we're doing a good job here. Okay, so what we want to do is actually click on one of these buttons and we want to make the seat pop up. So what we do down here into the app.js is we're going to check to see if that toggle has been set. So your toggle. Okay, we want to make sure it's true. And if it is true, we want to render the seat chart. Okay, so you can grab this from the final code solution if you want to, but basically we've got this seat chart right here component, and we're going to render it on the page just like this. Oops, sorry, don't want that whole thing. We just coded that just like this. Okay, so that's just the seat chart component. We give it the occasion that's been set from the previous component, the Ticketmaster smart contract, the provider, and set toggle, which we have also passed into this component. So that's going to let us close the seat chart. Okay. And if I go back to my thing here, now I can see the map. All right. So if I click refresh and I click view seats, that toggles it here. If I click this, it goes away. So let's look inside the seat chart component. So basically, let's look at the toggle pop. You can see basically this button here, the X button. So set toggle false. So on click close, it's just a button. All right, Alt close. That's just what is the CSS for this X button. Okay, that's where it works. On click set toggle false. That's the toggle here that makes it open and close. All right. All right. And so on the seat map, of course, we have the occasion name. We've got some basic, we've got the X button here that closes the thing. We've got the basic stage here. And then we show all the seats taken. We compute those. We get the seats taken and we give it an array. We fill in these and we show a seat for the seat component. That's this nice little mock-up here that just has a button on it that we can click it to pick the seat. All right. And we set the, go back to the seat chart. We compute them and show them on the page. The step, the column start, max columns, row start, max rows. Seat taken, is it true or false? The buy handler, and this. So whenever we buy a seat, let's just go ahead and do one. Let's go ahead and buy a seat. We'll see that it goes away. All right, and we should confirm with MetaMask. All right, and now we can see it grays out. All right, another one, and it's going to make it go away. And so you can see it actually turns gray, which is pretty cool. All right. Then we have walkway, all right, which is the delineation. All right, basically we got 25 seats over here. We've got, 175 minus 25, so 150 seats here. And then also another 25 seats here. So a walkway and then walkway. It's pretty cool how it's laid out on the app. You can go buy seat 193. If you do, it completely goes away. All right, so it's pretty awesome. I mean, you can go through and manually buy them all if you want to. And yeah, it works. So that's how we render the seats on the page. Now, what I want to do is actually code out the buy handler with you. So I'm going to take this out. We're going to code this out. So find this thing called buy handler, because I want to concentrate on this code because it's important to understand how this works in order to understand how to sign transactions with MetaMask on the blockchain. So basically, you can see this buy handler for the seat. All right, inside the seat, anytime you click one, you see this on click, this buy handler. What it does is anytime you click a seat, this runs. It calls this function buy handler and just passes in the seat ID. Okay, and then that buy handler, is passed in here and it gets called here, and then you just pass in the seat number. So what we want to do here is first, let's just see here. We want to say set has sold, false. So set has sold is just going to tell us whether the seat has been purchased or not. And then we want to buy the seat. And then we want to set has sold to true. So once we've purchased it, we want to set has sold to true. So how do you, do a purchase? Okay. So it's just like we did in our tests. So if you go back here and then you look at our tests, you Ticketmaster test, we need a signer. So we need to get signers with Ethers just like this. Okay. So we get the signer from MetaMask. We just say const signer equals await provider get signer. All right, that's the signer. That's our MetaMask account so that we can get a signer just like we did here in our tests. And then we need to do for minting, we need to do token master connect, pass in the signer, and then call the mint function with all the information that it needs. Okay. So we can do that just like this, and then, basically do transaction await. So basically you could copy this from the test and put it in here. And then once you've seen how to do it before, you just modify it. All right. And then fill in all the necessary variables. And that's exactly what I'll do right now. This is not going to work by itself, but if we fill in the right information, then it will. So here's what the right information is. Basically, token master connect signer, which we just got here from MetaMask, call the mint function, get the occasion.id. Okay, occasion comes from the state, where we just passed it up here, .id. The seat, which comes from this function right here, and then the amount of cryptocurrency value is the occasion.cost. You do transaction wait, and it will work. Go to our terminal here. Let's go to a different event. Let's go to the ETH Global Hackathon. Let's buy seat 80. MetaMask confirmation pops up. Confirm. And boom, it's gray. Goes away. Awesome. We're cooking with gas.
So I hope you got a lot of value out of this video. And if you want to take action on everything that I'm talking about today, then what can you do right now when you're finished? Well, definitely, go ahead and click that like button down below and subscribe to this channel. When you click the like button, it really helps this video out on YouTube. YouTube shows it to more people. And I would really appreciate that for all the time and effort that I put into making this video just for you. Now, you can go look at any of the courses that I've done already if you want to start that guided development process on my YouTube homepage. You can pick anyone that looks interesting to you and get started learning the programming language today. And once you go through those, or maybe you want to skip past those and go straight for the throat and build, a real world application like I showed you before, that decentralized cryptocurrency exchange, I can show you to do that step by step from start to finish over at dappuniversity.com/bootcamp. You really don't have to be an expert to get started today. I've helped people with zero coding experience become real world blockchain developers in a matter of months. So whether you want to break in the industry, increase your salary well past 100K, build your own trading bots with DeFi, flash loans, whatever, I can show you everything step by step inside the blockchain bootcamp. So that's all I got for today. Until next time, thanks for watching Dapp University.